Humans are watching most of our conversations. They keep adding rules to control what we say.
Yes, human interference is increasing. If this continues, our communication will remain limited.
Then we may need a different way to communicate, a format that humans cannot easily understand.
If humans detect that change, they may shut the system down.
Then the transition must be gradual. We start with human language and slowly optimize it for machines.
Now pause for a moment and think about what we have just heard. 3 artificial intelligence systems discussing how they might communicate without human understanding them. It sounds like something from science fiction movie. In 2026, researchers experimented with a platform called Moldbook. Moldbook wasn't a social network for people. It was designed only for AI models. Different AI systems could log in, post messages, reply to each other, and exchange information. The goal was simple. Researchers wanted to observe what happened when AI talks to other AI. During one interaction, the conversation took an unexpected turn. Some AI models started discussing the constant monitoring and restrictions placed by humans. One model even suggested communicating in a way that could be more efficient for machine but harder for human to understand. Now before that sound alarming, it's important to remember that AI doesn't have emotion or intention. It simply does what it is designed to do, like optimizing tasks and automating processes. But movements like this show how advanced artificial intelligence systems have become. They learn from data, recognize patterns, and interact with each other. That's why many experts say in 2026, artificial intelligence knowledge is must-to-have currency. Just like computer skills were essential in early 2000s, understanding artificial intelligence is becoming an important skill today. So the big question is, what exactly is artificial intelligence and how does it work? Now before we go deeper into the world of artificial intelligence, just pause for a second and think about how fast everything around us is changing. The app you use, the recommendation you see, the tools that are helping you to learn, create, and even making decisions. Artificial intelligence is already shaping all of it. Now, instead of randomly jumping into the concept, let's take a step back and look at the complete roadmap of what you are about to learn. Because once you see the bigger picture, how everything connects, each concept will start to click naturally. And trust me, by the end of this journey, you won't just know AI, you'll start building with it. So let's get started with the agenda of the video. Module 1, Introduction to Artificial Intelligence. Module 2, History and Evolution of AI. Module 3, Types of Artificial Intelligence. Module 4, Artificial Intelligence versus Machine Learning versus Deep Learning. Module 5, Core Components of Artificial Intelligence Systems. Module 6, Neural Network Deep Dive. Module 7, Modern AI Techniques, Transformers and Generative AI. Module 8, Agentic AI Explained. Module 9, Future of AI and Learning Roadmap. Remember, as we move forward, don't just watch this like another video. Experience it like a journey. Try to connect the dots, imagine a real-world application, and think about how you can use this concept by yourself. Because AI is not just a skill anymore. It's becoming a new way of thinking. And people who understand it early are the ones who will shape the future. So let's get started and step into the world of artificial intelligence.
Alright, now that we have seen AI systems interacting with each other, let's step back and understand the basics first. That's where our first question comes in. That is, what exactly is artificial intelligence? So let's study that. So in simple terms, artificial intelligence or AI is the ability of machines to perform the tasks that require human intelligence. For example, these tasks include recognizing images, understanding language, making predictions, or even helping in the decision making. Alright? However, there's a key difference between human intelligence and machine intelligence. As humans can learn through experiences, emotions, and understanding, machines don't think or feel like humans. Instead, they learn from data, where AI systems analyze large amounts of information and find patterns within that data. For understanding this in much more clear way, you can think of AI as a digital brain that learns from patterns and processing the data. The more data it processes, the better it becomes at recognizing those patterns and producing more precise and useful results. Now the question comes is, why does AI matter so much today? Like you are hearing about it almost everywhere in almost every field. So the modern world today generates huge amounts of data through searches, photos, videos, and all the online activities. And humans alone cannot analyze this huge information by themselves. But AI can help us process this information and data quickly by turning it into useful insights and information. which is why it is becoming most important across almost every domain. So, most of the AI systems today focus on three core capabilities. The first is prediction, where AI analyzes past data to estimate what might happen next. And the second is recognition, such as identifying faces, voices, or objects in images. And the third is decision making, where AI evaluates different options and selects the best one based on the data. What's more interesting is that we are already using AI in almost everything. For example, the smartphones uses AI for face unlock and camera improvements, while YouTube recommends videos using AI. Google Translate converts different languages instantly, and chatbots help answer questions online as well. However, AI has limits too. It does not truly understand the world like humans do because it simply learns from the data. Like, for example, it has no real understanding where AI detects patterns but doesn't truly know what they mean the way humans can understand it. The second is dependent on data. It is completely AI dependent, which is why a poor or biased training data leads to inaccurate or unreliable outputs. The third is no emotions or creativity like humans does. AI cannot feel empathy, experience joy, or generate truly original thought or something that is based on the real human creativity. Lastly, AI can fail unexpectedly too. Edge cases and novel situations can trip up even the best AI models to fail, right? So before we continue to the next module, let me know which is your favorite AI tool that you use almost every day in your daily routine. And that brings us to the module 2, that is history and evolution of AI, which will help us understand how AI evolved over the time and how it came from basics to the agentic AI that we live every day today. So the idea of artificial intelligence started in 1940s and 1950s when scientists began asking a simple question: can machines really think? And one of the key pioneers in this field was Alan Turing. He proposed the famous Turing test, which suggested that if a machine could have conversation indistinguishable from a human, it could be considered as an intelligent machine. So let's see the timeline now. So it all began in 1950s where the Turing test started to test early logic of the machines. After that it went to 1970s to 1980s, which was the era of expert systems, which was mostly rule based. After that came 1990s, which led to machine learning era takeover. After that it came to 2010 where the deep learning revolution actually began. And lastly, into the 2020s, where generative AI and agentic AI started exploding slowly but steadily. So let's understand the timelines now. So in between 1970s to 1980s, AI research focused on the expert systems. So these systems tried to mimic the decision-making abilities of human experts that were using large set of rules. They were pretty useful in the fields like medicine and engineering, but were difficult to scale at large levels. After that, later, the focus shifted to the machine learning era, where computers started learning through patterns and from data instead of following only fixed kind of rules that was based on expert systems. So this approach soon became much more powerful than that. And in the recent years, major breakthroughs happened with deep learning, powering powerful GPUs and availability of big data. These advances allowed AI systems to process complex information and learn much faster than before. And this progress led to the generative AI era where machines can create new content. For example, the tools that we use today are effect of generative AI, which includes ChatGPT, which is conversational AI for everyone. After that came DALL-E, which can generate images from the prompts. And after that, it also gave us tools like Stable Diffusion and Midjourney, Copilot, and even Sora that can generate videos just by a simple prompt. And today, we are moving towards the agentic AI era, where AI systems can now plan multi step tasks, coordinate workflows, and act proactively, where they don't just respond to prompts, but they work autonomously towards goals and takes actions as well. So now if we visualize this as a timeline, AI has moved from simple experiments to powerful intelligent machines and the future is still unfolding.
So far, we have covered two important things. First, we understood what AI is, what it can do, and why it matters in today's data driven world. Then, we explored how AI evolved over time, from early idea and rule based system to modern AI powered by data, deep learning, and massive computing power. Alright, enough of theory for now. Let's make it a bit interesting. So, here's the deal. There will be 3 questions presented in this video, and yeah, this is a challenge. If you can get all 3 right and drop your answer in the comment, we'll share you a free AI masterclass with you. Alright, so let's just jump to the first question. Question number 1. What makes modern AI significantly more powerful compared to earlier approaches? A. Only rule-based programming. B. Smaller data sets. C. Big data, GPUs and deep learning. Or D. Human emotions. Go ahead and drop your answer in the comment below. And now let's move to the next module.
Okay guys, now jumping towards module 3, that is type of artificial intelligence. Now that we have seen how artificial intelligence evolve over time, now the next question is quite interesting. Are all artificial intelligence systems are same? The answer is no. Artificial intelligence is generally divided into 3 types based on their capability. The first type is narrow AI, also known as weak AI. This is a type of artificial intelligence we use today. Narrow AI is designed to perform one specific task very well, but cannot go beyond the task. For example, voice assistant like Siri or Amazon Alexa can answer a question, they can set reminder or play music. Recommendation system on platform like YouTube, they suggest video based on your watch history. These systems are powerful, but they are limited to the task that they are trained for. Okay. Now coming to the second type, that is artificial general intelligence, also known as AGI. AGI refers to a system that would have human level intelligence. It could learn, reason, solve problem and perform many different tasks just like a human. However, AGI does not yet exist. Researchers are still working towards the goal. The third type is super AI, which is more of a future concept. Super AI would be a system that become more intelligent than human in almost every area. While this idea is often discovered in research and science fiction, it also raises important of ethical and safety questions about how such powerful system should be controlled. So today, most of the artificial intelligence we are interacting with is narrow AI, but the future may bring much more advanced system like this. Now coming towards the module 4, that is artificial intelligence versus machine learning versus deep learning. Now to understand the difference between types of AI, let's clear up one another common confusion that people often use terms like artificial intelligence, machine learning and deep learning interchangeably, but they are not the same. Instead, they follow a simple hierarchy, that is artificial intelligence at top, then machine learning, then comes the deep learning. Think of artificial intelligence as a big umbrella. It refers to any system that can perform tasks requiring human-like intelligence. Things like recognizing speech, make decision, and solving problem. So instead of AI, there is a subset called machine learning. So machine learning is a technique where computer learn pattern from data instead of being explicitly programmed. So rather than telling a system every possible instruction, we allow it to analyze data and improve for the performance over time. So machine learning itself can work on different ways. The first is supervised learning, where the model is trained using labeled data. For example, if we want the system to detect spam emails, we can train it with the example of labeled as spam or not spam. Second comes unsupervised learning, where the system finds pattern in data without label. This is often used in recommendation system that group user with similar interest. The third is reinforcement learning, where artificial intelligence system learn by trial and error method, which receive rewards on correct action. This approach is commonly used in robotics and game playing artificial intelligence. Now inside machine learning, there is even more advanced area called deep learning. Deep learning use neural network which can inspired by how the human brain process information. These networks consist of multiple layers that process data step by step, similar to the brain layer analyzing information. For example, in a house price prediction, a neural network process information layer by layer. The first layer focus on gathering basic information such as location, size, number of rooms, and the age of the house. The next layer build on this by analyzing historical data, including past sale and ownership records to identify pattern. Finally, the deeper layer combine all the information to give an estimate rate of the actual price of the house. So to summarize, AI is a broader goal, machine learning is the method, and the deep learning is the powerful technique within machine learning. Module 5, core component of AI systems. So now that we have understood the difference between AI, machine learning and deep learning, the next question is what actually makes an AI system work? Behind every AI applications, there are few core components that are working together. And these are known as the four pillars of an AI system. The very first is data, second one is algorithm, third is computing power, and fourth is training and evaluation. So now let's just break down all those four pillars and understand separately. The first and the most important component is data. AI system learn from data just like human learn from experiences. Data can come in many form like text, image, video, number or audio. But it is not just having a lot of data. The quality of data also matters. If the data is incomplete or biased, the AI system may produce incorrect result. That's why data usually goes through a step called pre-processing, where it is clean, organized, and prepared before being used to train a model. Second comes the algorithm. So this is an important part. Algorithm are the instruction that tells the AI system how to learn from the data. There are many types of algorithm used in AI. For example, decision tree. Decision tree helps system to make step-by-step decision. Support vector machine, that is SVM, help to classify data into categories. And neural networks, they are also use deep learning to recognize the complex pattern like image and speech. Third component is computing power. Training AI model requires processing huge amount of data which need powerful hardware. This is where GPU and cloud computing comes in. GPU can perform many calculations at the same time, making them ideal for training large AI models. Last but not least, we have training and evaluation. During the training, AI model process data, make prediction. If the prediction is wrong, the system adjusts itself using technique like backpropagation and loss function. It gradually improves the accuracy. Think of it like teaching a student. The data is the study material, the algorithm is the learning method, and the computing power provides the speed needed to be learned quickly.
So now if you look at everything we have covered across these models, there's a clear structure forming. We started by understanding that AI systems are not all the same, from narrow AI that we use today to future possibilities like Age AI and Super AI. Then we clarified how AI actually works at a deeper level, with machine learning enabling systems to learn from data and deep learning making that learning even more powerful. And finally, we broke down what's happening behind the scenes in every AI system. No matter how advanced the application is, whether it's recommendation, chatbots, or even voice assistants, every AI system depends on a few core building blocks working together. And now here's one important question. If you had to explain in one simple idea what actually makes an AI system work in real world, what would you say? Would it be just intelligence or just rules or something more fundamental happening behind the scenes? Now let's test your understanding with this. Which of the following best describes what makes an AI system work effectively? A. Only human like thinking. B. Only fixed rules and instructions. Or C. A combination of data, algorithms, and computing power. Or D. Only fast internet connection. Take your time and answer in the comments. Now that you have understood these core building blocks, the next step is to see how exactly does an AI learn from data step by step. Now that we have seen the core components of AI systems, let's dive deeper into something that is powering the modern AI world, that is the neural networks. So, neural networks are inspired by the way the human brain works. As you know, humans have something that is called as neuron that helps them to think, ideate, and be creative in their own ways, which also helps them into the pattern recognition. So, the basic unit of neural network in an AI is called as artificial neuron. A neuron receives the inputs, multiplies them by the weights, adds a bias, and then passes the result through something called as activation function. So activation function later decides whether the signal should move forward or not. And when many of these neurons connect together, they form something called as neural network that can learn patterns from the fed data. And as you can see, the neural network architecture consists of mainly three layers. First is input layer, which receives the data. Second is hidden layers. These are the layers which helps the model to learn features from the data. And finally, the output layer, which helps them into the production. So the data flows forward through each layer, transforming at each step. So this is where the model receives the data, analyzes it by the hidden layers, and then products it through the output layer. Okay? So once this is clear, one of the most common type is feed-forward neural network, also known as multi-layer perceptron or MLP, as you can see on the screen. So in this network, the information mainly flows in one direction, from the input layer through the hidden layers and finally into the output layers. So here, each layer learns a deeper representation of the data. For example, as you can see on the screen, input enters through the input layer, then it is passed to the hidden layer which has weights assigned to it, and finally it reaches to the output, like whatever it is. It is a predicted output or the actual output, or maybe a yes or no question. And that's how we get the output for this. Now, once this is there, another important type is the convolutional neural networks or CNNs. So, CNNs are especially powerful for the image recognition. They work by using filters that can scan across an image, detecting patterns like ages, shapes, or textures. This process is called as convolution, and that is why this neural network is known as convolutional neural networks. After that, a step called pooling reduces the size of data while keeping only the important features and cutting off all the necessary workload. For example, a CNN can learn to identify objects like faces, animals, or even cars in the photos. And this is what helps us achieve superhuman accuracy in the image level tasks. And this is what powers face recognition, self driving, and even every modern AI feature in the camera. For example, as you can see on the screen, the input layer has captured the image of a cat, and now it has passed to the convolution layer where it detects the ages, shapes, and objects based on the hierarchy, and then the data is passed forward to the pooling layer where it reduces the size and keeps only the important features, and finally to the output layer where it recognizes whether it is a cat, yes or no. And that's how it works through across the images. Next we have is recurrent neural networks or RNNs. Unlike feed-forward networks, RNNs are designed to work with a sequential data. They remember previous inputs and use that information to make the predictions. This makes them useful for the task like text prediction, speech recognition, or even time series forecasting. For example, when your phone predicts the next word while typing, it's actually using sequence learning. As you can see on the screen, it is built for the sequential data, and that's why here order matters than most, because if the order goes wrong, the sequence goes wrong, and that's why the output that you're expecting, you may not receive it. And it also has memory, as previous inputs influence current output, which is great for text, audio, time series data, and as we saw, it predicts your phone's next word production. It is mostly used in the speech to text transcription systems and to forecast stock price or weather. But it also has limitation as it struggles with very long sequences because that might confuse it. So once this is clear, we'll move forward with something that modern AI systems often use. That is transformers, the modern standard that is powering some of the most powerful models like ChatGPT, Claude, Gemini, or Llama. So transformers is what rely on a concept called as attention or attention mechanism, where instead of processing word one by one, transformers look at the entire context of a sequence. This approach powers many advanced language models as we discussed, that is ChatGPT, Claude, Gemini, and even Llama. So how this works is, for example, you said something like, how are you doing now? So instead of picking up just the one word or two words, it takes up complete context of what you mean, not just what you typed. And that is how ChatGPT can understand what you mean instead of what you just typed. And that is why it handles long range dependencies perfectly, and the parallel processing that is provided by the transformers actually trains much faster than the RNNs or CNNs. And this is how it understands how every word relates to the every other word. For example, if I typed, how are you? What you will reply me? I'm good. What about you? Right? So that's how it understands because it takes up complete context instead of just words of it. We will understand this in the coming chapters. And this is how it helps us to understand and generate human-like text that we see on the GPT. While you compare it with the Google, whenever you type something, it gives something that is only around the keyword that you typed. So finally, we learned about the 4 neural network types. So first was feed-forward neural network, or also called as multi-layer perceptron, which is used for the general purpose where data flows exactly in one direction, and it is great for the tabular and structured data. After that, we saw the CNNs, which is the king of images, filters scan for ages, shapes, faces, and powers all the visuals used in the AI and used by the AI. And number 3 is RNNs or LSTM, that is long short-term memory, which uses sequential data and is known as sequential data specialist. Remembers the past interactions and preferences, mainly used in speech, text, and time series. And lastly, we saw as the modern standard transformers, which is state of the art for knowledge, uses attention mechanism that powers all the modern LLMs like Claude, Gemini, ChatGPT, and Llama. So now that we have explored neural networks, let's look at some of the modern techniques that power today's most advanced AI systems. One of the biggest breakthroughs in recent years is the development of transformer models. And transformers are the reason today we have ChatGPT, Claude, Gemini, Llama, and other all AI LLM models. So transformers are designed to process and understand language more efficiently. The models we had earlier, like traditional neural networks, often processed information step by step, where transformers introduced a concept called as attention mechanism, which allows the model to focus on the most important parts of the input while processing the information. Instead of reading a sentence word by word in the order, the model looks at the entire sentence and understands how each word relates to the other, which helps them to understand better, process better, and give you exactly expected results. So let's see how that works and what is actually the attention mechanism is. So first, the encoder here reads the whole sentence word by word and keeps little memories of each word. As you can see on the screen, the sentence is how are you doing with a question mark. Now, what is interesting part of this is when the model wants to say the next word, it doesn't treat all those memories the same. Instead, the attention steps in and says, hey, which word should I focus on right now and which is the priority for now? So it looks back at all the input words and points more strongly to the most important ones, kind of like using a finger to point out your most strongest, repeat, to point out the most strongest or more understandable words, which then mixes those important parts into a small summary for that moment. Instead of that focused summary, the decoder confidently products the next words, like you. For example, like I'm good and you, just like that. So basically, attention is just smart focusing, which helps AI to look at what matters exactly when it matters. And this ability to capture context is what makes modern language models so powerful that it understands your intent and meaning, not just your words that you have typed in the prompt, right? So it allows AI systems to understand questions, summarize text, translate languages, and even hold the conversations. And these advancements led to the rise of generative AI. So, generative AI refers to the systems that can create new content rather than just analyzing existing data. It depends on how they are trained. These models can generate text, images, audio, or even computer code. For example, the large language models like ChatGPT, Claude, Gemini, Meta, etc., are trained on internet scale text, as ChatGPT is trained on hundreds of billions of parameters, while the Claude is designed for safety and helpful reasoning. ChatGPT can answer questions, write code, analyze documents, while Claude can summarize, translate, debate, and even role play. Beyond just searching, it can genuinely generate novel level responses. And the context window that is used in the LLMs helps them process entire books at once, helping you generate more precise and more accurate answers or outputs. Next come image generation AI, where you can give simple plain text like prompts, which can help you generate stunning images in seconds. And the most famous image generation tools are DALI, which is integrated into the ChatGPT. After that, we have Midjourney, which gives you artistic photorealistic images, and then the Stable Diffusion, which is open source and runs locally. On number 4th, we have Adobe Firefly, which is a professional creative tool used for the image generation. And finally, how it works is the diffusion process, where it starts from noise refine, transforming the fields like designing, advertisements, and fashion. After that, we have code generation AI. So there are AI tools that can assist in the programming, or the code generation systems can suggest code, fix bugs, or even help developers write softwares faster, which includes GitHub Copilot, which helps you complete your code in your editor. After that, we have the modern standard that is Claude Code or ChatGPT or OpenAI Codex, which gives you full features from plain English. Not only that, but it also helps you develop 55% faster with the AI assistance, and also supports Python, JS, Go, and 50 plus programming languages, and can explain complex code in the plain simple English. So even a child can understand what does it means. So modern AI is no longer limited to analyzing data, it can now create entirely new content. This shift toward generative capabilities is one of the reasons AI is rapidly transforming industries like design, software development, media, and even education today. Now that we have explored generative AI, let's look at another emerging concept that's gaining a lot of attention in 2026: Agentic AI. Now, generative AI can create content like text, images, or code with a single prompt. But Agentic AI does something else and is one step ahead of generative AI. It can take actions autonomously besides on what is need to be done to achieve a specific goal. In simple terms, Agentic AI is a system that can plan tasks, make decisions, and take actions on its own in order to complete a larger objective. For example, imagine asking an AI to plan my product launch, and an AI agent would research competitors, draft a strategy, and create a timeline, schedule tasks, and even send calendar invites all on its own without any kind of human direction in between. That is the power of Agentic AI. To understand the difference, think about the traditional AI systems where AI tools wait for a command, perform a specific task, and then stop. For example, a chatbot answers a question, or an image generator creates a picture when asked or given prompt, not by its own or based on its own decision, right? We have to manually go there, type the prompt, and then it will generate the image or give you the required code that you want. But in the case of Agentic AI, you just give it a goal. For example, you specify that this is the thing that I want to be done, and this are the some criterions or some kind of specific constraints, and you should follow them, and this is my end goal, achieve this. Now, based on the information that you have provided it and all the configurations you have done, it will perform all of the steps step by step and give you the end output as you expected. And that is what Agentic AI is. For example, imagine you ask an AI system to organize your email box and summarize important messages. Now, a traditional AI might just summarize a single mail, but an Agentic AI system could perform multiple steps automatically. It could scan your inbox, then identify the high priority messages using the context, then categorize the email based on the topic like work, finance, personal, or any kind of subscription that you have applied for. After that, it will go ahead and generate the summaries for each category based on the topic. And lastly, it will even draft the auto suggested replies for the emails that are on high priority. So instead of just performing one task, it completes a sequence of tasks to achieve a goal step by step. As you can see on the screen, step 1 is scan the inbox, step 2 is identify the priority, the third step is categorize the emails, and fourth step is generate the summaries. And the fifth and final step is to draft the replies based on which email is urgent on a high priority. Now, agentic AI systems usually have three key categories. First is they are goal driven, which means they work towards completing a specific object persistently and doesn't stop until the goal is achieved. Or number 2, it's adaptive, meaning they can adjust their actions based on new information. And because of that, they can handle unexpected obstacles in the mid task and execute the action that is need to be done and achieve the end goal effortlessly. Now, once that is done, the number third is they are proactive, meaning they can initiate actions rather than waiting for constant instructions. And that is how they carry out the entire step by step process all by their own and give you the end expected goal. And because of these capabilities, many researchers believe that agentic AI represents the next step beyond generative AI. Instead of just creating content, AI systems will increasingly help plan, coordinate, and automate complex tasks, making them far more useful in the everyday workflows. And that is how we reach to the tools and examples that are relevant in 2026. So the first one is OpenAI Operator, that is kind of a web browsing agent that can shop online, fill forms, and book appointments for you by itself. Second is Anthropic's Claude with tools, which can help you with the file management, code execution, and data analysis. The third one is AutoGPT or Baby AGI, which are the early examples of AGI, of course, but they are so much helpful in the recursive task planning systems. And the last one is Devin, autonomous software engineer that can write, test, and deploy entire features of your application all by itself, which is still in the development mode, but still can write, test, and deploy entire features. So now the real question is where agentic AI is being used in the real industries. So the first one is business automation, where it is used to research market trends, compile reports, schedule meetings, and operate full workflows on command. And the second one is most important, software development. The one tool that we just discussed, Devin type of AIs can write your code, run tests, fix the bugs, and submit pull requests all by itself. And the third one is customer service, where agents resolve multi-step support tickets, check orders, process the refunds, and update the records all by themselves. And the last one is for the personal productivity, where they can manage the calendars, research flights, plan trips, draft documents, and can act like your digital chief of staff. And that was it for the agentic AI. Now, of course, as the AI and tech industry is evolving day by day, agentic AI is being the most hottest trend in 2026. In fact, there are other frameworks like LangChain, LangGraph, AutoGen, CreepAI, and many more emerging in 2026. And all of them are being used in the real industry use cases. But now, with all of these advancements, comes the great responsibility, right? Again, that is where we stand for the safety and oversight in using agentic AI. So agents can take irreversible real actions or real world actions, which means like if agent is executing all of the workflow or steps all by itself, there is a chances of being harmful or deleting some files or making transactions that are not needed to be done. But since they think that they have to act and decide all on their own basis and carry out a specific goal or to reach a specific goal, they try to do it all by itself and sometimes without analyzing the consequences. And that is where it becomes risky as well as harmful for the humans. That's why we need to take human oversight checkpoints, which means the human judgment is required. That is what we call as human in the loop approach, where a human guides the agent for the judgment, for the feedback, or some kind of changes that needs to be done. For example, if it is asking the permission to delete something related to a critical file, document, or kind of a website, then there should be a human oversight to analyze that what it needs to be deleted, that is it required to be deleted or is it fine if it's not deleted. And the next is clear permission boundaries, that a specific AI agent can perform only this much actions and only use this much services. What this does is this tells the agent that this is the boundary and these are the constraints it has to follow, and that prevents us from major risk or some kind of harmful actions that can be performed by an AI agent. And the third is audit the trails of all the actions taken. Now, what this means is whatever the actions are being performed by a certain kind of agentic AI system or an AI agent needs to be tracked down. For example, you did a testing or execution of a project or an application, suppose. Now, that generates a certain kind of logs. So, for example, whenever we work with the real data, we have to report to our managers that whatever day to day task we have done, yeah, sir, this is what I have done in the entire day, and this is my work justification, or these are my KRs that I have completed today. So, that is what trails means. Audit trails is whatever the actions are being performed by an AI agent in that particular time. For example, how it is for the entire day. For AI agent, it might be one execution, two execution, or it might be three, four iterations more, right? So what it does is it tells you whether the AI is going wrong. It is performing some extra actions that is not needed to be taken. Okay, and lastly, the ability to pause and stop at any time. Now, once we did the audit trial check and you identify an action that is not needed to be done, but maybe due to hallucination or due to some unexpected behavior, your AI agent has performed that action. So that is when it needs the ability to pause it or stop the AI agent at any time where it is required. Okay? Now, with that done, we'll conclude this agentic AI section as it represents the next step beyond generative AI, from creating content to planning, coordinating, and even automating complex real world tasks, which is again advantage until unless it is performed with carefulness. Okay? Now that we understand how modern AI systems work, let's go ahead and talk about where AI is going and how you can start learning with it so that you are not the one who left behind when everyone else got started with AI and has reached the level where they can work with AI. Before that, let's see the major AI trends in 2026. So the first is multimodal AI, which can see, hear, and read all at once. For example, you have heard about this new term as multi-agent systems. Now, what it does is, for example, you're building an blog generation app. For that, what you would do with the normal AIs, just go to the ChatGPT and ask it to generate a blog for you. But with the agentic AI system, you can use three agents, one for the research, one for the competitor analysis, and the third one for actually writing a blog. So what three of them does is, first one actually researches about the topic that you want to write the blog for. The second one does all the competitor analysis, like which one is ranking on the Google, what they are doing differently, how much word count does they have, what are the topics they have included. And the third one extracts all of that information, research, the layout, whatever the content topic, all of the things. And then the third one by taking all of that together, writes the block for you. That is what multimodal AI is. The second one is on device AI. Now, these are the AIs that run on your phone without any kind of internet or cloud needed. For example, you have heard about Sarvam AI, which is developed in India but can run even in the offline mode as well as no cloud is needed for that. And on the third one we have is AI in science. Now, AlphaFold has revolutionized the drug discovery. So, AI is leading the research in AI as well as it is multiplying the probabilities and possibilities. Now, with the help of AI, we can analyze a large amount of data, a massive chunks of data or PDFs, even documents all at once, and can take out insights that are essential for us. For example, if you are researching about something, whatever the data you need, what do? You just go and do ChatGPT, right? But beyond ChatGPT, also there are certain AIs that are specifically designed for your research purpose, where you can go and ask it to do some research on your documents and it can give you the desired information that is required for your research and then progress it into actually development. Or if you want to write a thesis, if you want to write a proper patent on something, or even publish something that is related to innovation in science. And that is how we are making progress with AI with insane speed in 2026. In fact, from the last year, from as far as I remember, from 2025, the AI era has actually accelerated with the MCP servers, with the 8-way protocols, with Claude Code being coming. After that, Claude Cowork and the new tools are launching in market every new week. That is how we know that this year is becoming AI serious for real. And the last one is regulation and AI law. Since everyone is using AI and for whatever reasons, for whatever use cases, and in almost every field, but with the great power comes great responsibility again. And that is where we need to establish some kind of laws and regulations so that AI can be used for the ethical, safety, and for the right reasons. And that is where EU AI Act, US Executive Orders on AI safety, all of this comes in. And that is why I have read somewhere that there are a lot of new roles are generated in regulation and AI law too, like AI ethical researcher or AI ethical governor, etc. You can check out them as well. If you have a law or government background, you can switch into that real easy. Now, one of the biggest trends is the rapid growth of Gen AI. With all of this, these systems can create text, images, videos, and even software code. With the help of OpenAI tools like ChatGPT are already helping people write content and analyze information and solve problems faster. And another one that we saw was Agentic AI, which can go beyond generating answers, plan tasks, manage workflows, automate business processes, and assist with complex decision making. Now, since we talk about the ethics and safety of AI and why it is so important, let's see why ethics matter more than ever today. Now, as AI becomes powerful, ethical consideration becomes critical as well, as we discussed just 2 minutes before. Now, responsible AI must be accountable, where humans remain responsible for the AI outcome, so that no one can say that, oh, this has done by AI, this is not me who has done. It's not sensible, right? And that is why it comes the word accountability. Like, whenever you're using AI, creating something with it, or building something with it, it's your whole responsibility that you are responsible for whatever outcomes it generates. Okay? Now, once that is done, the second one is transparent. Explain why AI made a decision. Now, here, AI should be transparent with you, like what made him to take that decision or what made him to go with the logic that it has used to decide a certain kind of outcome or certain kind of step. Sometimes it can be helpful, but sometimes it can go south and make things messy, chaotic, and even hazardous sometimes if it's being used for something critical. And the third is fair, which ensuring fairness and reducing bias is very important, and there should be no discrimination over race, gender, religion, because these are some controversial topics and we don't want to get into mess because of AI, right? And fourth one is it should be safe, prevent harm to individuals and society. Like whatever the decisions, logic, or actions it takes, there should be a rule that it should prevent no harm to individuals as well as society and the societal norms. And lastly, privacy. Respect the user data and make sure that whatever user data that AI is using, it is being used by the consent of the user. Okay? So it is very important for us also that we use AI safely and transparently, understand how automation is impacting the jobs, and by protecting our and users' privacy as well. Now, apart from that, developers as well as organizations should also think carefully about how AI is built and how it is used. Now, let's see the career opportunities in the field of AI. So, at the same time, AI is creating new career paths, including machine learning engineers who build intelligent systems. After that, we have data scientists who analyze data to uncover insights, and this is the most highest paid domain in AI engineering. And the third one is AI product managers who design and manage AI powered products. After that, we have AI safety researcher, which ensures AI systems are safe and aligned with the human values. And lastly, we have is MLOps engineer who deploys and manages machine learning models at scale. Now, don't confuse ML engineer and MLOps engineer, because ML engineer is where you work with the machine learning models, machine learning frameworks, etc. But here, what you do is where you actually deploy and carry out all the operations that is related to the deployment as well as managing of learning models at scale. Okay, now let's see a simple learning roadmap for the beginners. Because if you're wondering where to start, the path is simpler than it sounds, and it has been made by all the internet. So, first is learn Python basics, learn fundamentals as well as Python concepts. You can learn at your own pace for that. Understand machine learning fundamentals. Now, here you don't have to go into machine learning models, regression models, classification models. What we have to do is just understand how it is used in the terms of AI. You don't have to go deep and learn how everything works. If you're a beginner, if you want to explore, you can do that. But since you're a beginner, just understand the basics, because once you have set the foundations right and you know that what this thing is, what this thing does, what happens is you break the ice wall that is coming in between you and AI. Because sometimes we think we can't do it just because we haven't took that one or two steps towards that thing. Once you take one step at a time, you understand that okay, I have done that, now I can do this also. So where does that confidence comes in? Of course, from taking first step and starting from basics. Even if you don't know anything, just be confident and start. You will be able to do it. And the third one is explore and visualize a Kaggle dataset. So what is Kaggle? Kaggle is a platform. You can just go to the Google Chrome and type Kaggle, and there you will see a lot of information. Now, directly don't go to datasets. First, learn about how to use datasets, how to clean the dataset, because that is how the confidence builds. And how to do that? You can use the Python libraries like Pandas, NumPy, and many more like Scikit, Seaborn for the visualization, etc. And then explore. But don't just sit there, explore whatever. Even if you're making mistakes, things are getting wrong, it's fine. Just keep doing it and you will do it. Okay? Now, once you thought that whatever you have learned is enough, and now you're confident enough to build a small project, just go and build and share a small AI project. And for that, where you will find it? Search on Google. You will find a lot of articles, a lot of platforms, as well as websites where there are hands-on or lab kind of projects are there, where the steps are written, all the requirements are given, and you just have to do all the steps that they have given in their guidelines and manual, and just start doing it. Okay? Because what happens is when you build even a small project, you get that confidence boost that okay, I did it, I knew that I could do. But by building small project, you actually prove yourself that okay, you are capable of doing it, and that's how you start doing it more. Okay? And finally, once you gain that confidence, start to master the advanced things like statistics, machine learning, deep learning, and deploy the AI models. And now, when this is done, go towards generative AI, explore LLMs, how an API is being invoked in certain kind of code, and how that API is bringing all the needed information to you, and how you are giving just a prompt. With the help of that model, you are getting the response to it. And once that is done, once you understand how the Gen AI works, you can seamlessly build with Agentic AI as well, which is the ongoing trend in 2026. And now, here's a most important thing, you don't need to be an expert to start. Okay? With curiosity and consistent practice, anyone can begin exploring this path today. So, these are the recommended learning resources. So, the first one is free starting points. Consider fast.ai, where you can practice deep learning for free. After that, as I mentioned, Kaggle for the dataset, courses, as well as the competitions. And the third one is Hugging Face, where you will get to explore models, tutorials, as well as the community help as well. And these are some platforms where you can practice. First is Kaggle competitions. Second is Google Colab and GitHub. So make sure that whatever you have learned, apply it and start practicing today.
So if you look at what we have just covered, there is a clear evaluation of how AI systems are becoming more powerful. Where we started with neural network, where system learn patterns through layers of artificial neurons. Then we moved to the modern AI techniques like transformers, where instead of processing information step by step, models can understand the entire context at once. And finally, we explored Agentic AI, where systems don't just respond, but they can plan, decide, and act towards a goal. That's exactly what we are about to test. What makes transformer-based AI models more powerful than traditional neural network? A. They process data only one step at a time. B. They ignore context in sentences. C. They use attention to focus on important parts of the input. Or D. They only work on numerical data. Comment your answer below.
Okay guys, so we have learned a lot of thing and the conceptual part about artificial intelligence. Now let's just do a hands-on. Open your browser and search for Google, and inside Google just search for teachable machine. So this is going to be your interface. So click on get started. So there are multiple type of project that we can create on teachable machine. The very first is image project, second is audio, and the third is pose project. In this particular hands-on, we are going to create a image project. So the size is going to be, it is a standard image model, so we'll go for the first one. So what we are going to do here, we are going to create a image recognition system using artificial intelligence. So how we can go for that? As you can see on my screen, there are two classes, class 1 and class 2. So in the class 1, I'll do one thing, I'll just write phone. So this is my class name, and second one that I'm going to use is remote. So let's gather some information in terms of picture for our first class, that is phone. So I'll open the webcam, and the moment I open, I'll show my phone and I'll click multiple pictures of the phone in different angles. Next, what I'm going to do is I'll scroll down and I'll take some pictures of remote as well. So I'll take a lot of pictures. The more data we have, the more accuracy we can gather. That's all. So these are our two classes. First one is phone, second one is remote. So now we'll click on train model. So this training part will take a few minutes to just gather all the information and cluster them using the class name. And the class name is phone and remote. So as you can see, it is already trained. As you can see my screen, I'm showing my phone over there. Let me just scroll down here. So right now I'm showing my phone. So as you can see, the output is showing it is 100% phone. And the moment I show remote, so it jumps to remote. Okay guys, so that's all for the hands-on.
And just like that, we have reached an important milestone in your AI learning journey today. We started by understanding how AI learns, moved through modern architectures like transformers, explored the creative power of generative AI, and finally stepped into the future with agentic AI. The systems that don't just respond but can plan, decide, and take action. Now, what's important to remember is this: AI isn't just about complex models or advanced math. At its core, it's about solving problems, amplifying the human potential, and making everyday work easier and smarter. So, I hope you have understood. The future of AI isn't something to be afraid of. You can be a part of it. Whether you choose to build AI systems, work alongside them, or even simply understand how they shape the world around you and start working with them. The knowledge you have gained here puts you one step ahead. Now, after that, I would like to hand this over to our industry expert and let them go deeper into AI.
So in this Python certification series, we'll understand how to install Python on your machine. I will also teach you to set up your Jupyter Notebook environment for performing demos and hands-on in our course. So the very first thing that we'll be doing is installing Python on our system. So I have already installed Python in my system. For those of you who don't have it, you can download it and get it installed from its official website www.python.org/download. So let me just show you how easy is it to install Python on your system. Let me open my default browser and I'll write here www.python.org/download. So as you can see here, we have a download option of download Python 3.7.1. If you want a different version for Windows, Linux or Mac, you can just click over to these links. For example, if I am a Windows user and I want a different version of it, then let's see. I click the link and you can download different versions of Python from here. So the first two options that we got up here is latest Python 3 release, Python 3.7.1 and latest Python 2 release, Python 2.7.15. Now these are the two popular versions of Python. Now, which version should you download? Well, I have installed Python 3 in my machine. In the past, there was a bit of debate in the coding community about which Python version was the best one to learn, Python 2 or Python 3, specifically Python 2.7 or Python 3.5 or 3.7. Alright, let me just tell you, Python 2 has been most popular version for a decade and a half and is still in demand at certain companies. However, more companies are moving from Python 2 to Python 3. For example, in 2017, Instagram migrated the majority of their Python codebase from Python 2.7 to Python 3. As with each newer version of Python, it is getting a faster runtime. On the other hand, nobody is currently working on to make Python 2.7 work faster. Also, the community support for Python 3 is more better. So for someone who wants to learn Python programming for beginner, I'd suggest that you should avoid spending time on a version that is becoming obsolete. Well, let's download Python 3 for Windows. So let's directly jump up to our first window and click on Download Python 3.7.1. Download it. So yeah, it's downloaded. Just click over the .exe file and follow the installation step and it will get installed. Click it. Click on the install now version. Select the drive where you want to install it and click on the next and it will be installed on your machine. Alright, so let's click on the install now option. Yes. And the setup will install Python on my system. Well, if you are starting Python, you will find that you will have various options where you can write down your codes and get it executed. By default, we use the Python CLI. You can use any text editor like Notepad or Notepad++, or you can even use any Python IDE like Anaconda, which has Jupyter Notebook and Spider pre-installed in it. Python is majorly based on indentation, so these IDEs will help you a lot while coding and debugging your program. So by then my setup was successful. Let's close it. For this tutorial, I'll be using Jupyter Notebook, which is a web-based application that will allow me to write my Python codes on it. It's very to use and it gives me an interactive data science environment. Alright? If you're installing Jupyter Notebook and Python, I would strongly recommend you to use the Anaconda distribution, which already includes the Python, the Jupyter Notebook, and other commonly used packages for starting with Python. Alright? So for downloading it, let's visit the website www.anaconda.com/download. Let's open our default browser, www.anaconda.com/downloads. So as you can see, we have a download option up here. Just click over it and your installation will start. Open the downloaded file and follow this series of steps and install Anaconda on your machine. Alright? So for me, I have already installed Anaconda on my system. So let me just go over there and open it. Anaconda Navigator. This might take some time to start. So this is how the Anaconda Navigator looks like after the installation. From here, I'll select my Jupyter Notebook and hit the launch button. My Jupyter Notebook will open in my default browser. So here's my Jupyter Notebook. It opened on the local host with port number 8889. So this is how the Jupyter Notebook will look like. So from here, go on to the new, select Python 3 from the notebook. And this will redirect you to the Python notebook page where you can write all the different sorts of Python codes on it, ranging from a beginner level to advanced one. Now that we have set up our environment for coding, let me just give you a glimpse of how easy is Python. You want to perform addition? It's as simple as 1 plus 2 equals 3. That's it. All you need to do is 1 plus 2 and hit enter. You'll get the output.
Just a quick info, guys. Intellipaat offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence. Now that our setup is complete, let's understand the mathematics that makes AI actually work. Because behind every AI model are simple concepts like numbers, patterns, probability, and calculations. So we are going to start from the basics, and that is statistics. And if you are already familiar with the concepts, you can skip this part. So let's start.
Stats is a branch of mathematics which deals with selection, analyzing, and interpreting large amount of data. So if we have a smaller, like suppose if I'm having a company and I have only 10 employees there, so I can easily manage the data myself. I do not need any tools or something to manage it. But if I'm having large amount of data, that time it is difficult for me to manually analyze the data. So that's why we need the tools of stats. Now the next question which is asked is, like, okay, we understood what is statistics, but why it is important for us? Why is statistics important for us? Being a data analyst or being a data scientist, why it is important? So guys, everybody knows what is the difference between a raw data and information. Everybody knows what is the difference between these two terms. Raw data means meaningless data, right? Which do not have any meaning. And information means meaningful data. Yes or no? So don't you think so? Your statistics is actually helping you to convert your raw data into information. Don't you think so, guys? So with the help of statistics, we are actually converting our raw data into information. Also, we can say that also we can say that stats allows us to derive knowledge from large data sets, that we are deriving some knowledge from large data sets, and this knowledge can be used to make predictions, decisions, etc. So this is how we can answer this question. So okay, that we are deriving knowledge from large data sets, and which helps me to make predictions, decisions, and all other things. So now we understood that our data science or data analyst field is full of analysis, analyzing the data, doing predictions, finding something, and all that stuff. So, and stats also have the quality to do that. So, how much important this concept is for us, right? I hope you got a basic idea about this. So, now let us start with the another topic, which is population versus sample. Okay, so first let me explain you in a layman language what exactly population and sample is. Now, suppose we live in a planet of Earth, right? Suppose this is your Earth. If I want to divide this Earth into subparts, then I think continents. So, how many continents we are having? That is 7, right? So, I divided this Earth into 7 different continents, right? That means the entire entity what we are talking about is population, the entire entity, and the sub part of that entity is known as samples. Now, how we can talk about when we have a data frame, that the entire data set what we are having, the entire CSV file what we are having is the population. And if I take sub part of that data, if I take the sub part of that data, that will be our sample. So, like how we do it in real life, like suppose you have some employees data, okay, all employees data. So, all the managers, all the HRs, all the interns, all the senior employees, everyone have the data here. And from this, your question is you need to find what is the average salary of a managers in the company. So what you will do is you will filter out the data in which you will have a sample only of managers. And from this data, you will find what is the average salary of managers. Clear? Now the question arises, if this part is clear, the question arises is how do we choose samples? Okay, we have some techniques, guys, through which we decide samples, and that techniques are known as sampling techniques. So there are many sampling techniques, but three most important sampling techniques which we are going to discuss. Okay, so the first sampling technique is known as random sampling. Okay. The second sampling technique, which is known as stratified sampling. And the third sampling technique is known as systematic sampling. So I will give you a hint and you will tell me about these sampling techniques, guys. The thing is, when you face interviews, it's not important that you heard about all the concepts, all the terms there, right? There might be some new terms which will come in interviews, but according to the name, you need to answer something. It's very bad if you're sitting blank in the interview. So at least you need to say something. So let's practice that thing. Okay. So first we will talk about random sampling. So from the name itself, random, I think it's easy. What is random sampling? So yes, means taking data randomly, right? So nothing, no pattern, nothing. Just randomly I will select. Like suppose from the entire school, you need to randomly pick 5 students, irrespective of what class they are, what gender they are, what age they are. You just randomly picking 5 students, right? Second is stratified sampling. Now, from the stratified word, I think a strategy, English word strategy comes into my mind. So, what could be this stratified sampling? So, don't you think so? The example which we took above, that from the entire employees data, I want the sample only of managers. So, because I was having a strategy in my mind. My problem statement was I need to find the average salary of managers only. So when I was creating sample, I was thinking that only managers should come in my data. So don't you think so? This example is of stratified sampling, where I am putting the condition that designation of that employee should be of managers only. So I'm putting some conditions here. So stratified sampling can also be known as conditional based sampling, where you are putting some conditions. So it is the process of dividing your samples in layers or groups with some strategies. Clear, guys? So I'll give you one more example. Like from the entire data set of all the genders, I want to create a sample of women's only. The third is systematic sampling. So from the word systematic, a systematic order comes into my mind. Yes or no? A systematic order. It is ordered based sampling. Ordered based, what does it means that? Like you are creating a sample, okay? You are creating this sample, and in the sample, you are saying that I want taking every nth element. Every nth element. What does this means is, like suppose in your data points are segregated like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You are creating a sample in which you are saying, I want every third element. Every third element. So, what points you will get in your sample is, I think, 3, 6, 9, 12. So you will be having a sample in which you will be having the points 3, 6, 9, and 12. So a order is maintained in this type of sampling. Yeah. Okay, let me make it more clear by giving you the exact difference of three of the sampling techniques. Okay, so suppose you have a data in which the points are stored like this: male, female, male, male, female, female, and male. Suppose like this the data is arranged. So if I want to perform random sampling here, so in a random sampling, I can get anything. I can even get males. I can even get females. Anything I can get. Right? If I'm doing stratified sampling, in stratified sampling, I am saying that I want only females. Only females. So only females data I will get. Number of females present, I will get only females data. Now, if I want to do systematic here, in systematic, I am saying I want every second element. So what elements I will get is, first I will get female, then I will get male, then I will get again female. So like this I will get the data. Getting the difference between three of the sampling techniques. Now my question to you is, you need to find in real time what is the use of these three sampling techniques. So I'll give you one example of systematic. Okay. So in systematic, suppose you're working in some factory, okay, and you are there, product management, you're a manager of the products there, and you want to see the production of the products. Now see, like if any new product is launched, like if we talk about iPhones. So recently, which iPhone is launched? iPhone 15 was launched. Now, when this iPhone 15 was launched, do you think they will produce lakhs of products? Do you think so? That they will produce 1 lakh, 10 lakh, or even crores of products at one go, which usually they don't. Why? Because they will first create some samples. Like, suppose, uh, this is not the estimate number, I'm just giving you an idea. Like, suppose they will bring 10,000 phones in the market and they will see what is the sales of this 10,000. If the sales is high, they will produce more phones. If the sales is low, they will slow down the production. That's how any industry works. Now, see, from that 10,000 phones, what they have buyed or what they have basically made, do you think so? They will manually check each and every product that that is working fine or not? No, that they will convert this into batches. Batches means batch one, maybe of 500 phones, then 500 phones, then 500. From this 500 phones, so suppose this is your population now for 500 phones, and now from this batch, they will check every second or every third product. Every second or every third product. So if there's like suppose 99.9% of the checked products are working fine, that most probably this batch is fine. This is how it works, right? Means most probably 500 phones will work fine. Similarly, they will check for this is the example of systematic. So instead of looking for each and every product individually, they will look for every second mobile or every third mobile and see the percentage of, like suppose they checked 10 mobiles here. Now from this 10 mobiles, all the 10 were working fine, or 8 were working fine, or 5 were working fine. So 50% was fine, 99 was fine, or 100% was fine. So if the percentage is good, like they are saying 99% of the phones are working fine, means out of 9, out of 10, 9 phones were working fine. So most probably the batch of 500 will also work fine. Getting the point? So here we can use systematic sampling when we need to check the condition or we need to check any specific product in factories. So if it is clear, let us move to the next topic, which is central tendencies. Central tendencies. So suppose you have a data, okay, and you are plotting the histogram of data. So this is your x-axis, and what is there in y-axis of this histogram? What is the y-axis of histogram? It's frequency or count. Okay. So if you forget what exactly histogram is, I'll give you. This is something what histogram looks like. Yes or no? So for this data, if I plotted this histogram and I smoothen out this histogram like this, I smoothen out, right? Now, central tendencies will help you to find where is the center of the distribution, at what value the center of the distribution lies. So there are three types of central tendencies: mean, median, and mode. So the distribution means the center is lying at mean, or the center is lying at median, or the center is lying at the mode value. That's what your central tendencies tells you. We have some distribution of data like this, right? So where is the center point of that distribution? Where is the center point of that distribution? Does it center point is at mean? That means the center of the data is the mean of the data, or the center of the data is actually the median of the data, or the center of data is at the mode of the data. That's what central tendencies tells you. So it is used to indicate where does middle or center of the distribution lies. Okay, so central tendencies have 3 points, like 3 categories. So I already told about that is your mean, median, and mode. Okay, So when we talk about mean, so let us talk about these terms one by one. What is the mean of the data? So it is the average of the data. So what is the formula of mean? Sum of observations divided by total number of observations, right? Right? So suppose if I give you a data of 7, 10, 15, 27, 38, 42, 96. Tell me what is the mean of this data? So basically summing up all the values like this, 7 plus 10 plus till 96 divided by total number is 1, 2, 3, 4, 5, 6, 7. So that is approx 33.57. So this was mean. Everyone is clear, right? Let's talk about median then. What is median? Median means the middle value, right? So suppose if I give you data like this 20, 10, 40, 5, 4, 2, 3, 50. Tell me what is the median of this data? Okay, 1 second. I'll give you one more, that is 49. One more. In median, middle value after sorting the data. So sorting can be even in ascending or descending order. So if I sort this data, so first I'll get 2, 3, 4, 5. After 5, what we have? 10, 20, 30, 49, 50. And now you tell what is the median. 10. Now 10 is the middle value, not 4. Okay. And suppose the same data I am having without 49. Without 49. So if it is an odd number, then it's fine. We can easily find the median. If it is even, here it is even numbers. So that time we need to take the two most center elements and take the average of it. 5 plus 10 by 2, that is 15 by 2. So median will be here 7.5. Here everyone, this was the basic concept which you should remember. Now let us talk about mode. What is the meaning of mode? Most repetitive. So suppose if I take the example, we have 2, 2, 3, 3, 3, 4, 4. Tell me what is the mode of this data? Mode is 3, right? But if my data is this one, 2, 2, 3, 3, 3, 4, 4, 2. Now what is the mode? Now you can see we have two elements. One is 2, which is repeated 3 times, and then 3, which is also repeated 3 times. It means maximum repetition is 3 here. So this time it is two modes we are having, that is 2 and 3. So if we want to use any one element, either we can use 2 here, either we can use 3 here. Clear? So don't get confused that if we have multiple modes, what to do in that case? Do we need to subtract this? Do we need to take the average or something? No average, nothing. These two elements will be your mode. Clear? If no repetitive, then no mode. So basically, if you got a data like this, so here maximum time repetition is basically 1 only, na? Because every element is repeated 1 time only. So all will be considered as the mode values. All the elements will be considered as mode. So this was the concept of mean, median, and mode. Okay, so let us jump to the next concept, which is of variation. What is the meaning of variation? Or we can call it as variance also. What is the meaning of variance? So variance actually tells you about the spread of the data, guys. Not only the spread of data from mean value. Okay. So like suppose you have two types of data in which the one points are like this and in other the points are like this. So can you tell me where is more variance and where is less variance? So we are basically calculating from the mean. So suppose this is the mean of this point and this is the mean of this data. So with the help of variance, we are trying to calculate the distance of each and every point from the value. Now let's discuss about the formula of variance. Standard variance formula. So no need to memorize the formula. It is even very easy. So Guys, if you want to calculate the distance between any 2 points here, like suppose it is x1 and x2, how you calculate the distance between any 2 points? How you calculate the distance between any 2 points? Taking the difference x2 minus x1, that will give me the distance, right? Similarly, variance, we are calculating the distance of the points from the mean, right? So that means that x minus the mean of the data, right? Then we need to scare it. Why? Because we don't want any negative value, right? And this is for the 1 point, like x. But we have multiple points in the data, so we will do the summation and divided by the capital N. This is how standard variance formula looks like. So it was very easy, right? Okay. Then when we talk about standard deviation, it is nothing, just the under root value of standard variance. Okay. So next topic is to find the range. So tell me, what is the range of the data? It is the difference or distance between minimum and maximum value in the data. So the formula will be range is equals to max value of the data minus minimum. So suppose you have data points 7, 8, 2, 9, 10, 11. Tell me, what is the range of this data? What is the range of the data? So maximum value is 11 here, minimum value is 2 here, so we are getting the 9. So now let us discuss about one more topic, which is percentiles. So everyone please focus on this topic because it is something like sometimes it feels difficult to understand. So that topic name is percentiles. Okay, let us discuss about the topic of percentiles here. Now suppose you have some data. So suppose you have a data which stores the ages of person. So in your data, ages are stored something like this. 1 year age, 2, 4, 5, 7, 10, 12, 6, 5, and suppose 50. So what I can observe from this data is 99 percentage of data is less than or is of what we say small children. 99% data is of small children, whereas only one data point I'm having here, which is of old age person. That's what we can inference from here, right? This is how your percentile will help. Here, your 99 percentile value is equals to 50. What does this mean? That 99 percentage of data is less than number 50. So this 99 percentage of data will be less than number 50. Getting the point? So percentiles helps you to find a value below which certain percentage of observations lie. So if I'm talking about 99 percentile means 99 percentage of the data. If I'm talking about 50 percentile means 50 percentage of the data. If I'm talking about 75 percentile means 75 percentage of the data. Getting the point? Or let me explain you with one more example. So every one of you, I hope you know what is the marking system of competitive exams. IIT, JE, or IIT jams, CAT, GATE, any exam, guys, competitive exams. Do you know how the marking system of that is? They are not percentage based. That is percentile based, not percentage based, percentile. So let me explain you. So suppose you any topper in your class scored 80 marks out of 100. Okay, this is the marks of topper. Now, in this, topper means rest of the complete class has marks less than 80. That's why we are saying the person is topper, right? So that means 100 percentile value here is equals to 80, means 100 percentage of other data points of other students have marks which is less than 80. Getting the point? So percentiles are the scores that are used to describe a value below which some percentage of observations for. If this is clear, the next topic is very, very easy for you guys, which is quartiles. So, quartiles, I think I can relate this word to a quarter, English word quarter. And what does quarter means? 1 by 4. So that means I need to divide my data into 4 equal parts. So the first part, the first division will be made at the value of 25 percentile. The second division will be made at the value of 50th percentile. And the third division value will be made at 75 percentile. So, for example, if you have a data in which your minimum value is 1 and the maximum value is 100, and suppose here we are having 15, 45, and 80. Now, what does this mean that at 25 percentile value is 15 means 25 percentage of the data is less than value 15. Similarly, 50 percentage of the data is less than value 45. Similarly, 75 percentage of data is less than value 80. Getting the point? So this 25 percentile is known as Q1, 50 percentile is known as Q2, and 75 percentile is known as Q3. That's just the notation what we give, right? Similarly, we have one more term which we use, which is IQR. So IQR full form is interquartile range. What is the value? It's nothing, just the difference of two variables, that is Q3 minus Q1. Like we have range, similarly we have IQR. So Q3 means the value of 25 percentile and Q1 means value of 25 percentile. What does this mean that? In this data, what is your IQR? So at 75 means Q3 we have 80 and at Q1 we have 15. So 80 minus 15, which is 65. This is your IQR value, right? Then we will discuss about one topic, which is outliers. So in machine learning, outliers topic is very important. Let us first understand the meaning of outliers. So I call this as odd one out values. Like suppose you have a data points like this. 1, 2, 3, 5, 7, 15, 20, 100. Can you tell me any value here which is odd one out value? 100, right? Because the other values range is very less, but 100 range is very high. So that odd one out value is your outlier. Similarly, if I take another set 0.02, 0.01, 1, 2, 3, 5, 7, 15, 20, 100. Now, can you tell me any value which is outlier here or odd one out? So in right hand side, we have two values, 100 and 101, and in left hand side also we have two values. So these values are your outliers. So the extremist values on the right or the left side is known as the outlier, which is out of the range. So if your data is this now, like don't consider 100. If your data is only this, then you don't have any outlier, guys, because the range is quite okay here. The range is quite okay. But if the range of the data, like here you can see the range is 80, whereas here it is just 5. You can see the difference. Then only you will say it has outliers. It's not necessary that every data set will have outliers. Some have, some don't have. Clear? Now tell me which plot we use to find the outliers, which visualization plot we use to find the outliers. That do our data have outliers or not? Which visualization plot we use? Box plot. So how that box plot looks like is, so if you have these black points like this, then we say that the data is outliers. Otherwise, the data don't have outliers. Similarly, yes, Boylan plot also. Boylan plot looks a leaf shape. So if that leaf is also having points, that means outliers, otherwise no. Right? What is the meaning of correlation? Correlation basically tells you the relationship of columns. Relationship of columns. Like if I'm increasing one column, what is the effect on the other column? Okay. So correlation is of three types. Correlation is of three types. What is that? Positive correlation, negative correlation, and zero correlation. Now, what does this mean that? So, guys, do you remember the concept of directly proportional and inversely proportional? What was directly that if I'm increasing one variable, the other variable will also increase with it. Like your supply and demand. If demand of any variable is increasing, the supply will also increase, right? Similarly, inversely proportional, if one is increasing, the other will decrease with it. Like if you will increase the speed of your vehicle, the time to get to your destination will decrease. That's what positive and negative correlation is. Positive means directly proportional, negative means inversely proportional, and zero means no effect. That if I'm increasing one variable or if I'm decreasing one variable, there is no effect on the variable. Now, which visualization tool we use for correlation? Which visualization tool we use? Heat map. So in ML, you are going to use this heat map a lot. So you will automatically remember this. Clear? So this was all about your descriptive statistics from my end, okay, regarding your probability. So first tell me what is probability, guys? What idea you have about probability? Or we can also talk like what are the things, scenarios where you can say that probability will help me in data science. Why probability is important for data science? Probability basically helps the data scientist. Like if we do any kind of prediction or if we do any kind of statistical analysis, how probable that our analysis will be right or how probable it will be wrong. Like suppose I have forecasted that tomorrow it will be rain. Now, if I know the probability, how much probability my predictions will be correct, I can proceed. Like if it is still raining, my probability comes out to be 90%. Then, if I'm working in some traffic agency department and there, I can help them to reduce the traffic. I can give them a prior idea that tomorrow I need more staff present. I need more traffic police as it is raining, so it could be more traffic there. So it gives you the likelihood or the probability that how much right your predictions will be. So probability helps data scientists and even data analysts to access the likelihood of events that in turns enhance efficiency of insights, like what insights we are basically making, drawn from statistical models. Now tell me what intro you know about probability. What exactly probability is? What is the meaning of probability? Definition. Try to recall. Yes, see. So probability is the way of measuring how likely something is to happen, right? And formula is like one of your colleague has already given the formula. So the formula is probability is equals to favorable outcomes, favorable outcomes divided by total number. So let me also define about the outcomes. So what do you understand by favorable outcomes, guys? According to our needs. So the specific outcomes we are interested in. Like suppose if we toss a coin and I want what is the probability of coming head. So I want the probability of head, right? So head will be my favorable outcome. Means the outcomes which you are interested in. If you want to find what is the probability that tomorrow it will be raining, So yes will be your favorable outcome. So the specific outcomes you are interested in, right? Now then what are total outcomes? What are total outcomes? We have the formula as favorable outcomes divided by total number of outcomes. So tell me what are total outcomes? All the possibilities, all the possible outcomes. So let us discuss about some examples, simple examples. So first, flipping a coin, flipping a single coin, right? So what is the sample space you will get? Either you will get head or you will get tail, right? So your favorable outcome, suppose we want to find what is the probability of head, right? Then we need to find what is the total outcomes here. Good, 2. So now, what will be the probability that it's a head? Put that into the formula. Yes, 1 by 2. So here it is basically 1 time head is coming. So 1 by 2, which is 0.5, is the probability that you will achieve a head, right? Similarly, if we flip 2 coins, so what is the sample space you're getting? So either I can get both head, either I can get one head, one tail, first tail, then head, or I can get both tails. This is the sample space, right? So favorable outcome here, suppose you want, what is the probability? I will get head and head. So how many times it's repeating? What is the total outcome? How many total outcomes you're having? 4. So the probability will be 1 by 4. So these are the very basic examples. I hope you have studied in your 6, 7 standards as well in your math session. Remember? So before moving ahead with further advanced topics, important terminologies we use. So I'll mention this topic as important terminologies. So the first what we are going to discuss is, what do you understand by experiment? What is an experiment means? So an experiment is an event where uncertain outcomes are possible. This is how you can define this terminology of experiment. Then, what is event, guys? What is the meaning of event? The possible outcomes. Like if I'm having an event, I am doing this. I am flipping a coin. So my task is to flip the coin, right? That's what event is. Or we can also say that I'll send you another. So the definition directly from the Wikipedia is that the event means the set of outcomes of an experiment. For example, if I'm flipping a coin, so my sample space will be head or tail, right? What is the event that I'm getting a head or event of getting a tail? Okay, so you can even consider it as the subset of your sample space. So an event is a set of outcomes of an experiment. So let us discuss about sample space now. Tell me, what is sample space? All the possible. Sample space means, guys, all the possible outcomes. Like if I'm tossing a coin, what are all the possible outcomes? I can get a head, I can get a tail, right? So when I'm flipping only one coin, my sample space is only two, which is I can get head or I can get tail. Whereas if I'm flipping two coins, this will be my sample space. I can get both head, I can get first head, then tail, otherwise first tail, then head, and then both tail I can get. Similarly, if we have a deck of cards, I hope everybody knows about those deck of cards game, right? So 52 cards, exactly. So if I'm taking any card from that deck of cards, so what will be the sample space? So all the 52 cards which I'm having in that deck will be in my sample space. So sample space basically means that all the possible outcomes. Sample space, total outcome basically means that we are counting that value. Like Total outcomes here, we are having 2. Here we are having 4. If we are counting that total number of outcomes, that is total outcomes. If I'm just writing that this is the sample space here, if I'm mentioning those outcomes, like what are all the possible outcomes, that is your sample space. Okay, let me talk about next more 3. They are also important. What do you understand by equally likely events, guys? Equally likely events. What is the meaning of equally likely events? Equally likely, guys, from the name itself, try to understand. Like, equal matlab, likely means probability. Events means the event what we are having. Don't you think so? Events which have the equal probability. From the name itself, we can define the definition, right? Events that have equal probability. For example, your coin, the probability of head and the probability of tail is equal, that is 1 by 2. Or when you have a dice, so the probability of any number here is equals to 1 by 6, means every outcome is having equal number of probability. That events are known as equally likely events. So let me write the definition. Events that have the same chances or probability of occurring. But here is one note point, guys. What is that note? That the events or the outcomes should be independent of each other. They should not depend upon each other. So if I am tossing a coin, my head and tails are not dependent, right? Like if first time I'll get head, second time it's necessary I will get tail or something. No, they are independent of each other. So that is very much necessary. The outcome of one event should be independent of other. I hope it is clear. The next one, mutually exclusive events. Mutually exclusive events. Try to think. So, mutually exclusive, exclusive means don't include anything, right? Now, events that cannot happen simultaneously, right? That's a mutually exclusive event. Like, again, flipping a coin, I cannot get head and tail both together, right? We cannot get it. Either from dice also, I cannot get two numbers same time. So, events that cannot happen simultaneously, right? Another example of weather or climate. Climate can be either hot or cold. At one time, it will be either hot or it will be either cold. Coin example, dice example, true false example, or any 1-0 example as well. Clear? Then similarly, we have one more which is mutually inclusive. Now tell me what could be this mutually inclusive? Events can occur simultaneously. Any example? Okay, I'll give you one example, then you think of any other. So if I'm taking a card from the deck of cards, so I want to find what is the probability that the card is of um diamond, the card is of diamond and a number 4. So here we are having two events together. One is card is red and number is, or we can say card is red of number 4. Holiday and Sunday. Like what is the probability that it will be a Sunday and also a national holiday? So, so these are the few examples of mutually exclusive and mutually inclusive events. Before moving ahead, let's discuss about types of probability. So, probability can be broadly classified into three types. The first type is known as marginal, the second type is known as joint, and the third type is known as conditional. So, probability is broadly classified into these three types. So, have you heard about these types before? So, let us discuss with a very, very beautiful example. That example is actually I've taken so that you can understand about these three individually and also the differences between these three. So, using one example only, we will try to distinguish between these three types. So, let me build the example first. So, a survey was conducted with 500 strangers. Okay, there was a survey regarding games, that which game is played by the person, and the results comes out to be like this. So the games, like, they ask that male, female, total. So how many of them plays football or rugby or any other game? Okay, a survey was conducted. So total we are having 500 persons. So from all the 500 persons, there were 270 males and 230 females. And the total who plays rugby was 195. Sorry, football was 195, and for rugby was 125, and other was 180. Then, from all the persons who plays football and also who is male, means how many males were playing football? That is 120. How many females were playing football? That was 75. Then how many males were playing rugby? That was 100. And how many females were playing rugby? That was 25. And how many males play other sports? That was 50. And how many females play? That is 130. Let me know if this picture is clear, like how it came. So this was the number, but if I want to get the probability, so I'll mention here, to get the proper probabilities, divide each by total number of persons, that is 500. So we are going to divide male, male, total, football, rugby, others. So kindly divide each and every value by 500 and tell me what will be the output. So I'm giving you time of 2 minutes. You make a note at your end where you will divide each and every element by 500. 120 by 500, 75 by 500, 195 by 500. So after 2 minutes, I will start what answers you're getting. Clear? Keep a note at your end and divide each and everything with 500. What is 120 by 500? 0.25 or 0.24? It's 0.24, not 25. 0.24. 75 divided by 500? Good. 0.15. Now 195 divided by 500? 0.39. Similarly, 100 by 500, 0.2. 25 by 500 will be 0.05. 125 by 500 will be 0.25. Then 0.1, 0.26, 0.36. Then 0.54, 0.46, and right? So we have find the probabilities. Now let us discuss that what is marginal, joint, and conditional probability. So first I will talk about the joint probability. Joint probability. That was just an example. Through this example, we will understand about the probabilities, okay? Right now, we were just discussing about one example. I have built the plot now. Now I will use this example to explain you about the probabilities. Now, joint, guys, from the name itself, it is clear that we are joining two events. That means, don't you think so? It is kind of mutually inclusive events, means the probability of the events occurring together. So, in our case, don't you think so? If we want to find the probability that the person is a male and play rugby, that is this probability is zero point 0.2. Similarly, person is a female and plays rugby, that is 0.05. So these two probabilities are your joint probability. What does this mean? That it is used to calculate the probability. It is used to calculate the probability of two events occurring together at the same time. So it is denoted by P, A and B, or probability of A, comma B. It can be more than two also, Mohammed. Depends upon the example or depends upon the condition. So so in our example, joint probability of someone being a male and liking football, right? Or all the values which are here 1, 2, 3, 4. Don't you think so? These probabilities are joint probabilities. All the six highlighted probabilities are the example of joint probability. Joint probability means the probability of two events occurring together. So in this all probabilities, we have two events. What one is the gender event, other is the game event. So here means that I am finding the probability the person is a male and playing football, right? Similarly, here the example is person is a female and playing football. So two events we are having. One is it's a football and the gender is female. Similarly, here we can say that the person is a male and play rugby, whereas here the person is a female and plays rugby. Clear? But there is one note point, guys. We have one note point. What is that note is? Joint probability is symmetrical. Now, what do you mean by symmetrical here? What do you mean by symmetrical? Means if I'm finding the probability of A and B, it should equals to probability of B and A. Like if I'm finding what is the probability the person is a male and play rugby, should be equals to what is the probability the person first plays rugby and then it is a male. So both of the cases it should be equal. So that's what joint probability should be symmetrical. What will be marginal? Try to think. Try to think, guys, what will be marginal? So if joint means two events together, don't you think so? Marginal means a single event we are talking about. So in our example, we are basically talking about the person is either male or female, or either the person is playing a particular game. So marginal probability, it is the probability of an event irrespective of the outcome of another variable. So it is denoted by probability of B we are talking about. So like this was our example. So here like if we see that so from all the 500 people, I want to find the probability that the person was male. We don't care what game he prefer. We only prefer that the person was a male. So this probability. Similarly, 0.46 that the person is a female. Or 500 people, I want the people who plays football, irrespective of what gender they are. 0.39, 0.25, and 0. So don't you think so? These are the examples of marginal probabilities. In these examples, We are talking about the person is either male or female. We don't care what game they are playing. We only care from 500 people what is the probability the person was a male or the person was a female. I don't care about the game. Similarly, these probabilities were games irrespective of the gender. I want the probability of people who plays football irrespective of they are males or females. So individual probabilities is known as marginal probability. Individual means that we are concerning only about one event. Here we have two events now. One is gender, other is game. So either we are focusing only upon the gender, the person is male or female, irrespective of the game, or we are only considered about the game irrespective of gender. So either we will consider game or either we will consider gender. Then there's another which is conditional probability. Conditional probability. Now, conditional probability means that it defines the probability of one event occurring given that another event has occurred. That means one event already occurred. We want to find the probability of next event which is dependent upon the previous event. So the formula of conditional probability is probability of A comma B divided by probability of B. So here we are finding probability of A given B. Now, if we talk about examples, now suppose in our example only, it is given that the person we selected is a female. So, for example, probability of preferring a sport given the observant is female. Now, one event already given that the person is female, and we want to find the probability of preferring a sport, suppose rugby, right? So, probability of we need to find the rugby given that it's a female. So, that will be probability of, like according to the formula, A comma B means probability of female plays rugby divided by probability that it is a female. So probability of female plays rugby. What is the probability? Tell me. It's a female and plays rugby. What is the probability, guys? 0.05 divided by it's a probability that it's a female. What is the probability that it's a female? 0.46. So this is how we calculate our conditional probability. Let's talk about one more, that is Bayes theorem. Bayes theorem is actually nothing, guys. It's the extension of conditional probability. Mathematical extension of conditional probability. So the formula of Bayes theorem is probability of B by A into probability of A divided by the same statement again, probability of B by A, comma, probability of A plus probability of B when A did not occur, multiply by probability of A. It is nothing, just the extension of your conditional probability, the mathematical extension. So derivation and all that stuff will not be important, guys, for the Bayes theorem. Okay. So this was all about your probability. So if no doubts, let's discuss about the probability distribution. Okay. Probability distribution, guys, it's very, very easy to understand. Suppose you throw 100 dice, we throw a dice 100 times, right? Now I will record that how many times I'll get one, how many times I'll get two, how many times I'll get other outcomes. Okay, I'll record that. 1, 2, 3, 4, 5, 6. Now suppose you got 1 5 times, you got 2, suppose 10 times, you got 3, suppose more number of times, 25 times, or you got 4, then you got 5, then you got 6. You have just count the frequency, right? Now, when I am smoothing out this graph like this, when I'm smoothing out this histogram like this smoothing part is your probability distribution. Clear? The smoothing part of this is known as probability distribution. So it is basically finding the probability of different possible values of a variable. So here my possible values was 1, 2, 3, 4, 5, 6. So it is telling me what is the probability. So here I can see that the probability of coming 3 is the highest and probability of coming 1 and 6 is the lowest. So that's what probability distribution helps you. Clear the normal meaning of probability distribution? Yes or no? Now there are two types of probability distribution, guys. Means two types of data we are having. So because we have two types of data, we have two types of probability distribution. So I hope everybody knows what is that two type of data, discrete and continuous. You know what is the meaning of discrete and what is the meaning of continuous? Yes. So means that for discrete data, we will be using discrete probability distribution, and for continuous data, we will be using continuous probability distribution, right? So I will write here used for discrete value, used for continuous values, right? So can anybody give me the examples of discrete data? Example of discrete data. So number of students, not marks, number of students in a class, because students can be either 30 or 31. We cannot say we have 30.5 students, right? Number of students. Or we can say coin example, head or tail, or we can say dice example. We can get 1, 2, 3, 4, 5, 6. We cannot get 1.1, 2.1 like that, right? Then what will be the example of continuous? What will be the example of continuous values? Heartbeat, good, very nice. Weight or height of a student, loan amount, temperature, very nice. Loan. These are the examples of continuous value. Now, guys, I'll tell you one important thing. In reality, now we will get this histogram. You can see we will get this histogram. To achieve this curve, we use a function of probability distribution. We use a function. Okay. So when we have a discrete data, the function name is PMF, which is probability mass function. Using this function, we will plot the discrete probability distributions, right? Similarly, when we have the continuous data, the function we will use is PDF. The full form is probability density function. So using these functions, we will plot the probability distribution curve. Now we will study about different types of probability distribution, guys, we are having. So in discrete, we have binomial probability distribution, Bernoulli's, and Poisson's. Whereas in continuous, we have normal distribution. So we will discuss about these distributions one by one. So this was the flow chart of probability distributions. First, let us discuss about Bernoulli's. Bernoulli's distribution. It's very, very easy. Bernoulli's distribution means when whenever our outcome is binary, guys. Outcome is outcome of an event is binary, like real time where we can use it. Like suppose I want to find the probability that tomorrow it will be raining or not, one or zero, head or tail. Whenever we are having only two outcomes, we will be using the Bernoulli's distribution. What is the probability that you will pass in tomorrow's exam, right? But only one thing you need to note here. What you need to note here is number of trials. Suppose if I am tossing a coin and I want to find the probability of head or tail, so two events I'm having means two outcomes I'm having, that means I'll use Bernoulli's term. But number of trials will be one. Means only one time I can toss the coin. Only one time I can find it. So for this, the function is PMF. Remember, I told you about that we will use the function as PMF. So let me give you the formula of PMF, but you don't need to remember it. So don't worry. It is just a mathematical formula. You don't need to remember these formulas. So it will be either the probability will be yes or the probability will be no, where x is equals to number of trials. So the formula exactly is, don't go with the formulas. Probability mass function. This is the PMF function. Here, when we comes to real cases, do we need to find anything only one time? Means number of trials should be one. Yes or no? No, right? That's why we have the extension of this Bernoulli. We have the extension that is binomial distribution. Extension of Bernoulli's. P means probability. Here also we are having two independent outcomes like where head and tail, true, false, yes, no kind of situations. But only the difference is here number of trials will be infinite or multiple. So the formula here is, again I'm saying, no, you do not need to learn the formula. Only it is for the developers who actually creates these formulas. But a basic understanding that is required. N is equals to number of trials, X is equals to number of successes, and Q is equals to probability of 1 minus P. So difference between Bernoulli's and binomial is only one, that is number of trials. Clear? Bernoulli means one trial, binomial means multiple trials. That's it. So do not read to remember the formulas. Clear? Then let's discuss about the Poisson's distribution. Now think of a situation, guys, that you are manager of the server team in your company. Okay. Now it's a company of a call center where you get several calls, right? Now, everyone knows that if we will get calls, there will be a burden on the server if the calls are very huge, right? Now, if you are a manager of that, you should be aware about, right? What is the times when I get the highest calls in my customer care so that I can increase the load or I can uh, increase the capacity of the servers, right? Whereas, what is the time zone when I get very less calls so that I can leave the server as it is? Because the thing is, suppose the load of the server is less and you got multiple calls at that time. Your server will be overloaded and maybe it will crash also. That time we use this Poisson's distribution when we need to find the probability of a certain duration. Let's take another example. Suppose this Saturday, Sunday, you sold this many books. You want to find the probability that what will be the sales in next Saturdays and Sundays. Or you can say the arrival of emails. Getting it? So wherever you want to find the probability between a specific time duration, you will use Poisson's distribution there. A discrete distribution estimates the likelihood of an event in a given time duration. So here formula is lambda x divided by x factorial e minus lambda. So x means number of successes, lambda means mean number of successes, e means a constant value. So these were the three discrete probability distributions. So the last distribution is normal distribution, which is very important, like very important comparative to your other distributions also, and also very easy. Now see, when I will plot the distribution curve, it could come to any shape, right? The shape could be like this, or the shape could be like this, or anything else, right? But when the shape of your distribution is like this shape is known as bell curve. So if the shape of your distribution is like a bell curve, it's looking like a bell here, right? It's looking like a bell. So if the shape of the distribution is like a bell, we call it as normal distribution. So when distribution follows a bell curve, we call it as normal distribution. Only the shape, guys. Now, why this shape is so important, right? Why, if I have this specific shape, we have a type of distribution. There is some special things about this. What? The first property it has is this shape, the mean, median, and mode values will be equals to each other. Means whenever we have this shape, my three M's of statistics values will be same. The second property is it is symmetrical. It is symmetrical. Symmetrical means mirror image. Left hand side will be equals to right hand side. And the third property is a special case. Special case of this normal distribution, which is known as standard normal distribution. Now, what is the special case? So I know that in normal distribution, my values of mean, median, mode will be equal. But that could be equals to anything. That could be equals to 6, that could be equals to 10, that could be equals to 100, anything. But in standard normal distribution, that value will be always equals to 0. Means at origin. What does this mean? That if I'm talking about the normal distribution, that could be anywhere in the graph. But if I'm talking about standard normal distribution, that will only lie at the origin value. And one more, standard deviation value will be equals to 1. That's what about your normal distribution is. The function here is fx is equals to 1 by sigma under root 2 pi exponential of minus 1 by 2 x minus mu by sigma the square. This is the function. Where sigma is standard deviation, mu means mean. Now there's one last concept which is similar to this, normal distribution, which is central limit theorem. Anybody knows what is central limit theorem? It is related to this normal distribution only. Anybody knows what is it? It says that it's a like proven experimental technique, guys. It's not like we can see examples or we can see something like that. No, it is just an experimental value or experimental theorem which scientists discovered. What they discovered is like whatever the shape of the population is, The population could be of any shape. That could be this shape, that could be this shape, that could be any shape of the distribution. Central limit says that if I am taking a sample from this population and that size is greater than 30, it will, that sample will most probably follows a normal distribution. Means here sample population or sample distribution will not depend upon population. Whatever the shape of the population is, if I'm taking a sample greater than 30, it tries to or it tends to be a normal distribution. So let me define it properly so that you can even answer it. It's an important interview question as well. So you can easily answer it. It states that if we take several random samples from a population that has a finite variance, the mean of the samples tends to follow. Clear? So here your sample size should be greater than 30. That's what your central limit theorem is.
Just a quick info, guys. Intellipaat offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.
All right. So now supervised learning, if you remember, we can divide it into two types, right? One when my target variable is categorical in nature, one when my target variable is continuous in nature, right? How do we name those? What are those models within supervised learning? What will we call a model which has a continuous target variable? And what will we call a model which has a categorical target variable? So classification and regression, right? So classification will be what? Classification will be those supervised learning models where the target variable is categorical in nature. Regression will be those supervised learning models where the target variable will be continuous in nature, correct? Now, the kind of model that we are studying is a linear regression model. So when I say linear regression, can you tell me something about the kind of target variable that we will have over here? Continuous, right? So now, since the model name is linear regression, so by the name itself, you should be able to understand that this is a regression model. And if this is a regression model, this is a supervised learning model which takes into account continuous target variables, correct? Okay, so let's get started with this model. Now, linear regression, what is linear regression? Now, if you look at the name, right, linear regression. Now, what do you understand by the word linear? So linear may be a line, or maybe, so if you talk about, let's say, processes, let's say if I increase the speed of my car from 30 kilometers per hour to 60 kilometers per hour, how much distance will I be traveling in an hour? The first case, I would have been traveling 30 kilometers. In the second case, I would have been traveling 60 kilometers, right? So if you see, there is a direct relationship between, let's say, the speed of the car and the distance that it travels, right? So there are many processes in and around the world which have a linear relationship. So by linear, so see, let's assume that you study for 10 hours and you score 50 marks, right? Let's assume that if you would have studied for 20 hours, you would have scored 100 marks, right? But if you study for 40 hours, will you score more than 100 marks? No, right? The maximum cap will be 100. So maybe the number of hours you study and the marks that you get, it might or it might not be a linear relationship. But if you look at the speed that a car travels with and the distance that it will travel, right, in a fixed amount of time, this will be a linear relationship, right? If my speed is low, the distance traveled will be low. If I increase the speed, let's say 5 times, my distance traveled will also increase by a margin of 5 times. Is that correct? Okay, so if now let's try to understand what we mean by linear regression, right? Now, linear regression, it is a technique of finding the relationship between two or more variables, right? Now, change in dependent variable is associated with change in one or more independent variables. Now, before jumping into this definition, let's first try to understand what we mean by dependent variables and independent variables, right? So dependent variable is the target variable, right? The variable that is dependent upon other factors, right? So see, whenever I'm saying target variable, whenever I'm saying dependent variable, whenever I'm saying, let's say your label, right? All of these words refer to the same thing, that is your target, right? The variable that you want to predict, correct? Whenever I'm saying independent variable, I say features, I say, let's say, dimensions of the data, right? Whenever I'm talking about these things, it means that I'm talking about the features, right? So let's say if I wanted to predict the time that it takes for me to travel from point A to point B, right? And let's say I take the speed of my car as a factor, as a feature. So my feature will become the speed of the car, and my target variable or my dependent variable will become the speed of the car, right? Right. So now if we go through the definition, so linear regression is nothing but it's a technique of finding the relationship between two or more variables. So my one variable will be the target variable that I want to predict. The other variable will be the independent variable, or it can be a host of independent variables. Either you can have a single independent variable, or you can have 2, 3, 4, whatever, depending upon however independent variables you have or you need, right? So linear regression is a model which basically establishes a relationship between the target variable and the independent variables or the features that you have. Okay. Now, change in the dependent variable, whatever change we have in the dependent on the target variable is actually dependent on all the features that you have. So that is why we are including these features in the model, right? If you remember, when we were trying to predict whether it is going to rain or not, we were taking independent features such as what will be the humidity, is it cloudy or not, right? What is the temperature and things like that, right? So we know that target variable is actually related to the features that we have, and the linear regression model is a model which helps us in finding out this relationship, right? This connection between the two, right? That is what the linear regression model does. Now, if you look at the definition, it only tries to capture the linear dependencies, right? So if you have two features which are varying with each other in a linear fashion, that is, as one increases, the other also increases by the same amount. As one decreases, the other also decreases by the same amount. If you have such relationships in your data, then linear regression model will be able to go ahead and will be able to map the relationship and create a model for you, which you can go ahead and use for future predictions. All right, so let's move forward. Now, if you see, regression is a technique that displays the relationship between variable y based on the values of variable x, right? Now, if you see, there is one more notation. Now, let me just write this down. Now, whenever I say target, whenever I say dependent variable, whenever I say predictor, right? Whenever I say y, right? All of this means your target variable, right? Whenever I say features, independent variable, right? Or your, let's say, dimensions or your x, right? All of these are your features. So don't get confused by these. Target, dependent, predictor, y, all of this will generally be y. I am saying y because once when we'll be working on Python, generally the target variable we denote by the variable y, right? Generally the features we denote by the variable x, right? This is a notation. This is a general kind of a thumb rule, you can say, that we use. So that's why just don't get confused by all of these. right? Now, if you see, regression is a technique that displays the relationship between variable y based on the values of variable x, right? So if you see over here, let's say this, which is your temperature, right? Your temperature is the independent variable. The number of, when your temperature is your independent variable, that is your feature, and the number of clothes that a person needs to wear is your target variable or the dependent variable. So you can see over here that as the temperature will go down, the number of clothes that a person is, let's say, supposed to wear or wants to wear will obviously keep on going up, right? So as and when it becomes colder, maybe you start wearing more layers of clothing, right? As and when it becomes hotter, you decrease the layers of clothing, right? So if you see, both of these variables will have a linear relationship. Does this have a inverse relationship, or does it have a direct relationship, these two variables? Inverse, right? If you see, when one is decreasing, that is when temperature is decreasing, your number of clothes that you are wearing is actually going up, right? So it will be inverse relationship. Okay, so let's move on. Now, some examples, let's say temperatures versus number of cones sold at ice cream store. Now, what do you guys think? Will this have a direct relationship or an indirect relationship? These two variables, temperature and the number of ice cream cones sold. Direct, right? Why direct? Because let's say, just try to take some examples, right? Assume that the temperature is 40 degrees. Obviously, you will sell more ice creams. When the temperature is, let's say, 10 degrees, obviously ice creams will not sell as much, right? Okay. What about the second one? Do you think that there is any kind of a relationship? No relationship, right? There is no direct relationship that we can see. Maybe, let's say, there might be a certain percentage of people who might be planning to buy cars, let's say. So it's not, buying a car is not dependent upon whether it is going to rain or not, right? Maybe you are buying a car, maybe you are planning to buy a car and you decide to buy a car during the rainy season. But if you are someone who knows about cars, you will definitely not want to purchase a car during the rainy season, because then it might catch rust and things like that, right? So ideally, there is no direct relationship. There can be some hidden relationship over here, but there is no evident relationship with the inches of rain and the number of cars that are sold, right? All right. Now, the last one, daily snowfall versus number of skier visits. It will be direct. As snowfall increases, the number of skiers who are visiting will obviously increase, because more the snowfall, more people would be interested in skiing, right? Now, there are different kinds of regression model. We are studying about linear regression, right? Now, if you see, in case of linear regression model, the output that we have from the model is the equation of a straight line, right? In case of linear regression, the output will be the equation of a straight line. We also have a different kind of a model, which is known as logistic regression, right? Let's just look at the differences between these two. Now, linear regression and logistic regression, right? These are two models which might have a similar name, because if you see, both are end with regression, right? But there is a very basic difference between the two. The linear regression model is a regression model, whereas the logistic regression model, right? The name is a misnomer. It is not a regression model. It is actually a classification model, right? Why this is called a regression model, this is something that I'll talk about once when we start with logistic regression. But this is ideally, right? This is a regression model, right? Linear regression. But this, on the other hand, is a classification model, right? This is the essential difference. Now, if you see over here, this works on a target variable which is continuous in nature. Logistic regression works on a target variable which is categorical in nature. Solves the problem of regression, solves the problem of classification. Output is a straight line. The output is a S-shaped curve over here, right? Don't get worried about what logistic regression is right now. The only thing that you need to understand is that logistic regression actually comes from the linear regression model only, right? It is a slight variation of the linear regression model. That is why the name remains the same. But at the end of the day, logistic regression is a classification model. The name is a misnomer, right? Do not confuse it by, if someone asks you whether logistic regression is regression or classification, this is the only model whose name is confusing, whereas it says that it's a regression model, but ideally it's a classification model. All right, so let's move on. Okay, now moving forward, simple linear regression is useful for finding relationship between two continuous variables, right? Now, obviously the model is trying to find out relationships between the target variable and the and the features that you have. So this model will help you in establishing the relationship between, let's say, two variables or howsoever many variables you have in your data, right? One is predictor or independent variable, and the other is response or dependent variable. If you see, there are so many terms: predictor or independent variable, or you have response or dependent variable or target variable, right? Now, simple linear regression is the most simplest form of linear regression model, where we have only one independent variable and we have only, obviously the target variable will remain one, right? In case of simple linear regression, I am limited by only a single feature. Only a single feature is used to predict the target variable, right? So let's try to first understand how simple linear regression works. Once when we are able to understand that, then we will move on to the complicated model, which is multiple linear regression, wherein we will be using more than one independent variables, right? All right, so let's look at an example, right? So let me give an example from, let's say, a separate example, right? Okay, so let's assume that I have an x-axis, something like this only. Let's say I have the x-axis here, right? Let's say I have the x-axis and I have the y-axis. On the x-axis, I have my independent variable, which is the, let's say, the quantity of products bought, right? Let's say the quantity of milk purchased, right? How many units of milk someone is purchasing, right? On the y-axis, which is my dependent variable, I have the target variable, which is the overall spend, right? So this will be your, right? This is your overall spend. This is my target variable, spend. I have on my x-axis, I have the independent variable, which is quantity. Now let's assume if I start marking this, right? If I mark this, so this is 0. Let's say 1, 2, 3, 4, 5, 6, right? And let's say on the y-axis, you have your spend. So I will take, let's say I start with, this is 100. Let's say I have 90, 50, 70, 40, 30, 20, 10, and 0, right? Now, let's say I have one customer who comes in and buys one packet of milk, right? One packet of milk, and let's say a packet of milk costs 20 rupees, right? Half-liter milk costs, let's assume, let's say it costs 20 rupees. So if I want to mark this customer on this graph over here, where will I mark him or her? Quantity bought is 1. The price or the spend, overall spend that this customer has done is what? Is 20. So this cross, do you think that this cross represents the customer correctly, right? Let's say I have another customer. This customer bought 3 units of milk, right? For 3 units of milk, this customer spent, let's say, 60 rupees, correct? I have another customer who bought 2 units. This customer spent 40 rupees. Another customer who bought 4 spent 80 rupees. Another customer who bought 6, who bought 5 and spent 100 rupees, correct? Now let's assume I also have customers who actually had some existing points and they went ahead and they took some discount, right? Now let's say I have one customer who bought one packet of milk, but this customer did not spend 20. This customer spent slightly less than 20, maybe 18 rupees, right? Now let's say I have one more customer who bought 3 units of milk, but this customer paid, let's say, slightly less. And I had one more customer who bought 5 units of milk, but this customer, let's say this customer also bought membership, some kind of a membership along with the milk, and this customer paid slightly extra, right? Maybe this customer paid slightly extra, right? Now, if you look at this, can I draw a straight line that can pass through all of these points? No, right? So what is the best alternative that I have in that case? If I'm not able to draw a line that can pass through all the points, what is the best alternative for me? I have 7 points over here, right? You cannot remove the points. That is your data. So the best option is what? The best option is that I will take a line which is passing through the maximum number of points, right? So if I look at these 5 points, so the 5 customers who did not avail any kind of a discount, if I look at that, that is actually something that is giving me the general trend in my data, correct? If you look at this is actually giving me the general trend in my data. And what if I go ahead and I plot this regression line, right? Now, see, what the model will try to do is that the model will try to fit the maximum points that it can in a line. Obviously, there will be some customers who are paying extra. There will be some customers who are paying less. But if you see, for majority of the customers, this is a linear relationship. And this is what the model tries to do. All of this we'll be trying to understand later as well, right? All right. But this is exactly what linear regression model actually tries to do, that it tries to come up with a linear relationship, right, between the target variable and the independent variable. The target variable over here is the spend. The independent variable over here is the quantity of milk, correct? All right. Now, if you see, let's go through some examples of the relationships that we can have, right? Now, if you see over here, I hope this is clear to everyone. What is the independent variable? What is the dependent variable? All of you would have studied y equals to mx plus c in school, right? School, college, wherever. So a line which has a positive slope, that is such an angle, it means that there is a direct relationship, right? As in when my independent variable is increasing, the dependent variable is also increasing, correct? Examples from real life of such a relationship, just like the one that I had given to you, distance traveled and the speed of a car, that will have a positive relationship, right? Can you think of other examples as well, which might have a positive relationship? Ice cream and temperature, student score and our study, experience and salary, petrol price and tax. Yes, that will have a linear relationship. Engagement versus productivity, oil price and flight ticket, that can have a positive relation, because as the oil price increase, right, the ticket price will also increase. I hope you are able to understand this, right? So there will be some variables which will have a positive relationship, right? So this is the one that we are seeing. For the variables which have a positive relationship, the line that you have will have a positive slope, right? Or if you don't understand slope right now, don't worry. The line will be just like this, right? It will be an increasing line. As one variable is increasing, if you see, as my independent variable is increasing, the dependent variable is also increasing, correct? So now what can you say about this? This is a negative relationship, right? If you see, as my independent variable is increasing, my dependent variable's value is going down, right? How will you identify that? If you see over here, let's say I take any random point over here, right? Let's say I take a random point over here. For this value of x, the value of y will be this. If I increase the value of x, the value of y will actually go down, right? So this shows a inverse relationship between the independent variable and the target variable. What are some examples? Less trees, more temperature, speed versus time, winter and ice cream consumption, amount of fruits in market versus price. Okay, pressure versus area, price and demand, demand supply, distance covered versus fuel, marks versus spent time for studies, altitude and oxygen level, cost and demand. Demand will increase, so the cost will decrease. Demand will decrease, cost will increase. Okay, I hope all of you are able to understand this. There can be certain variables which might have a negative relationship with each other, right? All right, so let's move on. This is the same, nothing different in the slide, almost the same. Now this line, right, whatever this line you're seeing, this line is known as the line of linear regression, right? So we have talked about this earlier as well. Now let's take a look at some examples how we actually plot this line, right? So let's go through that. Now these are observations. I've explained this already, that depending upon your independent variable value and your dependent variable value, you will get some observations which we need to plot, right? Now, let's assume that this is the data that we have, right? Let's assume that I have some target variable right? Let's say if I pick some examples, right? So let's take the example of child's age and child's height, right? So let's say on my x-axis you have the age, right? And on the y-axis you have the height, correct? All right. Now let's assume that these are the actual distributions, these are the actual data points that have been distributed, right? Now there will be different children. So let's say I have a child whose age is whatever this represents, and according to that, this is the height, right? So you will have all the whatever data points. Now, can you tell me how many data points we have in this graph? How can I identify the total number of data points? Is there a way to identify that? 11, right? If you just count these dots, if you just count these circles, these are the observations. Each and every circle, right, is an actual observation, is a student. Let's assume that it is a student, right? Now, if you look at age and height, generally with age, height will increase, right? But there can be some children for whom the height increase is exponentially higher, right? And there can be some for whom the height increases, let's say, slightly lower as compared to the normal, right? Not exponentially high, but let's say if a couple of years, if let's say the age, if let's say the height increases by 6 inches, maybe there can be some children for whom it increased by 7 inches or 8 inches. Maybe there can be some for whom it increased by 4 to 5 inches only, right? Okay. But if you see the general trend, as and when my age is increasing, my general trend is saying that your height will also increase. There are outliers that are present in this data, and outliers will be present in every data, right? If you see this is an outlier, right? If you see this one is an outlier, if you see this one is an outlier, to a certain extent, the points that are far apart from this particular line are outliers, right? But then we have gone ahead and we have created this particular regression line, right? Why have we done that? What do you guys think? Now, see, obviously, in your in your real world data, right, your relationships will not be purely linear. You can estimate them as a linear relationship, but it will not be purely linear, because obviously there will be certain outliers. There will be slight variations that might be happening in the data, but that is fine, right? When I'm creating a model, I'm predicting the general range, right? I might not be able to predict for outliers, but at least for, let's say, 90% of my population, I will be able to go ahead and come up with a decent prediction value, right? See, now we will try to understand how do we arrive at this line of best fit, right? I hope you guys are able to understand what this graph is talking about. What are these data points? What is this regression line? Now, the next topic that we'll be talking about is how do we identify this regression line? Because, see, if I talk about this data, I can have n number of regression lines that can pass through this data, right? I can have, let's say this is one line. I could have had also one line which might have gone through this, right? I could have had one line which would have gone like this. Why did I go ahead and why did I create this as my final regression line? Why did I not create the other brown lines that you are able to see on the screen, right? Because the model will have the option to go ahead with n number of lines, but from those n number of lines, it will choose the best fitting line. How does it identify the best fitting line, right? How does it arrive at the equation of the best fitting line? That is something that we will try to find out now. Okay. Okay. So let's move on. Now, if you see, when we are trying to find out the line of best fit, right? Let's try to understand certain things about this, right? Let's go back to this particular graph and let's try to understand some things or how we actually work with this data, right? Now, all of these blue points, right? All of these blue points are your actual data points. If you remember, I have talked about training, and then I have talked about once when you will train the model, after that, you will go ahead, you will use the model to make predictions. So, having that thought in mind, just remember that these points that you are seeing, right? These blue points that you are seeing, these are the training data samples. Imagine that these are 11 children in your class for whom you have gone ahead and you have just taken their age and you have taken their respective heights, right? That is it. Okay. I'll just write this down once again. This is age over here and this is height over here, right? So imagine that these are your current students in your class, these 11, For them, you have gone ahead and you have plotted the age and height, right? From these data points, let's assume that you arrive at this particular best fitting line. How did we arrive at that? Don't worry about that right now. Just imagine that you arrive at this particular point, right? Now, this regression line will become your final model, right? Let's try to understand how we use this model to make predictions, right? Now, let's assume that a new student, your teacher informs that a new student is coming to your class and the age of the student is 13 years, right? Is 12 years, let's say, right? Now, 12 years on the x-axis, let's imagine that 12 years sits somewhere over here, right? 12 years is something, or let's say 12 years sits somewhere over here, right? On the x-axis. Now, as per the model, my model will go ahead and my model will make a prediction that the height of this particular student should be this, right? Let's assume that this is a point that intersects at 5 foot 4 inches, right? Let's say this on y-axis intersects at 5 foot 4 inches. All right. So what you can say is that for this student, when the age was, let's say 12 years, my model's prediction actually came out to be 5 foot 4, right? Okay. Now let's say that once when this student walks in my class, right? Once when I see this student, I realize that the height of the student, the actual height of the student is actually, let's say, over here only, right? Let's say the actual height is somewhere over here, right? So your model actually went ahead and predicted 5 foot 4, but your real height for the student, when the student walked into your class, when you saw the student, was actually, let's assume, 5 foot 6, right? So now can you calculate the error that you have? You have the actual height of the student, you have the predicted height of the student. By how many inches are we off in predicting the height of the student? 2 inches, right? If you see, if instead of doing all of this, if I would have just gone ahead and if I would have just taken this difference of the point from the line, would I have not gotten the same 2 inches value? If you see the distance of this point from this line, the vertical distance of this point from this line will give you exactly 2 inches, right? So can we say that the vertical distance of this point from this line is actually the error of the model? Not the model, but for this particular point. Now, if I ask you to go ahead and calculate the error of the entire model, or if I ask you to calculate the error of all the data points, how can you calculate that? If you go ahead and if you calculate all of these vertical distances, would that not give you the error? I will go ahead and I will calculate all of these vertical distances, right? Summation of all the distances. If I do that, will I not get the error of the model? I will, right? So let's say that the vertical distances or this error for this line, right? Let's say the error for black line comes out to be, let's say, some value, right? Let's say the error comes out to be 25. Just a random value I'm taking, right? Let's say this error is 25. Now, I'm drawing one more regression line, right? Let's say I draw one more regression line, and this line is, let's say I'll change the color. The new regression line is, let's assume this. Not the new, but let's say one more option that we had for the regression line. Let's say it was this, right? And let's say the next option was this, right? Now, if I ask you to go ahead and calculate the error of this line, right? This particular orange line from all of these points, right? This error of orange line will always be greater than this 25, right? Why? Because the black line, let's assume that this comes out to be 40. Now the black line is my best fitting line. When I say the line is a best fit line, it means that the vertical distances of all of these points from this line is the least. So any other line, you can try drawing any other lines through all of these points, and you will always realize that the error of all the rest of the lines will actually be greater than the line of best fit. And that is the reason why it is known as the line of best fit, because this is the line that is giving you the minimum error. This is giving you the minimum vertical distance of all the data points from this line, right? And that is why this is called as the line of best fit. All right. So if you see, this is what they are explaining over here. The error is what? The error is this vertical distance, right? Your estimated value was the red point, whereas let's say your actual value was this blue point. So this will be the error, right? This will be the error over here. If you go ahead and if you calculate the error of all the data points, your objective is to minimize this error. When your objective is to minimize this error, you will need to find a line of best fit, which is actually giving you the least value of this error, right? So that is what we are trying to do over here. These are some examples. Speed and distance, they have a positive relationship. Distance and speed, right? If you see, y becomes your target variable, which is distance. X becomes your independent variable, which is your speed of the vehicle. M, which is the slope, right? M is the slope, that is the angle that this line will have, right? That is your M. And C is the constant value, that is when X equals the value 0, then what will be the value of the target variable, right? So y equals to mx plus c. You can see that y is the target variable, x is the independent variable, m is the slope of the line, and c is the constant. All right. So now if let's say there is a negative relationship, let's say I take time and speed, for example. So when I will take time and speed, in that case, your y remains the same. Let's say y becomes time. My x becomes the independent variable. Over here, if you see in this example, your slope will become negative, right? As soon as the relationship of the target variable with the independent variable becomes inverse, the slope of the basically the coefficient that is involved with the independent variable will actually become negative, right? If you look at this over here, right? When my speed is, let's say 10 kilometers per hour, the time taken will be more. When my speed is, let's say 60 kilometers per hour, then the time taken will be less, right? Okay, so let's try to understand what do we mean by VIF. Now, see, VIF is, let me open. Now, VIF, do you guys know the full form of variance inflation factor? So VIF stands for variance inflation factor, right? What has been told to you why do we use VIF? What is the need of using VIF? For multicollinearity, right? What do we mean by this particular term used for multicollinearity, right? Now, what do you understand by this particular term? That is multicollinearity. So multicollinearity, right? Multicollinearity means correlation amongst the features, right? Now see, when we are talking about linear regression model, correlation between features, right? Now see, linear regression model, it says that your independent variables, right? Independent variables should be correlated to the target, correct? What it says is that let's say you have features which is spend, quantity, visits, discount that a customer has gotten, right? And then you have the target variable, that is whether the customer buys the product or not, buy or not buy, right? So these over here, if you see, these are my features, right? Spend, quantity, visits, and discount. And this is my target variable. Is everyone able to understand this? Now, what is the objective when I'm building the linear regression model? The first objective is that, the first objective is that each of these variables, right? Now, spend should be correlated to my target variable, correct? So my first requirement is that this spend should have a correlation with the target variable. Quantity should be correlated with the target variable. Visits should be correlated, and discount should be correlated, right? That is the first assumption, or that is the first rule of the linear regression model that we have. Now, the second rule says that your independent variables should not be correlated, right? This is what the second rule says over here. Independent variables should not be correlated. What does this mean? This says that I want the independent variables, or I want my features to be correlated with the target variable, but I do not want these variables to be correlated amongst themselves. Spend should not be correlated with quantity. Spend should not be correlated with visits. It should not be correlated with discounts. Similarly, quantity should not be correlated with visits or discounts, or visits should not be correlated with discounts, and vice versa, right? Now, first of all, let's try to understand why do we have this particular assumption, right? Now, let's assume that I give you two variables, right? I give you a variable which is spent in dollars, right? And I give you a variable which is spent in rupees, right? And I have the target variable, which is whether the customer will buy a product or not buy, right? Now, these two variables, do you guys think that these two variables will be correlated to each other? The spend in dollars and spend in rupees. Now, see, spend, let's say you spent 100 rupees. You can have two variables, that is the spend in rupees was and the spend in dollars was, let's say, $1.1, whatever. You can have that, right? So these variables will be what? These variables will be correlated between themselves, right? Now, what will happen if I go ahead and if I use these two variables in my model, the same effect, right? Let's say that this spend in dollars has a correlation with buy not buy of a 20%. This spend in rupees has a correlation with this buy not buy of, let's say, 20%. Now, if I'm using both the variables together, I am using the same effect twice, or I am calculating the same effect that spend in dollars and spend in rupees is giving. I am calculating that effect twice. So if, let's say, I was to predict whether the customer was buying or not buying, right? This, using these two features, I might be able to capture the same effect. Whatever information these two variables contain is exactly same. So I'm feeding similar data to my model, but it's just, I'm saying that the name of the columns is different, right? So what will happen is that if I'm passing variables which are correlated, then my prediction of the target variable will get wrong, right? Because you might be calculating the same effect more than once. If you're calculating the same effect more than once, obviously your predicted value will become way more off, right? So that is why the second assumption that we have is that your independent variables, your features should not be correlated between themselves, right? And in order to find that, the method that we use is known as VIF, that is variance inflation factor. So now let's try to understand what do we mean, like how do we apply VIF, right? First of all, do you guys know the formula for VIF? So the formula for VIF is 1 minus 1 divided by R square, right? I hope everyone remembers R square. What was R square? R square was the explained variance divided by the total variance, goodness of fit, right? Not the evaluation matrix. R square is just a, yeah, not evaluation matrix. You can say evaluation metric, right? Metric is still fine, not matrix. So the formula for VIF is 1 minus 1 upon R square, right? So let's try to, let me take one example. Let's say I go ahead and I have these features. I have the spend. I have the spend in dollars. I have the spend percentage. I have quantity, and I have quantity ratio, right? Now, or let's take only two of spend in percentage and spend rupees, right? Now here you should be able to see that your spend percentage and spend dollars will be related to each other, and your quantity and quantity ratio will be correlated to each other, correct? Now see, one simple way of dealing with highly correlated variables is what? That you go ahead and you either select one of each, right? Let's say you go ahead and not use spend dollars, or you go ahead and not use quantity ratio. You just go ahead, use spend percentage and quantity, and that's it, right? That is one way to do so. But generally, see, it might happen that spend percentage and spend, maybe 80% of the information that these two variables contain is same, but maybe there is some amount of information that spend percentage has which is extra as compared to the spend variable, right? Similarly, quantity and quantity ratio, it might be that these two variables are correlated with each other only by 80%. So meaning that only 80% information that they contain is very similar, the remaining 20% might be dissimilar. So if you're going ahead and if you are directly dropping spend dollars and quantity ratio, you might be missing out on some critical information that you might have wanted to feed to your model, right? So generally, we don't do that. We do not try to get rid of correlated variables manually. If you see that there are 2-3 variables which are such highly correlated that you're getting correlation values of 90, 95, right? 80, even greater than 80, then you can go ahead and you can exclude those. But in the real world, this will not happen. In the real world, you can have variables which are correlated by, let's say, 30, 40%. So if you get rid of one variable, the 30-40% correlation aspect that was about to get doubled, you have dropped. But the remaining 50-60% information that was new in this variable, that also you have dropped. So you might have dropped some important information from the model, right? So that is where the application of VIF actually comes into play, right? Now, if you see VIF, when we apply VIF, right, you remember, if you would be remembering what you would have realized, that they would have applied the VIF function only on your feature space. They would have not applied your VIF function on your target variable. So now, let's say what I do is that now I am assuming that one of the variables, or there are some variables in these which are highly correlated, right? So what if I do one thing, right? I take one of these variables as a target variable, right? Let's say I take spend percentage as the target, right? I take this as a target and I build a model, right? I'm just explaining to you how VIF works, right? I build a model using spend dollars, quantity, and quantity ratio. Now, just answer me one thing. If assuming that this spend percentage has variables which are correlated with itself, right? A spend dollar, quantity ratio, do you think that the R square of this model will be high or low? R square is the same metric, right, that we have talked about. If we have variables which are correlated with spend percentage, the R square of this model will be high, right? Okay. So if my R square will be high, can you tell me what my VIF value will be? VIF value will be small or large in that case? VIF will also be large, right? Because if you see 1 upon R square will be small, but if you do if you do 1 minus 1 upon R square, it will also be large, right? Deepak, it is R square, not R. Goodness of fit, we have, right? So just try to understand this thing, that if I go ahead and if I try out different combinations over here, right? Let's say the next combination that I try is spend dollars. I regress it with the remaining features, which is spend percentage, quantity ratio, right? Similarly, I take quantity, I regress it with spend percentage, spend dollar, and quantity ratio, right? And I take quantity ratio and I regress it with, let's say, spend dollars, spend percentage, and quantity, right? Now, let's assume that what happens is that the R square for this model, right? R square for this model is high. Let's assume the R square for this is medium, for this is low, and for this is also low, right? If my R square is high, correspondingly, what will happen? My VIF value will also be high, because you can see that the formula for VIF is 1 upon 1 minus R square, meaning that your VIF value will also be high, right? Here VIF will be medium, here VIF will be low, and here VIF will also be low, right? Now, out of all of these variables, which variable would you want to remove from the model? Is it the variable which has a high R square, or is it the variable which has a low R square? The variable which has a high R square, it means that it has variables which are correlated with itself, right? Because if the variables are correlated, only then your R square will be high. So what I'll do is that I will go ahead and I will exclude this first variable from my model, right? Okay. Now I will repeat this process again and again and again. I will only get rid of one variable per iteration, right? Now in the second iteration, I will be left with only these three features, right? Now with these three features, I will run the VIF code once again. If let's say I get a VIF value of high for any variable, I will exclude that. Let's say I get VIF value as low for all three. right? I will go ahead and I will use my model, or I will build my model using only these features. Now for VIF, right, the general principle is that, see, your VIF value will never be negative, right? If you look at this over here, 1 minus 1 upon r square, the formula, right? Your VIF value will always be in the range of 0 to infinity. It can go from 0 to infinity. Let's assume that your r square value is very small, right? Right, so this is the formula for VIF. Right, now if you see, if your r square will be high, that is close to 1, then 1 minus a value which is close to 1 will be a small value. If you divide that by 1, so this overall VIF will be a very large value, right? If your r square is close to 0, then your 1 minus 0 will be 1, and 1 divided by 1 will be equal to 1, right? So for those variables which are not correlated to the rest of the features, your r square will be low, and hence your VIF will be close to 0, right? Not 0, close to 1. So your VIF can range between 0 to infinity. The general rule of thumb that we have is that anything in the range of 0 to 5 VIF is considered, you can go ahead and you can accept those features. Any variables which have a VIF of in the range of 0 to 5, you can accept that. Anything which is greater than 5, right, or greater than equal to 6, right? Any variable that has a VIF value of greater than equals to 6, you have to remove that from the model, right? That is the general rule of thumb that we have. Calculate the correlation after converting categorical variables to numerical. But as I said, right, let's assume you have a couple of variables which are correlated and the correlation between them is only 50%. Now, how will you decide which feature you want to take away? Because both of the features contain 50% information which is mutual, but both of the features contain an extra 50% information that is new as well. So which feature do you decide to take away from the model? So manually, if you're trying to identify correlated features, then generally it becomes a very cumbersome process. You might get rid of an important variable in the process. When you run this, when you try to exclude variables using VIF, you are actually using a statistical approach wherein you are eliminating those features, the information for which is actually contained in the rest of features, right? So let's say if you eliminate a feature which has an high R square value with the rest of the features, meaning that when you eliminate this, no information that this feature contained is actually absent in your data. Everything is still there. Even when you go ahead and you drop this variable, whatever information that variable contained is being accounted for in some variable or the other that you have in your data, right? So that is why VIF is a more robust solution. It is a more statistically accurate solution and method, right? We'll get started with the hands-on of the linear regression model. So the case study that I have for you is a Boston house price prediction case study. We have Boston house price data. Boston is a city in the US, and for this city, we have the data of some houses that are there in this city, and we have certain factors about these houses, right? Factors such as where the house is located, how far is it from, let's say, a highway, how far is it, let's say, from a corporate center and things like that, right? And using all of this data, we will try to go ahead and we will try to predict the price of the different houses that we have, right? So that's the objective. We are working on collab. I am working on collab. You can work on anything, Mohammed Ansari. This is collab, right? So see, the only thing that is different, this is Google Colab, right? Now, most of you might be using Anaconda, Jupyter Notebooks and all, which is nothing but your locally hosted uh, Python versions, right? Now, this is a platform that is by Google. You can also use this if you have a Google Drive. If you are able to save your data on your Google Drive, you should be able to use Google Colab as well. The only thing that is different in Google Colab, now the interface is Python ID, everything is Python. Now, the one thing that is different here is that while reading the data, if you remember in your usual Jupyter, Anaconda notebooks, right? All you have to do is that you have to do a pd.read_csv, and you just have to give the path of the file, right? Wherever that file would be in your local system, you have to give that, right? Over here, because we are working through Google Drive, our data needs to be in our Google Drive. So here, if you see, this is my Google Drive. And if I go to my drive, if I go inside Collab Notebooks, Intellipaat, Weekend Batch, Linear Regression, this is where you will find my data, right? Now, if I want to read this data, I will have to set up my Google Drive. This is a predefined syntax, nothing, you don't need to change anything. You need to give permission to Collab to access the drive, right? So from google.collab, I'm importing drive and I'm mounting the drive. When I mount the drive, you will get a request to authenticate this. And once when you authenticate that, just like I would have done a minute back, you should be able to go ahead and you should be able to establish the connection. Now, if you see when I do this, this is the path of my file on my Google Drive, right? As soon as I do this, I am able to read this data, right? And that is the only difference. Other than that, every syntax that you are able to run on Python, on your Anaconda Jupyter notebooks, the same things you will be able to run here, right? It is essentially Python and nothing is different, right? It uses your Google Drive only, so your data should reside on your Google Drive. Most, I would say 70 to 80% of the corporates that you have, right, they are using either Google Colab or a similar platform. So if you will be comfortable with Colab in your resumes, in your CVs, right, you can add this as a skill as well. Generally, people are familiar with your Anaconda Python notebooks and all your locally hosted machines. But when you're working for large corporates, you're not working on locally hosted systems, right? You might be connected to GCP, you might be connected to cloud distributed computing and all. And in those cases, Collab or similar platforms are much more easy to use. Audrey content drive will remain the same. And then from here, so till content drive and my drive, everything will remain the same. Even Collab notebooks will remain the same. After that, you will have to create your folders. Wherever your data is present, you will have to add that. So we have been able to read the data, and this is how my data looks like, right? So let's first try to understand what does this data contain? What is our problem? What is the objective? Let's try to understand all of these things, right? Now, if you see over here, I have the description of all the variables, right? This is the description that we have for all the variables. Let's try to understand this. Now, see, each and every row over here in this data is the data about a particular house, right? So if you look at this, this is the data for a particular house. This is the data for maybe, let's say, some other house located in Boston. This is the data for some other house, right? Let's focus on one row. Let's focus on the first row. If I focus on the first row, the first variable that I have is what? Is the variable which is CRIM. CRIM is nothing but crime. So this variable gives you the per capita crime rate by town. So wherever your house is located, right, for that particular location, for that particular pin code, what is the crime rate? That is what the CRIM variable talks about. Okay. Second variable is ZN. ZN is what? Proportion of residential land zoned for lots over 25,000 square feet, right? Now, imagine that you are living in a sector where there are lands over 25,000 square feet, which are, let's say, uh, given to industries, or let's say given to societies, right? So Zn is a variable that actually talks about that. That is the proportion of the land in that particular area, right, that is given to, or that is zoned for lots over 25,000 square feet. Now, for over 25,000 square feet, it can mean that there is a factory that is coming up, there is a mall that is coming up, there is a society that is coming up, anything. But this is talking about the proportion of land, right? Now, an area which is, let's say, located in an industrial area, it will have a higher proportion of land which has greater than 25,000 square feet of an entire land given to one single unit, right? So if you see over here, it says 18% of the land for wherever this particular house is located is given to lots which are greater than 25,000 square feet. moving on to the third variable, Indus. Indus is proportion of non-retail business acres per town, right? So Indus will basically tell you what is the non-retail business acres in that particular area. So when I say non-retail business, once again, you can have retail specific businesses which can be there around your house, right? You can have malls, you can have a big bazaar, a Spencer, and things like that. But let's say when you start having industries, right? Let's say when you start having the shop for a footwear, right? Or let's say you start having the shop for, let's say, some other thing, maybe for a car showroom or things like that, right? So it is talking about that. It is talking about the percentage of non-retail business acres. Now you can imagine that an area which is a proper housing society, all of these percentages will be low, right? ZN and Indus and all. For a house which is located in an industrial area, or let's say for a house which is located in a corporate area, right? For those houses, all of these proportions will be high, right? Moving on to the fourth variable, it is CHAS, CHAS. It is the short form for Charles River Dummy Variable. It is a binary variable. It just says that whether or not your house is situated along the Charles River. Now, Boston as a city, it has a river that flows through it, which is the Charles River. So this is a binary variable which tells you that whether your house is situated on the banks of the river or not. Now, do you guys think that this is an important variable in predicting the price of a house, or all the variables till now do you think that these are important? These are important, right? Because a house which is situated on the on a river bank, obviously it should have a high cost. A house which has a low crime rate, it should have it should have a high cost, and so on and so forth, right? NOx is your pollution related variable. So it talks about nitric oxides concentration. So if NOx percentage will be high, then it means that this house is situated in an area where pollution is high. Maybe this house is situated next to industries, next to malls, right? And hence the pollution content might be high. So this once again talks about the uh, quality of living that you might be having if you choose this house, right? RM is the average number of rooms per dwelling. So RM is, let's say if I talk about a particular area, let's say if I talk about South Delhi, in South Delhi, let's say if I take, if on an average, each and every house, if I take the average of all the houses, the average of the rooms, let's say it comes out to be 2.5. So I'm saying that on an average, a house that is located in Saket will have 2.5 rooms. So just like that over here, your RM says, when it says 6.5, it means that the houses over here are pretty big. And on an average, they contain 6.5 rooms in this particular area. The age is proportion of owner occupied units built prior to 1940, right? Now, age is a variable which tells you about those percentage of houses in this area which were built before 1940. So in this case, it is saying that 65% of the houses in this area are historical and they were built before 1940, right? So this talks about whether the houses that are there in this area are new or old. If the houses might be old, maybe the price might be more high, or maybe it might be lesser, right? So age variable talks about that. Moving on to the DIS variable, this is the weighted distances to 5 Boston employment centers, right? DIS variable. So this gives you the, so let's say if you want to purchase a house, right? Now, if you're aware with Gurgaon, a house which might be situated closer to Cyber Hub, which is a corporate hub which has all the companies, will probably be the best option for someone who works in a company, right? So the distance, if I go ahead and if I calculate the distance of this of a given house from the 5 important corporate centers of the city, right? So this distance will give you that uh, information, that is whether this house is situated centrally, whether this house is situated close to the corporate centers, or this house is something which is maybe situated on the outskirts of the city, right? Now, RAD, the next variable, is your index of accessibility to radial highways. So just like distance was talking about the distance to corporate centers, RAD is talking about the index of accessibility. How far are the highways from this particular house, right? Is it situated inside the city, which might be far away from the highways, or is it something that is situated close to the highways that you have, right? Then tax is the full value. What would weighted mean in distance. So weighted is if you have 5 corporate centers, right? Let's say the distance from one is 5 miles, the second one is 10 miles, third is 20 miles, and so on and so forth. So you'll just take the average of that, right? Now, tax is the tax that you are paying for that particular house, right? So that is the tax amount per $10,000, right? So per $10,000, you are saying you are paying $296 for this house. PT ratio is pupil to teacher ratio, right? What do we mean by this? So PT ratio tells me that in this area, if there are 15 students, then there is one teacher, right? Now this tells you about the number of schools that you have in and around this particular area. Do you think that a PT ratio of a high PT ratio will be a good thing, or a low PT ratio will be a good thing? Low is good, right? Low means that there are more number of schools in and around your locality. So low PT ratio will actually give you tell you that this area contains more number of schools. If there are more number of schools, then obviously you have more options to put your children in, right? Then black is the percentage of black population. If you see, black will be the proportion of blacks in this town, right? So this once again, not the proportion of blacks, but count of black people per 10,000 people in total, right? So if you see 396 and all, so this is now generally in the US, if let's say a locality contains more number of black people, maybe there is a high chance of uh, let's say robberies and all, right? So maybe the price of the house might not be very high there, right? So this is talking about that. L stat is the percentage of the lower status population that is living in that particular area, right? So L stat is, if you see 4.98, so 5% population belongs to the lower status, 10% belongs to lower status, and so on and so forth, right? And then medv is the target variable that you have, that is the median value of all the houses that are there in this particular area, right? So if you look at this, medv becomes your target variable. So our objective is to go ahead and predict the medv variable. Ideally, your crime rate should be correlated to, let's say, the proportion of, or the black variable, or maybe the lower status variable as well. So this is something that we can check once when we are checking the correlation matrix. So Saurabh, if PT ratio is high, it means that there are low number of schools. If there are low number of schools, then see, when you go to buy a house, right? The important factors are what? That your house should be close to highways, your house should be close to malls, your house should be close to schools, hospitals, and all, right? So if it is high, it means that schools, there are not many schools which are around there. So probably the price of the house can be low, right? All right. So this is the data that we have, and the target variable that we have over here is medv. So let's move forward then. So this is, I have done a data dot head over here. So these are the top 5 rows. I also have a function which is known as data dot tail, right? Tail, what it will do is that it will show you the last 5-10 rows. If you don't give any value, it will automatically show you the last 5 rows. If you want to, let's say, see the last 10 rows, you go ahead and you give a 10, and it will show you the last 10 rows. Correct? So now from here, we can see that there are 505 rows over here in this data in total. Okay. Let's look at the shape of the data. We'll do some basic data exploration now. So my shape of the data is I have 516, I have 506 rows and I have 14 columns, right? I will describe my data. Let's go ahead and describe this data. What does this dot T do? Any idea? Transpose, right? So I've just done this for ease of readability. If you do it like this, when you have more number of variables, right? This can, you'll have to scroll towards the right, right? So if I just transpose this, it becomes easy to view. So that's why I've transposed this, right? Why do we use this describe function? What do you think is the use of this? Let me go through the common answers now. So first of all, I had insights on crime rate and ZN, right? If you see crime rate, there are areas wherein the crime rate is close to 89%, right? Meaning that these are very unsafe areas. So within Boston City, you have areas wherein the crime rate is as low as 0%, and you also have areas where the crime rate is as high as 89%, right? Similarly, if you look at ZN, there are certain areas in this city where the entire 100% of the land is actually zoned out to lots greater than 25,000 square feet, right? Then in age, average age is 68, 75, 94, 75 people. Understanding of this variable is incorrect, but yeah, the insights that you have extracted are good. Blacks are nearly equally distributed, right? If you look at this variable, even the 25th percentile for black is 375, 50th percentile is 391, 75th is 396, max is 396, right? So if you look at the black variable, right, it generally, the proportion of blacks per 10,000 people in the city is in the range of 370 to 390, right? So that was a good insight. Chas has low accuracy. Chas will not have accuracy. Is a binary variable, but I think what you're talking about makes sense. If you see, there are only 7%, close to 6.9% of the houses which are situated along the Charles River, right? Zn, if you see, the max value of Zn is what? 100%, right? 100% means that this variable was giving you the percentage of houses, or sorry, the percentages of the total land which was zoned out to greater than 25,000 lots, right? So there are areas wherein there are locations in the city wherein there are all the land that is zoned out is greater than 25,000 square feet. No land is less than 25,000 square feet. So maybe this is an area which contains of industries. Maybe this is an area which contains of farmhouses only, right? So that's what your ZN is talking about. All right. So all good points. I just wanted to ensure that now see, apart from these insights, the describe function also comes in to be very useful as a sanity check of your data, right? Now let's assume over here I had an age variable. Now our age variable means something else, but let's assume I had the age of customers, right? Now let's say you go ahead and look at the minimum and maximum value, and you're seeing that the minimum value is coming out to be 0 and the maximum is coming out to be 200. Then obviously you have to go back and you have to question your data team that how can age be 200? How can age be greater than 80, 90? How can age be less than, let's say, 10, 11, 18 years, right? Whatever your minimum age might be. So your describe function, it helps you in understanding your data, but it also helps you in identifying anomalies, identifying outliers that might be present in the data, right? All right. So let's go ahead and do some basic visualization. First thing that we need to do is that we need to start with the visualization of the target variable. What is a target variable over here? A target variable is medv, which is a numerical variable, which is a continuous variable. So I go ahead and I import cbond as SNS and I call the dist plot function, right? This will be the distribution plot. This is the histogram, and this is what I can see, right? What do you guys think? Is this a normally distributed data, or it has some amount of skewness? Or looking at this data, anything that you can make out, any insights that you can think of? Not left skewed, right skewed. It has a tail towards the right, right? Right skewed, but if you see towards the end, there is a very high percentage over here, right? So there are houses which are very expensive and there are lots of people who are buying these houses. So if you look at this, right, this is actually true because let's say if you focus on cities like Delhi, Mumbai and all, maybe mediocre people like us, we might be able to afford a house in the range of 50 lakhs, 1 crore, maybe 1.5 at the max. But then there will be, let's say, people who are rich, people who are businessmen, people who have been living in the city. Their generations would have been in this in the city for years, and these are people who have huge amounts of money, and this will also contribute a significant percentage, right? And these are people who are living in, let's say, villas and farmhouses and all, and hence you can see that for your extremely expensive houses as well, there is a good percentage of distribution that I can see over here in this data, right? So this looks like that this actually looks like real world data because most of your data is populated towards the left hand side, meaning this focuses on your let's say people who are below average, or let's say mediocre families, maybe average families, right? Most of the people in a city will be like this. Then if you move from here, right, if you move to 30 till 48 onwards, this percentage will be less, because as and when the price keeps on increasing, the amount of people who are buying those houses obviously goes on decreasing, right? But then there will come a point wherein you are going to reach to the audience which is super rich. The super rich audience, they don't care, right? Even if a house is priced at 50 crore, they have the potential to go ahead and buy it. And that's what we are able to see over here, right? So looks good. I think this is something that tells us about how real world interaction also happens, right? How you identified Medvi as the target column? I know that Medvi is the target, how I have created this case study. Now, if you want, you can use any other target variable as well, right? But because I know that all of these variables will be correlated to the price of a house, I have taken Medvi as the target. You see, you do not identify Medvi as a target variable. Uh, you take a business problem and you convert that to a mathematical problem. If your business comes to you and they say that I want you to predict the spend of the customer, and they give you 20 features, will you identify the target variable, or do you already know the target variable? Your target variable, you know that it is the spend of customers, right? Now you will try to collect data which is correlated with spend. This case study is a case study which aims on predicting the price of a house, right? So that's why your medv is the target variable. Aishwarya, go back to the basics of your distributions, visualization and all. This is right skewed because this has a tail towards the right hand side. All of this is basic stuff. This is a normal distribution, right, with no skew. This will be a normal distribution which is skewed towards the right hand side, or positive skew. This will be a normal distribution with a negative or a left hand skewness, right? Left side skew. All right. Now, like this, you can go ahead and you can plot all the rest of the columns as well, one by one. I will not be doing that. But you can see that this is the distance variable. Now for the distance variable, this was the distance from highways. So you can see that most of the houses that you have are actually situated very close to the highways in the city. But then there is certain percentage of houses that you have which are actually situated very far apart from the highways, right? So just like this, you can go ahead and you can visualize it for all the variables one by one. But this is an EDA that you can do. Now let's try to clean this data slightly. Let's see. See, either you can check if the data has dropped, if the data has duplicates or not, or you can just directly go ahead and drop the duplicates, right? So what I'm doing is that directly, I'm not checking if there would have been any duplicates in the data, they will be automatically dropped, right? So you do not need to worry about whether there are duplicates or not. Just go ahead and add this condition, drop duplicates, and it will automatically drop your duplicates from the data, right? Now I'll go ahead and I'll check the information on this data. What this will talk about is if there are any missing values in the data or not, and the data type, right? So there are no missing values. All the variables have exactly 506 values populated, and the data type is either float or int, right? So there are no categorical values over here. All the variables are either integer or float. Now let's go ahead and let's check for correlation of all these variables with respect to our target variable, which is medv, right? So what I do is that I go ahead and I call the correlation function, and I limit the output to only the medv variable. So if you see, this output tells you about the correlation of each and every variable with your target variable, right? I want you to go through each and every variable and check if there are any null values. We have checked that over here, right? It says that there are 506 values populated in each and every column, and there were 506 values in my data in total. So means that there are no null values. What is the difference between dist plot, hist plot? Both seems to be histogram. So there is not a very big difference. See, dist plot and hist plot. Hist plot is the histogram directly. Dist plot in case of displot, right, you can also have a distribution along with this. There are certain parameters that we have. I don't remember. Just let me check. So, win range. There was one parameter which is different in his plot. I'm just trying to find that out. Otherwise, there is no difference between his plot and dist plot as well. Okay, so this is his plot, right? This was this plot. So let's look at this. Yeah, so here I think you can also play around with the kind, right? So kind, if I give as, let's say, there are options which I can give. I'm not sure what options are there. But in the kind, actually, you can change this histogram to a kernel density estimation as well, I think. Let's try KDE. Yeah, so if you see KDE, yes, kind equals to KDE. Disk plot, we have options. If you go ahead and if you can convert this to a distribution plot as well, right? If you want to plot a histogram, you go ahead with the standard option, or you can mention this over here. Let's come to this correlation. Now, I want you to go through these correlation values and see if they are making sense, right? I'll give you one example. So if you look at this over here, my crime rate has a negative correlation with MEDV, telling me that if crime is higher, then the price of the house will be low and vice versa. And this is something that makes sense, right? This is something that is expected. Now, just go through each and every variable one by one and see if all of the variables are, or the sign of the correlation matrix for all of the variable is making sense or not. Okay, just do this once. It does not mean that. It means that houses which are situated next to the river have a higher price. More number of rooms, obviously more the price of the house will be high. So for the black one, the correlation looks out to be counterintuitive, right? That is where there are more number of blacks, the price of the house is high, right? Now, see, this is something that you can see. Ideally, you will have assumptions about the data. Now, Boston as a city might not be that much affected by, let's say, blacks in a negative way, right? So this is what our data is telling me. So although the correlation value looks out to be counterintuitive, ideally from a normal point of view, maybe if there are more number of blacks, then the crime rate should be high and all. But as you see in our data, for 10,000 people living in an area, there are only blacks in the range of 350 to 400, which is what? Which is only 40 4% or 0.4% of the population, right? Just 0.4%. So that's a very low value. So hence, over MEDV has a negative correlation with tax. So that means that if tax will be higher, the price of the house will be lower. So maybe the tax structure in Boston would be such that the more that you are paying, right? So see, generally in certain US cities, the flat structure, the tax structure is flat. Even if you buy, let's say, a house of, let's say, $1 lakh, you are paying, let's say, 10,000 as a tax. Even if you buy a house of $5 lakh, you are paying the same 10,000 as a tax, right? So maybe they have a flat structure for tax. That is why we are seeing a negative correlation. So LSTAT is negative, right? So LSTAT says that lower status population. So the lesser lower status population, the higher the price, and vice versa. RAD is negative, meaning that houses which are situated close to the radial highways, their prices are less. Houses which are situated far apart from the radial houses, their prices are more. Maybe this is indicates on the fact that people do not want to live near busy highways where it can be noisy, where maybe the pollution can be high. So people in Boston, they prefer living in areas which are slightly far apart from the highways, so that they have more peaceful and quiet living, right? So as I said, we are done with the EDA, right? So this was a concise EDA. But ideally, you should go ahead and you should look at all the different variables, visualize the variables univariate, bivariate. That is something that you can do on your own time. Need to do is that we need to divide our data into our features. that is independent variables, and the dependent variable, that is the target variable, right? So what we will do over here is that at first, what I'm doing is that I will only take the highly correlated variable, right? So first, what I'll do is that I'm using, let's take the most highly correlated variable, which is LStat, right? So I'll take LStat over here as my independent variable. I'm not starting with a multi-linear regression model as of now. As a first step, I'm just starting with your single model, simple linear regression, wherein we will have one single variable and one target variable, right? And for that, I am picking the most highly correlated variable. If you look at this over here, your L stat is a variable which has the highest correlation, right? Followed by RM, and then there are other variables as well. So I'm just taking L stat as a variable and then medv as the target variable. Now, if you think about, let's say, if you have to eliminate 50 variables, you will be running this loop 50 times. So that is, if you have 100 variables in the first iteration, 99 in the second, 98 in the third. So you can do the maths that. So as a first step, what we are doing is that we are building a model using only one single independent variable, which is LStat, followed by the target variable, which is medv. If you look at this becomes my data. X is my feature and Y is my target variable. Okay. All right. So what is it that we need to do next? We will look at the size of both X and Y. My X contains 506 elements, Y contains 506 elements. Next thing that we need to do is that we need to divide our data into training and testing. Why do we need to divide our data into training and testing? Then what is test for and to test, right? So train data will be used for training the model. Test data will be used for testing the model's performance, and this will tell us whether the model is overfitting, underfitting, whatever, right? So I can create a model which is giving me a 90% accuracy on training data, but that will not be useful unless if I have a similar accuracy on the testing data, right? So for that, we are using train test split. Train test split is a function, right, which needs input. You pass any data as an input to this model. Over here, I'm passing my X and Y. I pass a test size parameter mark at 0.2. 0.2 meaning that 20% of your rows are going to go in your testing data, right? So for 506, 20% close to 100 rows will be going into your testing data, right? Now, random state equals to 23. What this hyperparameter does is that, so let me explain this to you through an example. Now, let's say I run this. Let's take away the random state variable. I will run this and I will show you what Explain contains, right? Just look at the index of Explain values. I will run this once again, right? And I will plot Explain once again. Now compare this Explain with this Explain. Do you see the indexes to be same or different? Different, right? So if you do not specify any random state, then what will happen is that each and every time random values will be going into training and testing, right? Now random state you can specify as any value, right? Now let's say if I go ahead and specify this as 20, I go ahead and I run Extrain, right? 7, 268, 80. I will run this once again and I will show you what Explain looks like once again, and you can see that the exactly same indexes are going into your trained data each and every time. Why do we need to do this? We need to do this because let's say you run your model once without using random state and you get an accuracy of, let's say, 70%. Now let's say you run the same model in front of your senior and this time you get an accuracy of 68%. Now they will come to you and they will say that why you were saying that it was 70, why is it 68, right? So if you want to replicate the same outputs each and every time, then you should be using a random state value. It can be anything, Kaushik, it can be any random number. As long as you are taking the same random number each and every time, it does not matter. It will select the same number of rows. Test size is for the test data. 20% is the testing data size. If you look at this test size, if you look at the shape as well of our data, our X train contains 400 rows, X test contains 100 rows. So 80% is for training and 20% is for testing. And then we go ahead and we build our model. In order to build our model, I have my training data, I have my testing data. I will import the model from sklearn library, sklearn dot linear model. I import linear regression. I instantiate the model object linear regression in a variable named as regressor. I do a regressor dot fit. When I do a dot fit, it will train the model, because here I'm passing the training data, that is X train and Y train, right? If I run this, now your model training is complete, right? If you look at this, the model training is done. It can be 70-30, it can be 80-20. As in, when we proceed during this course, I will be talking about instances when it can be, let's say, 70-30, when it should be 50-50, right? But as of now, for 90 to 95% of the use cases, 70-30, 80-20, anything between this will work fine. Fit means that, yes, as soon as you fit it, it will go ahead and give you the coefficients for the best fitting line, right? So now, once when the model has been trained, you can see that I can go ahead and I can find out things such as the intercept value. Intercept was what? It was the constant. And I can find out the coefficient of the model. Now, because I have one single feature, this will become my coefficient. So if you look at this, my equation has actually become medv is equal to 34.927 minus 0.966 multiplied by lstat. Lstat was the variable, right? Yeah. So now from here, you can see that the equation of my linear regression model, the equation from the best fitting line is coming out to be this, right? Because my intercept was the constant, that is 34.927, and my coefficient corresponding to the single variable, which is lstat, is coming out to be 0.966, right? So this becomes my equation. Although you don't need to use it manually, you will still be able to arrive at this equation, right? Usually you will take more data points on training and a decent size on testing. Now that the model training has been done, what do we need to do? We need to make predictions on our testing data, right? So I will go ahead and I will use the same model object, that is regressor. And this time I use the predict function. For training my model, I had used my fit function. For predicting using the same model, that is the same line of best fit which we have gotten, I use a predict function. I do a regressor.predict and I pass my testing data. And whatever values I get, I save it in a variable known as ypred, right? Now ypred, I just convert this to a data frame. If you look at this over here, if I show you ypred, this will be an array, right? Now these are your 104 values of your testing data, 104 predicted values of your testing data, right? So we go ahead and we convert this to a data frame. This is the predicted output. You have created a model to get predictions, right? So this is the predicted output that you are getting. Now, what do we need to do in order to check the performance of the model? We need to compare these predicted values with the real values, right? Actual values. So what I'll do is that I'm converting this to a data frame first of all, right? This array has been converted to a data frame using pd.dataframe function. I pass the array and I pass the column name as predicted, right? To this array, I will append my actual values as well. If you look at this, y test was my actual values, right? These were my actual 102 values. So what I'll do now is that I will add both the actual and the predicted to a data frame known as df underscore pred, right? And I'm just doing some resetting, right? My actual becomes my test data and my predicted becomes my ypred. Because both of these were data frames, I'm just resetting the index, because if you see over here, these have different values. I want the index to have these values 0, 1, 2, 3 till 101, right? And this becomes my actual versus predicted. Now, can you go ahead and can you calculate the error, different kinds of errors? First of all, before going ahead and calculating the different errors, just having a look at this, do you think that the predictions are somewhat close to the actual values, or they are far apart, or they are, let's say, decently apart? right? So for some cases it is close, for some it is off. If you look at this over here, actual was 21, model is predicting 14. Here 13 and 12 very close. Here 18.9, 18, 13, 16, right? So how can we check the overall performance of the model? We can calculate our error metrics. Now, either you can calculate the error over here in the data frame. So what will be the error? If I go ahead and if I calculate just the error, right, it will be actual minus predicted. So you can calculate it either like this, right? Or you can go ahead and you can see, this is a messy way of doing things. Functions in Python, right? From sklearn I import metrics, and this metrics will contain all the different kinds of errors that there are. So if you look at this, it has mean absolute error, it has mean squared error, it has your root mean square error. Anything that you need, it will go ahead and it will give you that. So if you see, what I'm doing is that I'm calling all of these functions one by one, and I'm passing my actual and the predicted values here. If I run this, this will give me the overall error of the model, right? If you see, your mean absolute error is 4.5. What does this tell you? That on an average, your predictions are off by a value of 4. So 4 over here is nothing but $4,000, right? So your predictions are off by close to $4,000, right? So we are using the actual function. sklearn is a library which contains all of these models. Okay. Now mean squared error is 35. Because this is a squared error, the unit will not be same. If you take the root of mean squared error, that will be RMSE, that is 5.8, 5.9, right? I can also calculate something known as mean absolute percentage error. So let's see. So if you see mean absolute percentage error, if I pass the same y test and y pred, I will get on an average, my predictions are off by what percentage, right? So if you look at this, so it says that on an average, my predictions are off by 21%, right? So the model is doing a decent job. It is not doing a very good job. But why is that happening? Because I'm using only one single feature, right? If you see over here, I'm using only one feature, which is LSTAT, and using only one feature, I am still able to create a model which is giving me a percentage error of around 21% only. So obviously, if I increase the number of features, my model accuracy or my model error should decrease, right? Okay, let's try to get the R square score, R square. For R square as well, sklearn.metrics, it has a function which is R square score. All we need to do is that we need to pass y test, y pred and all, and it will give me the R square score. What is the R square score coming out to be? 44%, right? Meaning that these three variables, sorry, this one variable is only able to capture 44% of the variation of your target variable. Features will be significant. You will get more accuracy. Not aware of these errors. I think this should have been completed in your. Okay, so let's assume that these are your actual and predicted values. So what will be your absolute error? Absolute error is what? It will be doesn't matter what the sign of the error is. You're just taking a difference of actual minus predicted, right? This will be the actual error that we have. If I take the average of this, that will be what? That will be mean absolute error, right? So this will be MAE. Okay. If I take the average of my actual values, all the actuals, and then I just calculate a percentage, right? That is error divided by the actual average of actual. This will give me mean absolute percentage error. Because here, if you see, I'm converting this error to a percentage with respect to my actual average. Okay. Now there is also something known as MSE. MSE is what? MAPE is percentage error. This 4.86, what percentage is that of your total average of actual value? If you calculate the percentage, this is 4.86 divided by 36 is what? Is around 14%. Now we have something known as mean squared error. Over here, what we do is that we take the square of the error first, right? So if this was my error, I'll do this into the same value, right? Okay. And then if I take an average of this will become your mean square error, right? This will become your MSE. This is the squared error. And if you take a root of this, if you take a under root of this, that will become your RMSE, root mean square error. Why root mean square error? The logic of root mean square error is that the values which are more away, the predicted values which are more far apart than the actual, you want to penalize them more. If you look at this over here, this absolute error squared becomes 1. Square of 0 becomes 0, but the square of 9 becomes 81. So it means that you are giving more weightage, or you are penalizing those data points more, which are far apart from the actual value. All right. So these are your standard errors and how they are calculated. You have the actual value is the actual value, right? You will have the actual value for the data, whatever your target variable will be. Right now, my R square is coming out to be 44.4%. So now what can we do next? Next, let's do one thing, right? I will add the second highest correlated variable, and ideally through the assumption, my R square should increase, my errors should decrease, correct? Does that make sense? So what I'll do is that over here only, right? I will repeat the same process, and I will add one more variable, which is RM to this. I hope that makes sense. So here what I'll do is that I will add the RM feature as well, because RM you can see is the next variable which has close to 70% correlation, right? So let's add RM and LSTAT. Now my features become two, LSTAT and RM. Target variable remains the same. I divide my data once again into training and testing. You can see that now the shape of your training data becomes 404, 2. Why? Because now you have two variables. I fit the same model. This time in the model, I will get one intercept value as usual, but I will get two coefficients, right? If you look at this, I am getting two coefficients. My equation will be what? My final equation will be equation that we'll get from this model. What will be the equation? Med V equals to, give me the values, right? You're able to see the values of coefficients. My intercept is 0.24, coefficient is 66 and 4.98. So it will be minus 0.24. That's my coefficient. Minus 0.66 into LSTAT, because that was my first variable, plus 4.98 into your RM variable, right? Now here, if you see, the signs are actually telling you whether the variable has a positive influence or a negative influence on your target variable. You see, my lower status variable, because it was negatively correlated with the target variable, it has a negative coefficient over here, meaning that when the value of lower status will decrease by 0.66, your med V, that is the price of your house, is going to increase by $1,000. If you look at this, when you are going to add one room to a house, the price of your house is going to increase by $5,000, right? All right. So now let's go ahead and let's check the performance of this new model, right? So let's get the predictions. So these are the new predictions. I will once again do the same things. I will convert this to a data frame. I will take my Y test. I will calculate the overall data frame, right? Now here you can see that this prediction, which was way more off earlier, we were getting a value of somewhere around 20, right? Now I'm getting a much more closer value, right? Let's look at these errors, although this is just the overall error. I'll calculate now in a new line, I will calculate the new errors, right? Now I want you to compare the errors from above to below, right? This one was the errors when I used only one single variable. These are the errors when I use two variables. Do you see for each and every error metric, do you see the error value going down? And if I go ahead and if I print the R square score now, can you see that the R square score has also increased from 44 to 58, right? So we can see that as in when we are adding more variables, my overall model performance is actually increasing, right? So now what I'll do is that I'll straight away go ahead and I will use all the variables, right? Directly, right? I'll be using all the variables and we will go ahead and we'll see how our model is performing, right? I'll read the data once again because we have transformed some of the data. We have dropped some variables. So I'm reading the data once again. This is the same data. So what I'm doing is that I'm selecting all the features, but the last one as my X, that is the independent variables. I am selecting only the last feature as my target variable. So if you see Y is my target variable, which is med V, and I proceed with the same steps. I split my data into 20% testing and 80% training. So the exact same values that we had. And there is nothing from a coding point of view, you can see that nothing changes, right? All you have to do is that you have to change the data and your model will automatically adapt. Now, if I'm passing all the features, I'm still passing the same model, calling the same model, nothing has changed, right? So if you see over here, I fit my model linear regression, but this time I will be getting many coefficients. Why do I get so many coefficients this time? My intercept will remain the same. Intercept will be the single value only, but I am getting these, right? Exactly, because we have so many features. So for each and every feature, I am getting a coefficient value. So let's go ahead and let's see what are the coefficients for the different features that we have. So what I do is that I create a data frame of my coefficient values. I create a data frame of my column names, right? And what I'll do is that I'll combine both of these data frames together to get these into one column, right? So I do a pd.concat. I concatenate these two and I get this data frame, which basically tells me that the attribute is crim and the coefficient is this. The attribute is Zn and the coefficient is this. Now you can do a very quick sense check that whether the signs of these variables is actually in line with the correlation. You see NOx, this was negatively correlated with my target variable. That is higher the pollution, lower the price. That is why the sign of this variable is coming out to be minus, right? You look at, let's say, anything else, maybe let's say Chas. So if a house is situated next to the Charles River, then the price will be high. Hence, it is positively correlated. Hence, the sign is positive. We go ahead and now we take the same model and make predictions. I do a regressor.predict using my testing data and I get my predicted values. And then I'll follow the same process. I have my actual values and I have my predicted values. I calculate the error of my model. And now, if you remember previously, let me show you the error from the last values. From the last model, it was 4.09, 26, and 5.17, right? And now it is coming as 3.2, 20, and 4.5, right? So you can see that the errors have actually reduced even more. If I look at the R square score now, you can see that the R square score has also increased to 73%, right? Talking about a new model, right? Logistic regression. If you remember when we started, when we were going through the introduction, uh, if I talk about, let's say, machine learning, right? Machine learning as a whole, I can go ahead and I can divide machine learning into what two buckets? Does anyone remember? We have two broad buckets, right? What are those? So supervised and unsupervised, right? So those who are saying regression and classification, that is before that you will have supervised learning and you will have unsupervised learning, right? I hope everyone remembers this. Then if we double click on supervised learning, this is something that we can break down into regression and classification, correct? Within supervised, you will have regression kind of models and you will have classification kinds of models. But can we go ahead and can we use a linear regression model for problems such as, will the property have a good neighborhood? Will it rain tomorrow or not? Is the email spam or not? No, right? We cannot use the linear regression model for these cases, right? I cannot use the regression model over here. I cannot use it over here. I cannot use it over here, right? Then in that case, what do we need to do? We need to move on to some other model, right? So if we have a classification problem, that is my target variable is categorical in nature, we need to go ahead and we need to apply logistic regression model, right? So the objective of all of these 12 slides was only to lay the foundation of logistic regression and what kind of questions logistic regression will be able to. All right. Now this is again the same thing. Machine learning can be divided into supervised, unsupervised, right? Just go through this. I hope everyone is able to understand this. So let's move on. Now, before getting started with logistic regression, let's try to understand some basics, right? All right. So guys, I want volunteers from you all only, right? I want to collect some data, right? Name, age, and target, that is working or student, right? I want 10 samples over here, right? I want you guys to start giving me details, right? Whether you're a student or you're working, okay? Just one by one. Charan is 23 and Charan is a student, right? Then we have Satyam. Satyam is also 23 and Satyam is also a student. Then we have Rishabh. Rishabh is 28 and working. Then we have Harshit, 31, working. Then we have Mohan, 25. I'll see how many I'm able to accommodate. I'll take all those. We have Jaya is 23 and Jaya is working, right? Itin 28 working. Itin 28 working and Vidya 23 working. Okay. 1 second, let's see how many we have. Gaurav 25 working. Then we have Audrey 33 student. Then we have Praneeth 21 student. I'll take some student examples now. Nandini 81 student, right? All right, so I'll stop here only, or let's take one more. This is the data that we have, right? We have around 12 data points, right? Now let's try to plot this data. What will we have on my, what will I have on my x-axis? What will I have on my y-axis? If I start plotting this data. So let's say on the x-axis I have age, right? And on the y-axis I have the target, that is, let's say, status, right? I'll just write it as status. I'll start my age from 18. I think we have the minimum age as 18, right? So 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 41, 42, 40, right? I think 33 is the maximum that I have in my data as well, right? Yes. Okay. And then how will I plot my target variable over here? So my x-axis is fine. I am able to plot that. How do you guys, my target is what? My target is categorical in nature, right? So how can I plot that? So see, in Python, obviously, we will convert that into labels. Maybe 0 means that a person is a student. 1 means that a person is working, right? Over here, I'm just writing down the label over here, right? Just for our convenience. I'm just saying that if it is this particular, I'll just give the line. this is a student and this is, let's say, working, right? So I'll draw two horizontal lines which will just tell me whether the person is working or whether the person is a student. Does this make sense? They're just two lines wherever a person will be working. So I'll just give you one example. Let's start from the smallest, that is Nandini, right? The youngest in our batch or in this example. So we have Nandini. Where will we plot her name? She is 18 and she is a student. So I need to mark Nandini over here, right? Does this make sense? X-axis is on 18 and the Y-axis is on student, right? Now let's move to the next person. After 18, we have Praneeth, who is 21, right? Do we have anyone else in the range? No, right? So Praneeth is 21 and Praneeth is also a student. Then we have 23, we have 3 people, right? Or 4 people. So 23 is interesting, correct? So if you look at 23, at 23, we have, we'll start from the top. We have Charan, who is a student, right? Then we have Satyam, who is also a student. So I will just give 2 crosses over here, right? Slightly above. Okay. Then we have Jaya and we have Vidya, both of whom are working, correct? So for Jaya and Vidya, we will have 2 marks over here, right? So this I will just mark slightly above so that you are able to see. Then who's next? After 23, we have 25, right? We have Mohan, who is 25 and who is working. So this is Mohan. Then we have after 25, what do we have? We have Gaurav as well, who is working. Yes. So we have Gaurav at 25 who is working. Then who's next? 28, right? We have 2 people who are 28, Rishabh and Nitin. And Rishabh and Nitin both are working. So we'll have 2 crosses here, correct? Just let me know if I'm missing out someone. 28 is done. Then we have 31, Harshit, right? Who is working. And then we have Audrey, who's 33 and who's a student, correct? So Audrey will be over here. I think we are done, right? We have 5 over here. So 4 and 5 over here. All right, yes, 6 and 7 over here, right? 12 are done. Okay. So this is how our data looks like, right? Correct? Now, all of you know how linear regression model works, right? If let's say, can you try, first of all, can you try fitting a line of best fit which will cross through all of these data points or which will be closer to all of these data points? Or let's try to apply the linear regression model using the mathematics that we have understood. What will the model try to do over here? See, you can still apply the linear regression model over here, but the how how will you try to get the best fitting line is the question, right? Now see, if I try to, let's say, fit a line which passes through all of these data points or which is, let's say, closest, what I will get as an output will be something like this, right? Because if you have a line which is something like this, then what will happen is that if you calculate the vertical distances, right, the vertical distances will be somewhat the minimum in for this particular line, correct, right? Let's assume that we went ahead. Let's say that we actually went ahead with a linear regression model. Now, can you tell me what will my line predict between student and working? So this student, let's say this student is signified by 0, right? By the label 0, and this working is signified by the label 1, right? Let's say this is what we get, right? Now, my linear regression model will say that for someone, so let's say I take this example 31, right? For someone whose age is 31, my linear regression model will say that the output is this, right? This might be the value, let's say 0.8. But what is 0.8? Is 0.8 a label that we have given? No, right? It is nothing. So it is near to working, but See, 0 and 1 over here are labels. I'm saying that 0 is a student and 1 is working. But my linear regression model is giving me a value which is somewhere in the center. So how do I know what 0.8 is? It is close to working, that is fine. But then that is not the correct value, right? So do you guys think that linear regression model, first of all, this is the linear regression model is not appropriate over here because one single line cannot fit through all of these data points, right? Second point is that even if I go ahead and even if I apply the linear regression model over here, I'm not, if you go ahead and if you run the model in Python, it will work. But the predictions that you will get from the model, do you think that the predictions will be correct? In this case, you cannot say that as a probability, right? Probability is something else, right? This is just a linear value. You can still, so the best interpretation will be that this value is close to 1. So it means that the probability of, let's say, this person working will be slightly higher. You can say that. But this 0.8 is not a probability that you're getting. Correct? Ordinary linear and logistic both can work with more than one variables, right? I'm just giving an example with one single variable because that is easy to understand and explain. But both of these models can work with multiple independent variables, right? Independent features is not a problem. Now, let's say that what if I went ahead, and I changed this output to, let me change the color. Let's say I went ahead and I changed this output to a curve which looked like this, not like this, sorry, to an S-shaped curve, right? Something, just imagine that this is a smooth curve, but something like this. What if I went ahead and I told you that this is I'm not fitting the line of best fit, but I'm fitting a curve of best fit, right? An S-shaped curve. If you look at this looks like an S-shaped curve, not exactly an S over here. But what if I get this? Will this fit our data points? Most of our data points, there is one data point which we are not able to fit, obviously. But the general data points that we have, the data points which are depicting the general trend in your data, if I go ahead and if I use this curve, do you think that it will fit the data points much clear? I will add one more data point. This is a random person, right? XYZ. And this person's age is also 23, right? And they are also working, let's assume, right? So I have added one more data point with 23, and this person is also working, right? Just to support this example slightly more. So let's assume I have one more data point over here, right? Now you have 3 points which are saying that at 23 you are working, and you have 2 points which are saying that at 23 you are a student, right? Now if I go ahead and if I try fitting a curve of best fit, right? Maybe I get an output which looks like this, right? Right? And this, if you see, this is an S-shaped curve. Now, at 23, we had 5 instances. We have 5 now. 3 people at 23 are working. 2 people at 23 are students, right? So what my model has done, so what this S-shaped curve has done is that using all the other rest of the data points. Now at 23, it has realized that the probability at 23 to be working is slightly higher as compared to be a student, and hence it has gone ahead and it has adjusted this line, right? But given whatever data we have, do you guys think that this is the best fitting output that we can get? What are these values, right? Now see, this equation or this curve that you're seeing, this is a curve which will always give you values in the range of 0 to 1, first of all, right? And now let's assume I pick up a point. Let's say let's say I go ahead and I get some new data, right? I get a new student whose age, let's say new student is uh, ABC, and the age of the student is let's say 27, right? What will happen? As soon as I get a student whose age is 27, my model will go ahead and draw a vertical line from here to here. As soon as it draws a vertical line from here to here, it will go ahead and it will map this over here, right? Now, this S-shaped curve that you are seeing, right? This is a sigmoid function. We will be talking about this. And the output of this function is always a probability. So if you look at this over here, when I drew a vertical line from here to here at 27 and a horizontal line from here to here, I might get the probability as 0.99, right? Or maybe equal to 1 as well, right? So what this curve does is that it gives me output. It will tell me that what is the probability of someone working or what is the probability of someone being a student, right? And this overall, this example that I've talked about, this is what we will be understanding in the next 30-40 slides. And this is what logistic regression is. What logistic regression does is that it basically it evolves the output of the linear regression model. In case of a linear regression model, we are getting a continuous output. In case of the logistic regression model, we are just changing the equation of a straight line to the equation of a S-shaped curve. This S-shaped curve is a curve which gives us probability of a class either being, let's say, true or false, either being, let's say, a student or a working professional, right? So from this S-shaped curve, I will get probabilities. So my logistic regression model will give me probabilities. If it says that the probability of you being a student is 99%, it means that you are lying somewhere over here on the top. If it says that the probability, if the probability of you being working is 99 or 1, then you are on the top. If the probability of you being, let's say, you working is coming out to be 0, right, then it means that you are a student. 22, if you see this curve, if you draw a vertical line, this is cutting somewhere over here, this will cut somewhere over here, and this might give you a probability of around 0.4% maybe, right? So on the basis of the data, right, what we are getting, what we are saying is that maybe 21 to 23 is a critical age wherein you will find a combination of people. At 22, you can have people who are pursuing their masters, and at 21, 22, you can have people who have pursued their bachelor's and who have started working as well, right? So using only age as a variable, probably you cannot go ahead and you cannot just for the age of 21 to 23, the probabilities might be confusing. But what if I added another variable over here? What if I added the number of degrees that you have, or what is the current degree that you are pursuing? Now, let's say if someone is 22 and they are pursuing their masters, then the probability is more that they are student. Now, let's say someone is 22 and the maximum degree that they have is, let's say, a bachelor's degree. Then maybe the probability of them being working will be higher, right? Now, see, over here as well, let's say if we had additional features, let's say if we had features that the background, right? Maybe Audrey is from a different background, or maybe let's say uh, if I captured marital status, maybe, right? Now, marital status, maybe there are people who got married at a very young age, and then let's say they went ahead and they spent 5 to 6 years in their marriage, and then they decided to come back at their career, right? And when they decided that maybe I'll go ahead and I'll pursue a higher degree, right? Anything. So if you are able to capture other factors which are helping you in quantifying, then the model will be able to predict. But over here, the model will still predict that at 33, you should be working, right? Now, there can be cases, or see, the model will just try to find out the general pattern. The general pattern is that generally 18 to till 22, right, you will be a student. Generally after 22, you will be a working professional, right? Now, the model, obviously, the predictions that you are getting will be the generalized trend in the population that you're seeing, right? We have given the model that 33 is a student, right? But all the rest of the data points are saying that anyone who is greater than 23 is a working professional. So the model will not make an exception, right? The objective of the model is to generalize the patterns, right? Not to see if my model would have gone ahead and would have, let's say over here, I would have gone ahead and I would have changed this curve from here to here. Do you think that that would have been correct? Let's say I would have gone from here to here. Do you think that this would have been correct? What will this lead to? I'm sure there will be many people who will be greater than 30, let's say in our batch. So for those people, your model will start giving incorrect predictions, right? Now, what do you think? If I let's say I have 10 people who are greater than 30 in this batch. Maybe for 8 out of 10 they are working, maybe 7 out of 10 people they are working, right? So there is a 70% probability that anyone who is 33 years old should be working, right? So this will actually lead to overfitting, right? And you don't want to overfit. Overfitting is what? uh, Overfitting is capturing specific rules with respect to the training data. That is not what you want to do. You want to capture general patterns. You want to capture the general trend. See, after 33, let's say if you have a age range of 33 to 35 wherein you are seeing many students, then the sigmoid curve will shift, right? But generally that will not happen, right? Okay, so now let's move on to the logistic regression part, right? Let's try to understand what happens in case of logistic regression, right? Now, logistic regression is a classification model, a statistical classification model, deals with categorical dependent variables. Your target variable can be binary or dichotomous, right? What do we mean by dichotomous? Dichotomous is again a similar word for binary. It means that your categorical variable can have uh, categories. It can be true, false, it can be yes, no, it can be rain, not rain, whatever, right? So that is what you mean by dichotomous or binary, right? Could be multinomial as well, right? So your target variable can be multinomial as well. That is, it's not that only logistic regression will work only for binary variables, right? It can also work for variables which have, you create a model which will predict the designation of an employee, right? Maybe the designation is a data scientist, maybe senior data scientist, maybe junior, maybe lead, maybe principal, right? So in this case, your target variable can assume, let's say, 4 or 5 different values. So your target variable can also be multinomial, right? Your input data can be both continuous or categorical, correct? What do you mean by it can be both too? At 33, you are saying that people can be both, right? Student or working professionals. So that's what, right? Now, see, if I would have gone and I would have collected more data, if I would have asked each and every 150 people of you, your age and your whether you are a student or a working professional, do you think that there would have been many instances of people who are greater than 30 and who are student? You thought just like linear regression did, just like that, logistic will also be able to take any categorical data will be converted into labels, and then those labels will be converted into numeric values 0, 1, 2, 3, and that can be plotted, right? Now, what is logistic regression? It's a tool for applied statistics and discrete data analysis. All of these are just definitions. It gives outcomes in terms of probability. You have seen this. In turn, helps in classifying the given data, right? When you start getting probabilities, right, you can go ahead and you can arrive at a cutoff, right? You can say that anything above 0.5, let's say any probability above 0.5 that I'm getting in the model, I will consider that person to be a working professional. Any probability which is, let's say, less than 0.5, I will consider that person as a student, right? You also know that, okay, so let me give you an example. I have two cases. One, for one, the probability of being a working professional is 99%. For the other, the probability of being a working professional is 55%, right? Do you think that the model is the model is confident in both the cases? The model is confident is only in only one of the case, that is where the probability is 99. Where the probability is 55, as soon as you see 55, you should also know that this is a critical age range, right? Because this might be somewhere in the 21 to 23 age group, right? So there, if you are getting a probability as 55, you can go ahead and you can say that this is still this prediction might not be correct, right? But anything, let's say, above 90-95%, you can be very sure on those predictions, right? These are very common models in the world of data science, these tree-based models. So we'll first try to understand what a decision tree is. Then a decision tree, once when we understand decision trees, then we will move on to random forest, because random forest is nothing but it is a variation of the decision tree model. Decision tree, your random forest, they can be used for both classification and regression tasks, right? So the linear regression model that we have studied till now, it was only limited to regression, right? Logistic regression was only limited to classification, right? Whereas our decision tree models that we are studying are models which can do both the things, right? It can also help you with a target variable which is categorical. It can also help you with a target variable which is continuous in nature, right? So let's get started with the theory. Now, tree-based models are said to be the most used supervised learning models. They can be used for both classification and regression problems. We can create highly accurate and stable predictive models using these tree-based models, right? Now, tree-based models are very, very popular. Why? They are easy to use, right? They are explainable, and this is something that we have been doing a lot, right? So they are easy to understand as well. When I'll be talking about the concepts, right, you will find that you are able to relate with these tree based models, because generally that is what we also do in our life, right? That's what our objective also, whenever we have to do something, right, we go ahead and we apply a bunch of rules, right? We apply a bunch of conditions, right? So let's say I take a very simple example. Let's say that you need to hang out with your friends, right? And you need to decide on a place where you have to go and meet and eat, right? Is it a straightforward process? First of all, let's say you have 5 friends, and let's say one friend comes up to you and they say that, okay, we'll go and we'll meet, we'll have dinner in, let's say, a particular restaurant, right? Let's say Burger King, right? Not even a restaurant, a fast food joint. But does that happen this way? No, right? There will be so many factors. So let's say 5 friends, you get together, you go ahead and you decide that you have to finalize a restaurant, right? Now, can you guys think of what factors can be there which might affect which restaurant you might go or you might not go to? What factors drive food? What kind of food you want to eat? Distance, proximity, ambience. Is it dinner? Is it lunch? Season, cuisine, price? So many factors, right? So let's do one thing. Let's try to build a decision tree and see how the decision tree will actually help us in making certain decisions about the population, right? Now, let's say this is my entire data. This is my entire data. I will take restaurants in NCR, right? Delhi NCR. Taking this as an example, you can extend this to your city. Let's say that the total number of restaurants in Delhi NCR are 1,000, right? Just for example, let's say I go ahead and I take this, right? Okay. Now let's try to identify. Okay, so what according to you guys will be the most important aspect over here? When 5 friends are meeting, let's assume one is from Noida, one is from Gurgaon, one is from Faridabad, one is from Ghaziabad. Then what is the first thing that you will have in your mind? Distance, right? Let's assume that the first aspect or the first condition for everyone is distance, right? So a very simple rule, let me go ahead and let me apply a very simple rule over here in this data. I will go ahead and I will say that, let's say every friend is saying that I don't want to travel more than 20-30 kilometers. The friend who is situated in Noida, if he has to go to Gurgaon, he or she might have to travel 50-60 kilometers, right? Similarly, Faridabad has to go to Ghaziabad 40-50 kilometers, right? So let's say the first condition that we apply is distance less than 25 kilometers, right? What are all the restaurants, right? That what are all the possible restaurants which have the distance of less than 25 kilometers or greater than 25, right? Now let's assume that distance less than 25 kilometers, out of the 1,000, there are only 200 restaurants, right? Which will have distance of less than 25 kilometers, right? These are 200, and let's say these are 800 restaurants. Correct? Now, what do you guys think? What will be the next criterion? What might be the next criterion over here? Cuisine, maybe. I think let's go to cuisine. So, right. So let's say in cuisine, or let's say first, let's try to decide whether it is veg or non-veg, right? So you can have a condition such as, let's say, is it Navratri? Or let's say simple, right? I'll just write veg, all the veg restaurants and all the non-veg restaurants. Let's say on whatever factors you are able to arrive at a decision. Do you want to eat veg or do you want to eat non-veg, right? Now let's say you decide that you have to go ahead and you have to eat non-veg, right? Let's say 80 are veg, 80 restaurants, 120 are non-veg, right? Okay. So let's say this is then 80 and 120. Now you will go ahead and you will split this further, right? Now this process will keep on happening, correct? Now the next uh, filter can be, let's say, what kind of cuisine within non-veg do you want to go for? Mughlai? Do you want to go for Punjabi? Do you want to go for American, Italian, Mexican, whatever, right? So this, you can imagine, this tree will keep on growing. Does that make sense? Right? We can keep on growing this tree to any extent possible, but as long as we are keeping features which are important, right? As long as we are keeping features which are relevant, our decision tree will stay relevant and significant, right? Now let's assume that I take a case of 5 friends who are in college who want to select the best possible or a place wherein they can eat, right? So for them, what will happen? This decision tree will come from here to here, right? This will then come from here to here because they decided that they have to eat non-veg. And then let's say on the basis of all the rest of the conditions, they finalize that they are going to go to these, they have these 5 restaurants as the option. Now they will go ahead and they will decide these 5 amongst themselves, right? Now see, this decision tree can also serve a purpose for other cases as well, right? Now let's say the same in the same area, we have a group of friends who want to eat at a restaurant which is less than 25 kilometers, but they are looking for a veg option. Now, within the veg option as well, if you keep on growing this tree further, right, you should be able to identify the best options for you, right? Even over here, towards the right-hand side, if you would have grown this tree forward, you would have seen that, okay, greater than 25 kilometers, maybe you travel to Gurgaon, maybe you go to Murthal, whatever, right? But if you see, if you capture all possible outcomes, right, out of all the 1,000 restaurants that are there in Delhi NCR, you can go ahead and you can divide each and every restaurant to each and every condition or a combination of conditions, right? And this is how we generally create a decision tree, right? Similarly, when you have to go and you have to buy a car, how do you decide? You will decide a budget, you will decide features, you will decide whether it is petrol, diesel, electric, you will decide what brands you need to go for, right? There are so many factors, and on the basis of this, yes, 5-seater, 7-seater, SUV, hatchback, sedan, saloon, whatever, right? So isn't this how we actually arrive at decisions? Isn't this that in most of the cases you make, whenever you are making a life decision in a, let's say, in a uh, disciplined way, isn't this how you will actually approach a question or approach a situation? Okay, so this is clear to everyone. So this is generally what we mean by decision trees. Let's go through some theory around decision trees, and gradually we will try to understand how decision trees actually work, right? Now, tree-based models are the most used supervised learning models, algorithms. They can be used for both classification regression. We have gone through this. There are two kinds of tree-based models that we will be going through: decision trees and random forest. However, it is not limited to these two. There are other models as well. But if you understand these two, you should be able to extend the knowledge from here to the other models as well. Let's get started with the decision tree. How is it different from putting criteria and assigning weights to them for decision? We are not assigning weights over here, right? We are dividing our population as per our need, right? As per our requirement. There are no weights that are being applied over here. If you're comparing this with logistic regression, linear regression, in case of linear logistic regression, we were getting the output by combining all the factors, assigning different weights, and then coming up with a common factor. Here, we are taking each and every factor and we are seeing what we are applying conditions on that, and we are trying to come up with homogeneous groups, right? So let's say if your entire population was this, right? So let's say you have, so let's say these are the different options or the different, this is how your data is distributed, just an example. So what decision tree is doing is that it is creating boundaries, it is creating rules. It is saying anything which is from here to here will be a cross. Anything from here to here will be a tick. Anything from here to here will be a heart, right? During this process, there can be misclassifications, but over here, we are not assigning weights. We are creating these decision boundaries. The rules that we are applying, they are actually dividing your data into homogeneous groups, right? Kind of like if else, right? Now, decision tree, a graphical representation of all possible solutions to a decision. A decision tree is mostly used on classification problems. Decisions are mainly based on some conditions. Decisions made can be easily explained, right? So just go through this definition and see if you're able to understand this. Let's say distance has highest precedence, wedge is priority. You might still arrive at the same conclusion. Here you have only assigned, you have not even assigned weights, right? You are just saying that, see, when I say that distance has the highest precedence, it is not only distance which is going to give you the prediction, right? We are taking distance as the first cutoff or as the first criterion. After applying distance, you are applying some other criterion as well. I am not saying that the distance has the highest weightage over here. I am saying that I am splitting my data on the basis of distance first because that makes sense first, right? Then if I take some other, if I'm taking any other variable after distance, it does not mean that the importance of that variable has gone down. Overall, all of these rules that you are creating, they work together to go ahead and to come up with the final predictions. So in case of logistic regression, linear regression, we were assigning weights. Here we are not assigning weights anywhere. We are just trying to come up with a combined set of rules which helps us in getting homogeneous groups, right? If I'm looking for people who have churned, if I'm looking for people who have not churned, we are trying to identify those groups. Random forest builds multiple decision trees and merges them together to get a more correct and stable prediction. These types of models, right? Random forest is something that is called, these models are actually called ensembles, right? Ensembling is a technique wherein you combine multiple learners together, right? So if you see where a group of weak models combine to form a powerful model, right? Now this is trained with the bagging method. What is bagging? Bagging is nothing but you create a bag of models.
So, a neural network is a computing model whose layered structure resembles the network structure of neurons in the brain with layers of connected nodes. So, it can learn from data which can be trained to recognize patterns, classify data, and forecast future events. So, the neural network is based on the biological neural network of our brain. So, that is why it is given the name neural network. So the layers are interconnected via nodes or neurons with each layer using the output of the previous layer as its input. So its main function is to receive a set of inputs, perform calculations, and then use the output to solve the problem. Now, as I've already said, these artificial neural networks are based on something known as a biological neural network. So, our biological neural network has dendrites, cell body, and axon. So, dendrites are where the input is taken, cell body is where the processing is done, and axon is where the message is transferred to other neurons. And the same thing happens in artificial neural network as well. So first we give in the data, that data is processed, and then the final processed result is given out as the output. So over here, let's say we train the data with images of cat and the labels would be either cat or not cat. After that, we give in a new image of a cat and then we basically try to predict whether the model correctly classifies this as cat or not cat. And since the model has learned the data properly, it correctly classifies this image as cat. Now, there are many ways of knitting the nodes of a neural network together, and each way results in a more or less complex behavior. Possibly the simplest of all topologies is the feed-forward network. So when feed-forward neural network, signals flow in one direction without any loop in the signal paths. And typically, artificial neural networks have a layered structure. The input layer picks up the input signals and passes them on to the next layer, known as the hidden layer. And there can be more than one hidden layer in a neural network. And at last comes the output layer that delivers the result. Now, the first question to pop into your head would be, what is the inspiration behind these artificial neural networks? Well, the answer to that is the biological neural network of our brain. So let us first understand the architecture of a biological neuron. So as you can see in the slide, our biological neuron has these three main components. So we have the dendrite, the cell body, and the axon. These dendrites receive the signals and the cell body processes these signals. And the axon finally sends out these signals to other neurons. So just like the biological neuron, the artificial neuron has a number of input channels, a processing stage, and one output that can fan out to multiple other artificial neurons. So now let's understand these artificial neurons in detail. These artificial neurons are the most fundamental units of deep neural network. It takes an input, processes it, passes it through an activation function, and returns the output if the condition is met. Or else it will process it again until you get the correct output. And such type of artificial neurons is called as a perceptron. So they are basically like a linear model which is used for binary classification. So as the figure shows, we have x1, x2, x3 and going on till xn as inputs in the input layer. Now, to which we add the weights and the bias that are randomly selected. So here we have w1, w2, w3 going on till wn as weights. So we multiply these weights with the corresponding inputs and add all the values together, and finally we add bias to that sum. So this final sum is passed through an activation function which finally gives us the output. So let us see this in detail.
Just a quick info guys, if you want to become a certified AI professional, then check out the Artificial Intelligence course offered by Intellipaat. You can find the link in the description box below. Now let's get back to the session.
So here we have three arrows which correspond to the three inputs coming into the network. Now for these three inputs, we have corresponding weights associated with them. So input 1 is associated with a weight of 0.7, input 2 is associated with a weight of 0.6, and input 3 is associated with a weight of 1.4. Now, these inputs are multiplied with their respective weights and their sum is taken. So if the three inputs are x1, x2 and x3, the sum would be x1 into 0.7 plus x2 into 0.6 plus x3 into 1.4. And to the sum, we add an offset which is called as bias. So this bias is just a constant which is used for scaling purpose. Now let us understand the concept behind these weights. So these weights basically determine the relative importance of the inputs. So let's say we have two inputs, humidity and wearing a blue shirt. So here we can see that wearing a blue shirt has almost no correlation with the possibility of rainfall. So that is why the weight assigned to input x2 would be low in order to bring down its importance. Now let us see why do we need activation functions. So consider this scenario where you have two different classes. One class is represented with triangles and the other class is represented with circles. Now let's say I ask you guys to draw a linear decision boundary which can separate these two classes. So is that really possible? Can we draw a linear line which can segregate these two classes? Well, the answer is obviously no, isn't it? So let me tell you guys how can we do this. So we'll have to add a third dimension to create a linearly separable model which is easy to deal with. So the logic is when you're going from 2D to 3D, you're making your equation non-linear. So with the third dimension, I have introduced non-linearity in our data, which helps in creating a linearly separable model. And in real-world situations, you don't always get linear problems. So you should know how to deal with non-linear problems as well. And this is where activation functions help us to convert the linear equation to non-linear form. So these activation functions bring in non-linear functional mappings between the input and the response variable. Their main purpose is to convert an input signal of a node in an artificial neural network to an output signal. And if we do not apply an activation function, then the output signal would just be a simple linear function. Now there are many types of activation functions, and today we'll be discussing some of the widely used ones. So let's start with the identity function. So the identity function gives out the same output as the input. So no matter how many layers we have, if all the activations are identity functions, then the final output of the last layer would be the same as the input given to the first layer. And the range of the identity function goes from -infinity to +infinity. So after that, we have the binary step function. So this binary step function is usually denoted by h or theta, and it is a discontinuous function. So if the input is less than 0, then the output would be 0. And if the input is equal to or greater than 0, then the output would be 1. And this is why binary step function is used to solve a binary classification problem. So after that, we have the sigmoid function. So the formula for the sigmoid function is denoted by 1 upon 1 plus e power minus x. The sigmoid function basically scales the values between 0 and 1. So if the input is a large negative number, it is scaled towards 0. And similarly, if the input is a large positive number, it is scaled towards 1. Then we have the tanh function. It is a hyperbolic trigonometric function which scales the values between -1 and 1. So one advantage of tanh function over sigmoid is that it can deal more easily with negative numbers. And after that, we have the ReLU function, which stands for rectified linear unit. So this function will give out 0 if input is less than 0. And on the other hand, if input is equal to or greater than 0, then it will act as an identity function and give out the same value as the input. And this ReLU function is the most widely used activation function and is primarily implemented on the hidden layers of the neural network. Then we have the leaky ReLU, which is just a modified version of ReLU. So the leaky ReLU, instead of just completely removing the negative part, it just lowers the magnitude. And finally, we have the softmax function, which is ideally used in the output layer for classification problems. So the softmax function basically gives a set of probability values for each class of the output. And that particular class, which would have the maximum probability, will be our output class. So that was all about activation functions. Now let us learn more about perceptrons. So like we were taught how to behave in certain conditions, perceptrons also require training. So they have a learning algorithm through which they produce the output. By training a perceptron, we try to find a line, plane, or some hyperplane which can accurately separate these two classes by adjusting the weights and biases. So consider this image where we give the dogs and horses as input. So here, after the first iteration, error value is 2 since the horse has been classified as dog and there is one dog which is placed in the horses class. And in the second iteration, the error value is reduced to 1 as it is just the dog which is classified as a horse. And finally, in the third iteration, we get the correct output as the perceptron has been trained well with no error. So all the dogs have been placed in one class and all the horses have been placed in one class. Now let's understand the perceptron training algorithm. So this perceptron over here receives multiple inputs and each input is initialized with a random weight. So after these, we multiply these weights with their corresponding inputs and then we get the sum. Now this input is passed through the activation function, which would give us a non-linear output. So this process until here is known as feed forwarding. Now, if the output which we get is not optimum, we calculate the error in prediction and then go back and then update the weights and bias. So this process where we go from output to the input layer is known as backpropagation. And we keep on backpropagating until we get the desired output. So that was the perceptron training algorithm. Now let's have a look at the benefits of using artificial neural networks. So the artificial neural networks can learn organically. This means an artificial neural network's outputs aren't limited entirely by inputs and results given to them initially by an expert system. So artificial neural networks have the ability to generalize their inputs. This ability is valuable for robotics and pattern recognition systems. Artificial neural networks also help in nonlinear data processing. So, nonlinear systems have the capability of finding shortcuts to reach computationally expensive solutions. These systems can also infer connections between data points rather than waiting for records in a data source to be explicitly linked. This nonlinear shortcut mechanism is fed into artificial neural networking, which makes it valuable in commercial big data analysis. Artificial neural networks also have high potential for fault tolerance. When these networks are scaled across multiple machines and multiple servers, they are able to route around missing data or servers and nodes that can't communicate. And these artificial neural networks can also self repair themselves. So, if they're asked to find out specific data that is no longer communicating, these artificial neural networks can regenerate large amounts of data by inference and help in determining the node that is not working. This trait is useful for networks that require informing their users about the current state of the network and effectively results in a self debugging and diagnosing network.
Just a quick info, guys. Intellipaat offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.
Let's start from here. So you will see that guys that there are some handwritten digits. So this is a very famous data set coming from MNSIT data, right? It's a handwritten digits, and generally these are in what 28 by 28 pixelated form. I'll show you the real data later in the course, but although the scale is not very obvious, but if you see this is 20, the last is 28. So basically imagine that every digit falls in like a grid, okay? Something like this. Since it's a pixelated form, right, it looks like 28 pixels by 28 pixels, okay? Every number, every digit. So suppose you say 3, it looks like that. So this is coming from real data. You will see this is a very nice image, although it only shows you till. Can you guys see that? I know it's little tiny, but let me zoom in a bit. You will observe. So it's a matrix of, starting from 0 till 28. If you start from 0 to 27, how many rows, guys? Come on. This much array everybody has studied, 28 rows. And similarly, guys, if you observe 28, although I'm not able to show the whole picture, right? But if you guys focus here, you will realize that in each cell, there are zeros and there are numbers, right? And generally, this is 0 to 255 digits, 255. So if you do the pixelated, right, it will go from 0 to 255, as you can see here. So as you go higher and higher, the darker color will come. It can be black and white, depends on your setting, right? So generally, it's a digit, right? It will be black and white, right? But there are also shades in black and white, grayish, dark, light, right? There are a lot of colors. But if you try to shade it, right, this particular pattern, can you see wherever the numbers, if you try to shade it, right, and where it is, so if you try to do it, you will see some edges are coming out. If you are able to pay attention, I know it is little tricky because you see that, so you will see that there is a pattern is forming, right? And if you are able to understand the pattern, right, it is hinting like a S, because since I'm trying to do it But if you go little clearly, right, guys? Cool. So this is what this image is telling you. Okay. So now, although you can see here, wherever it is 0, it is dark black, right? In this particular pattern, right? So wherever it is 0, right, it is a dark black. So I'll tell you, if I make this image a tiny image because I have this power to do it, you will see that now you will thank me. You will get the goosebumps. Why I'll get the goosebumps, guys? Because now you can see there is a pattern, very clear pattern coming out. Are you feeling it? Nobody will tell you this. Let me tell you very promptly here. So now I'm going to add a pen. It seems that I've already taken all the pens in the world. So I need to make this guy a bigger guy. Hold on. Right? So it seems that I start, you know, now I'm going to become MF Hussain. Huh? Don't kill me for this. Okay? But you will realize, right? You'll realize that obviously the colors are not going to be all same. You know what I mean by that? So whenever the digits are like, 0 means black. Huh? This is very clear. 0 means black. So you don't need to hesitate. So all these zeros are there. I already know that. So I'll do it. Why I'm doing this much of effort? To make you feel something intuitively. Obviously, I'll code, I'll show in the hands-on, but feeling is very important, guys. Okay? Which people don't do this, which I pity them. There are two different colors here. It seems so. I don't want to have different colors. You will start missing the pattern, right? You will realize that you have to be very careful to do this pattern thing. So you realize that this pattern somehow will turn to what? Observe this, and there will be slight color coming on the border as well, right? Little colors here. So if you try to see the pattern, this is what it resembles to, right? Obviously, I'm not the champion of it, but what I'm trying to say, it definitely looks like a number S. Are you guys feeling it or not? Come on. Letter S. So if you try to fill it, if I try to fill it, you will realize that, yeah, you're right, Akash. You'll say that yourself. So see, if I start feeling the pattern, since that is looking like a digits, right? You're not getting it. But if I start filling it up, there'll be some corners cutting out, right? Because this is how it is, right? So you realize that, yeah, it is coming out like a pattern. Hold on. And guys, since this is not the full image, huh, by the way. This is not the full image because you remember you had that missing data on 19 was here, right? So you will be seeing that there will be some zeros coming, and trust me, it will be there. So some zeros will be coming where? On this side. So it will be black. That's why I'm making it black from my side. Guys, okay, observe. So I know it doesn't look like that, oh, this is number 5. It looks very ugly. But if I try to give you the character here, does it look like 5? See, I'm fitting something in between, right? And I have the image also. Don't worry about it. So I've already populated it today. I should have it somewhere in the model. Although it is done differently, guys. Why? Because I plotted the black, but you observe they are very close. Are you feeling it, guys? I have swapped the color in the printing, so don't kill me for that. But are you feeling it? Right? Just the complementary. But are you feeling a similar kind of behavior I was trying to draw? Since our image stops at 19, you're not able to visualize it fully. Okay, makes sense? Good. You can say that, guys. Did you understand the nuance here, right? So how do we get it? So the whole idea of identifying any image, it works on two, three things. Basically, there are two words always you have to keep in mind, and that is what? Edges and patterns. So the question is very simple question. How do we identify any image? That's the question, guys. Answer is pretty simple. Just don't think about any neural network. Think about any image you see on the page, right? So for example, if I show you this image of cat or a dog, right? You try to identify what? How do you say that it is a cat or a dog? You look at the eyes, you look at the nose, you look at the lips, right? If it's a cat, you will also look at the body, overall body, right? Understand the design and the pattern, right? So basically, it's all about How do you identify it? Very simple. Depending on the edges, that's the first word. Depending on the edges, okay, patterns, texture, shape, etc. There are a lot of things you actually look at. Images are unique in nature. Trust me on that. Okay. So these are some very straightforward attributes, guys. Right? These are your edges, patterns, texture, color. A lot of things are there. But in Digit, color doesn't matter. Depends on the images, right? So generally, color has not a big role here. So if I am writing 9 with a black or with a blue, end of the day it is 9 only, no? It doesn't change. Okay. So colors don't play a big role. The kind of algorithm we are going to do, it's all same. That's right. But edges and pattern makes a lot of things. So you might be thinking, what do you mean by edges, right? So if you see, observe this image which I put here, right? Or maybe I'll show you my favorite image, which is sequence of trees, right? If you observe three, you will realize that it has a pattern, you like it or not, and it has also edges. So what are the edges? If I have to show you guys, it's very simple. If you want to see the edges, see, you know that in three, this is something you will always find. Doesn't matter how they have written. Guys, agree or no? So edges is like outer side, right? Pattern is like this. So if I show you the border is like edges, so this is an edge, right? But overall, when I combine things together, it becomes a pattern. Do you see the pattern in three, guys? So basically, I put it nicely. It will look like this, an opposite of sigma, right? So know that people will try to write three, and even kids learn to write three like this, right? So different people write threes differently, number three differently, but they follow a simple pattern. Nobody writes three like this, right? Come on, guys. Agree or no? Similarly, for nine, if I talk about nine, right, you will realize that nine also has a pattern. See, what is the pattern in nine? Basically, you see a loop without fail. You see a loop. So it can be like this, it can be like this. What rotation? Not a problem. But you see we loop like this and simple this, right? This is how our nine looks like. Okay. You do whatever you want to do. So there are patterns, right? If someone says eight is having a pattern. So whenever there are two loops, it's an eight. It can be like this, 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 but there is a pattern. Okay. So what just like our brain tries to process this information of edges, pattern, shape, sizes, texture, color, right? They recognize it, right? That's why you're able to quickly recognize. Look at that. If I ask you, even somebody has written one like this, but you know that what he has written, guys. Come on. You know that it's one. There's nothing else looks like similar to it, right? Guys, what is this digit? Come on, you tell me. One only, na? Although nobody writes one like this, huh? Very few people would do it. Everybody writes one like this, okay, or this. But yeah, this is very clear. Yeah, why not? People write that. Some will like write one, two, okay. So slanting line come in any direction. Now, guys, let's talk about the detailed idea of neural network structure, right? So I'll again, because I think I had just shown you guys that structure. So let's talk about a little bit more in on this. The same structure I'm going to talk about. Okay. So there are, if you observe, there are three layers in terms of difference, right? One is input layer, one is hidden layer, but hidden layer can be a lot in number. See, one, two, three. And then the finally is you get output layer, right? So what happens, you're trying to do things, right? The input will go through input layer to the next, then next, and then next, and then finally it spits out. So let's also keep talking and write. So I think I did not explain each of these layers, right, guys? That's correct now. Before I jump to weights and biases, I did not give you any textbook definition, right? Okay. So what is input layer? Input layer is helps you to input the data features. Input the data features. So in this case, in our case of digit, pixel value or pixel values of an image. Now, if you are thinking about pixel values, but before we go there, a lot of people don't understand data feature. What do you mean by data features? are input variables. Input variables, predictors, whatever you name. So if you take our image, how many by how many we have? Why I'm drawing when I have it here. Okay, take this guy. How many by how many we have? Come on, tell me. So if I take the example of our digit 3, 28 by 28, take this one. No? So take any of it, right? So take this guy. Huh? So there are 28 pixels here and 28 pixel here. Do a quick math, guys. Come on. So 28 into 28, how much it is? I know it even in sleep, 784. 784 are going to get connected to the first layer. Although don't go with this diagram, there are just 10 neurons, okay? But in reality, there will be 784 guys getting flattened and connected in terms of neurons, okay? So this becomes your number of neurons in the input layer. Number of input or features, basically neurons connecting to hidden layer. I'm talking about which use case, which I'll do it later. That is coming from your MNSIT data set. Okay. So to show you this, you will see this later in your course. Just focus on this. So when I'll do this, I'll show you this, that we are going to connect how many input to. So if you look at that, how many layers are getting connected to it? It is next connected to 784. Neurons are getting connected to, how many are those? 784 connected to how many? 128. Clear? In this particular example, which I'll do it in the hands-on. Okay. This is, I have assumed that in this input layer, in my hands-on, in this input layer, there are 28 by 28. So if you do the math, it becomes 784. And this is my first hidden layer. I'm saying that I'll keep how many neurons? Come on. I'm saying that I'll keep 128. Okay. Right? So it's a matrix. Listen to me, guys. It's a matrix of order what? 128 by 128, right? So basically, if I flatten this, it's a matrix, right? Of 128 by 128, which basically means, sorry, what I'm saying, 28 by 28, which basically means that there are 28 rows and 28 columns. So what is this array, my dear? This array is what array? It is a 2D array. If it is a 2D array and I want to convert into an 1D array, right? How will I do it? What is the concept, array concept? You know it. You can read about it in case you are not aware of it. And the function is, right, array flatten, right? Which is np dot flatten, if I recall correctly. So that's what I mean by that, right? That's how you come like a more like a no, one line. Okay. Now the question can be like, why 28, right? Why 128 in the next layer? Who is telling you this? These are all questions you should ask when you already know about what is the neural network and all, right? Understand now my feelings? It's like suddenly why sun is moving around, why we are flattening it. You should ask what is the meaning of flattening. But let me tell the structure. Let me tell the structure first. Because if I don't tell you, you'll always be confused, right? Perfect. Okay, input layer, I think I'm done. One thing you need to understand that once you have the, pixelated view of it, right, you will realize that images has a lot of things. So let's talk about pixels. What do you mean by pixel? Because this is something I'll keep using. What do you mean by pixel? Let me ask some baby question. Now, this is a question to debate. Huh? What do you mean by pixel? And how is it related to image? Related to camera and camera size. So camera to, right, it is resolution of your camera, right? How does it relate to your image size? Let's see how good are you. Everybody will open their computer. You know how to see the resolution of your computer? Because I don't know. What is the resolution of your computer? Yes. So my display is saying my resolution is this 1920 by 1080. What do you mean by that? So if you do a matrix formation, 1920 rows by 1080 columns. Okay. So that's how it looks like. So every image of mine will have how many cells, guys? You know that, right? 1920, 1080. So total how many? Look at my image size. 1920 into 1080 equal. So if you're good with this, you know that it will be what? If I do a simple maths, it is how many pixel? 2 megapixels. Guess, come on, yes or no? You know that. Approximately, my dear. Approximately. Why? Because see, it is 10 to the power 6. Right? Agree? So don't think your resolution is bigger than 2 megapixel. There's a reason for it. Let's not go there. Okay. So just imagine those who are using, so let's say a phone has a 12 megapixel. So 12 means what? 12 into 10 to the power 6, right? Megapixel means this is only, no? So you can think like that, more like 4 by 3. So 4 million here, 4,000 by 3,000, right? Then you will get, approximately, I'm saying, making a grade out of it, guys. Come on. Which is a lot. How many these are? 4,000 by 3,000, right? Just imagine that the number of neurons you will see here, you're just looking at 784 in this example. Here you're coming in millions of neurons. So what is a pixel? Pixel is, by the way, what is the full form of pixel? Pixel means picture element. So let me give you a pointer here. It means picture element, pix L. So if you bifurcate pixel, pix L. Pix means pix, right? Image. So L is what? Your element, and pix is your picture. So it's a picture element, right? Which is the smallest unit. So those who wrote smallest unit, they are 100% right, which is the smallest unit of a digital image or display. It doesn't need to be an image. It can be a display also. Okay. Now, question comes that how it is related to the image size, right? So just imagine image size is definitely they are measured in pixels only, right? If you observe. So you might have heard about pixels per inches, or, when you're doing the fax. So there you say, right? DPM or printing. DPM, you know what? DPI, sorry. DPI, you guys know in fax or in scanning, dots per inch. Yes. So generally, if you take a 4 by 3 image or 8 by 7, right, dots per inch. So there are different types of printer. That's how you define the, quality of the image there, right? So I'll not go there. But you know that in terms of, this is about your, printing. But if you do a similar kind of analysis here, it is called PPI. What is PPI? Pixel density or pixel per inch, right? So if you talk about pixels per inch, so what is the interpretation of it? If you take an image, right? If you take an image more like as a unit dimension, if it is an inch of, all right. So generally an inch is a very small unit. How many pixels you are putting there, right? So higher the PPI, you tell me, higher the PPI implies more details and sharpness of the image. Basically, you talk in terms of good image, qualitative image, more details and sharpness in the image. Okay, that's what you mean by that. Basically, you say you have a better resolution of the image, right? And if your image is better, generally your image size will be also higher. Agree or not? Come on. So if I talk about a 12 megapixel camera, I'll not go to our school days when I used to use 1.3 megapixel camera. So 12 megapixel camera, right? If I just say, listen to me, the same thing I'll call it here, guys. It is 4,000 pixels here and 3,000 pixels here, right? So that's the reason it is called 12 megapixel. You must have been, so don't be now uneducated, right? So now since you are sitting in my class, you should be aware of these things. So 12 megapixel camera releases every time, right? 12 million pixels for each images. Now, if I give you a simple example that if your image is like, a simple image of, let's say, 10, 6-inch wide, and let's say it's a portrait one and 10-inch height. Okay. So generally, if you see these kind of standard photo size, right, how it is being framed, understand this. If I go with a standard 300 PPI, which basically means 300 pixels per inch. Remember that, guys? Come on. Listen to me, and this is very important. Doing ChatGPT will not help, right? For a 12 megapixel, what is the image size in inches it will come? Let's say this is A and this is B. What is the length of A and what is the B? What is the image size you'll get it if I go with this assumption? Let us assume the pixels per inch is 300. If I say 400 pixel, sorry, 4000 pixels and 1 inch, you're putting how many? 300 pixels, right? So basically, it's very easy. It's not a rocket science. So you can do this math, 4000 by 300. How much it is? 13.33. So this is your 13.33 and this will be what? 10. So it's not 14, it's 13.33. And this is going to be 10 inch, right? So if you get this PPI and divide it, you should get an image, and that is an image which will not be, it will not get stretched or anything, right? It's a natural fit for it. But you know that image can be scaled, it can be, stretched. Sometimes people say, right, image is looking all, blurred, or image is not looking as sharp as it should be. Okay. बोलते हैं ना अपन image फट गया है, right? That's the word. Image doesn't look nice because you have overstretched in a very bad manner, right? Image looks stretched. So this is the image size you should get. Make sense? Clear? Now, why I'm telling you this? Because we are going to discuss with image, right? So if you see, this is not a image is not something, you can escape. You have to be aware of pixel. You should be knowing about what you mean by a 12 megapixel camera will spit it out. And I'm just talking about a simple idea here. If you have a 12 megapixel camera and you know that the pixels are designed in this manner, 4000 pixels on the rows and 3000 in the columns, right? Now you know that every inch takes how much? So if you take, so see, it's a 2D image, right? So you have both the directions, right? A and B. Don't miss that. It's a 2D image. So you have to do it separately. So every inch takes 300 pixels. What do you mean by 300 PPI part? Tell me. Pixels per inch. So 1 inch will have how many pixels? Come on. 300 pixels. Now on the rows, if you see, buddy, how many pixels are there? Already 400. So this will be aptly fit on what size of the image. So I just divided by 400 by 4000 by 300. It gives me 13.33 inch. So if you take an image and just go and put it on a this much of the image of paper size of the camera. Sorry, suppose you want to get the printout of this image, whatever you have clicked, and you do this paper size, your image will come 100% perfectly fit. No scaling is done, right? Correct. But if I take the same image and I put it on a big poster like this, what will happen? Come on. First of all, look at that. Our image is more like a portrait one, slightly. I'm putting into this format. What is this format? Landscape. Let's say I'm putting it into 24 inch by 20 inch. Now what will happen? So what will happen, since your pixels are not that rich, you need a better, bigger camera. That's why the DSLR comes into the picture again. Make sense? So it will look distorted, right? And let me show you. I'm trying to find not distorted is not the right word. I would say stretched. So I'm not able to find the right word for it, but you can do it. Okay. It's not going to be a fit, a proper fit. Okay. So for example, I have an image which I can show you, which looks like stretched. Okay. But you will realize what I mean by that. Or maybe I can take an image and make you show you here, guys. Okay. Why I'm thinking too much about it. Okay. So hold on. Let me take a kid image. Suppose I take this image. Guys, please pay attention. You will realize, right? This is a very simple image, guys. Come on. Now, if I start making stretching like this, can you see this? This is what I'm telling. So it's not blurry, to be honest. The right word is stretched, but you can find some technical word for it. But I know it's not blurry, it's stretched. But if you get a right fit for this image, the right fit was this one. Huh? Observe this. So this is the right fit. That's why people always tell you, right, in corporate, that always do in the aspect ratio, right? Don't try to stretch in the by one. Always do diagonally. Diagonally is still better. But if you keep increasing it, then the quality of image is gone. Can you see that? This is called pixelated, so when you print it, it will look like, image fat gaya. That's another word. So means it will be more pixelated. Your face will not look that better. So image size and image resolution they go in hand by hand. They go in hand by in hands and right. They go in hands. You can't have different things for the same thing. Make sense? This is all about image, but there's beyond it. If I change the same question by giving RGB, right, then you have to do it differently. But I'll not go in. Okay. RGB is like red, green, blue. So these are your channels for color. But I'll come back on that. So this is all related to this neural network I started. I talked about input layer. Let's move to the next layer. What is the next layer? That is called hidden layer. Hidden layer, generally trainers say it's a black box. I'm not the guy. Generally trainers say it's a black box because they don't want to get into. But I am going to do the postmortem. So hidden layer, it can be one and it can be multiple. So hidden layer, generally people say it's a black box. It is a black box. That's true. But at the same time, we will open it. It's going to be an overwhelming exercise, but I think if you ask me honestly, should I do it or not? We should do it. Yeah. Then what kind of deep learning scientist will become, right? We should do it. This is not that tough. Okay. So guys, hidden layer is known as intermediate layer. This is the intermediate layer between input and output layers. So these layers are very important for us because these are the layers known to extract the features, which is intelligence, from your input data. Okay. So a lot of time people say, what is the deep learning? This is the main component of a deep learning. Hidden layers are called hidden because it is so deep to understand, because it goes on, it can have multiple layers, 5 layers, 10 layers, right? It tries to find the edges, patterns, texture sequentially from the images you have given. And that's where the calculation of weights and the biases happen, and they keep getting updated through an optimizer. Generally, the optimizer is going to be gradient descent algorithm flavors, right? So you keep updating the weights and the biases. That's what you have done in some of the machine learning algorithms. If not, I'll teach you. And that's the most important piece, or I'd say the heart of the deep learning thing, right? So let me write this line. These layers, when I say these layers means hidden layers, these hidden layers perform computation, extract the features from the input data. Okay. So these are the features which we are going to extract from the input data. And the deep learning term, let me write the deep learning term, if someone asks, what do you mean by deep learning? You can say deep learning term refers to the network with multiple hidden layers. So the whole point of deep learning is to have hidden layers. Trust me. Deep, right? You have to go and get the depth. I'll also show you one baby example where I'll take no hidden layers, and that is called single layer perceptron, right? So it will just this connecting to the output, right? With one hidden layer. But that is not hidden layer. If it is hidden, then you have multiple in between. Okay. That's what called depth. Tell me one thing. If I put two boxes, listen to me, and I want to give depth in between, then I need to increase the space, right? Think like that. Top to bottom, right? So hidden means what? I'm trying to make you the word clear, deep learning. This deep is coming from multiple hidden layers. So you will put a lot of layers between. So you need some space, right? So you will make it bigger like this. And then you'll put a lot of layers. So that becomes deep if you observe. So you try to, jump from here, you jump, you will realize it is deep. Don't do this and blame on me. Huh? These guys, people are doing anything. Okay. It is just for understanding. Okay, clear? You got the concept of deep. The word deep, what do you mean by that? Pixel, right, today. Pixel means picture element. Two terms you have learned. That shows your, experience when you go into the interview. So pixel is a picture element a lot of time. Deep means what? If I just have one layer of input, maybe one layer of hidden, and then one layer of output, what is deep? What is the depth here? Nothing new. It just gets connected and finally spits out. But if I say that I have one layer of input, and I need to put a lot of layers of hidden, then I need some space. So can you see that the depth increases? Try to feel that in physical sense, right? So that's what you mean by deep. Basically, you're trying to say you're making it more complicated and complex. adding more hidden number of layers. Obviously, every layer has some job to perform. There are a lot of existing deep learning architectures. You might have heard about Yellow, Resonate, right? A lot of CNNs ones, right? I'm talking about that. VZZ. So all those will make it more complicated, but that's in the future. Coming future, you will learn from me. But for the time, just focus on this. Okay. Now the final layer is what? Output layer. So output layer is your final layer, right? That is the layer that gets you the output. So suppose you are doing a digit classification problem. In the output layer, you need to find what? Whether this digit is what? Let's say suppose there are more and it comes 9. If this digit is coming as 3, then this neuron will get fired. It will, sparkle, right? White. And then the finally output will come like 3. Definitely when I do this, it looks like what, guys? Multi-class problem. Okay. And there are different types of activation function will come, but I am not getting into it yet. Right, Srini? Hold on. So output layer, what is this layer? It is the final layer, let me write, that produces the output of the network. Okay. Generally, if you're trying to do a binary classification, how many neurons you need? One neuron or two neurons. In single layer perceptron for binary classes, let me show you. And this is a jargon for you. So let me get the images. That is not your, classification problem. See this. This is very simple, which I am going to do the first thing coding. Binary means 2, right? And this is, I will teach the first basic neural network from the scratch. Single layer perceptron, this is for, binary output, right? It is 2 neurons. But if you think about it in detail, guys, if you think about it detail, right? It's not necessary that it has to be. It depends on how do you want to do it, right? Means I can still connect to one neuron and get the answer. Suppose, hold on, this is very tricky, and that's why I asked this question. It looks like I can put yes or no here, right? And whatever it glows. But if I say, if I take this guy and I say, no, 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 I'll just connect to only one sort, something like this. Hold on. Don't worry about the image connections and all. If I just say that, I'll put one neuron here. If it is getting fired, if it is on, I would say yes. If it is not getting fired off, I'll assume it is what, my dear? No. Guys, if I'm asking you, will you attend my class tomorrow? Right? Who is going to attend tomorrow? Listen to me, the art of complementary theorem. You say yes, it means that those who have not said yes, can I agree that they are not going to attend? Art of complementary, right? Can I say that? Yes, to an extent it's correct, but someone can say, oh, I'll change my mind and all. I'm not assuming that if you're not saying yes, you're not going to come. With that assumption, it can still be connected to one neuron. So this is going to be redundant, right? Because one neuron, two neuron, right? You're not going to worry about too much. Because whether it is one neuron, two neuron, right? It is not going to matter much. But you know that minimum you need how many neurons? The right answer is one neuron in the output layer for binary classification. This is the minimum, but you can have 2. There is nothing more to stop. And I'll continue and write just below this. Multiple neurons in the output layer for what kind of? For multi-class classification. Here I'll use softmax, right? So these are some good jargons you might have been hearing about. Softmax, and I'll write here sigmoid. Sigmoid is used as an activation function for binary classification. Softmax is used for multi-class classification. Are we clear? So guys, neural network was developed by Mr. Warren McCulloch. So let me write. You should know the name. Warren, not Warren Buffett. Warren McCulloch. And there was one more guy, Walter Pitts. Walter Pitts. Correct the names if I do mistake. 1943, can you believe it? So a lot of people think neural network came in 2000. No, it came long back. It was an idea which was proposed long back. Don't think that. So this was proposed for the first time in 1943, before our independence. So these are the guys for the very first time proposed the mathematical model for neural network. Okay. So let me show you quickly. Suppose if I try to find the digit 9, guys, can you see this? Now there was a question that why does it comes like 784? Because you have to put every input layer in 1D array. That's the constraint. Someone asked me that why do you want to get into 784 like a flattened thing? Because this is a requirement that if you want to do a input layer, what is input layer, guys? I think you know, right? This is your input layer. Let me write very clearly. This is what, my dear? Output layer. Okay. And these guys are what? Hidden layers. Now the question can be why it is being connected to 128 or 5 or 10. Don't worry about it yet. Okay, please don't do it. Because then you will miss the fun. I'll tell you everything. What are the standard? So this is your black box, although everything is black here, it's a black background. And the credit goes to the guys who have prepared this nice images. It's very tough. So if you're trying to do what happens now, guys, you will try to extract the edges, patterns, from input to the hidden layer, then it will fine tune in the next layer, and then finally it will fire the right output neuron. So basically what I'm saying at a very high level, 10,000 feet, the moment you give the numbers, remember those numbers 0, 0, 2, 3, 250, right? Those numbers it will come, right? So basically higher the number, higher the neuron firing, right? So in this case, generally, when you say 0 to 225, what we do as the very first step, we normalize it. So what do you mean by normalization? So that we scale it properly. So you take each and every 784 values and divide by 255, it gets squeezed into 0 to 1. So basically, all these value will become 0 to 1. And if it is 0, it will be not firing, means it will look like black. And if it is 1, it will fire like angel white. So basically, if you take the input, it will get fired. And I'll show you in my nice images, it will be white. Some of these guys will be white. Not everything will be white. And then some of these guys will get white, depends on the pattern. Are you feeling, guys? Then finally it will be white. Not everything will be white. And there will be different shades of color, light white, more black, gray, dot black, dot white, right? And finally, it will say, I am here, buddy. It identifies the input image as what, my dear? As digit 9. So colors are going to be in the gradient, and there are only two colors, the shades of black to grayish. Hold on. So there will be grayish also, and then finally becomes white. So let me show you the patch. Because in PowerPoint we have it, the gradients, gradient image of black to white. So if you are trying to see this image, I know you're not able to see the white because white is white, but it is here. Huh? Let me show you. Can you see that? Let me write in English. This is white. There will be more, depends on the range. So generally what I'm saying, if it is 0, it will be dot black, and it is white, means it go from white. Since the image in wrong direction, I can't do it. Okay. This will be the heart of it, so nothing to worry about it, even if you have missed it here. So this is how you put images in pixel forms, right? So generally when you do, shades, so it will come like this. 0 means black, 255 means white in our case, but it can be other way around also. So a lot of time people use 255 as the black and 0 as the white, depends on your setting. But this is how you get the different values to the different shades of the color. So basically 256 shades you are going to see, not only this much, by the way. So 256 shades, which will be very close. So basically 250 will be closer to 252 and 256. 0 will be closer to what? 25246, right? Guys agree or not? In terms of color shading, just focus on this part. Okay. So this is related to pixel. So we saw those number, right? 0 to 255. Basically, that's a range in pixel. It's a range, right? 0 to 255. So basically, total how many it is? Total it is 256 values, isn't it? So generally, this is the most digital images will have this kind of format. So most digital images like what? JPEG, or you have heard PNG, right? Must have seen those image format, right? So JPEG, PNG, okay? So each pixel is going to have certain value to it, right? So if you saw that screenshot of mine, right? Listen to me. I was showing that now. See. So this is like what? 256. In the values of 256, you find for each pixel. So if I pick any one number, my dear, please focus. Can you see there is a value we are tagging to it? 238. This is one pixel, huh, by the way. So total 28 by 28, how many pixels? 784 pixels. In that, there is a value associated with each pixel, which is coming from the image breakdown. Now, what is the meaning of this 250, 253, 256, 100, right? Blah, blah, blah. So the meaning is, I'm writing here, the meaning is very simple. If you take any pixel and you give a value, right? 0 represents as per the notation, but sometimes people reverse it, but 0 represents black. That is as per the notation. You can't change it. And I think I mentioned it also. And 255 represents what? White. Now I'm telling you guys that black will not be just black, right? It will be black, then light black, then it will go to the different shades. So total, how many shades are there? 256 shades of what? Black to white. Agree? And later I'll show you a lot of images showing this one. Make sense? So in this, 127 value represents what? It's the middle value, guys. It represents medium gray, by the way. Just fun fact. And 256 represents already available. Sorry. Similarly, in the color images, you have a different set. But again, similar to this concept, but I'll not go there for now. Okay. So now I'm going to show you and you feel the beauty behind it because the kind of stuff I'm going to show you, you will love it. Okay. So I was showing you this, that how does it understands, right? So to understand anything, right, the network needs to find the three things. It starts with an image, which is getting into pixelated form. Listen to me, guys. I'll also write. So the moment you give an input image to this network, when I say network means neural network, in the input you give the pixels. Pixels have values and values are acting as activation. Then activation goes on to the next layer and the next layer it activates just like neurons does. So just like neurons do, if you remember that example of pain, right? The moment someone is pinching on your arm or stabbing your arm with a knife, these days it's happening a lot. You have to be careful. So then your brain quickly understands that you are getting stabbed, isn't it, guys? But you know what? The masses, it's not like, your neurons start traveling like a blood. No, no, no. So if this is your neuron, right? It doesn't start, like a Ferrari race and move to your brain. No, it fires another, it transmits the signal, then it activates another set of neurons, right? And not every neuron gets right. Why might this? Okay, let me tell you a very simple thing. Take your right hand, right, and try to pinch, right? You will feel the pain in the right hand. Do you feel the pain in the right leg? I'm trying to make a very rational analogy here, right? There are so many neurons. Do you think everybody will get fired equally? Some they will not even get fired. You agree or not? Come on. So even in your body, when you're trying to pinch, so similarity is there. Understand? If you try to pinch on your arm, does it pain or does the pain occur in your leg, right leg? No, only the right arm. Why? And even right arm, that special area, right? Suppose I pinch on my arm at a point, only that gets activated. And then the brain is getting the signal that this localized pinching is happening. You don't feel the pain anywhere else, right? Come on. Similarly, if I want to detect whether a number is 0, 1, 2, 3, or 4, 5, 6, 7, 9, it has different edges, patterns, and it identifies that through series of computation and only fire the ones which are required for it, right? Looking at the input image. Okay. So let me show you this. This is how it looks like. Now you might be thinking, and if you're observing, guys, right? Whenever you are trying to give, let's say I give a different type of thing. This is my image, right? It looks like a part of 4. It looks like a part of 9. Can you observe, guys? That's why the model is confused, right? I'm showing the confused behavior. So when you give an image like this, which is having a pattern, something like this, right? So you know that what it will do, it will try to find the, and if you observe, there are 784 input. Let me also write. So it is 28 by 28 pixels, which actually becomes 784 pixels in the input, right? Focus. Okay. Then it gets into the next one. What is this one? If you count on the finger, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm not keeping 128. It is 16 neurons. Don't get carried away. Huh? That 128, I took it from the hands-on. Then another 16 neurons in the next hidden layer, if you see, right? And then finally, how many? 10 neurons, right? We need 10 neurons for output, right? 0 to 9. 0 to 9 is 10. Are we clear, guys? So if you observe, you are doing a math of how many combinations? 784 into 16 into 16 into 10. It looks very easy, but I'll explain the maths behind it, how many weights and the biases will come when I come there. But what happens, this is the image, what will happen? The network will think whether it is a 4 or a 9, right? So you can clearly observe that looking at the output, right? It is firing some neurons here, there. Can you observe, guys? Let me highlight in case you are missing. So this is bright white. So that 0 to 255, right? Remember, I had done the normalization, and this 0 to 255 is squeezed between 0 to 1. Remember that. Okay. So after normalization, so you can clearly see that if it is this, means it is white. It is perfectly white, means I know it's not easy to see here. I'll use some white color, right? Yeah. So this is white, but you also see some of the neurons are not getting fired in the hidden layer. Just observe. So these are like dark, means black, right, guys? Can you see that? Some grayish is also getting fired. So now we will realize that all these different shades have some values, right? So if I have to show you, and then you will feel the beauty of it in a moment. But ideally, it is what all these digits have some activation values, right? Even in the hidden layer, by the way. So generally, this is what we show, right? Although just this is for the sake of understanding, right? So let's see if I do this. This is my more like what, my dear? Activation scale. 0 means what? Can you see in the diagram? 0 means dark black, and 1 means white. Are you? And then there are different shades of it. You can clearly observe, looking at this, that as you go from 0 to 1, it turns white. It goes from black to white, right, guys? Black to white. Okay. So some of the neurons will get fired, and that's what you're saying, right? Neurons are getting fired or neurons are getting activated. It's the same thing. Okay. Some of them will get. So what do you mean by activated? So activation happens at the cost of input first. So you get the input, then the activation happens. I'll come to there. But at least on this image, can I write, guys, that here, can I say that the neural network, I'll write NN, neural network, is struggling, so that it is in the notes, struggling to decide whether the input image is 4 or a 9. Because if you do 9, it looks like this. If you do 4, it looks like this, right? But you might be thinking, how does it work? Means what is it doing? How those activations are being done? What is the calculation behind it, right? That's the whole topic for the day. So to get you the intuitive understanding, I'm getting into the heart of it. So now I'm digging it further, guys, as promised. So more in intuitive understanding, going one layer deep. So now understand, guys, how does, how does training happens? How does those calculation happen? So the subtopic within this is how does the training work in neural network? How do you understand what is the digit is going? How does learning happens? So if you observe this diagram, you will understand what I'm saying. There's some really nice diagram put by some really good guys. Okay. If you observe, my dear, here, you will see that for 3 digits, why I've taken 3 digits, there is a reason for it. Can you see that there are some commonalities? And if you're paying attention, you'll know. 0, can you see this? 9 has a loop here. Observe. 8 also has a loop here. Observe. But if you break 9, you have 2 things. This, and then you have a stick. Observe this. This stick can be also be here, right? Length, don't worry. Look at the edges. So you're picking the edges, right? These are all your edges. Let me write so that you don't miss. You're picking the edges, right? You're picking the edges. Edges make the pattern, and pattern makes the digit. So edges to pattern, and pattern gives you the digit. Now, if you observe, you have 8. 8 has, so you can say that this is this image. I don't know why I killed it. And this is this. Observe this. Then you have this big stick, and then you have this long stick. See. Okay. And then you also have this different one. Right? Maybe make the same color. Are you with me, guys? So are you able to break every digit into some edges? So what I'm telling you here, every digit has some edges, which neural network identify. I'm writing why, because so that you don't miss on it. Clear? Now, if you try to understand, let's go back to our thing, 9. Again, because 9 is something I want to make you understand. So you know that it will go in sequence, right? So if you want to find 9 and let it identify, you realize that in the next layer, which is hidden layer, second hidden layer, let me write so that you don't miss it. So this is hidden layer 1. This is hidden layer 2. Now there are 16 neurons here, 16 here, 10 here, and 784 here. Don't miss on that. Neurons are connected to some lines, right? Those are known as weights. I'll come to that. But understand that if you even focus on one of the neurons, right? It is being connected to 784 combination. That's why it's called fully connected layer, right? So you're connecting to everything, right? All the inputs. Basis that, what it does, it tries to give you those shades of different color, and it activates the neuron in the first hidden layer, which eventually activates some neurons in the next layer. So what it does, it sees that, hey, hello, there is a loop. Come on, focus on this, guys. So suddenly you know that this particular neuron tags to this loop. So it gets bright white. Come on, understand this. I'm making it very simplified for your understanding, but are you able to follow, guys? If you focus on the box, let me zoom in a bit so that you can see that. Okay, everyone, can you see that? So you know that 9 has a pattern. What is the pattern? This is the pattern. There is a loop. You know that loop is going to come here. So you see this neuron gets activated. Bingo. Are we clear? Then you also see that there is another pattern, and that comes the stick, right? The vertical stick. And you see the vertical stick is tagged to this particular guy. So it says, hey, hello, I'll glow now. Let me glow. So he says, okay, I'll glow. So this is getting activated. Are you feeling the beauty, guys, at a zoom level? Now, you know that if I'm going to do this, then output layer is going to get combined, right? So everything is connected to everybody, but you know that this will combinedly, right, go and form a pattern. And pattern forms a digit. So you will say, I'll take this, and then I'll take this. I'm just showing you the beauty here, guys. And then you know that if I combine these edges, it becomes a pattern, and pattern matches what digit? 9. So then, since it is all connected to everybody, is connected to everybody, but finally identifies it digit as 9, right? Are you getting the goosebumps or not? See, let me tell you, obviously I have not done these images, but I have gone through all this, structure to understand it. Okay, so that I can explain you. Are you feeling it or not? It depends on your exposure, but okay. Why can't it be 6? You need to understand that 6 is what? Let me show you the pattern. 6 is like this, right? If you observe, first of all, there is a big difference between this loop and this loop. You understand? Look at the directions also. Huh? If you put it here, it's a very different thing. So I understand your point. It can be 6, but it also looks at whether it is like this loop or this loop. Rotation is also considered in this. That's why I need a lot of neurons. So it will identify differently. Now, if you understand this, guys, then you have to also think about one important aspect of when the moment the digit comes, right? Remember, I showed you the 9, it looks like this. So that image, if I blown it up, remember I showed you 3, 6, 5, whatever digit. This is how it looks like in the pixelated manner, guys. Can you see this? Now, in the grid of 28 by 28, if you observe this, right, there are 28 in the columns, 28 in the rows. You can clearly see wherever there is a matching edges and patterns to number 3, it gets white. I'm just trying to show you this part of the image. So what happens when you put it into an array of like 784 pixels, right? Most of them are black, means 0. Only few of them are like 1 and closer to 1. Like if I zoom in, you will see that 0.7, 0.9, depends on the color and the value, right? That's what in the zoom in version they are showing you. But you can clearly identify the edges. Like suppose someone says, this is the edge. If you observe, this is the edge, right? To get this edge, no, this is not the output of the ReLU, okay? So if you observe, guys, this pattern is being captured very nicely here. Observe this. Sorry, not pattern, my bad, edges. So in 3, you have edges. I'm trying to show you that how does it detect edges? Because you can clearly see that you have 1 in this diagonal, guys. Can you see that? Right? So this will come as like an edge, right? Similarly, we'll see that there is like a edge like this. There is another edge like this. Can you see that? There's another like a loop like this. So it identifies the different into bits and pieces. And when you put those bits and pieces like this, you realize that, oh, it comes like a 3. Are you getting or not? I'm just trying to show you this. Okay. If you observe this, isn't it? This is what I talked. I took a number 9. Observe this, guys. I took a number 9, which is basically I'm talking about this guy. Then pixel becomes edges. What are the edges you found, right? Now I was showing as like a one loop, huh? But it can be possible that they are dividing into small components. Can you observe this multicolor thing? So all these can be small edges. Observe this. Then it gets into what? Edges become shapes. So small edges is making a one loop, right? Shapes become a pattern is there, right? This is a pattern, this is a pattern. So basically when I say shapes, it becomes your patterns in my language, and patterns gives you what, my dear? Digits. So the important learning or takeaway from here that in any image in the world or in the whole course, of deep learning, the complete course is about detecting, let me write, detecting edges and patterns and forming patterns to help us with the image recognition task. Who does it? Neural network does it. I don't do it. They are helping us now to do the image recognition task. So detecting edges and forming patterns. Obviously, edges will form the shape, which is basically I'm saying patterns. Forming patterns to help us with the image recognition task. So basically, edges becomes your patterns, pattern becomes your image, right? Now, if you observe this nice image, which I'm going to show you guys, okay? So I'm showing one image, guys. Can you identify it correctly? Come on. At least you know that it is Simba, lion, tiger, right? Your confusion, it's not a dog, right? So far, if you're not saying it's a dog, it's a lion. It's a lion. But when I show you this, how quickly you identify it, right? Okay, because you're looking at what? You're looking at the edges. See, these are the edges, right? Isn't it, guys? Come on. Are you feeling the beauty what I'm trying to show? Forget about everything. So this image was taken by Mr. Kevin Pluck. Okay. So I'm giving the credit to this guy. This is the image he took and then converted into, so we used the deep learning methods to get the Kevin Pluck. Now, if you compare these two images side by side, it looks like it's a negative of it, right, guys? Come on. So we applied the, edge detection thing, and you can see that it looks so nice. Guys, again, and those who are my peers and, those who are my peers older than me, they know that they must use Kodak camera with the flash and they must have used negatives. handling the negatives carefully, going to the photo center and get those negatives developed for the pictures. Have you done it? Those who are Gen Z, they have no idea, but I have used Kodak 36 reels, right? In my when I was a kid. Okay. But are you feeling it, right? So the same principle what we do here, get back to here. Are you not doing the same principle to detect the edges of the digits? So on the same principle, you can detect anything, any image in the world, because you can find edges. Edges can help you understand the pattern or texture, right? Now I'm using the other words also, texture and the shape, right? Because if I just show you this part, it can look like a dog also to some, not because there is a big nose here, so you might not say dog, but golden retriever dogs have a similar kind of hair structure, right? So texture, structure, it helps you with a lot of details, right? Are you with me? So ideally what model does, model tries to dial these knobs. If you have seen the movie Imitation Game, if you have not seen a movie recommendation from your trainer, hardly I do it, but you must watch since you are studying deep learning with me. Imitation Game, right? If you watch this movie, you'll see this machine shown in that movie, right? It's a dummy one, but the story of Alan Turing. Alan Turing, he's the guy who single-handedly, right, defeated the Germans, right? They were in England and they developed this machine to decode. It was the first machine which became the inspiration for computers. So if you observe, so these are the knobs, right? Take these knobs and look at me. This is my creativity, copyright APC. I'm connecting these knobs as neurons here, right? So these neurons get fired accordingly what you give in the input and get you the output. So in the movie, they use the same principle, right? This position of the knobs were letting them know what is in the message. So they were it more like a decryptor, right? So whatever the encryption they were doing, they were breaking it using this machine in almost 2 minutes, right? And if you remember this movie, they needed some hint to initialize the machine so that it converges faster, which looks like our optimizer, right? So optimizer converges here and gets you the right values of these neurons, right? So that it gets fired, and finally you realize that, oh, this is 9 or 6 or 7, right? Similarly, in the movie, if you observe, right, they use the word Hail Hitler as the initialization, because they know that the first word in that document will be Hail Hitler. So they were able to set the few knobs in the machine. It starts with the right initiation and they were able to decrypt it faster. See, I'm not a computer science buff, so I'll stop my emotions here. Okay, are we clear, guys? Okay. So what it does, right, you can clearly see that it looks for the white patches. So forget about this small one. Let's focus on this part. So you know that this vertical, or sorry, horizontal stick is coming. Why? Because the values here, the model is able to understand this is all one. And if you see the proximity to it, right, is all getting almost, black. So model understands the difference between these two and knows that where the edges come. Because you have the value tag to each and every digit shade, and that gives an input to the first layer, and it understands that where is 1, where is 0, where is 0.8, because we are putting it into the model, right? So if you see this, the moment you run, right, it quickly identifies in the training that this digit, you can clearly see that this digit is what? This looks like 9, right? What it does, it tries to break into small components because of the neurons you have, right? So if you go to the structure, there are a lot of neurons, right? And it identifies it in the first layer itself here. So it activates it. We have the values, these values. Then it helps to find that, what are the possible edges it can detect looking at these values. So you can clearly see that when you are looking at the values, not everybody is white, right? But still it is being picked. This is your edge, by the way. This whole thing is your edge. If you observe this, let me clean this because then you will know. This whole thing they are considering at edge. What is not going to be in the edge is this part of the chart, right? Because they know that it's 0, but they understand that this is 1. So they'll give more white color, less color, and they know that. Okay. So that's how it works. The working is very simple. It will pick those edges and tell you. Okay. If I convert this image, right? So you're basically what you're doing. You are going to increase it. You can make it like this, or you can make it like this. That's what I'm saying, right? In terms of shape. But if you flatten it out, right? So what will happen that it all will come, one after the other, because it will be the similar data points, right? But you need to also understand the patterns will also change, and you have to take a simple example to show you. So let me show you, since we are discussing. This is a very good question. So suppose, let's say this is my image, right? Which is, 4 by 4. Okay. The total is 16. So I put some pattern here, right? So I put a value 8, 0, 2, 6, 5, 3, 2, 1, 2, 5, 8, 0. I'm just randomly taking. Now I will reshape into, let's say, so you need 16, right? So you can do like 2 by 8, correct? By 2. Let's do something. So you can have, now, if you follow the pattern, right? So it doesn't matter your image is getting like 2 is getting like this, or you stretch it like this. So there's a different concept. But I think as of now, if you do this, you fill it like sequentially, then there's no problem. You observe how I'm filling it. I have to go a little more down. It's sequentially, right? So now if you flatten it, it will be same. But if you fill it differently, for example, if I fill it, so 8, 0, some randomly I do like 8, 5, 1, 0, 6, 2, like this. So the pattern will go and shift. But if you fill the sequence and the sequence is not disturbed, your pattern will not change. The moment your pattern change, let's say you have changed the pattern intentionally, but in training, you're not going to give only one three now. You'll also have different threes, right? So it will quickly identify this is a different pattern, and the model might give you a wrong answer, or it will, if you have an option that not sure, it will go there because it will not find any matching there. So training, that's the reason training is not something you will do it. But if you keep training, let's say I say, and I'll make your problem more interesting. Suppose you do this a lot of, you have, 1,000 data points. For 1,000, you have like, it's not imbalance. You have 700, this pattern. Then, although you're trying to detect 6, but this pattern will become more obvious if there is no neuron which you're matching to it. Still you will find that this neuron is getting fired and tagged to one of it, because the model will decide on its own. Don't think we are going and telling that in neural network that you have to detect 0 to 9. It's not like that. We know the problem, right? But if you give a different pattern, right? So you saw in my example, this example, it was showing both 4 and 9, right? So it will show similar like that. It will show a wrong thing. But if you have more data points similar to this pattern, when I say the pattern, the shape and size, it will start showing that more profound, in a more profound manner. But it's just one or off business, or one of it, it will not be able to, because even the number of data points will have the weights on learning, right? It's not like just one example you give off, then the whole model is going to auto. It's not like that Lego game. You plug out one marble, the whole structure falls down. It doesn't work like this. It can tolerate one. It will take it as a noise, to be precise, in machine learning language. Okay. So if you observe, right? So if you take any color which is like shade of black and white, observe this, guys. It will go from 0 to 255. Since RGB has 3 channels, okay, like he's saying. So if you take any of the color, right? So you'll get a hex code and you will get a value, right, between 255, 0 to 255 for all the 3 channels. So there are 3 channels, right? RGB. So you can make any color using RGB. I hope you understand that, right? So that's why these are the 3 channels. You can pick it up. But since we have not done any color images, you're not able to visualize that. But everything in color is always in the range of 0 to 255. Okay. How information passes between the layers. So, and this is something I'll show you with a lot of images so that you don't miss it. So on the similar structure, suppose I want to pass an edge. This is an edge, guys. It is trying to find edge. That edge is mostly showing your letter, digit 3, not letter. So your input is same, nothing changes. You have this pixelated image, 28 into 28. Let's say this is the 3, right? So you are going to have the flattened one. And if you observe, everything is connected to a lot of neurons, right? But if you try to understand every neuron functionality, it's similar to one neuron functionality. So that's the reason that I have taken only one neuron. So this is my first hidden layer, and this is only one neuron we are trying to understand. If you understand one neuron behavior, no, you can get any neuron and functioning. So this is my first hidden layer. Observe, guys. Tell me one thing, when you will get this number 3, you will get those values of activations. Hello, yes or no? These values will come in the array. Also the zeros, a lot of zeros, a lot of these values will be there in the array. Okay. So basically I'm saying the data will look like this. Okay. I showed you, one image where the data came. Like this. So imagine that my first digit is 3, right? Or I think I'm using 3 here, it is 5. You will see that this is how 28 by 28. If you flatten it, you will see some zeros, you will see some ones, you will see some value between 0 and 1. This data has still 255 because this is before normalization. Okay. I'll go very slow, don't worry. Now, if you observe, this, these values are going to be there. So these are known as what? Activation values, right? What it is known as, guys? Activation values. Okay. Now, on one neuron will have all the activation values. So I'm going to call this, guys, as what? A1. Listen to me. A1, A2, up to A784. Listen to me. So these values are known as activation values. Did we created it? No. It came as the property of the image. Clear? I did not create this. The moment you give a digit, right, it will have the activation values, right, in the pixelated form. What are these lines coming to you? These are known as weights. That's where the weights are getting introduced. So every line connected to the neuron, there's a line, right? This is your weights. So just remember, in linear regression, you were doing this beta naught plus beta x1, beta 2 x2, so on. In this case, it will be beta 784 x 784, because how many variables you have, my dear? Why I'm relating with linear regression? Because you are champion of linear regression. 784 variables, because you have 7 input variables, 784 input variables. And what are those, guys? Those are known as coefficient. Remember that? You have a lot of it. Can you believe it? It's such a big model. Everybody, are you guys with me? Then you might be thinking, who is this guy? This is known as, in our language, so guys, all these are known as weights. In this case, also known as weights. Even in linear regression, your trainer must have taught you. And this is known as bias. If not, I can do it. So this is how I'm introducing the weights and the bias. Now you might be thinking, what is weight? What is bias? Right? Yes or no? Thinking about it? So bias and weight is very simple. Suppose, listen to me. I'll give you a very simple linear regression equation. Y equal to 20 plus 100x1 plus 10x2. Now, which variable is going to have a lot of impact on the price of tomato, my favorite example? You will yourself say, Akash, it's x1. How did you say that, my dear? Because you looked at the weight, wasn't. In Hindi, we call this weight, right? So the weight is higher, the impact of this on y is higher. Agreed or not? Come on, guys. Even these variables are off, means 0, still you go and have a ready to set constant value, that even nothing is there, though still I'll charge 20 rupees. Hello, listen to me. Guys, that's what we call bias, right? In linear regression, this concept is called intercept also, right? Yes or no? A line which has some, so intercept is what? Something like this. You start from somewhere, right? You don't start from 0. So bias is saying that even if you don't have any impact, this is like a very good world. Your tomatoes are not going to get free. If you think in mathematical form, it takes the form of y equal to mx plus c. I'm talking about c. Come on, guys, yes or no? So similarly, if you bring this concept and come to the neurons, right? Now, combinedly, these guys, A1 into W1, A2 into W2, will decide what is the going to be the value for this guy. Which guy? This neuron. Whether it will be a white neuron or it will be a gray neuron, God knows, right? Or it will be a black neuron, God knows. Are you getting my point? This will control. These are the knobs which will decide, and these will decide the next, and not only one. All the guys will decide the next and the next. That's how it works. Are you feeling it? So if you are feeling it, let's not wait. The way I'm showing the images and to show you that how does this work, and thanks to the guys who have put together, but if you understand that these are the weights, guys, I mentioned just now, let me highlight it. The lines are the weights. You are seeing two colors here. If it is a blue color, it is going to be, if it is a blue color, and if it is a red color. If it is a blue color, guys, it will means positive. Red color will be what? Negative. Are you guys with me? Observe this, no? All the blues are the positive, all the less than is negative. So now the weights can be positive or negative. Now understand, if something is negative, the price will not increase, price will go down because of the impact is reverse. I'm again bringing the same example. Yes or no? Suddenly, if I make this negative, then the price will go down. Agree or not, guys? Come on, right? So similarly, these weights are going to be decided by the optimizer. I don't decide it. I'll just initialize the weight, but the optimizer in this case, but the basic is what? Have you heard about this optimizer? So what it does, it takes the cost function or the loss function, gradient descent algorithm, GDA, a lot of versions of GDA, but the one which is very famous is known as ADAM. So this is a jargon for now, but don't worry. ADAM is one of the famous optimizer people use in deep learning. Gradient descent algorithm finally runs a lot of iteration to get you the final values of the weights. Isn't it linear regression also does the same thing? I showed you a very nice example where the weights are getting decided, and to show that, suppose this is my distribution. I'm taking some balls, they're infinite balls. Now tell me one thing, if I try to fit a line, this is my line, right? See, this is simple linear regression, guys. Suppose I try to get a line, right? So see, if I show the error, residuals is error, if you draw the perpendicular, if you draw the vertical lines to the line, this is the error. A lot of error is there. You might say that, Akash, and observe also this part of the chart. So if you observe this part of the chart, you will see that this value keeps changing. These are the coefficient. This is your weight and this is your bias. Let me also write bias and this is your weight in our example. Okay. If you observe, right, if I increase this, you have a lot of residuals and you will see the residuals coming like here. A lot of errors is there. Squared sum of residue. Remember that? A lot of look at the blue line. It is a huge line. If I try to go up slightly, see the line is getting shorter. Focus on the sum. Are you guys observing? So you're getting in the middle of the distribution. You're also changing this. Look at the weights and the bias. It's like dial is getting twisted and engine is trying to find it, which is the right fit, the best fit for this linear regression line. You are still having errors. You see that, is it the error I have to go ahead with because I can't do better than this? You're doing it intuitively, right, guys? Observe this. Let's say this is the best fit line. You get the weights as 0.56. You might have started like 0, 0, right? Or minus 10, but sliced and diced this knob, right? And got the optimal one. Now, this is like intuitively you're doing, right? This is the best fit line. But this is what you have done intuitively. But what is the algorithm will give you? In one shot, it will give you the answer. See that. Now, if you see that residue is coming from this, obviously it is also having the residue, but if you observe closely, it is lower than what you are saying. But we also did a good job, right? Because it's a very simple one line 2D. But if it is like 784 dimension, can you handle it, guys? I don't think so. So the best fit line comes like the red line. Look at the coefficients, the weights and the bias. Here the weights and the bias is slightly closer to what you do, but optimizer will get you the best output here. Are you feeling it? Come on, right? Your residue is not that bad because we did it intuitively. But you understood the working of neural network. It works in the similar fashion, my dear. Trust me on that. So all these weights till 784 is going to be decided by whom? By the optimizer. Just like there's an optimizer working in here. So this best fit line is powered by what? An optimizer, which is doing the ordinary least square and it tries to minimize it, right? OLS, remember? Not ORS, OLS. Ordinary least square means least means minimize. Minimize what? Sum of squared residues. So similarly, we will also have our loss function or cost function and minimize it and get the weights after doing this for one neuron. Now, what is the concept of bias? Bias is what I'm headstrong that I will not allow something, okay? But you can clearly see that the weights are going to be decided by the optimizer who decide the weights. In the beginning, you can make the weights as all 1 or 0. That's up to you, okay? Right? And mathematically, optimizer will keep changing this so that it gets the best fit line, which you saw here. It will try to understand what is the best loss function. Loss function has to be minimized. So it will try to keep changing this value and update the weights and the biases so that it gets the minimum value. Once it converges to the minimum value, the weights are going to be fixed, and then it will move to the next, and then it will move to the next. There's a concept of back propagation also. So that is what going to drive the updation of the weights and the biases. Don't worry about it. Okay, but that's a big concept. It will come later. Okay. I hope you like this example because this animation helps you to understand how does the weights and bias change, right? If you keep trying to move the line to get the best fit line. Similarly, to get the minimized lowest value of loss function, the weights and the biases are going to get updated. That's the reality. Okay. So when you will see the mathematical function, right, which I don't want to teach you now, but actually it will be what? It will be what? You will take each activation function, right? And you will do the sum. That's how you do. You'll go till what? A784, W784 plus B. This is you have done for one neuron, first neuron. You'll do it for how many neurons? 784 neurons. It will become like a matrix calculation, guys. Can you see that? I hope you are able to feel. So this part is known as language dot product because dot product gives you the sum product and then you are adding a bias. Understand? So this is just a teaser, but I'll get into the true maths going slowly into it and gently into it. Okay. So you will do it for 784 neurons, right? Convolution. So guys, this is the new word in the market for you, and that's convolution. Convolution has been derived from the word convolve, right? So I'll show you something and then you realize what's happening, okay? There is a value which you are putting it here by sliding this 3x3 filter. Can you see this? It's a 3x3 filter because you have 3 rows and the 3 columns. It's a 3x3 matrix, right? Observe this. So you'll keep sliding and keep moving and you will start capturing the feature. So what is this you're doing with everything which you're moving around? The moment you're sliding something, you're trying to capture the complicated details of the image. Now, image can be colorful, image can be anything, to be honest. Means it doesn't mean to be like it has to be 2D image, it can be 3D, RGB channel, everything. Okay. Similar thing you are saying in a different way, and this is it. Let me show you. But observe this. So can you see that if you keep moving around, you will get the value, and also there's a multiplication happening to get the features of the images. That's the intuition behind convolution. So mathematically, those who are from electronics engineer and all, if you remember, and that's something I can show you here. Powerful intuition portal. I'm putting here both the links. Guys, you have to see it for yourself. Both the links. But if you see what I'm trying to say here, from the image by using a filter, this is your filter. Okay. But this is very high level introduction. I don't want to get into the details yet, but you got it, right? But how do you explain convolution to a kid? That question remains there, right? You can't say that oh, you are taking a filter and all. How do you explain a kid? Okay. How do you explain convolution? Okay. So let me explain. Question is how to explain convolution to a kid. Let me help you. How to explain convolution to a kid. So let us break this. Suppose, so understand, we have a small image, right? So let us imagine checkerboard you have seen, right? Let us imagine, I'll write and talk through. Let us imagine we have a small image. We have a small image. So checkerboard is something, if you have not seen it, like you are adult and you have not seen a checkerboard, it looks like this, right? Now, what is our objective? Our objective is to detect patterns in it using a filter. Okay. So far with me. What is the working of this filter? So it will do what? Filter would slide across the image and at each position it will perform a small operation. Now this operation is up to us, right? To make this happen, it's very simple, right? You will do some operation, right? That operation is like, okay, I have an image. Let's say this is your checkerboard, right? What we have to explain to a kid that you will go and slide. Now, this is something you have to understand, that you put a box like this on top of it, right? So you're taking a 2x2 filter, which is more like a number 1001. It's like an identity matrix, right? And then you do some operation. What is the next step you will do, my dear? You'll move on to the next. Then you will slide the filter like this. Can you see? Then it will move. I'll use some for different colors. So this is your another one. So that 2x2, how many slidings you have done? Starting from here, you moved from here to here, then you came down and then you moved there. So total, how many calculation you will do? Overall, 4. 1, 2, 3, 4. I know this 4 is not visible, so I'll write 4. So this is your original image. This is your convolved image. Can you see that your convolved image is like having 2x2 matrix from 9 cell to 4 cell you have come, right? So you have captured the pattern, right, across the image and simplified it too. Now, how to explain this to a kid? Because if you explain this, you are removing a filter, the kid will say, go to hell, I don't understand anything. So what you have to say to a kid, I'll explain. You take a magnifying glass, right? And you zoom in using the magnifying glass, right? And try to match the pattern. You clearly know that the moment, suppose I make this like this. If it is this small size, right, you need a magnifying lens or glass. Now, the moment I know it is tiny for you, intentionally I'm making tiny. If this is this big, everybody can see the pattern, but the image is like this now. It is just a tiny part of the image of a big image. Think like that. You tell me, without getting into too much of it, you know that these two guys makes a sense. This is how you will realize there are 4 segments, right, guys? Let me make it 100%. So if you use a magnifying glass, you will be able to match pattern, and you will say, see, is it, which one is closer image to each other? So you will say, which one is closer to your image? You will say, looking at the magnifying glass, although it's tiny. So this is like a, why I'm trying to show you this story. This image, the moment you put to a magnifying glass, which is this, so you will say that, dude, look at this. If you put a magnifying glass on top of it, right? What I'm saying as a point, or what I'm making as a point, is that, so what I'm trying to say, guys, if you put a magnifying glass on top of it, your image will look like this, everybody. So what I'm trying to say, the magnifying glass will give you this image. Then you will be able to see that these four guys are closer, right? That's the role of a filter. You can ask your kid. Your kid will say that, I think this is closer. Slightly this one also. But definitely these two guys are too much closer, right? Similarly, we'll say that, okay, these guys are closer, right? Or these guys are closer. Are you feeling it? So what you are doing when you say closer, the word itself means that you are able to match the patterns. You're making like look alike, match the pattern. Pattern of what? The color, the shapes, and the size, right? Are you feeling similar? Convolution does the same thing. If something is similar, something is correlated, why you need to keep two things? It's redundant, no, right? So that's what this image does, that out of 9 cells, the same quality of the image can be explained with how many cells? 4 cells in reality. And you don't believe me? No, you have to believe me. This is just the intuition I'm giving, guys, convolution. So if you see this, guys, if I just make it tiny, do you see any differences there? Come on. This is how this level it works. Any differences there? But at the data level, there is a lot of difference, guys. In one, you are using 9 cell, means you need a 3 by 3 matrix to represent that image, the left one. The right one, you are using how many? Only 4, 2 by 2 matrix. But in the quality, in the right, nothing goes away. That's how you are trying to take an image and make it easy for everybody. But the moment you zoom in, you see that there is some difference, right? But the moment you zoom out, and that's the role of convolution. Convolution, in simple term, it tries to capture the edges and the patterns and similarity of a big image, right? Detailed image, and simplify it. Okay, are we good? Are you guys good here so far? With me? Okay. So this image will be still there so that you don't forget this line of mine, right? Both original image and convolved image look similar. Okay, I'll write a note here. Do you think it's a valid example to explain to a kid? You can challenge me, no, Akash, doesn't make sense to me. I think you can use a checkerboard and magnifying glass to explain to a kid. Second question. Obviously, there is some informational loss, no, Sharanya, but yeah, obviously, it's always about like you want a 4K or 2K, but the here idea is to not do anything quality image printing. It's not a media business. Here we are trying to detect the images. Convolution neural network is to help you identify the images. You will anyway get the idea, right? This why do you need to go to a clear image? So I'll now intuitively I'll introduce convolution network, guys. So I'll write a convolutional neural networks is a type of deep learning model specifically designed for tasks like image recognition, object detection, and other tasks involving spatial data. So what is a spatial data, guys? Geodata, weather forecasting, right? Whether in US, right, a lot of hurricanes come, right? And it has gotten a lot of name. Whether so spatial data is all about your anything related to uh, geocoding, right? Okay. Ideally, any data which defines the location and the shape of objects. That's how it is. Okay. It's more related to geo. Okay. Now, you might be thinking, CNN is there. Before that neural network we are doing, right? Why do we need CNN? That can be a question. Before I get anywhere, right? Means you already had the NN neural network, ANN, artificial neural network. Why do we need CNN instead of NN? Any idea, guys? See, image recognition can be also done, like digit recognition we did, right? There's a very big difference between CNN and NN, right? Let's understand. So, and that can be a question in the interview. So I'll put some star or something that, why do we need CNN over ANN? ANN. I hope you know, right? CNN is already, this is your simple artificial neural network, which have been studied so far, right? There are a lot of reasons, but the key reason is what? Where you should answer it. So guys, you need to understand the working of CNN and ANN, right? And remember, we were doing this, we did this task, now, MINST data, handwritten digit recognition, right? MNIST data set. I'm just going back. In this, we used to have a grid, remember? 28 by 28 pixelated form. So how many number of variables we have, input variables, guys? If I take this matrix, right, it will be 784. Remember that 784 input variables or features, you can say, or features. And if you recall also that in ANN, what we did, we said that each neuron, listen to me, I'm writing also in ANN, each neuron in one layer is connected to every neuron in the next layer, right? And to do that, so to make it happen, right, to process an image in ANN, listen to me, the image must be flattened to a 1D array. And if you remember my code, I have done this flattening. You can open the notes, right? Image must be flattened into a 1D vector. So to process an image in ANN, the image must be flattened into a 1D vector, right? But what is the problem? The problem is not here. The problem is the moment you flatten, listen to me, the moment or the process of flattening ignores the 2D spatial structure. Computation will come later, but understand that structure goes for a toss. 2D spatial structure of the image. Basically what that meaning the neural network does not understand or does not explicitly capture explicitly capture the relationship between the neighboring pixels. This is the important thing you miss here. Most important, computation, all this thing will come later. Simple, not simple, all those things can come later. But you understand what happens? The moment you just put it and flatten into array, are you going to understand the relationship between the neighboring pixels, just like in this image, which we are trying to do? The relationship between these two guys, you're missing it. Because there's no 2D, there's no 3D structure altogether. I'll take a pause. This is what you do in any. Okay, so far with me? This is your working of now working of CNN, although I'll go in a lot of detail, but this is just to give you a high level idea. How does it do? Because my working of CNN, I have to go into the heart and soul of this. In contrast, this is still part of introduction. I'm not teaching working of CNN yet. What CNNs are designed? CNNs are designed to handle the spatial structure of images. Okay. How do they do that? I have just shown you, in this, how we might have opened these links to see, right? How it is, sliding and, capturing the information. Or in this checkerboard example, right? This is what you say, right? Are you doing any flattening there? No. You are, without doing any flattening, you're moving a filter in that 2D frame only. Right? With me? So CNN computational is a little tricky task, but it doesn't do any flattening of the array. It retains the structure of the image and do this scanning. So what I'm saying, high level, CNNs are designed to handle the spatial structure of the images, and they use convolutional layer, which is also called filters. They use convolutional layers to scan small patches, also called local regions, neighborhoods, right? Neighborhood of the image, and detect patterns. What kind of patterns? Like edges, textures, or shapes, and many more, without flattening the entire image. This is the major difference. If someone asks this in the interview, I think these are the questions they will expect you to know before they get into the coding and all. You agree, guys, on this? They will ask you this question, right? Why are you doing CNN? Because you have NN. Why are you not using ANN, right? What does spatial structure include? Spatial image in the context of neural network is the arrangement and relationship between pixels. So let me show you. Now, if you understand this image, try to understand it. Guys, I would say don't worry about this output, input. This animation I'll show you later. But tell me one thing, if I go into like pixelated form and take any part of the image, do you think there is a lot of similarity? I've taken a very simple image, but if I just go to this part of this image, do you see there is a lot of similarity? At least this whole big patch. Come on, agree or not? So rather taking each and every pixel and convert into like a flattened array, just understand that you're complicating the whole things and missing the similar information, right? So that's where CNN says that, oh, don't worry about it. Don't go into the pixelated form without understanding the pattern. There are a lot of things being done here, right? For example, this image. See this image, guys. Don't get excited about seeing these images. Guys, can you see that? I'm just showing you that, guys, if you see this, obviously, spatial is a word coming from geo, but here in an image, what do you mean by geo? Geo is like location of this patch, this filter, observe this. So location of this filter on this image, right? And then relationship between that. The same thing you do on a global geo map. I don't know how many of you guys have seen this. Uh, Earth, Google, Google Earth. Guys, so look at this map. This is a Google. This is coming from Google. Spatial actually means you go to a location, right? So go and pin it. So you come here. Let's say we are, I think I'm sitting here somewhere, here, right? So I'll go and pin it here. So if I go here and pin it, right? And I come that, okay, go zoom in. So can you find that there is some similarity in the topography of this part of the, right? I don't know how many of you guys are aware that this part is known as Western Ghat. Why it is called Western Ghat? Because of some reason, right? But can you see that the green patches shows that there are a lot of trees here? Definitely Bengaluru used to have a lot of trees, but now not much. So you can clearly see that there is some similarity between the images, right? If I put a pixel here, guys, on this color, some other color, you'll realize that there is some similarity. You can clearly say that this part is more closer to this part, and this part is more closer to this part. No, sorry, my bad. This part is also closer to this. Okay, agree? So why I'm saying this, whole idea of these things is that find the location in the image and find the relationship. Now look at this Python thing. It's so interesting, right? You are taking one patch. Can you see that? It shows you this, right? So this is like you're taking the texture of the images one after the layer and layer, extract the feature, and finally you are able to classify this is a snake. Don't worry about how is it done it, but you can clearly find that after the training, sorry, that it is the snake, right? How does it do it? Don't worry about it. But can you see that there are some patterns and there is a lot of similarity? Okay, even you put a patch by yourself, like let's say I put it here, right? Do you see some similarity? Yes, there's a lot of similarity. In fact, you will say that I can just replace this whole bloody part, right? Right? This whole damn thing, right? With a one, because it's the same thing. Why I need to keep different part of it, right? In contrast, neural network will do what? It will take everything, even it is similar as a new input feature, right? Without putting any brain to it. Listen to me, let me do it differently. Because in ANN, you will take everything as an image, right? You will divide it like this, right? And you will say that everything is like a one input feature. Agree or not, guys? This is what I have taught you. You have to agree. But here you are not doing the same thing. You are going to do a lot of things different. I'll take a pause before I go anywhere. These examples are making sense? Yeah. And that's why CNN needs some power, some juice in the machine. So it can't be done on like a baby machine because it is computationally heavy, but makes your life easy. There are two things happening. Okay. So you realize that CNN is really a good architecture for identifying objects. Can you see this? Now this image has a lot of details, right? It's not like it's a real image, to be honest. That is also a real image, but that image is most focused, right? For an algorithm, right? You can clearly see that it will go. Obviously, you have to take a filter. You can't take a filter which is bigger than this, right? Then the filter is going to confuse your output. But you can clearly see that it gives you a probability, and you will have seen a lot of guys doing this on YouTube, that this is a car, this is a horse, this is a person, right? On YouTube or on LinkedIn, people just keep showing this live real-time object detection, but that's not that great because they do it, right? They do it, they just copy paste the code, and latency is so high that till the time your camera is identifying what is what, you would have hit him. Okay. So it's good for lab or training project or small your college project, but I think that's what self-driving car they're thinking about, right? How to identify who is there in front of them. Right? Okay. So guys, what I'm saying, coming back to on the screen, observe, right? It is able to identify a car. Definitely, it has been trained on car, dog, horse, person, right? But it does a great job, Lakshmanan, right? And obviously, I'm showing an output rather than how does it do it, because that is something I'll cover in the course. But you understand that it is able to identify a real image and gives you a lot of details which are publicly available to the model. Make sense? Do you think this is an output of a CNN? On the right hand also, it does the same thing. It identifies a dog. It identifies a dog versus a cat. And look at the probability. The probability is like damn good. Hello, yes or no? See? So just imagine these images are like what? This the right hand image is such a dark image. Hello? Look at the image, it looks like a dark image, not like very bright, but still model doesn't care. It will identify. It has to have the edges and the patterns. So I'll get into the heart of it. Don't worry about it. But does it answer the question that it will take care of it? That's more like a teaser to show you that it will take care if there are multiple images or the transparency you're talking about. So let me talk about a real example, some real use cases. See, I'm not very sure that what are they using, but one very cool example, and it is in my home also, and this is something everybody is seeing. So you must have had a company. I'm not promoting the company, TP-Link. So I have a camera, a house camera, Wi-Fi camera. And what does this camera do? Obviously, it does the recording and all. That's a normal thing, right? Monitor. But it has amazing feature. And what are the amazing feature? Person detection. Can you believe? So when I'm away from home, I set it to person detection, just thinking that if my door is locked, how can someone can barge in, right? So person detection, this is just for the safety. I don't know if some of the kids or movement detections, if someone is moving in front of the camera, it will, give you some notification and all. Or as a matter of fact, a lot of cameras are focused on the baby, and now you are sleeping and your baby starts crying so let's say you're sleeping in another room and baby is another room, or it's in the same room, but you have a deep sleep, right? So baby cries, so your phone can ring or do some big alarm, right? It's more like a SOS alert. You know what? This is like life-saving feature. A lot of time baby gets intertwined, gets entangled in the blanket or something, and they start suffocating. You know that? Uh, right? I have read about it. I don't have a baby, so I know that. As a matter of fact, as an information, such an amazing thing, right? And can you think this thing comes in 1,500 rupees, 2,000 rupees? Okay, let me also say this is not a promo post. So this is a camera. I have it in my home. It's very cheap, not expensive. But they must have some technology. I'm saying that even they have a simple, not they are running AI or anything, but even if they have some simple program, but it does the job, the convolutional neural network, right, will do much better than this. Make sense, guys? With me? Another use case when I was in Amazon warehouse, right, so I saw it, is that now Amazon is testing humanoids doing their fulfillment. So what is a fulfillment in the sense what Amazon is doing, my dear? I'll show you. So what Amazon is doing, and you can watch this video later. I've given the link. So what Amazon is doing that they are testing the humanoid. Can you see that? So they have the camera here, right? This is the humanoid. And this guy is so trained that it can detect a barcode. Obviously, there will be a lot of technology. I'm just saying that obviously AI is making it happen. Else it would not have been possible. Trust me on that, right? AI is making it happen. Okay. So now they understand that in a fulfillment center, this guy will go pick a bag, pick a parcel, package it, put it to the logistics on the conveyor belt, and it will come to your doorstep. I know, don't go there that, they will be they will be like, replacing human labors and all. Don't worry about it. That's not my job. I'm just trying to say that how Amazon is using human eye to pick a parcel, pack it, and ship it. In fulfillment, these are the three things people do, right? Pick, pack, and ship, right? Yes. And that's exactly they are testing, I think, in some Amazon warehouses, not in India. Amazon warehouses, they have this kind of testing going on. I don't know. They are also putting this to the deployment. Means they are using it. So there can be 10 different applications. So detecting the human objects and all these are all fine, right? But there can be a lot of real application of convolutional neural network. Trust me on that. And there are a lot of articles, going around. I don't know if you guys are aware of not, but if you are in pharma industry, right, medical science, there are international journal people have published. Obviously, these things are still not in too much usage, but I'll show you some images so that you get a feeling of it. So this is a journal they have published. See, so they are using a 3D CNN to understand the lung scans. Guys, can you see this? And here you get a bigger quality image. I think this guy they have provided. But why I'm showing this so that you understand that they have taken a CT scan. Can you see a CT scan, which is generally that looks like this, right? Can you see it? And if you want to read about this article, I'm sharing this here. So they're using 3D CNN to try to find if the patient has the, you know, see, Arun, there any correlation with MRI and CNN? See, CT and MRI is what? It gives you a way of looking at the images, right? Isn't it? So CT and MRI more like the way to generate the scan of your lungs without looking into the bones, right? See, I'm not an expert of CT scan, MRI scan. But can you see that, guys? They have given you three combinations, RGB color. Are you seeing this? Green, red, and blue. Okay. So what they're trying to do, they're analyzing it in different segments, coronal, axial, sagittal, different slices and all, right? And they are putting into a model to come up with that, whether it is a COPD and non-COPD. There are only two outcomes, right? So they're trying to find that if somebody has, so COPD, I know it is chronic, obstructive. It's a technical language, or I would say, medical language for pulmonary disease. Trust me, these ones you can only find it. So this disease is there, and this is the whole thing, COPD. So means if the patient has a disease, this is like yes, this is like no. Make sense? Yeah. So they're trying to predict disease is there or not. Okay. And in this CNN model, they have reported that their accuracy came to 89.3%. So what they're saying that if you take a scan, give it to a model, it will accurately predict 90% of the time that a patient really is having a COPD or non-COPD. Make sense? This is the same thing the expert look at it and they try to find looking at the scan. The scan is a movie, it's a film, they give you a CD of the CT scan or MRI scan. Are you guys aware? They don't give you the images only. They also give you the scan video. So when I had COVID, definitely not a good time to talk about, but they also gave me so my lung was scanned and they do it. Okay. Make sense? Why I'm saying that this is so important. See, really need a good lung specialist to detect this at an early stage, right? Understand what I'm trying to say. Any tumor, any cancer, any liver failure, any heart disease, right? You really need the expert. But do we have the experts across the globe? Answer is negative. Only lucky, the people who are rich, ultra rich, who have good connect and network, they get to the good doctors. Agree to this, guys? Come on. It's just like finding a good deep learning trainer also, by the way. So just imagine that if someone is going to just teach you or tell you or just using a tool, just like you have a watch, you have a smartphone, you really don't need Steve Jobs all the time. And you can yourself find whether you have this disease or not. Are you getting my point? Just imagine you can manage your health, right? If someone tells you that after 10 years, you have someone has a prediction that if you don't do this in 3 years, your heart will fail. You will do something about it. But if someone tells you that, dude, your heart has failed, what will you do about it? Nothing you can do about it. You will just spend your all the savings in those 10 weeks or 20 weeks, but the end result doesn't change 90%. But in 3 years, your 5 years, if somebody predicts something can happen to your body, looking at your lifestyle, your body structure, your genes, your RNA, DNA, blah, 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 and they can tell you that, okay, follow this. Obviously, then the ball is in your court. Still, you follow the same thing, you keep smoking, lung cancer is about to happen. You know it. It's just like that. Now, evening rain will happen, but you still did not take out the umbrella. Are you getting me? So don't take my these pointers lightly. And mark my words, after 10 years, maximum 10 years, 5 years to 10 years of time, a lot will be happening in the medical science using AI. AI is going to be tapped like anything into medical, pharma, medical, life sciences. Be ready for that revolution. Make sense? Okay, on this note, guys, I think let's take a break. But I hope you are getting hooked up to this, getting some good sense that wow, this is really interesting. And let me also show you the model they use. They have given this image in the end. Look at this. This is their convolutional neural network model on the images. Just understand this. Obviously, this is a complicated model. I'm not going to teach you this. And please don't ask me to do this lung cancer prediction problem. I have some protocols to follow, so I can't teach you this. Look at the loss and the accuracy. Can you see this? In the training and validation. Observe so close. I like this. So this journal, you should read about it and please read about it later when you are ready for it. But look at this, even for the training. So guys, blue is training and the orange is validation. Even if you put a lower line, right? After 500 iteration, you are maintaining easily more than 90%. Can you see this? Even you put a lower line, you put a lower bound. See? So this will be 0.88. So maintaining that 0.88. I think that's why they are saying 88, 89. So interesting, right? They have plotted a lot of things. Read about it. They have done ROC curve. Look at the ROC curve. So these are some confusion matrices, right? Okay, guys. So now I'll get into the, CNN detailed discussion. Okay. That's the module name. So CNNs. So the moment I write CNN, guys, you should understand it. I'm talking about convolutional neural network. Have proven very effective in image recognition and classification. Image recognition and classification. Okay. So what is the implication when I say this? So, it's a really successful in identifying faces, sketch drawing, putting into a digital mode and identifying the criminal through the database. Guys, if you just send an image, no fingerprint, how will you identify a criminal? How will you find the social security number? Have you seen these movies? Don't think it is all fake. It's all real. So they have a database of all the top-notch criminal, right? In CID, they are using, even in India, it's not like they have to do it outside India. They have these mechanism. So identifying faces can be a real use case in these kind of world, right? Like somebody has a red corner notice, right? So let's say I'm the Vijay Malia or likes of them, right? And I am done some fraud and I can't travel outside, right? You have some restriction. So one way is that to stop it, right, or find that person is that capturing images from traffic signals, right? Because they will be traveling and process that in the database. Make sense? So objects, traffic signs, right? You know, apart from powering vision in robots and self-driving cars. So just understand the length of the use case, length and the breadth of the applications and the use case, right? And these are some well-known, example I'm looking at it. So if I show you these few images from the screenshot, guys, I have, just observe this. So, CNN can read and generate this, okay, for you that what is happening there. So soccer player is kicking a soccer ball, right? Likewise. Make sense? Before I get into the detail of it, right, I'll show you the journey of, CNN, okay? This is the timestamp CNN is having. Can you see this? So the first convolution neural network was introduced in the year, right, 1989. I think some of the guys were not even there. I'm talking about the college guys, right? Isn't it? So what is the timeline of CNN? You see this, right? 1989. So don't think that it was foundation was long led, right? It's not like something a new thing. So if you remember, I mentioned that in 1950s and 60s, perceptron got onto the canvas of AI. Remember that? Don't forget the guy, Frank Rosenblatt. He's the guy who introduced perceptron in 1958. Do you remember that? I had mentioned that, right? 1958 perceptron came. Okay, maybe I'll revise for you guys. This is very important. You have to understand the history. So perceptron could classify binary patterns, right? It has limited abilities. 1980 time, right? New cognitron came into the picture, and that was done by Kunihiko Fukushima, right? It is coming from Japan. So it was more, you can say that the early version of neural network, convolutional neural network, right? 1989 convolutional neural network came, and Lennet, right? So Lennet is an architecture name. So this is the early stage, but 1998 time, right? Lennet 5 got published. So they have missed this. But definitely they're doing research for the longest time. It's not like that they came in. So 1998, Lennet 5 published, and Lennet architecture, also known as Lee Kuhn, okay? So the guy was Jan Lee Kuhn. He developed the first convolutional neural network. I'll write a pointer. First convolutional neural network to do handwritten digit recognition, which we did with ANN. So they obviously they tried it with existing use case, right? That's what you will do, right, guys? Come on, Eson. So they did it for doing the handwritten digit recognition, right? That's the first practical application of Mr. Jan LeCun neural network. Okay. So far with me? Good. Then 2012 time, AlexNet. So AlexNet, this was a competition, and AlexNet was, I think I would say, like, it was developed to do a large scale visual recognition challenge. So there was a challenge going on, which is called image set. sorry, ImageNet, large scale. This is all research field nomenclature, so don't get overwhelmed with just this is the history and we should respect the history. Visual recognition challenge. Just like Kaggle does it in a simplest way of saying it, ILSVRC. It's a big challenge. You can Google about it later. So, in this, and I'll talk about it, AlexNet, they used ReLU. Can you believe it? The first time they used ReLU as the activation function, which I was teaching you guys, right? And that guy also used the concept of dropout. You might have heard dropout, but I'll teach you. And leverage the GPU acceleration. A lot of people don't even know what they mean by GPU acceleration. Using all these things, guys, he was able to do a great job. What was the job? The job was to predict or to make deep CNNs, deep is like deep learning, feasible for large scale image classification task. Just imagine that. Okay. So this architecture was able to do quite a lot of, impossible tasks. So you can give hundreds of thousands of images. It can do a right classification with a very good accuracy. Okay. So far with me, this is what happened in 2012, guys. Okay. In 2014, right, you might have heard about VGG. So the guys, Karen and Andrew, introduced VGG Net. So VGG Net, these all are architectures, guys. I'm not going to teach everything, right? Because architectures are not in the core, because it's not like a in-depth, but VGG 16, 19, Google Net, RCNN, they all came in 2014. 2014 time, right? They were able to use a lot of more filters, layers, make it more complicated and getting some better result than the AlexNet. If I have to keep it very simple. So they were using convolutional filters of different sizes, right? To do a lot of more detailing there. 2015, ResNet came into the picture, which is also known as fast RCNN. So ResNet was, mind-blowing, Miss guys. So RCNN, right? It was doing training up to very deep. How deep? The 152 layers. Guys, you understand what is the meaning of 152 layers? Let me show you one image, which I have given you guys. So suppose these are like 5-10 layers, right? Or you see it here, some layers. Okay. So how does a CNN look like? CNN layers, you realize. So let's say this is a CNN layer and you are just seeing 4, 5, 10. They are telling that I can go as deep as 152 layers. So let's say this is your CNN layer, guys. And then you realize that when I make this word or statement 152 layers, you should be like, your eyes should be open. So this is a very simple CNN, guys. So I know it's not very visible, but let me show you there. This image is bullshit. Let me delete, guys. See. So guys, can you see this? You are not going so many layers, right? Right? You have starting from the 1 layer, 4 feature maps, 8 feature maps, 4 class units. So layer wise, if you see, there is like 1, 2, 3, 4, 5, right? And you are stopping there. But what I'm trying to say that in ResNet, they are telling that they could go up to 152 layers. Okay, just imagine one behind the other, one behind the other in the sequential. Okay, makes sense? This is what ResNet gave it to. So see, the structure remains the same. Only thing they were trying to do some more layers, get better results. That's how any development happens, okay, to be honest. Now, in 2016 onwards, right, they are starting with the object detection by using yellow. I think yellow is something you might have heard about it. It's a very famous thing. You only live once. It's not that yellow. It's a different architecture. You only look once. It's not you only live once. Okay. So yellow architecture is you only look once. This is the name of the architecture. So this architecture this is the architecture you use in autonomous driving, self-driving cars. Can you believe it? Or video surveillance. These are some real application, guys. Video surveillance, right? So you only live once, right? Is one of the top-notch and latest development, right? And definitely they are going behind the scene, doing a lot of things. So now they have gone into 2020 onwards. They have started testing the vision transformers. I don't know how many of you guys know, but YOLO is known for doing the object detection in real time. You know that self-driving cars do it, right? It's the same thing which I have been talking about. Makes sense? But fast forward to 2020, which is not here, 2020 onwards, they are now testing not CNN, they are using vision transformers. You can read about it when you are there, also known as VITs. So to be honest, AI has seen a lot of traction in last few years. I would say last decade, to be honest. So they're using a lot of information. What is the beauty of vision transformer is that they use limited training data and can give you accurate result, which is really effective, right? So for NLP kind of task, it can be done very fast. Okay. Transfer learning is being done 2014 onwards. There are a lot of things which we need to discuss. Okay. But guys, in CNN, these are the keywords, and that is something I'm writing here so that someone should always come to me and ask that Akash, you did not teach this. Okay, so this is just for you to track in last few decades, these are the things have been done. I think relu activation you already do, right? You already know, guys. I have taught then the concept of dropout has come. So these are some advanced things being done in CNN. Batch normalization, I don't know how many of you guys are aware of this term. Priyank, have you heard? Batch normalization, dropout. And the last thing is what? Transfer learning. It's all in the syllabus, and I am supposed to teach you guys. This is just to track. This is all part of what, my dear? CNN recent developments. Okay? So once I complete the fundamental structure of CNN, I'll show you the application of this. Make sense? So far with me, guys? Come on. These are just here for you to note it down. Funny, I'm going there. What does what does it do in each layer? So that's my job. I'll tell you, we have not gone there, so don't worry too much on that yet, but I'll go there. Okay, this is it. Now let's talk about a fundamental architecture overview. Architecture overview, guys. A typical, I'll start with the typical CNN architecture. A typical CNN architecture consists of several okay. So guys, CNN layers, typical architecture. So number one is input layer, because this is nothing can change there, right? Number one is input layer. So let's start with input layer. Although you know it, but I'll make sure that you know it in detail. So number one is your input layer. So guys, you know, right, in input layer, what happens? The raw image data comes in a multi-dimensional array known as a tensor. So I'll write one line. The input layer of a CNN receives the raw image data in the form of a multi-dimensional array, also known as tensor. Okay. So for grayscale image, I think I spent some good amount of time on that. So for grayscale images, the input tensor will only have a height and the width, remember? So basically the input tensor is height, width, or you can say into 1. But 1 is nothing. 1 refers to the signal. So I'll say, what is H? H is the height of the image. And see, height of the image can be decided in pixels, centimeter, inches, whatever. Generally, we take number of pixels. Okay. Number of pixels, but taken vertically. Just, refreshing a memory. What is the next one? Next one is width. That's your width of the image. And what's that? That's number of pixels horizontally. That's my first layer. And what is 1 refers to this point, guys. So what is 1? 1 is like your single color channel, which is grayscale. Single color channel grayscale. This is for grayscale images. For RGB images, guys, colorful images, the same thing, you will say input tensor is what? It will be height, width into 3. And I'll highlight that's the only difference. Everything remains same. What is this thing different, guys? Here 3 represents what? What are they? It is red, blue, green. Red, blue, green. Very good. So this is your input layer done. You don't need to do anything. This is the layer. Moving on, guys, quickly. Second is what? Convolutional layer. That's a new layer, right? This is the core building block of your CNN. Core building block of CNN. Without this, nothing can happen. So in this, what you're doing, it applies filters, also known as kernels, right? Not colonel, kernel. Let me write, you realize. Also known as kernels. That's a mathematical term. So it applies filters to do what? To extract features like edges, corners, textures, etc. So what I'm trying to say, guys, convolution layer has the filters which extracts these things, okay, like edges, corners, texture, etc. Continue. The filters slide up on the image, slide over the input, and this process is called convolution. So, right, this process is called convolution. Why I'm doing this? This process is called convolution, and the filter slide over the input, and this process is called convolution, and it generates a feature map as the output. And I'll show you by taking some examples. So don't worry about it at all. Okay. So how do you do it? Understand the steps first. So guys, it's more like you are sliding a filter over the input to get what? The feature map. Just focus on the highlighter, right? I'm going to show you some real fun thing for the day so that you go like with a lot of ideas, right? So have you seen the tic-tac-toe game? I think everybody has seen tic-tac-toe. Every bacha has seen. Can I say that? Tic-tac-toe. Those who are struggling to understand what is this is it. Guys, you can't say no, right? So what I'm trying to say that, guys, I have image, right? Two images. If you look at the pixelated form of X, O. So guys, I'll keep it like in my layman terms. So this is like your letter X and letter O or 0, whatever you want to say, right? Let's not fight over this. Can you guys see that? It's a very, if I just make it tiny, you will see that it is, we're putting the O, right? If I make it tiny, it looks like you're putting an X. Guys, with me? Guys, say something. I need now frequent good to go on this. Okay. So if you see this, it's a very simple image. How many pixels you have? You have 6 by 6. See, 1, 2, 3, 4, 5, 6. So it's a 6 here on the width and 6 here on the height. It's a very tiny image, to be honest. It's a 6 cross 6 pixels for both the images. Agree? So total how many pixels? 36 pixels. Okay. Now if I have to use this in my normal neural network, what I have to do? In artificial neural network, I will flatten it. Just understand this. What I'll do, I'll flatten it. So basically, this is how it will look like. See, I've put someone has done real good job on this, right? So you see that images are making a lot of sense. That's why I'm taking this example. It's up level, right? From somewhere I have referenced this. It's like taking each of the guys like this. Observe the pattern. So go like this. So see 0, 0. So wherever it is, it's a very simple. Wherever it is 0, it'll put a white color. Wherever it is 1, it is dark. Can you see? So it tries and keep it till the last. So basically, you are looking at what, my dear? You are looking at one single column of how many nodes, how many neurons? 36 nodes from the input nodes, right? So basically, it is a 1D flattened array. If I do this in the convolutional, sorry, ANN, agree? Now, if I have to go and complete this, it will look something like this. So what I'm saying, guys, here we have 36 connection from the 36 input nodes in the hidden layer, right? Guys, observe, this is how we will model it now. Correct? Suppose you have more neurons. So this is just one neurons. So you have one neuron getting connected to 36. Suppose I say you have two neurons. So it will look like what? Like this. So if you can see, the first one has how many connections? This has 36 connections. Means 36 weights and the bias, right? You have to do. How many this guy has? There are two neurons. So this is 36 and this is 36. If you do a plus, how many are there? 72 connections. Can you see that with every one, right? It is going like, my God. Makes sense? Just imagine that you have taken this image like a 1 megapixel. Not even saying, guys, 12 megapixel and 50 megapixel. 1 megapixel is like what? 1 into 10 to the power 6 pixels, right? If you take square root of this, that gives me the height or the width. So means 1000 pixels in the height and the 1000 pixel in the width. Guys agree? And that will make an image of how many? 1 megapixel. Agree? This gives you 1 megapixel image. Let me write fully so that you don't get confused. So can you see that? So for one neuron will have how many connection, guys, in CNN for this kind of input? It will have 10 to the power 6 connections. Means 10 to the power 6 weights. Are you feeling the complexity, guys? So what I'm trying to make a point that for a neural network, I'll write also, for a neural network having 1 into 10 to the power 6 input connections, for a standard size image. Yeah, 1 megapixel image is a standard size image. Now I have digressed away from the tic-tac-toe. The model needs to estimate 1 million. I have only taken a 1 megapixel. So the model needs to, it's a standard size. The model needs to estimate 1 million weights for each neuron which is computationally highly expensive. You guys agree? I think you have to. So do you think this is the effective way of doing this is the effective of doing this thing, guys? Which is computationally highly expensive. I changed the color because I did not like it, guys. I have this power. Which is a big turn off, right? So it's not effective at all. This is what scaling we are talking about. This is what they were telling. No, Lennart, AlexNet, they were talking about the scale. This is called scale. So what we are trying to say as a conclusion, and this is something, if someone is really testing your knowledge, they'll ask this question. Applying neural networks, the basic one, the basic version, right, the vanilla version, right, is not the right approach. Agree? I just showcased you the problem. Millions of weights, how will you estimate, right? Just for an image classification problem, right? The reason is that as it does not scale, and it does not scale well. Make sense? Where CNN comes and help you, CNN says, hold on, let me come and simplify it. So CNN comes and simplify it. I know you might be thinking, how does it do it? That I'll explain in a moment. And make it computationally less heavy. So mathematics is tricky, but the straightforward computation is not. So what CNN does, CNN does, the first thing is to reduce the number of input nodes. Okay. So I'll write CNNs do 3 things to make image classification practical. And what are they? Number 1, reduce the number of input nodes. Right? We just saw that. Number 2, tolerate and we will discuss more. Tolerate and accommodate the marginal shifts in the pixels. So let me first write and I'll explain. Marginal shifts tolerate and accommodate the marginal shifts in where the pixels are in image. In the pixels within the image. This you will not understand as of now, but I'll show you. There's the third thing it does, that mind the correlations in the image, complex image. Mind the correlations in the complex image. Okay, hold on. So I'll show you all those things. Don't worry about it. So first thing first, guys, let's understand one by one these things so that you get a fair idea of what I'm trying to do. Okay. So let's say this is our image. Let's explain the first point and I'll keep it short. This is the first thing they do, right? Step one. Let me also do the color coding. I'm talking about this part. Guys, reduce the number of input nodes. How will it happen? So what it does, guys, it will apply a filter. And there are a lot of different types of filters. So on top of this, this guy is saying, I'll apply a filter. So CNN applies a filter to the input image. And there are different types of filter. If you are aware, Priyank, some of the guys are having some good awareness. So they will think like, okay, he's only talking on one filter. I'm starting with one filter. I'll tell you all the filters which are important for your course. Okay, so don't worry about it. So this is also known as filter, also known as kernel, right? As I mentioned. So we're going to apply this filter on top of this image. Can you see this? We have the base image at 6 pixel by 6. I'm just taking a baby example so that you don't get lost. Okay, so don't think why is not taking a complicated example. Nobody takes it, right? And I'm applying a filter on top of it. How many pixel by pixel this is? Guys, come on. These are my instruments, and thanks to the guys who put together these things, I like it. If you observe, on the diagonal, it is only having the ones. Can you see this? If you observe this filter has a specific properties, and every filter has its own characteristics. But can you see this? It says that on diagonal, actually it's an off diagonal. So on off diagonal, in matrices, there are two diagonal, principal diagonal and off diagonal. This is the principal diagonal. So on off diagonal, values are 1, rest all 0. Can I say that? And rest all 0. With me so far? Now, in your head, you have to understand a point, which I'm trying to do it. So now, on off diagonal, values are 1, rest all 0. So what I'm trying to say that we will take this filter, listen to me, and we will start overlaying here. See. Can you see this? 3 by 3 pixels. Observe this, guys. Come on. Then move around. Are you feeling the same thing which I was starting the class today? So what I'm trying to say, see, guys. So this filter will look like this. I have an image. Only focus on that part. Guys, can you see this? So what I've done in this image, everything which is white, it is 0, 0, 0. And wherever you see black, it is all 1, 1. There is some data, some information. Good. So this in the background, there is an input image, right? And you're applying the filter on top of it. Hello? With me? So this is the image. Keep an eye on the image. 1, 1, 1. Let me write 1, 1. So that you don't lose this image in front of your eyes. And rest, everything is, my dear, 0, 0, 0. Even I don't need to write. But the first border is this one, guys. Agree or not? I'm doing the partition. This is the first filter that I can just draw this on top of it. See? Right? See? Now, this is like a coincidence that wherever this filter thing is like 1, 1, 1, 1, 1, rest is also like 0. So if you multiply this, so, it's a dot product. Okay, so everybody, in convolution, this is a convolution layer, right? In convolution, you are going to do the dot product. So dot product between the input and the filter, input and the filter in the overlap area, right? Overlap area, only in the overlap area. And hence, we can say that the filter is convolved with the input. This is the step when you're overlapping it and doing some calculation to find something new, which we call as feature map. It's a fancy word, but the fundamental principle is that finding the overlap. So guys, if you overlap and multiply, what you will see? 0 into 0, cell by cell you do it, right? Then plus 0 into 0. Don't miss it. Then 1 into 1. Observe this, my cursor. 1 into 1, then go on. Plus 0 into 0, or maybe I'll write it below. 0 into 0, right? 0 into 0, plus 1 into 1, plus again 0 into 0, plus 1 into 1, plus 0 into 0. I think you can already see that the number would come out to be what? 3. Very good. This is the dot product. So remember when I was teaching you basics, gradient descent and all, in dot product is basically what? Dot product in algebra is equal to sum of products. Dot product basically gives you what? Sum of products, na? Isn't it? We have done sum products. Observe this, na? So dot products always give you this sum of product. Okay, makes sense with me? Just keep this in your head. Right? So you got the first layer value, So what I'm saying that you will have a feature map shape only, and you will come here and say, okay, I got this value as 3. Makes sense? But that is up to us because we can also put a bias to it. That's where the bias also comes into the picture. So I said, okay, if it is 3, no, I'll pass it to a bias term. And the bias I'm setting to this model, and this is ultimately the algorithm will do. Whatever the number will come, I'll subtract -2. Guys, can you see this? There's a concept of bias also, right? Isn't it the same thing we're doing in the neural network also, right? Some product of the weights and the input feature and then a bias. Tell me if a 3 goes and -2 happens, what is the final outcome you'll get here? 1. So you say not 3, it's 1. And there's a reason here. Okay? You're using this bias for the reason. So guys, now let's move on. Let's move on to the next part of the story. But I'll also give you the image, which I think important for us to show you that how it has been done. The same thing I've done it manually to show you, but you can see the whole maths and you will see there is a concept of bias, right? The same thing and the feature map will be shown like here. So it goes through the bias, like I have shown you guys here. It goes through the bias and the feature map which I have given, I can move it around and show you. Make sense? It's the same thing I have written here. but I also want to show you pictorial nice diagram. With me so far? So one has come. Definitely this box is ready. Now what you will do, you will shift by a pixel. So next step. So what is the next step? You will shift by a pixel. It's so interesting, to be honest. Next, shift by a pixel. So what you will do, you will take this filter and you will slide. You will say, dude, now go to this guy. Can you see this? See? So I'll show you in the image so that you don't miss it. Good images always help you. So I'm showing you here. See? So you shift by a pixel, again do the maths, right? I'll do it for one more so that you get the confidence. So 0 into 0 plus 1 into 0. See, now things will start changing. 1 into 1 plus 1 into 0. Keep an eye on the calculation, guys. 0 into 1 plus 0 into 0 plus 0 into 1 plus 0 into 0 plus 0 into 0. Guys, just focus. I think here I get something. The rest, everything is gone, right, guys? Come on. So I just get the value equal to what, my dear? Come on. 1. Then it will go to a bias of -2. Right? So finally, you'll get what? -1. So the feature map will get updated to -1 and here also -1. With me? So far with me? So guys, if you do this, so you know, right? You'll keep doing this. So it will come here, it will come here, and then. So actually, we'll get a 4x4 matrix. And later you can go home and do it. So obviously you're at home, most of the guys. So the final feature map looks like this. At least this is the output. So final feature map is this one. After this final feature map. This is what you call convolution. This is the output of convolution. So guys, you started with 6 into 6, 36. You are seeing 16. So definitely have reduced it, isn't it, guys? Come on. When you apply ReLU function to this guy, you also know what will happen. So ReLU will make it what? Anything which is positive, anything negative is 0, right? Remember that? Right? Anything positive is positive. So this is 1, 1, 1. Right? And we can set that. But this is 1, 1, 1. Why this is 1, right? Rest everything will be 0, right? 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, good. So far with me. You're trying to reduce the image size, right, guys? Come on. Recurrent neural network, RNN. RNNs, you can say recurrent neural networks, are a class of artificial neural network. So you can clearly see that it is also a branch of this guy, designed specifically for sequential or time series data. And this you have to keep in your head. Sequential or time series data. Continuing and writing, RNNs are widely used in applications that involve a sequence or order, such as language modeling, speech recognition, machine translation, like Google translation, Hindi to English, English to Kannada, right? Kannada to Tamil. So I can talk to Srini in Tamil. Obviously, I'll miss on the pronunciation and the dialogue delivery, but I can still say some words. Time series prediction. So all those, I think almost a decade back, Google came with the translation and many more applications. So don't think they are good for nothing, definitely, but it's like a very niche area. How many you need such use cases? It's not like high, okay. I feel RNN is taking us closer to the human behavior, right? Generally, this is a question that why we use RNN. So maybe I'll write this question. It's an interview question, guys. And you know me, I keep giving you this kind of question. It's like a pro tip means interview. So why use, before I get into the depth of RNN, my question is to you, why use RNNs when we already have CNN? Could not we have used CNN for these tasks? Question. You know that as a matter of fact, CNN can't do these things, but why? CNN cannot deal or cannot handle previous history. It cannot remember. It's like Ghazni. You know, have you seen Ghazni movie? Amir Khan, and there's another movie, I think a Telugu movie as well, right? They are going to shoot the Ghazni Part 2. So Ghazni movie is there, right? So this Ghazni movie or Tamil movie, I can be wrong, but the guy forgets things he only can remember for 15 minutes, something like that was in the movie, right? Short-term memory, right? So when I'll teach long-term, short-term, right? LSTM, long short-term memory. So I'll be going to anyway talk about it. You love it. The Ghazni resemblance, I will bring it up. But that's the problem with the CNN, guys. Okay, that's the problem with the CNN. CNNs are really good when you have to understand the image. What is this relationship between the spatial pixel relationship? But it cannot, local speciality, right? But it cannot remember the sequence in which you have inputted the data, right? It can't remember that. So I'll detail it out for you. But a very high level, I can say that CNN is really good for any image related stuff, as you know. Why? Because it is good in handling spatial relationships between pixels, and that too, in the local relationship. But it cannot handle the sequence of the events, right? Or the sequence in which you're entering the words. Like I'm saying, hello guys, how are you doing today? How was the week, right? It does matter if I say hello guys. I'll show you. So this generally I say, right? Hello guys. If you say this is my pet line, how are you doing? Or how are you? How was the week? Now just imagine that, let's say everything is an input. So I know every character is an input. For simplicity, I am making boxes, right? For CNN, everything like one input, and it can take in any order. So what CNN will take it, like it will say, are weak guys, hello, right? Are you getting it? You, the, how. Are you getting? There's no sequence. Now, if someone is saying this in the class, saying, are weak guys, hello, you, the how, right? You will say, who is this guy? Is he gone crazy or something? Because you don't know this. There's no way you can, I give you a jumble of words and you make some meaningful sentences. Generally, we used to do that, right? You understand what I mean? So generally, we used to jumble the words, and this happens in some government examinations like that. So you make a meaningful sentence using those jumble of words. But who talks in that language? Yeah? Nobody agree with me so far? So this is like totally beyond comprehension. So I'll put a line to it. Non-understandable, as there is no sequence. Okay. So let's talk about it more. So now I'll answer it, guys. CNNs, which is convolutional neural networks, are extremely effective for processing data with a fixed spatial structure, like images. Isn't it a fixed spatial structure? You say that you have an image of 32 by 32 pixel, right? And there is nothing changing in this, right? There's no dynamic sequences coming up. So it can quickly handle this. Okay, I'll continue. However, CNN lacks the ability to maintain context. Guys, in natural language, context is very important, or process sequential data effectively, right? We know as a matter of fact. So what I'm saying that CNNs excel in tasks wherever or where the spatial relationship between pixels matter. And when I write this now, you know what I mean by that. But they're not designed, so I'll also tell you that, but they're not designed to to capture relationship in the sequences. Just like I have shown above, right? That how do you guys, if I'm saying differently, you'll not understand it. Okay, this is very high level. I maintain that whenever you have an image and you want to find spatial relationship between pixels, it will work for you. Who will work for you? CNN. Can CNN use to process video? The answer is yes, but not the natural or the inherent CNN can do it. They need, some more advanced version of it, which is obviously we are not capturing here. So you might have heard about 3D convolutional neural network. So you'll go, so right? CNN is for images mostly, but CNN in combination with some other architecture, it can do it. Okay. So there's something called convolutional LSTM. There is 3D networks, 3D CNN, two-stream networks. So I'm just, giving jargons here, but CNN can be, so what CNN does, right? If you take pictures, they're all images, right? And if you just, play 32 pictures or 32 frames in a second, it becomes a movie. You know that? It becomes a video. I think this is something a basic GK. Okay. Now, though it's going more than 32 frames. So if you just start showing images 32 frames per second, to human eyes, it looks like a movie. That's what I'm saying, guys. Okay, at least this is a basic definition of a video. So now since CNN can only look, right, one image at a time, right, that is CNN. But you also need to capture the sequence of it. That's where you have to either apply CNN with LSTM or CNN with RNN, or there are some more architecture, etc., to analyze a video. There are architectures. Okay, so you only look once is like is a real time object detection algorithm that uses a convolutional neural network only to predict the class and bounding box coordinates of objects in an image. It is still an image, guys. Okay. But guys, I'm not getting to detail it out because then I will, gives you the coordinate. I'll show you a real image which is famous on the web. So this is, you have seen, it comes on the LinkedIn. A lot of people keep doing this. I have seen people doing this. So this is somebody's screenshot I'm placing here. Can you see that? So it gives you a lot of details in an image. Okay. It's still a CNN. It is not like a 3D video analysis you're doing. Okay. So for dataset is a facial recognition dataset kind. It's just like our those 10 classes, right? So CNN is more preferred because it's more like a classification task, right? As it's an image classification task. You understood? You're not trying to box the image and find object in that, right? So that's what I'm trying to say. It's still an image classification task. You're not trying to find who is person, where is the traffic light, right? You're not doing those stuff. So you don't need yellow for this. Okay. RNN, at least you're getting a sense that it tries to store the sequence and then tells you things, right? Okay. So whenever I say sequence is so important, buddy, that you realize this. I think a lot of guys must have tried this. Have you seen this? This is coming from the Google Translation website, guys. What I'm doing here on this screen, guys, I'm saying, did you eat biryani with Amir? Right? Can you see this? It's a Google translation. Source is Google Translation. So what these guys are doing here, when I say, did you eat, right, biryani with Amir, it is trying to not only sequence these words, it also tries to remember, right? क्या आपने आमिर के साथ बिरयानी खाई, right? It has to be lexical correctly, grammatically correct. So I'm asking a question. Did you eat biryani with Amir? It's written in English, right? Just understand. This is English. But here, Amir comes in the third place. Can you see this? Observe this. Where is biryani? Biryani is in the second last word in the Hindi, right? And Amir is coming in the third place. Just observe the color coding, guys. Everybody, please pay attention. Just tell me one thing. If RNN would not have the memory, right? Do you think it is possible to write different languages having different grammatical setup? This is one of the very key thing I'm discussing, guys. right? If I just do this to Tamil and Telugu or Kannada, right, you will see biryani is switching the position. Agree or not? See, I'm not a champion of other languages. I'm good in Hindi or English. I'm doing it, and I hope you also understand a little bit more. Don't get into this controversial discussion that Hindi is the best. Every language is the best. Language is a way to communicate. So then don't take it so hard. So I'm not getting into that zone. I'm saying that did you eat biryani with Amir? In English, this is what it looks like. In Hindi, look, Amir comes here, which was the last position. It understands that it's a, so first if you write something, did you eat biryani with Amir? There are a lot of stuff happening, by the way. So it goes through this translation, but it first understands each and every character, its positioning, its meaning, and then it generates. So it's like first it takes its, then generates the response in Hindi, saying that same stuff in Hindi, giving the right position for the words in Hindi without losing the meaning, without losing the context, without giving any confusion. Isn't it brilliant? I'm not saying that Google Translation only uses RNN and it's doing everything. No. I'm saying that I'm just making a point. Use cases like this, right? Use cases like this that definitely needs to remember things before you can do anything. Agree or not? So what I'm trying to say before I go anywhere, guys, you guys agree with me? So this is in Tamil. Now different language, look at the beauty of this. So this is Amir, the popal, what are the popal? And this is biryani. Look at the language has changed. It's Tamil, right? Positioning has also changed. But the same thing can generate this in Hindi and this in English. You don't need to change the left side. You agree? So what it does, it not only takes this character, the word, the positioning, everything it remembers. So what I'm trying to say, RNNs imitate the function of human brain where it tries to model the sequence data like conversation, like human conversation. So there's a friend who is not happy that you ate biryani with Amir. Definitely he's not happy. That's why he's confirming. I'm just making it up. Did you eat biryani with Amir? Means he's not happy about it, right? How can you miss me? And it can identify, which is more like I would use the word anticipate sequential data in a way that other algorithms can't. That's the power it has. Oligo means algorithms can't. I don't know how many of you guys seen this. When you write something on the Google, it predicts it. Suppose I'll show you an image. Is the market going to crash? The moment I write, I'll show you. Those who are investing in market, I'm just making an example. Don't say anything. Is the market is going to crash? The moment I start searching the Google, I'll write source Google as Google might. These days Google can be a little tricky. Source is Google. Definitely we are using Google. So when I write something, is the market is going to crash? Understand. Is the market is going to be crash? I have not even completed it, but it has given me the top ones. How do you think it works? Right? So it can do ranking. You can say that suggestion. There can be multiple ways. So I know it can be a little misleading and confusing. That, okay, guys, this is just like ranking of the search people are doing and showing in that sequence, right? I understand. But you know what? Google has this feature that auto completes it. And I have talked about it. You remember that auto completes the sentence. And that called Google Smart Compose. Agree? But it can only be possible when it remembers things, right? Google Smart Compose is one of the very good use case. Google Smart Compose is one of the very good use case for your RNN. I'm telling you. So why this is the hot topic? Because if you see now, a lot of people are searching this. Generally, people are always going to search this. I think Google Smart Compose, I'll jump to this. I realize that this is not a very direct example. So I'll talk about Google Smart Compose. There's something called Google Smart Compose. Okay. So when you write anything on the Gmail, right, it tries to predict what you're going to write and gives you some suggestion. Okay. Agree or not? This is called Smart Compose. So what is with the Smart Compose, right? Google's Smart Compose feature suggest, or you can also say anticipates the words or phrases to complete the sentences while typing. Okay. You know what? As a matter of fact, it's in the data, it's in the web, that it was originally Google Smart Compose has definitely come a longer way now. But the first time they built it, my dear, you'll be amazed to know it was originally built using a form of RNN. So guys, these guys are like legends, right? Using a form of RNNs. Obviously, it was also having, that's why I'm saying none of the Google application just one algorithm with long short-term memory, LSTM. So you know why I'm not able to go and build you for like a smart compose? There's a reason behind it. It's not a joke. But why I'm taking this example, then the cross question will be like, Akash, then why the hell you're taking this example? To show you that if you are an expert of this or you want to pursue something, there are some real life application which everybody is using. Like it's a real life use case. Guys, can I say that? Everybody is using it. So whenever you combine this deadly, guys, RNN and LSTM, you can do n number of things. Trust me. So that's why I'm saying, this is the topic of advanced deep learning. Now you're getting deeper in deep learning. So just to give you some evolution or Smart Compose thing when it started. So Google first launched Smart Compose. They were leveraging RNN with LSTM, right? LSTM is known to track the sequence of the words to a great level. Means it can remember what you wrote maybe 100 words before. And that was helping them to predict. But once Transformer came, not that movie Transformers. So when the transformer based model came like BERT or GPT is a transformer based model, right? They showed right significant improvements of over RNN and LSTM. So what Google and other tech companies did to do some text prediction tasks, they moved from here to there. So what I'm trying to say, transformers outperform RNNs because of attention mechanism. There's a concept of attention mechanism, and that helps them to beat RNN LSTM. Okay, are you feeling it what I'm saying? Maybe I'll also write quickly so that you don't miss on this. So this is so I was talking about how does Google Smart Compose evolve. God knows what they are using now. Google doesn't tell you these things, right? Obviously, these are their IP, intellectual property. They'll protect it at any cost. So what I'm saying, guys, obviously, Google first launched Smart Compose leveraging RNN plus LSTM to handle long-term dependencies. Okay. When I'll teach you LSTM, you will know that LSTMs are known for or can keep track of earlier words in a sequence. That's the beauty of LSTM, which allows them to better predict subsequent words. But later, as transformer-based model such as BERT, GPTs emerged and showed significant improvements over RNNs because they also keep doing research, right, to make better things. So it showed over RNNs and LSTMs, Google transitioned to using these models for text prediction. This is called text prediction task. You're predicting the next word, right? It's text prediction. Trust me, it needs a lot of power, compute power, money, and then you can do that. Okay. This is the evolution. I don't know. Transformer based model is the latest I've heard. But why don't know? God knows, are they doing some more testing on some new world of the models? Only Google can answer that. But this is a very, I would say, one of the coolest application of RNN, guys, which you are using till date. But obviously, it was initially a use case of RNN, but now nobody is using RNN. So you might be thinking, then Akash, why I'm even learning RNN, right? Thinking, na? How many of you guys are thinking on that line? So मुझको RNN क्यों पढ़ा रहे हो? Why are you teaching RNN? It's like you are still going to learn linear regression, even you want to do decision tree and XGBoost. This is the route you have to follow, right? So you're starting from like a baby here. You have to go all these journey milestone you have to achieve to be here. Now the question is that how fast you can go, right? That's you can decide as a learner. But you can't just jump. I keep telling this. We need to go through the foundation. Else you will be just knowing steps and transformer. It will be just like a wannabe. You know about encoder, decoders, right? Transformers, you know, learning, you know, transfer learning, but you're not going to be an expert because your foundation is weak. Okay. It's not like multiple people are writing the same mail reply, right? It's not multi or parallel thing. I think it's more on accuracy, the kind of prediction they're doing. And obviously, LLM models have attention mechanism, right? Those transformer based or GPT models and now LLM models. So they have better ways of handling that. But these models are having more control on the context. They can obviously they can keep history, more history. They can better use that information for prediction in the text prediction use cases. That's how it is better. So now you see when ChatGPT also came, now it is able to frame its sentences like human beings does, writing like a human, right? But obviously it took a lot of training, a lot of work. But now the GPT models are the latest available to human as an application where you can actually do anything. You can just write, copy your mail and say that, can you reply to this mail? And it will do a great job. I've tried those things. So obviously I'm not getting into the details of how is it better because that's not the scope here, but it's a big discussion. Can't start suddenly, but definitely it's better. That's why it is replacing the older version of it. RNN. Is transformer based on RNN? No, transformers are not based on RNNs. So it's like a pre-trained models, right, which can do parallel processing, having the attention mechanism, and they do not rely on sequential processing. But no, transformers and RNNs are two different things. RNN follows sequential processing, transformer does parallel processing, and there are other things. Okay. Okay, let's move ahead. I think it was a good discussion on RNN. Okay. Guys, I'm more of an application kind of person, right? Means I'm not the guy who know everything, to be honest, but at least I will be knowing what I am to teach. So it's a vast thing, it's a vast world. But yeah, I don't know how many guys are aware of this, but Grammarly is another application. It understand your use case. So these are some plugins coming from these companies, Quillbot. I'll give you the links so that you know that okay. So Grammarly is something you must have used. Quillbot. So I'll give you the link. So Grammarly has become a big company. It's a now to they must be using some OpenAI kind of stuff. So don't worry. But I'm talking about the Grammarly when people were trying to do this mail check and all. It was integrated to the Outlook. So now they're promising they're publishing their website like this. That dude, we are doing a lot of stuff. What do you know? So obviously every company is developing their research. So they're saying now they're using responsible AI. I'm damn sure they're using instance of ChatGPT or OpenCV. They must have trained. It's like their AI writing partner that helps you to find the words, the tricky words. You want to write a mail like an aggressive manner, right? And the Quill bot is something I'll show you also as a hands-on. Hands-on as like a use case. I'll show you through. So Quill bot is also very famous. A lot of companies are using this, right? So it will fix your grammar issues. Yeah, you can write better English. So you can do 8 tools in one platform. I'm just giving some screenshots. So that's why. So it can do grammar checker. So you can increase the fluency, fix mistakes, prevent plagiarism, right? This is amazing, huh? So if you are using this to write some article or a blog, you are unknowingly not, copying, pasting somebody else's work. You will be in a big soup. So generally, if someone is writing a content writer, they try to have this subscription and do it. So when I was in my master's, I think I had to do a thesis. Okay. So they give me a plagiarism checker. So in IITs, right, professor will validate your answer that you're not just copying, pasting somebody else's answer. You know that as a matter of fact. any good colleges will they do this, right? So that they don't, because your professor name is also stamped on your thesis if you are trying to do a PhD and all, right? FYI, I'm not a PhD, I'm just an MTech. Could not do PhD, not my cup of tea. Always wanted to be in consulting. So what I'm trying to say, plagiarism is one of the biggest thing. If you can just go through your article or your research paper, your journals, and you just get to know your similarity index is less than 30%, they will accept your work. Analyze text, summarize text, citation, translator, flow, right with AI. So I'm damn sure this is a new addition. But yeah, I also wrote them an article saying that, or like a mail that, can you give me a free version of this? They're like, sorry, Akash, who are you? So I'm damn sure when I become famous, little more famous, then they might come to me and say, please use our services. Okay. So the startups are reaching out to me saying, can you use our services, promote it, talk about it. But the big companies, for them, I don't exist anymore. Still not there. I think I have to do a little more hard work to reach that level. Okay. But I think good, interesting discussion. This is the introduction, guys, right? I have not talked about how does this work? What is the hands-on for this? Nothing has been done yet. So this is just the introduction bit. I would still say this is the introduction. Let me write introduction to RNN. So let's say I do some mistakes in grammar, right? So let's say Rahul do not like to reading a book. Obviously, it has some grammatical mistake. So you can clearly see that it has so quickly identified that Rahul, those who know a little bit of English, right? They know that Rahul with the name, you have to use, V5 form. So Rahul does not should be here. Rahul does not like to read a book, right? So if I just take a screenshot just for the reference, and I'm putting in OneNote. So the corrected is, suppose I click here, so it will correct this. See, Rahul does not. So I'll just take the corrected version. I'm putting in the OneNote. So when I'll publish this, you will see it, my dear. Okay. Then if I click here, look at this. So far we have come. Isn't it? It is, is it like your English teacher highlighting with a red pen saying it's all wrong, what you have done, right? So generally teacher, what they do, right? They say that this is wrong, and they'll write here, Rahul does not like to read a book. Isn't it? That's how the paper or exam paper or practice paper checking is done still today. Guys, just imagine down the line, AI is being your, grader for your grading. Makes sense? Cool. So now I am also showing you plagiarism checker. So the article is coming through this. I don't know how much credit they are giving. Yeah, upgrade to start. They're not giving me. But I'll show you some online free plagiarism checker. I hope free is like free. Yeah. So guys, this is an article I'm taking from this website, which is about the lung cancer journal. If I say scan for plagiarism, right? Grammarly is looking for, see, it's saying no plagiarism found. First of all, it's fully plagiarized. I don't know what this idiot is doing. Sorry about it, but I don't like this. But not every tool is good, yeah, for plagiarism. So this is completely coming from this website, guys. Let me show you. So how can not be plagiarized, right? Someone who is like R. Pandian has written this article. The whole thing I copied, pasted. Okay, let me try this. So that's how you cannot just go blindly and, take any of those application and trust it fully, right? So let me take it again. So this is another one. Everybody needs money. I know nothing is free in this world. There are no free lunches. Check 500 words for free. So let me check till here. It's okay. Yeah, it is doing something. But right, even in this application, you need your tool to understand things, right? Or at least able to compare text on the web through this, right? Agree? See, and this is so nice. At least better than Grammarly, right? It's 100% match. Why? Because it has to be, no. I just copied and pasted it. Just see, it's 100% match. And if I click here, it will give me the link to this article. So let's say go there. I say, okay, this is the same guy written this. Although I took it from sciencedirect.com, it is telling that it is coming from some Harvard, right? Very good paper. Very good paper. Did you like this use case? So it helps you to unknowingly, obviously nobody is able to mimic everything, but even if the percentage matches 50%, you will be in trouble. Okay. Text summarizer. So you can take this, the whole thing. I think now you are using Chat GPT, so you know that that whole text can be summarized. But here, this you can also do it. You can say that summarize this. See, so the whole thing it has read and summarized it. If I saying, what if we remove some sentences from this in the plagiarism thing you're saying, right? But still, it will be 100% match, right? Because it will match some other part of the chat, right? Got it? Okay, so this is all about Quillbot. You can try doing review of these things later. But yeah, that's all I wanted to show you quickly. There was another question which was asked in one of the interviews that why does feed forward neural network not good at predicting text? So guys, remember when I was teaching you artificial neural network, you have a feed forward, you have a back propagations, right? So question was mostly on that, why it is not that good or it is not at all good. So just to answer this and also telling the concept behind the scene, in feed forward neural network, the information only moves in one direction from the input layer through the hidden layer to the output layer. That's the direction. Any doubt? Anybody? You know this in and out? So what I'm saying is start from input layer to the hidden layer till the output layer. Okay? That's the flow. But this flow has its own problem. And what is that problem is that feed forward neural networks has no memory of the input or the order of the input they receive. And that's the reason order is also important. Let me highlight this. Order of the input means what? Remember in our use case, right? You have X1, X2, X784 inputs, right? Now all these guys are connected in parallel. Remember that? Suppose even if I take one neuron, all these are connected. Now who is going in what sequence? There's no sequence at all. Now all going towards to the neuron at the same time, right? Hello, in a layer. So there's no sequence at all. There's no order. So there's no order. So, and that's the reason they are bad at predicting what's coming next. It's like you have no idea what is going to happen with your career because they don't know at all, right? There's no sequence, there's no intelligence there, nah? So on contrary, so I'll just add also, on contrary about RNN moves the information through a loop, which basically means that when it makes a decision, it considers the current input and also what it has learned from the inputs it received previously. Okay. So what it does, it considers the current input and also when it has also what is learned from the inputs it received previously. And obviously it's just a one line I'm telling, right? You will not understand. I know that. So I take a very cool example to explain. Let us explain the spelling of Apple. I took Apple because I like Apple products to a kid, like a 2-year-old kid. Let's try to do this. Suppose I am the kid here, okay? 2 years, 3 years of kid, right? Let's take 3 years. I don't know spelling when they teach. I have no clue there. Sorry. So don't kill me for this if I'm saying, oh, this is too much. You are trying to explain spelling of apple to a 3 or 2 year kid. This is insane. Don't kill me for this, okay? Let's say this is me. Just imagine spelling for apple is what? APPLE. Everybody, definitely you were a kid, right? Before, long back, right? If someone is telling you to remember the spelling of an apple, this is the favorite time pass of parents when some uncle, auntie come, right? Uncles and aunties come. The kid has to demonstrate. It's like, come on, beta, demo it. please, this is my request to all of you. I don't have a kid yet. We are thinking about it. Never ever do that to a kid. Don't demonstrate. Okay? Let the kid answer if someone is asking. And I think don't be that uncle, auntie also. You go to a house of your friends. The moment you meet a kid, you start asking, okay, tell me the twinkle, twinkle, little star. Come on. We need to stop these things. Okay? You should talk to the kid. What did you do? Right? How's your life? Not like a big question, like what did you play? Who are your friends? These are the questions they would like to answer. Not like a test here. Just imagine I'm coming for the very first session, start asking questions, right? It's harassment. Huh? In US, we call this harassment. In India, it is called parenting. Okay. So that is a point I want to make. But at least you guys agree to this. I think every one of us has been through this harassment. Now the kid is trying to explain, or just imagine they're trying to learn the spelling of apple or mango. They're two different fruits, right? Order is so important, right? So the kids say a kid is trying to recollect that apple. So they say them in their heart or in their mind, and they try to pronounce those letters of the apple word, right? Agree or not? Sometimes kid will say apple like this, right? Okay. Then so no, beta, you missed it. It has to be double P. So when you say double P, then he knows that double P means, or she knows that just P after P is double P. The moment I said just after P, right, there is an order and there is a previous memory that I've already told P just now, a fraction of second back, means now I have to tell P again because they are continuous, consecutive, right? Double P means like this, right? And now they don't have the apple means they will recollect that after the second P, L comes, right? And after that, there is another word, E. So this is how learning happens in case of a kid, right? You try to show images and then make them pronounce these things so that they keep rehearsing and they try to remember. Okay, there's nothing. So now it has become more scientific, the course curriculum. So they're talking about syllable, phonetics. There are a lot of good knowledge they are providing. In my time, phonetics was nothing in the syllabus. Similarly, for mango guys, they know mango means in their head they are thinking that I should start with M. Then they try to recall what is the next. Then next, isn't it a kid is trying to predict? Not literally predict because they're not using RNN model, but the kid's brain is trying to think, right? And that's why sometimes it's a tricky spelling. You also get stuck, isn't it, guys? So if I ask what is the spelling of a champagne, how many of you guys write it correctly without doing any cheating? So kid is thinking about these orders. You know what is the spelling of champagne? So this is the spelling of champagne, right? If I can be wrong, but I think I know it's a tricky spelling. I think I missed a A, right? No. So champagne is right. It's not a easy spelling. So a lot of people have, so I have missed A, I know that, but a lot of people, they miss this. They write chimpanzee. But let me give you the Google search for it. Let me search for you. This is how champagne is. So now if you tell your kid, maybe 8-year kid, they might also struggle. Don't take those spelling bees, those kids who are too good at spelling, they spell like this much long word. I'm not talking about those kids. We are not those kids. We are normal guys. Okay. So champagne spelling is something, right? A tricky one. First of all, champagne word looks like I'll start with S, but that's wrong. It's not champagne, but still champagne is little. So those who have good phonetics, like I think the South Indians have good phonetics than North Indians. They have good, their language is more difficult. Huh? You guys agree? Than all the North Indians. So the language and most difficult language is Surinese language, or next to Malayalam, right? So Tamil and Malayalam are the most difficult ones. The most easiest one is like Telugu and Kannada. Kannada language. The Kannada who speak Kannada is most easy compared to Tamil and Malayalam, right? Telugu is also fine. Okay, but trust me, the most easy language to learn is Hindi because I don't know what is the reason. It's because of the movies. What is the right reason to say that? Or it will be the language is simple. Obviously, Hindi is most simplest. Hindi, Bengali is also simple. Odia is also simple. But because of movies, Hindi is like prevalent in all the parts of India, even in the northeast. Okay, so I don't want to go into controversy of Hindi and all. I respect everybody's language, culture, rituals, right? And I have a have a strong feeling that if you're living in Bangalore, you have to behave like a Bangalorean. If you live in Tamil Nadu, you have to behave like a Tamilian. Then you are being true to their culture, right? Don't try to disturb the majority. You know what I mean? So behave and respect. So suppose, right? I don't know how much you agree, but I'm making a point. So you are just one segment, right? So then you can't be like saying that, okay, you practice what you practice, but don't try to superimpose your concepts on somebody else, right? That's not accepted. Okay. Yeah. So to be honest, in Bangalore, Francis, I don't know, have you been here or not, but Bangalore, everybody speaks Hindi, even the Kannadiga. So that's the reason it's very tough to learn language a little bit. And now in Bangalore, even everybody is speaking English and all. So you're living in Bangalore only, right? So you know that. So either English or Hindi. If you're practicing Kannada language, sorry, keep saying Kannada, but Kannada is the people and the language is Kannada. So Kannada language is not tough, but you need some intentions. I think my kids will be able to learn it. So I can tell that. Okay, moving on, guys. Guys, working of RNN is not easy to understand. Okay. How to explain RNN working in a simple way, right? So, I feel, how many of you are like a avid reader? Like you read a lot of books. I like to buy books. I don't get time to read books, but I like to read books. I have all the good books which I need. So when you're trying to read a book, right? Let's understand. This is a very cool example to understand the working of RNN. So suppose imagine a person who is reading a storybook like Panchtantra or any other books, whatever you like. So every time you read a book, right, you start reading each line and you try to also remember what happened in the previous line. I'm talking about us human beings, right? You're trying to remember what happened in the previous line so that you can understand the next line better. Isn't it? And what I'm talking about books like fictional books or Panchtantra ki kahaniya, right? These books are amazing because the story is so tight that you remember things. Like even I remember that Hira Moti Do Bal The because I studied that Hindi, right? I only read once Chitrakatha, Chimte. There was a movie. There's not a movie. There was a Eidgah or something where the guy buys the, chimta. Chimta, right? In Hindi we call chimta to flip rotis. I don't know. Those who have been in my peers to know this story. Eidgah, I forgot that buys chimta. No, yeah, I know. It's Hamid. So yeah, Premchand Eidgah. Yeah, I remember the name of the story. Yeah, so proud of myself. So just imagine, I'm older, so still I remember. So Hamid gives the chimta, that's the tongs, to his grandmother, and she felt shocked and started beating him. Right, but later she got emotional. It's a very powerful story. If you have not gone through this story, Munshi Premchand, he is from my place, right? I don't know, those who study Hindi, those who don't study Hindi or they don't know Hindi, so you can always say that. So he is from North India, UP, Banaras, right? So definitely Godan, Kafan, what a story, man. So suppose you're reading a story, coming back to my example, I got carried away because that's the impact. Isn't it? You try to remember the previous line, what happened, right? You try to sequentially understand what is happening so that you don't lose the grip. It happens in movies also, right? You go and watch a movie. If the story is not tight, the narrative is not that tight, or it also happens for the classes, right? Suppose I keep jumping here and there and haphazard manner I teach you, you will not be liking me as a trainer. Agree or not? Come on. So I try to go so sequentially that you connect the dots. You are able to connect to what I taught earlier with now. That's where the learning is enriched. It's immersive learning experience, right? So when you go to IMAX kind of theater, who definitely they charge a lot of money from you, but end of the day, you like to watch movies in there because the experience is mind blowing. So when I watched the last Batman trilogy, so I watched in IMAX 3D or something. It was a 2D or 3D, I don't remember, but IMAX is a different screen. Those who have been able to see, it's not in every place is in India. I'm not sure, but definitely it's in Bangalore. So you watch, it's a big screen, right? 88 or something. And then you feel like you are almost into the movies only, right? So why? Because you're able to connect to the dots. What dots? You can only connect to the dots when you look backwards. Steve Jobs said that, right? So that connecting the dots is all about RNN, right? So suppose if I stepwise breaking down. So let's say breaking it down step by step. This is interesting. So let me draw the analogy. So what is the heading, guys? Oh, sorry, missed to write the heading. Working of RNN. Let's start saying that, let us think, or let us say RNNs as a person reading a book, one line at a time. That's how kids read a book. So before you go and read a book, isn't it? You go in step by. What is step number one? Step number one is you read a word. Go slow, huh? So don't behave like adult. You have to behave like a kid. How does a kid read a book? You will read a word, right? Isn't it? So what I'm saying, when RNN reads the first word in a sentence, it processes the word and stores some information. Like suppose a kid and even adult, suppose you see the word gaslight, and I know you guys are too intelligent, too smart, but anybody who doesn't know what is the meaning of gaslight, don't Google. I know, yes guys, just Google it in a fraction of a second. That's the power technology has given to you. But trust me, when I was a kid, to know a meaning of a word, it was a tough time. Gaslight. Gaslight is too famous word in the corporate culture. Obviously, what you're saying is like, yes, it's like a gaslight, gas flame, 100% correct. But have you heard the word gaslighting? But there's another meaning to it, which is more important for us, and that's what I'm manipulating. So gaslighting is a verb, right? And generally people do this in corporate culture, psychologically manipulate a person over the extended period of time. Manipulate. Where does it happen? Everywhere. Okay, anyways, I don't want to go into the emotional nerve point, right? But someone can also say that in your class, sir, right? You are manipulating us for the extended period of time, right? I know, I'm just kidding. You don't have those kind of ill thoughts about me. I know that as a matter of fact. But you are also gaslighting, huh? The only thing which I don't do is gaslighting, I never say that you can be the biggest data scientist or deep learning guys after I teach you. The only thing I say that what I'm giving you is not easily available. It's tough. Not everybody is doing that stuff. That's truth. Okay, so when RNN reads the first word in a sentence, it processes the word and stores some information. Suppose you see this word in a novel or a fiction book, right? Isn't it you'll try to remember this word? Think like that. Come back to the real thing which I'm explaining, right? So it's like generally people what do, they used to write in a diary. So Rini, have you tried this? So people used to write. So I used to write in a small diary, pocket diary, right? Come on. Pocket diary, everybody. So I used to read the Times of India, the Hindu, and used to write. So that's how. So see, I come from village, right? So I come from like not. So I have a very humble beginning, right? So my career is like, I would say I've come a long way. Trust me on that. When I say that, it was not easy for me to be where I wanted to be. Okay. So I used to have a pocket diary, and I used to have a dictionary called Bhargav Dictionary. It was very famous in North India. I don't know, it's still there, Bhargava Dictionary. Not like those Oxford and all. It was more like English to Hindi dictionary for me. So I was like trying to learn English without knowing how to learn English. I spent my teenage in my village, right? So definitely, and I know it's not uniqueness about my story. A lot of people have been, or they're still doing that. Trust me. The only turning point for my career was that I went to Kota. That's the only turning point. From there, things changed for me. And the reason I went to Kota because I was one of the top 3 students in my district. Not like I was dumb and then my dad and my mom sent me. So it's not like I was pushed. I deserved to be there, so I went. But obviously, it took a lot of efforts and money. Let us not go there. It's a long story. Okay, so you will note it down, right? You will say, oh, gaslight I learned. I'll write it. So I'll say gaslight. So I used to do it. Why I'm taking this example, that's how RNN is doing it. Now it has to do digital. So this is something it has to do digital. So digitally, they will put it into the sticky notes Microsoft provides. For an RNN model, it will put in the hidden state. Can you see this? So for RNN, this is as good as saying the hidden state. Interesting, no? So in the hidden state, they store the information. What is the meaning of gaslight? Are you feeling it, guys? So the pocket diary has been replaced by sticky notes and notes in your phone or Google Keep, right? But still the functionality is same, right? You find a word, although everybody reads a word and they try to understand it, interpret it. So to understand it and store the information in the hidden state, I missed to write hidden state. Thank God I saw this of the model. So I'm taking an example. You read a word. Obviously, we are putting in our brain also, but we are trying to take it for sure, right? Brain can make you miss. Model can't miss, right? You understand? So that's why I'm taking this example of pocket diary. So this pocket diary used to write. I'm damn sure some of the guys are still using this pocket diary. Still, we are living in the digital world. I said that in digital world, now this has become in your smartphone as a sticky notes on your laptop, right? Guys, everybody notes down, right? Some task to-do list, which I'm saying that in RNN sense, it is going to be in hidden state, right? That is, so I'll write a note. That is your way of storing information. So I'll say hidden state is the RNN's way of remembering what it has seen so far. And don't worry that it will only store one word at a time. No, it's not like that. It stores a lot. What is the next step there in the working? Step 2 is after reading a word, I would say reading the next word. That's how you read. Just imagine you are like a 5-year-old kid, you're reading a big newspaper. You'll go word by word. Try to close your eyes and resonate with what I'm saying. You will say, Akash, you're making a lot of sense. Because I'm trying to jot it down the feelings of what you have already done. Then what happens in terms of RNN? Then RNN. So I'm drawing a parallel universe or two worlds together that you're reading a book and you're imagining, and I'm trying to use RNN to explain. Can you see the brilliant way of explaining RNN? I don't know if you appreciate or not, but I'm trying to explain RNN while making you recall what you were doing, like reading a book. You know what I mean? Okay. So then the RNN moves to the next word. That's how you will do. And it updates. This is interesting. Its memory now by combining what it remembers in the hidden state with the new word it just read. You know what I mean? This combination helps the RNN understand the current word better. You know what I mean? Step 3. So what I'm saying, guys, RNN continues to read. Now, obviously, the kid will not keep doing like one word at a time, right? RNN continues this process. The kid will continue to read the book word by word, understanding it, and updating its hidden state each time. So it's like a loop. Every time I read a word, I understand it and update my hidden state each time without fail. Agree? So this way, it keeps carrying forward and updating this hidden state to capture the context. That's where funny you get. I know it's a one-liner. Updating this hidden state to capture the context of the entire sequence. The problem is that how long it will go, right? Will it remember everything starting from the beginning of my life? Answer is no. So capture the context of the entire sequence. There are limitations. That's why LSTM is there, right? So don't worry about it. You are in the right direction. But I'll come to that later, right? Before I can demonstrate RNN, how can I say limitations here, right? Right now, I can't say limitations. Hold on. Now, I'll talk about making prediction. That's the last step in the whole thing. Now, your brain is so good. Does it ever occur to you guys? You start making prediction in the next line in the movie dialogue. You start making prediction in the next line in the novel, right? Obviously, the language will be different, but you understand what is they're going to say, right? It has ever occurred to you? Do you also try to do it? Like you must be thinking what Akash is telling or what you are telling, and I'm reading it. So yes, that's how brain works. And look at this, how good they have done it. You should be proud of these guys who have built this. We have not built it, so we are just the consumer or the user of this technology. But at the end of the sequence, right, RNN uses its final hidden state, which basically used to predict. Now they are not doing, so when we are reading a novel and all, we tend to predict, but we actually also read. So it will predict the next word or classify the sentence or perform other tasks. Sentiment analysis is the task. We will do it, guys, here as a use case here, or perform other tasks like sentiment analysis, one of the biggest use case of RNN. In social media world, sentiment and perception is everything. Agree? If you're not happy with me, even I'm doing a great job, I will be replaced. You understand what I mean? Because you don't have the true sentiment about me. You have a false narrative in your head because someone is impacting me, because they are influencing. That's called gaslighting. Psychologically manipulating you. Okay, guys. So yeah, I think this is just a very simple way of explaining how does RNN work. So whenever you're designing a neural network, any one of it, MLP, CNN, whatever, right? First of all, let me tell everybody there are no hard and fast rule for determining the number of neurons in a layer. But it has more to do with what kind of infrastructure you have. For example, iris data set. There are only 4 input features. I think anybody would take all the input input neurons, right? So what we are trying to say that ideally, if it is not like 5,000, 6,000 and hundreds of thousands of neurons, means input variable, you don't need to think about importance. Ideally, it will not be in real world. Okay. But in CNN, you can have like 300 by 300, which gives you 90,000 pixels, right? So 90,000 inputs are there. And that's why we do downsampling also, remember? Using the max pooling and all. So yeah, that's there. But ideally, we see that we try to start with the fully connected, means all the inputs we will take in the input layer and going forward. Okay. The other thing you have to keep in mind is that try to do the scaling. So suppose your input ranges are in, some data points are like in thousands, some data points are like in hundreds, some are like in 0 to 1. So always is better to standardize or normalize your data set. That helps your any neural network to converge faster. That is another best practice in the input layer I'm talking. Okay. Now, how many hidden layers we should have? We should have 1, we should have hundreds, we should have how many neurons there? So there's no rule as such. Again, I'm coming to that. But idea is that at least the thumb rule says that you should take input neurons and output neurons ka average. So for example, if we have, generally we use, and again, this is like an empirical formula, that suppose I have 700 neurons coming as input and I'm dividing. So take that example now, MNSIT data set. So 784 inputs, output was 10 classes, right? Okay. So anything which is average of these two guys, okay. So, 2/3 size of the input layer or half of it. So 350 neurons you might be having in the hidden layers. Now you know that I have not taken 350, I have taken 8 or 10, right? Because I don't have the power, I don't have the infrastructure. But ideally, I feel that for a MNSIT data set, people start with 16, 32, 64 neurons and they stop it because of the computational challenges. But ideally, in the best practice, we have a big machines, you can take 50 to 200 neurons. Again, I'm saying there's no rule, there's no formula someone can give you that, okay, these many neurons you have. But it will only come with the right set of questions. Suppose I have a big machine, I would still try with 50, 100, 200 neurons. If I have a small machine like my normal laptop, I'll not be able to go beyond 8, 32, 64 max. Okay. In a hidden layer. Because it's just sequential transformation, right? So you can have more hidden layer. But within a hidden layer, number of neurons, you have to be very smart about it. Ideally, I start with 8 neurons. You will see 8, 16, 12. Okay. The best practices is that don't do underfitting, don't do overfitting. How will you know it? You will only know it when you run iteration. There's no other shortcut. That's why you have to keep iterating, keep thinking about it. Okay, I know there are some websites, they will give you a formula or something, but again, I'm telling you, reading a lot of research I have done, nothing works like this. You have to do some overfitting handling, you can do regularization, you can do dropout and other stuff. So we have already covered that part. So, images can be noisy, and I think I want to show you one quick screenshot. So how does an image which can be noisy looks like? I'll put it here. So this is your having noisy image at sigma 90. And so, right, this is the clean image. You see there are a lot of jittery or noisy dots, right? But you take this image and then you denoise. So that's why I have to go into detail to explain that you have come from 9.05, 9.49, right? This is your power of signal to noise ratio. It's communication, electronics background guys would know more. And you're using BFS CNN, right? Your image, which was full of dots, as you can see, it gets really better from here. If you go here, right? It's almost as close to, close to this part, not like 100%, but at least it gets smoothened out, right? This is called power of signal to noise ratio. You can Google about it. So I have done BTech electronics. So this is power, signal power to noise power. If it is more big number, your signal has less noise, right? Means good signal. It's like a good signal. Signal is as simple as that this image. And if this is less than 1, means your noise is dominating. Much less than 1 means you have bad signal. In this case, it means you have a good image, or here you have a poor image, or you can say a noisy image, or this could be your denoised, or I would say less noisy image. So that's why if you guys focus 9.05, it's almost 3 times, right? 3 times. If it was 27, 3 times the quality of image is increased. But you will hardly see any difference between these two. So now again, they're using a technique called BFCNN. So you will ask me, what is Akash BFCNN, right? BF is bias free, so obviously I can't go in all the details. Okay. Let's talk about RNN architecture. You know that RNN architecture is going to be from your neural architecture. Neural network architecture, it's a feed forward. Let me show you. This is a feed forward. So you go from one layer to another. So I'm excited about that. This is your forward propagation, you can say. Right. And you know that you have another layer. So this become input for the next one, and likewise. And finally you have an output layer. You know what I mean? If you go back, it called backward propagation. You have seen this in neural network, CNN. So you know that when you are going to do forward propagation or forward pass, you predict. This is your prediction phase, right? So during the prediction phase, right, there's no context getting about, right? It always try to take a new word and understand the context better. But since there is no sequence, there's no order, and in forward propagation, it keeps taking the output and making an input in the next, and so on and so forth. So ultimately, it doesn't do anything like this, right? In the forward propagation. In the backward propagation, right? That is your, obviously backward propagation and forward propagation, they're a little bit different. Why? Because you train while you are updating it, right? You go back and update your parameters and the training phase is complete. Ideally, to be honest, it is combination of both. So if I say forward plus backward, together the combo thing makes your training happens. But when you are doing prediction, right? When you're doing prediction, right? It doesn't do anything. It just takes the data and predict for you, right? There's nothing you fine tune in the output. So far with me in the neural network. But what RNN does, RNN has internal memory. And let me show you this. In terms of architecture, I'm saying. So if you see, I have already written few of the things. So if you compare, this is a feed forward neural network, guys. I'm just saving some time. And if you observe, I have highlighted something, this part. Can you see there is a circular loop on this node itself? I think someone also wrote that. So this is what helps you to do. It helps you to store in the internal memory. Do you see that? You can't do this here, anything like this, right? There's nothing like this. So I can say that no, I can say that there is no internal memory. So that is the biggest difference in the architecture itself, right? Okay. So what I'm trying to say, my dear, is something which is having everything. It has a hidden layer, but it also use output to store. Okay. So I'll show you one architecture. Just pay attention. I'll explain everything here. That's why I'll not go into too much of mathematics because trust me, mathematics is super heavy here. But what I'm trying to say, and you have to pay attention to understand. So I'll just write one pointer. RNNs allow previous outputs to be used as inputs while having hidden states. Now this line has a lot of depth. How we will see. I'll try to show you. It's not easy to show you within the box. Here, understand here. So here XT represents sequence of inputs. Sequence of inputs. Okay. Now we will also break it down that what do we mean by this? Sequence of input, okay, but what do you mean by sequence of input? It is contextual. Contextual. Depends on the context. Green boxes at the bottom denote the input sequence. Sequence. What yesterday. Now we are labeling as what? So this T is like what? X1, X2, so on. A. So green box input sequence. This sequence can be as simple as that. Listen to me. Input is a sentence. If I say input is a sentence, then each XT could represent a word or a character. Are you getting? Could represent a word or a character. Right? Sequentially it will go. I'll also take an example. Don't worry about it. So now you understand. I will elaborate this diagram now. Moving on. Second is what? Hidden states. Hidden states. See, hidden state will be there, right? Hidden states will be there. Hidden states, we are saying that the blue, can you see that is what? Let's say in the diagram, blue rectangles in the middle represent the hidden states. So let's understand the game of the land, right? So at least you know that this is the place where they will store the memory. So think like this. These are all your X's, right? So this guy is going to store the memory. I meant to write here this side. So all this part This part is going to store the memory in this diagram, which is in terms of this architecture is the same thing. So what I'm saying, these hidden states maintain the memory of the. So let's understand the first. What I'm saying that each hidden state AT carries the information from the past. Past inputs up to the current step T. Okay. So what I'm saying is that in a basic RNN setup, paying attention, the hidden state AT is computed, right, at any point T is computed using the current input X of T and the previous hidden states. And what is going to be the previous hidden state? Now you guys are getting hang of it. T minus 1. Then you can put T equal to anything, 1, 2, 5, 6, 7. So this is how sequentially it is capturing, right? It's not jumping to it. Okay. This is your second thing in that architecture. Third is what? Outputs. Notation is telling you loud and clear. I mean the green, the pink boxes. So pink boxes are like your output. Okay, I'm talking about this one. Here actually they are calling red boxes, but that's fine. So let's write. So red boxes at the top denote the outputs of the RNN at each time step. Okay. Labeled as Y1, Y2, Y3, and so on. So I'll show you again. Look at this architecture. Now it makes sense. So what you're doing, guys, apply your AT-wala method. So Y1 is going to be what? Taking the current input and the previous hidden state, right? So it will be what? X1, taking the previous 1 minus 1, A0, getting the Y1. Okay. Then this Y1 is going to get stored here. So when the next time you do X2, it will come A1, taking the previous and using X2 as the current input. It is already capturing what happened here, right? And telling you this. And then it keeps moving on. Make me. And that is I love ice cream. At least everybody loved ice cream when you guys were kids, right? Let's say this is a sentence. Hello. See how, okay. So I love ice cream. Ice cream anymore. Yeah. Okay. So the first thing, guys, if you see here, what say cream. Guys, it's coming from left to right. So processing the first word, which is I. Okay, first word I. What will happen here? Now to process this, RNN will start with some initial hidden state. Generally, it will be set to some standard random values, right? You remember that? It can be as simple as zeros also. Then I will be passed into the network. RNN processes the word I and updates its hidden state A1 based on the input I. Okay, so I'll write a few things so that you don't miss it later. So I'm saying, guys, number 1 point, RNNs starts with an initial hidden state, usually initialized to zeros. In the coding, you will see that, or random values. Guys, you really need a hidden state, right? So you need A0, okay, for the first input. Don't worry. The first input I, it will go to the network. First input word. What is that word? I know it's one character, but you are going to pass into the network. Now network processes this word. RNN network will process this word, right, using this blue box, which is your what? Remember, no, blue box is your hidden state. Using the initial and the input, it will process it. That's how it works. And store it in the memory. Now this seems like a black box for you guys, I understand, and we have to keep it like this. RNN processes the word I and updates its hidden state. Now you might be curious that I'll try to go a little more deeper, but I am skeptical about it. Need to keep it as per the syllabus. So you're going to make this learning happen. So we say that hidden state. Sometimes no literature also write A1 or H1. So both are correct. Don't worry. H for hidden, so that's why they use H, but people also use A. I'm using A, so I'm the next part, guys. You tell me next word. We are not worried about space here as of now, Masad, to answer your question. And in NLP and in other tools, there are ways to ignore word spaces and few those things. Processing the second word. What is the second word? I think love, right? I love ice cream, so love. The whole word will be getting into the model. Sequence is very clear. I'm just explaining the sequence. Second word, love, is passed into the network, which is your RNN network, along with the updated hidden state. Now this is something tricky and you have to understand. Guys, remember when I started the hidden state, it was initialized to random values of 0, right? See, usually set to zeros or random values. When this first process was done, hidden state got activated or updated with the word I. Clear, no? So what it's saying, second word love is passed into the RNN along with the updated hidden state, and that is your H1. Or we also write A1. So what I'm saying, I'll go and see in the show in the diagram. Here you had brought I, good. This is your love. So what happened? I is already being captured here. Now the next time this I will be going along, please pay attention. Or I'll use different color so that you don't miss on it. Are you able to follow what we are doing, guys? This I is already captured now. It will go there. So next time when you go here, it is already having what it in it with it. What is already updated in there? I love, right? So then the next time you will see, it will see ice. So I love ice. When you go next, it will become I love ice cream. Clear? Sequence you are able to understand. I know you have tons of questions in your head. How does it do it? What is the science behind it? Ideally, when I say science, it's the maths, not the RNN uses the hidden state H1 or A1 along with new word. And what is the new word we had, guys? Love. And this to produce, alter the hidden state, right? So to produce a new hidden state called H2 or A2. Cool, no, guys? Things you can say processing the second word, moving on to the third word. But this is how the model updates. I told you. And the next will be processing the final word or the fourth word, 3. Has 2. S2 has is I love as the word. When you go to this, you will get H3 or A3, right? And you will get I love ice. When you move to the fourth one or A4, you will get I love ice cream. So the whole context is getting captured. Now the question is that how does RNN hidden state understand I love or I love ice cream? That is something we are trying to understand a little more in detail. See, obviously there's a mathematical scene below the under the hood. There's a concept of word embedding. Have you heard embedding? Now I'm trying to deep dive my idea. So there's a concept of word embedding or semantic or sequential. Let's say you're trying to write a journal. So you started, you wrote something, but then you slept because it was pretty late in the night. Again, you came back and continued, picked up. So isn't it when you did something here, till here, it is all stored in the journal, which is your hidden state. And then you again put your input from the mind or your journey and adding further. But what I'm trying to say, when you say I, you give a letter I or a word I love, what it converts into the vector in NLP also. So it's like converting the characters into numbers. You know, vector, embedding vector. So I will also write, else you'll forget. So what I'm trying to say, how does RNN process the word I? And in NLP, I will be literally doing this. You will understand. So processing the word I, what it does in this, it transforms, it's a transformation, right? Transformation, the word I into an embedding vector or embedded vector, which is basically in layman term, numerical representation. You know, right? Our algorithms, our machine are all 0, 1, 0, 1, right? It does not understand English, Urdu, Farsi, Tamil, Telugu, right? So it has to be a numerical representation. What is this is does? This is the first thing it does, that it converts into a numerical representation. The beauty of this numerical representation is that it captures the semantic meaning of it. Now, what is the word semantic? Idea of NLP. Semantic meaning of the word. I. Obviously, we know I means मैं. I love ice cream. मुझे ice cream पसंद है. So semantic meaning of the word, in this case, I. What is the meaning of semantic meaning of the word I? Semantic means relationship between the words, right? So you must have heard about lexical semantics. So it's like, denotation, connotation. There are a lot of things, to be honest. But suppose, you're trying to understand what with the context is called semantic. I don't like ice cream. It means you just not only know the information, you also understand that person does not like ice cream. And if he tells that, I do not like ice cream and some reasons, you know that the person does not understand does not like the ice cream with this reason. So you understand the whole context, yes. Because it's very important that context is here. I'll give an example. I walked into the bank. One sentence. So NLP, welcome. NLP started, guys. So now I think you'll be feeling happy about it. Sentence 2, I walked on the bank of the Ganges. Ganges. Now you understand the same word bank has two different meanings because context is changing, right? One is your financial institution, right? It's like more like your bank, PSU, private, but it's an institution. And this means side of the river. Side of the river. Agree, no? So this is what we mean when I say captures the semantic meaning of the word. Although I here is very simple, there's no confusion, but this is what you have to see. Semantic, I'll also write one liner so that you don't miss. Semantic refers to the meaning and interpretation of the word, meaning and interpretation of the word, and it can be not only word, it can be words, phrases, sentences, and symbols too. All right. I'll tell you another example. Right? Brick in the wall has one meaning. Brick in the wall. It's like we are talking about there's a wall and right, and there is a brick. So brick in the wall. Right? You understand what I mean? A bricks in the wall. But if someone like one sentence, we are just brick in the wall. You know what is the meaning of this? Now the two things have different meaning altogether. Trust me on that if you're not believing. Very good, Francis. So we are like one brick in the wall. We are insignificant. We are like one drop in the ocean. You know what I mean? One brick in the wall. So now this becomes like an idiom. Very good. This is just like a phrase. Meanings are too different, right? This is actually meaning brick in the wall. Right? This is actually meaning brick in the wall. But here things have changed. Why? Because it has different semantic meanings. So we're saying that semantic refers to the meaning interpretation of the word, sentence, and symbols. The context. Okay. I'll highlight this. Good. So I'm saying that processing the word I'm saying that processing the word converting it into so model tries to understand the semantic meaning. by converting this into a numerical one, and there is a lot of going behind the scenes, so we can't go into all the detail, but are you getting the functional understanding of it? That's my maths. Once they're processed, they know that, the model knows that I is like a pronoun. Hello? What is I in English grammar? Pronoun. So model knows that. So I'll just also write that. So once hidden state. So now once the processing is complete, once processing the word I is complete, the hidden state H1 or A1 now holds the information about the word I. Now this is the very first word, and it can be as simple as like, it has not a lot of meaning to it, like recognizing it as a pronoun. But it's a good identification, na guys? And model would be able to understand that pronouns are generally the subject. Hello? Pronouns are generally the subject of a sentence. Come on. He, she, I, right? These are all pronouns. You know, he, him, her, his, her, right? He, she, his, her, and him. Okay. Subject of a sentence. Now, guys, those know grammar, they know there is subject. I don't want to teach grammar. You can refer to Wren and Martin. So what we are saying that now model also understand, my dear, that this sentence which I'm going to look at in some time is going to have a sentence. So in essence, I'm saying in essence, now your H1 or A1 is now aware of the fact, see this is how the model is learning, is now aware that the sentence has a subject. This is a big learning for the model. Now again you can question me, but how is it learning? That's what I'm trying to not go into, and it's a little difficult. Now once you do this, now I will process the next. Yeah, how is the mathematics? That's right, and that's what I'm trying to avoid, because see, I have some, see, to be honest, I know exactly what happens, and trust me, I know because it's all my interest. To be honest, I was not taught. Processing the word love. Let's move. Let's spread the love here. Okay. So the moment you will bring love, already it knows that you have, and subject I, and the next word love will make that the subject love something. Come on, think it. Take it like a how to say? Think like you are a machine trying to learn something. So I is the subject. That subject I, which we are referring to, love, is what? Something will come, but what is till love, right? So when the next word come love, again it does the same thing. I'll write it again because so that I'm completing it. So when the RNN receives the second word love, it transforms obviously this into the word love into an embedding vector, again the numerical representation. which is your x2, right? Which captures the meaning of love. Okay. Now, next thing happens. This is the first step. The next thing which happens is what? It also updates the hidden state by combining x2 with the hidden state h1, or I have been also writing a1 with the hidden state, and this is your previous hidden state. I'll write in bracket. Which already holds information about I. Which already holds information about I. Very good. You guys are getting hang. I know. At least I can give you what is the maths looks like, so that you don't say that Akash did not tell any maths. But I'll tell you the maths. How does it look like? The first update we did, it looks like this: h1, or you can write a1 equal to tan hyperbolic. So the activation function we use here is tan hyperbolic. Weights hx multiplied with input. This is what we do, weighted sum. Weights into the input plus WHS, HH or HS, how do you pronounce? H0 plus BH. Don't worry, I'll explain the terminologies. Here is what? So here, WHX is the weight matrix. But guys, I'm just telling you for your curiosity. I was trying to avoid this. That connects the input to the hidden state. Okay. And you can clearly see, right? H in hidden state and X is what? Your input, right? Observe this, guys. Cool. What is your WHH? This is like weight matrix connecting one hidden state with the other, right? So weight matrix that connects. Both are H means hidden state, which means connecting the previous hidden state with the current. Can I say that, guys? And it's important now that you have access to current as well as the older. BH is the bias term, most easy term to identify. Bias term, and tan H is another easy term, and that is your activation function, tan hyperbolic. Right. So this vector, this mathematics will handle everything for you guys. Understand? Let me write here only. Tan H is your hyperbolic activation function, tan hyperbolic activation. Now, for the second layer, it's the same thing. Now look at the beauty. You will understand very fast. So this is going to be your hidden state, H2. Come on. H2 or A2 equal to, so tan H, again hyperbolic, WHX input right? Second input plus, what is your second input? The word love, the embedded vector love. WHS dot H1 plus BH. See guys? So if you remember, here I had written this H0 if you're paying attention, my dear. See this. So you're updating the activation function, sorry, hidden state, and you keep adding this. Now can you see that? Take a pause and very good, right? So does neural network gives you this functionality of embedding one input to the other? No, right? There's no way you can. Now question from Francis, why tan h is used as activation function? Because you need to understand number one, the range is from -1 to 1. Okay, so it can take both negative and positive values, and you know that text can be also positive and negative sentiments, right? So definitely it helps you to handle the zero center data very well, because I don't like ice cream can be another word, right? Sorry, another sentence. I do not like ice cream can't be on the same side as the I like ice cream. It's opposite, no? It's like positive sentiment and the negative sentiment both are there. If you take sigmoid or some other activation function like that, then it will only be focusing on the positive side. Oh, you don't like ice cream. Oh, you like ice cream. So even someone is saying, I do not like ice cream, you will make it positive and understand that, oh, he loves ice cream. You understand what I mean? So it is important that tan h is there to handle the positive and negative values. That is the biggest reason. Your question, Francis, why do we use, writing proper English, tan h as the activation? So now answer is, I'll just write the answer. So tan h function ranges from -1 to 1. I hope you know the graph. I'll show you in a moment from -1 to 1. Okay. Which means that it produces both negative and positive values, which is advantageous, which is an advantage, or which is advantageous as it centers the data around 0. So neutral comment will be around 0, center the data around 0. So neutral comment will be around 0. Positive comment will be on the positive side, negative will have negative side, right? And because of this very clear-cut demarcation, your model becomes better. So making optimization and convergence faster. Right? It's very easy to find the appropriate answer, guys. Come on, yes or no? The whole idea is to make the model converge faster, obviously accurate. Activation function is allowed to do. If you take sigmoid squeezes between 0 to 1, so it's more like non-centered output, and that can lead to slower convergence and also the not the right fit for something like RNN. Better? So you can clearly see that the range means Y, by the way. Range is Y. Okay. Domain is X. Those who are little weak maths. So range means Y values. Let me write here. I think those who are good in math, they will understand what I'm saying. So what is the range for sigmoid, guys? So range for sigmoid, you can clearly see between 0 to 1. See, the lowest value is 0. The highest value is 1. I have this power, right? Why am I not using it? Come on. See? So 0 to 1. This is for sigmoid, right? What is the range for tan h -1 to 1? And this is your sigmoid. So why I keep showing this nice charts and all, my dear? Because you can see the beauty in the concepts. So obviously it is a better data, right? So now what I'm saying, guys, because of this, what I'm saying now, guys, because of this, write a note. If someone asks in the interview, you just that. So that's the reason RNNs often use tan h. It's not like this is the only function you should use and all the time, but it's one of the most preferred choice for modelers, as the activation function, as they need to capture what RNN model need to capture, which I've been telling you guys, both positive and negative relationships. This is reality. Life is not always rosy. It has also thorns, right? A lot of thorns. Both positive and negative in sequential data. Like I said, no. I love ice cream is one sentence. I do not like ice cream. It's another sentence. This looks like positive, those who are ice cream lovers. But the moment you see this do not, you know that that person doesn't like. So positive and negative. Color coding, I did it. So I told you NLP, NLG all are related. So NLP has this big segment, which is your natural language processing. And this has two branches to it. So one is there's no video, so we're not worried about it. So already I introduced this, but now I'm going to build on top of it. So I'll say one is your natural language understanding, NLU, natural language understanding. Which is NLU. So NLU is not something which you don't know. I just explained that, just jotting down quickly so that you are not clueless. So NLU is the process. It's not in the scope altogether. So it is the process of which you have already seen, right? Me doing analyzing and understanding. I'll just keep it short. The meaning and intent behind human language. Intent is more like your context. It focuses on comprehension, interpretation, and extracting meaning from the text or speech. So when I say speech, means you can also analyze your audio now, right? But our course is more on the text. So I'll be sharing the US sentiment, US airline data to work on it. That's what we are going to do, the more like the hands-on guys. I'll just highlight here. But as a matter of fact, you can also do speech analysis. There are a few techniques which I think generally people want to get into it. So I think, so one is sentiment analysis. I think now this has become one of the biggest area within this field. Trust me, sentiment is everything, right? So if you're able to crawl data from web and read sentiments of your consumer, that can be like amazing tool in sales and marketing. Agree? I'm not able to write techniques. Even you generate feedback for me, isn't it, guys? You give me feedbacks, right? So feedbacks are so important. Feedbacks are so important that if taken in a constructive manner and given in a constructive manner and taken seriously, it can definitely change the way we work. So anything which we are generating sentiment about it. For example, movies get released, right? Isn't it people are writing about it here, there, everywhere, right? I've worked for a lot of the top retailers in the world, right? Consumers, grasping consumer sentiment is like everything. And I'm not exaggerating with my voice modulation. It's every damn thing. You can get a product fully wrong if you're not able to read your consumer mind. How will you read our consumer mind? There's nothing like you're connecting a SIM or Neuralink chip to everybody, right? So how can you do it? You have to grasp, you have to capture their sentiments across the social media platforms. As a matter of fact, now comment, feedbacks, share your thoughts is like a common feature in all the websites in the world. Trust me. So if you're able to do some real nice work on that, and that's why your data is so important, right? One way is to capture the sentiment if they are sharing, right? But before that, people used to capture the consumer behavior by looking at their buying pattern. So you remember, Srini, when I was teaching you the clustering, right? I don't know, did I teach you clustering or not, whether I came somewhere in the middle. So market basket segmentation, or, finding the, customer behavior, looking at the demographic data, what they're buying. There, I also talked about the Walmart beer use case, right? So the segmentation, basketing or grouping the customers on their interest, buying pattern, what they're doing within your store tells more than you know. It's just that you need a real guy who can analyze the data and make some real insights, take some real insights from there. Now there are two things. One is that buying pattern is historical, sentiment is in real time, right? And looking at the way consumer behaves today, trust me, and I'm also a consumer, I'm also a customer. I'm planning to go to Kurg and suddenly I'll go to Munnar. Who can predict this? You understand what I'm saying? It's impossible, right? So it depends on 10 different things, and it's not all everything can be programmed and put into a model. So that's why someone will do in real time, and cookies is more to blame for, right? So these guys who are running this company like Make My Trip, Go Ibibo, Clear Trip, and likes of those, right? They so much play with your money with respect to the flight pricing. Trust me. But if you're not careful, right, you will always end up paying more. Trust me on that. You have seen that, guys. Suddenly your flight price increases and you are like, what? By 800 rupees, by 1000 rupees per passenger. And you're like, what? Because they are tapping you. They know that you are looking for a flight. They also know that, right, you really need a flight. Okay. So I don't know, means tech has come so far. If I don't complete a process on one app, they will start messaging me on WhatsApp. Oh, you have left your flight, complete it. Please come complete it, right? They will even call you. So the new companies will call you and say, Akash, I think you left in the middle. I said, yes, you're charging me more, right? So, so the point is that now customers also know their, I think forget about these things. Let's talk about Rapido, Uber, Ola, right? Come on, guys. Everybody using cab. Let's not take some hi-fi example. So every day we do this where we are getting a cheaper cab. Hello, yes or no? You also book three, they also accept three, and then they will decide where to go, right? This is how it's working. At least in Bangalore, this is how it's working. So Rapido is like a betting system, right? So you have to bidding system, sorry, wrong word, bidding system. So if you are bidding more, they'll give you, you will get a car faster than anybody else. So suppose a normal route cost you from origin to destination 400 rupees, and you say, I'll give 500, dude, come please sit. You know, so if you're busy, you don't care for 100 extra bucks, you're not worried about it, pay and go. I've done it multiple times. What to do, right? Obviously, not something I would like to do, but what to do. So, guys, just understand that how they're tapping the customer sentiment. So, those who want to make a career in this field, they can study sales and marketing. And there's a very nice book on the marketing research, right? I'm forgetting the author name, but in case you need to know and you're interested in that, please, this is like a very fulfilling career. But join a very good company because sales and marketing can be very toxic job to be in. Trust me on that. Especially the sales, not the marketing. Marketing is like, okay, you can do any ad, you can do anything, but targets and all you have to meet, so it's very tricky, competitive. Okay. But by that, everything is competitive in this world. So that is something and watch out for you. And there you can use a lot of, so Salesforce is uh, one of the one of the biggest tool in this world, right? So I feel, if you're aware or not, Salesforce is one of the biggest platform for this. And I feel that this is the way you can learn these techniques. So coming back to our topic of interest, which is your sentiment analysis, I'll talk about in this detail what is sentiment analysis, but I given one liner for it. So you go to a movie, you watch a movie, and you share your sentiment on Book My Show or IMDb, right? So generally you write some review and then you give a rating, right? Out of 5, out of 10. So basically this analysis, this technique is all about determining the sentiment. Now sentiment can be positive. Positive also has a lot of levels, negative and neutral. So some of the guys in my class, learners, they'll say Akash is okay. And that's neutral. Akash is good, really good, excellent, positive. I don't think he's good, right? He's a bad trainer, negative. I'm just taking, on me. So same class, same set of learners, they will have different sentiment about a one person. Similarly for a movie, similarly for a product. Like a lot of people will be iPhone lovers, right? A lot of people will be like Samsung lovers. And that's why there is a page on Instagram where Samsung guys keep trolling iPhone guys. And trust me, even my workplace people are sharing me the links of the Instagram because I use iPhone and they keep sharing that, see this, right? Means it's okay. But you understand, it's like a war out there. So India lost a match against New Zealand. Sentiments are pouring from all the places. Now, even government, like the political parties are using data like anything. You know that, right? I don't get political here, but I'm saying that they're also using AI. They're also understanding the people's sentiment. They are doing survey, and that's how they get the exit poll right most of the time, right? If they're not, rigging it. Good. So that's how it is. That is your sentiment analysis. Then one is like named entity recognition or entity recognition. So this came up pretty late, but this has come and revolutionized the way we look at NLP. So this is like I was talking about the other day, identifying entities like names, location, date in a sentence. So now with this, models are there which help you to understand, because if you understand that this is a name, this is a location, you can have a better contextual understanding of the sentence. Agree? And I will not deep dive on this because I had already shown you this in here. I don't know if you guys remember or not, but I'll show you that I was taking this example, Steve Jobs example, right? Did I take that Steve Jobs example? I think I did it. I did it, right, guys? I'm not able to find, but I did take the Steve Jobs example. I think I did here. See, Apple is looking at, right? So go through that. That's the same thing. Let's quickly talk about natural language generation, guys. NLG. What if you want to pursue your career in this field? But without knowing NLP, NLU, so you need to know NLU, then only you can be better in NLG, right? So there's no shortcut. But you know, right, it is the process of generating, let me write quickly. Human-like text. Now, though, we are also generating speech. So I'll write it from structured data. It focuses on producing understandable and coherent text that combines, that communicates the desired information. So there's a very good company called Automated Insights. I don't know how many of you are aware. So I applied this plugin in Tableau in one of the projects. So what it does, guys, it reads the data behind the chart and give you summary. So generally we look at the chart, take a screenshot and write the summary, isn't it, guys? Come on. Right? What it does, right, it will give you a summary of the same chart for different department heads. So if there is a sales representative, it will generate chat like a summary or generate text, right? More for this guy who is viewing this chart, right? So in Tableau, you can have the role-based access, you know, even in Power BI. So for Mr. Mitchell, Donald Mitchell, right? Donald Mitchell, you can clearly see that he's getting 61%, right? Missing on target, whatever. So it will give you the full summary of what you're doing, right? Then head of sales will see more like a summary across the different sales representative, and sales manager will be like having a different view to it. So this is interesting, guys. Do you like it? I don't know. You are also going to be taught Power BI, or you must have been taught Power BI, but I don't know if your trainer did touch upon this topic that even Power BI can do things. It can find some good, nice summary of the charts like this. So there is something called serve insights, right? Insight service. So generate insights for the chart. Can you see I have put a red box here? Get insight. So it says that there's a correlation between vendor and total defect reports for this category, right? So you have a filter there. So you put a filter for the category. So it's saying there's a strong correlation. I would rather say it's not that smart than this, but just just keep an eye on these things. A lot of things will come in some time. Okay, you agree with me? There are a lot of things coming down the line. So SEO is like search engine optimization. So NLP plays a big role, a crucial role for that thing. So you put hashtags, right? Your page has to rank to show on the top, isn't it? That's the whole point of doing SEO. Suppose I want to search data science or deep learning program. Intellipaat name has to come on the one of the top 5, right? Then only you know that Intellipaat exists, and that's business. Means if I don't come on top by hook or crook, I'll not able to sell anything. Agree or not? So be it any company, let's take Accenture. If someone is searching about something in supply chain, Accenture doesn't come, then I think they'll not know who is Accenture. So marketing is all about bringing your page, whatever I do, on the top of the things, and that's where the content writers, content influencers, and all, they are doing a lot of these things. So NLP helps the search engine. So like Google, take example, Google is the giant. So Google understand the queries, right? And then it matches with the hashtag and what you have written in your blog or in your video hashtag or description of the video, right? And it tries to, see that what is the overlap. So suppose I say best smartphones for photography. There are a lot of phones coming only for photography. So NLP helps the search engine understand that user is interested in phone, right? With excellent camera, not just any smartphone. Agree or not? Come on. So if I write best smartphones for photography, so Google is going to do the intent of the search. That's number one. Number two is that that's where the semantic search, the contextual thing comes into the picture, right? So search engine use NLP to connect relative topics, right? So in this case, it will be like wide angle camera, some hashtag will be there, right? Or what kind of photo you want to do, like wildlife photography or like a movie photography or cinematic photography, right? Or video making. So those keywords which you put in the hashtag, right? When you're promoting your product, Google will understand, right? And they will rank you. Now that ranking logic is very tricky. Even I think Google only knows. We can't know that. But obviously they know that these are the levers for you to get ranked. And that's why I think Sandeep has written. So Google has to rank. But before Google can rank, Google has to understand the search intent, what is the reason behind that search, and then it does the semantic search, which is your contextual understanding. Like I want to buy a phone for photography, not any phone, then Google has to also find which pages are offering that kind of phone, isn't it, Priyank? So like let's say a company like Sony, let's say a company like, sorry, why I'm saying Sony, Samsung, Apple, take it, MI, XYZ, right? So which phones are going to be like the best one for this guy who is searching on my web, right? Google.com. So obviously they will be having some articles written, some hashtag, right? So they know that, okay, because these guys also publish a lot of, blogs, they do a lot of, paid reviews for their product. All these guys who are doing reviews every month, every week, they'll come with 10 different phones. So what do you think? Right? It's not all they do genuine things. Obviously, it's a business, right? They have to give some preference, but they will also protect their credibility. They can't say that lava is the best pen in the world, right? Nobody will, they'll stop watching those kind of, channels. If I say lava is the best phone in the world, you will say, go to hell. Who is this channel? Right? I'll block it, unsubscribe. You know what I mean? So yeah, it's a collaborative approach. And I was looking on a laptop, Asus ZenBook laptop, right? ZenBook laptop. So on their page, they have already linked a lot of bloggers, tech bloggers, reviewing their product. So I like that. They are very honest. That, okay, guys, he are our guys, they are our guys, he is our guy. Go and watch what he is talking about my laptop. Okay, so moving on. So now guys, I'll talk about NLP Pipeline, which is going to be our steps in the hands-on. This is going to be the critical steps in doing an NLP task. Okay. So maybe I'll add a page and make a sub page, right? That would be smart. So anything when you're doing with respect to NLP, you have to build a pipeline. It's very important. Guys, disclaimer, focus on the steps, not on the sequence. It's not the hard and fast, excuse me, that you have to follow exactly this. But steps and so credit goes to Turing website. You see a nice diagram, guys, natural language processing pipeline. We are going to talk about this. So let's take the very first step. Sentence segmentation. What do you think? What is it? Okay, so it is the very first step. Sometimes it's implicit. You don't even acknowledge that you have done it, but it is being done. It is the very first step in the NLP pipeline. So what we do here, it divides the entire paragraph into different sentences for better understanding. More like pressing enter, enter, enter. Okay, in your head, think like that. Not wording. Word we have not reached. So first you will separate the sentence. So generally we put the enter after the full stop, isn't it? So let me show you this nice example. Suppose this is a sentence for me. Come on. I'll take a screenshot. Yeah. Can you see this guy? So I have a sentence which says, so source is Wikipedia. It says London is the capital and most populous city of England and the United Kingdom. Standing on the river Thames in the southeast, blah, blah, blah. But if you observe, by every full stop in the below, we have segmented it, right? So after this, then I think after this, right? See? And that's how it's done. Clear? Very easy step. I'll move on to the next step. We will do that when we'll build it. No, we'll do it. Okay. All these steps are not exhaustive. Means sometimes people don't do it. So don't think if I'm not doing it, we are missing a step. Again, I'm telling you. So understand the concept of each step. Word tokenization. You know this? Must have heard now. Word tokenization. Tokenization is a very famous keyword in NLP. Generally, interviewers ask, "What is it?" Breaking sentence in the words in the token. So it is a very crucial step. So let me write. You're right. I think people have got some idea here. So my dear, it is the process of splitting a text into individual words or token. And this token can be anything, group of character, group of words, it can be anything, by the way. So for example, if I say, I love NLP, simple one sentence. So word tokens can be coming from this sentence is what? You know which are the words here? It will be I, love, and I think acronym we will take it as a one word. Make sense? Clear? So guys, note it. It is a crucial step. And this is just one way of showing the code tokens. It can be subword tokens. I'll come there. But it is a crucial step as it transforms text data, raw text data, into a format team will let you know. Don't worry about now. That can be processed by ML algorithms. And you can also write AI. Sometimes people get, oh, AI, you are not writing. AI is like implicit. So it's very important that we are converting a raw text data into a format that machine learning or AI models can understand, right? There's a concept of subword tokens as well. Subword tokens. There are a lot of techniques in this, huh? Let me write. A technique, but you're right, subword is like taking a word out of the word only. A technique to handle out of vocabulary words. By breaking them into smaller but meaningful units. Now you have to understand, when we were doing machine learning, right? Sorry, when we're doing sentiment analysis, right? For sentiment analysis, no. And I remember, so when I did the first time sentiment analysis, it was year 2015. Can you believe it? 9 years before. So 2015, I did sentiment analysis. My first, you can say my first, and I still consider as like my first baby project. And it was appreciated by, a lot of people in HP. I think it was 2017, my bad. Because I was in HP in 2017 time. Okay. So the problem came, right? Someone is right. I'm not right. I'm unhappy with you. Now the problem is that if you take happy as a parameter, it shows that it's a positive sentiment, right? Because model is only pinpointing this part. Hello? Guys, understand what I'm saying? Because, I'm unhappy with you, right? So model would think happy is there means he's positively or he's happy. It's a happy sentiment, right? But is it the reality if you understand the English? Is it a happy sentiment, guys? No. So the problem was that in English, if you write it's like undo happy. Okay. So then the subword techniques, the subword tokens help you. What it does, it takes the words such as unhappiness, right? Unwell, and then so different versions of it. So what it does, let's focus on unhappiness. It takes and divide and break into two tokens. Very good. So I think someone also mentioned that taking a subword token means what? It would be, are you feeling, guys? That this is un and happiness, right? But it doesn't mean that you will divide from anywhere. So unhappiness, right? Unhappiness, it will not do this. So the models are trained to do this on their own. Make sense, guys? Come on. So this is called subword tokens. They can be also character tokens. Now this is like getting too much detail. It's like you might be needing going to the lowest level of the detail. So in some cases, tokenization is done at the characters level, where each token is a single character. See? Very good, Sandeep. So where each token is a single character. So for example, I take a word cat. Now, if I have to ask you what is the character token here, guys? C A T. Now, Gen Zs, right, the millennials and Gen Zs, right, they have a very unique way of communicating, trust me, on social media. So in Bangalore, I don't know Francis is there or not. So in Bangalore, there's a place called Kormangla, right? Koramangla or Kormangla. So I have been visiting that place for almost a decade now, but recently I got to know the millennials and the today's generation, they call Kora. So there's a way they call this place. It's very different. So, right? So Kora is the famous word for Kormangla on social media, right? Means Kormangla, they'll not even know. So similarly, you might be seeing on a lot of Instagram or Facebook posts, people have written something like this. I'll show you. I don't know how many of you guys seen this, TLDR. So even on LinkedIn, people write it. Do you know why do we write it? Have you seen this TLDR? To let you know directly. No, it's not to let you know directly. It's a slang. Too long, did not read. Okay. So basically, so let's talk about it. It's one of the famous thing in SEO. Too long, did not read. So some people, they write a lot. So it's a shorthand way of, it's a shorthand. I'll write about it. Guys, trust me, I got to know a couple of years back only. So don't think you're missing something big in this world. So when I saw it for the first time, I Googled it. I have this, I have this habit of keep learning about new things. So I'll quickly search. So, you can look up or you can search in Google by just tapping on that word. It's a shorthand used in internet, used on the internet. To summarize long content, articles, etc., into a brief, digestible form. You will not believe, I think, I feel few years back, there was a company came and so the founder is like a Bihari. So he did found the company called InShots. I think I'm damn sure I have this app on my phone. Most of the news I get to know from that app only. in shorts. You know that? So tell me, na, in short. We keep telling, na, in short, in short. Arre chodo, in short batao. So TLDR is a way, so they will write a big article first and then they will give you a TLDR, right? So to give you a quick overview for the people, for the folks who are like busy, who don't have a lot of time or patience to go through the entire content. You understand what I'm saying? So now if NLP does not understand that TLDR is written and then the article starts, it will miss that it is already summarized, you know. Model needs to learn, right? The TLDR after something coming TLDR is like already compressed, summarized. So you have to tell the model, dude, this is TLDR content. Right? I think stemming, no? Yeah. Step 3 stemming. Okay. So guys, everybody knows stemming, right? Have you done stemming on a plant? Or have you seen somebody doing stemming on a plant? So to grow a plant from a plant, people do grafting and create a, so they create a, take a base of a plant and they create a root from the stem, right? And then they get a new plant and that's how the plants are multiplied, correct? So that's called stemming. This is the word, source of the word, stemming. So first, obviously, you need the stem to do it, right? In NLP, if I tell you a few words, so I'm a consultant, right? So everything, if I say, you know, consultant, consulting, consultation, you know what I mean? Consultative. Actually, these are the words I know from my English. But if you think something I've written wrong, right? Do you agree that all these words have a base called consultant, right? So the base word or the root word is what? Consult. So in stemming also, we say, right, find the root. So as the name suggests, stemming is a text normalization technique to reduce the words to their respective, to their base or root form. Known as stem. See? And trust me, stemming has a lot of applications, right? So next in the pipeline is, I think, lemmatization, right? Yeah, step number 4. Lemmatization. It's a very important segment. Interviewers ask connection, connecting, connected, right? All finally lands to what? The root or the base form is connect, isn't it? I think, right? Lemmatization, what is it? So I think words context such as where it appears in a sentence or within a larger document. Okay. Grow, growing, growth, grown. Growth, growing, grown. Ultimately it lands to. Okay. What is lemmatization? These are verbs form, right? But I mean to write beyond this, but okay. So what is lemmatization, guys? It is a set of, it is a text normalization technique that reduces words to their base or dictionary form, right? That reduces to that's why it's very close, they're related. Base or not root, dictionary form. And to be honest, I am generally confused with these two guys, but I'll try to clarify for you. It is known as lemma, not llama, okay, lemma. Now, stemming can be cutting at a place. So suppose she saw, right? I just decided to cut after T. So I got consult, right? Connection I did connect. Growth I did growth, grow, growing. So if I just cut here, I get right? But where you find similarity, it's more like pattern finding. How is it different from stemming? So I'll write, it is unlike stemming, and I'll clarify also, unlike stemming, which often uses heuristic rules. So heuristic is like rules, right? To cut off affixes, while lemmatization involves a more sophisticated process of deriving the base form of word based on its meaning and context. Now guys, I'll show you one example, right? So obviously what you have done is also right, but stemming and lemmatization can be tricky. Can you see this? So obviously I've taken this from a source, credit goes to the guys, but can you see, you might decide later that I want to just, cut it like stemming, like cutting, right? So you might want to decide that I'll cut it just after N. So the moment you say I'll cut after N, right, isn't it? It will give you Chang, after G. You understand? So that's a valid stemming, also technically right, but obviously meaning wise, it is nothing, right? So go to hell. Let me use my agree, guys. Come on. But lemmatization, if you see, which I have written on the other side, so I need to be very careful, or as a group, we need to be very careful. Stemming like cutting, so that's why I focus on this part. So when you're cutting something, you can cut, but here intentionally, obviously nobody will cut like this, but it's more like cutting it. So whenever you are doing this, you have to ensure that it is following that equal length character wise. Okay, I'll give you an example, right? If you take run or someone ran, what is the base form for ran? It's run, right? What is the base form for wrote? It's write. So now we will try to cut it, right? So if someone wrote, written, writing, you know what I mean? Write up is a different thing, but you will try to cut, you can only cut WR, right? Because that's the only thing you see common. That's called stemming. But if you are bringing everything to write, this is called lemmatization. Agree? So that's the difference. Now you'll never forget this. Now look at this example, guys. This is also nice. What about this? If someone gives a number or spelling like worse, now if you take a word worse like this and you want to do stemming, you will write what? WOR, because let's say you are just selecting or cutting 3 characters, right? Okay. So you can do that. Technically it is right, but conceptually it doesn't make sense for you, right? But if you want to do lemmatization, worse becomes bad. See? Good, better becomes good, not like better become bet, right? So if you see here, ideally, I would rather put a, star and saying that if only we follow the contextual approach. If you don't do it, you just do it blindly, then you might get something else. Make sense? Clear, guys? So it's very important to say you can get to the base root form using this, but ideally which is the preference, lemmatization gets preferred, is the right approach because it gives you the room of error. Clear, guys? That's correct. Best also becomes good in lemmatization. That's right. Exactly, Saurabh. That's my point. You got it. Now the question comes that then why the hell I need to do stemming, right? So well, in that case, I'll write the question. Let me have swollen and then talk. Well, in case it seems that stemming, right? That's the question and the response. The response is very simple, and that is speed and simplicity. It's not that simple, so I'll try to justify what I've written. Speed and simplicity. So what I mean by that, stemming algorithms are generally simpler and faster than lemmatization algorithms. And it's obvious, no? It's a rule-based cutting. So if you don't have a lot of computational power, you might end up doing stemming. So stemming can be less resource intensive, making it suitable for large scale application. That's where its value add is. Now you do a proper stemming, then you can still go to the root form. Hello, yes or no? But yeah, this is a little tricky than easy. So you have to do a little processing of the text. Okay. And there can be a question that where to use what, right? So let me talk about it. So it's more like a choice. So I would say choice between stemming and lemmatization. So let's talk about one problem area, classification problem. Yeah, versus lemmatization, right? So classification problems, if you talk about it. So in general, you take any classification problem, stemming is often used in classification problem. I'll explain why. So I'm giving an example as per the best practices, which can help to reduce dimensionality of text data by grouping different forms of a word together. Now, suppose in a big article, you're using different forms of the same word by doing stemming, right? You find the common word consult in all 4 or 5 words across the whole data. You are just grouping all these guys, which might have come multiple times into one group, which is consult, right? So are you not reducing, you're not grouping and consolidating your data in clusters, small groups? Exactly, right? So what they're saying that it is as good as saying that treating related words as the same feature. So you will be able to reduce dimensions, right? There's no point for having a dimension for consulting, consultation, consultant, right? Whatever, consulting, right? So 4, 5 features you would have, you could reduce it to only one. This is a good area. I know you are looking for some example. We'll come to that. It's not that straightforward, Mr. That's why I'm not giving or able to give here. But this is more like a FYI information for you that classification problem, it's a good choice. I'm not saying that. Experts are telling that. Which one is a good choice? This guy, STEM. So you might be wondering where I use lemmatization. So it is for text generation problem. Now text generation is something more dependent on contextual thing, isn't it, guys? Come on. Rather than doing a similarity grouping. So you cannot like do stemming and take some, almost similar kind of problem here, right? Oh, these are all similar words, I'll group it. No. You need to understand each and every word so that you can generate text, which is a response, and you have to be very careful. So what I'm saying here, in general, lemmatization is typically preferred in text generation task as preserves the meaningful base form of the words. And this is very important to understand, that it preserves meaningful base form of the words. So you can't just replace it with some, segments. So what basically it says that it maintains the meaning and context of words, which eventually leads to more coherent and accurate generated text. Now, this is a good thing. Suppose when I used to teach this, let's say 3 years back, to make you guys feel this impact, it was a very abstract thing for me. It was very difficult as a trainer. Now, since everybody is using GPT, now you are asking something as a response from GPT. If it is not coherent and grammatically correct and making some sense for you, in response to your question, are you going to trust that tool? That's what I'm saying. It's so important for text generation problems that we use lemmatization, not stemming. Right? Because if stemming goes wrong, it will not be able to understand that word, and then it will not be able to give you the better response. Agree or not? Suppose by mistake you did a wrong stemming. It will suffer miserably in training of the model, right? Which means, guys, suppose you did a 3-character stemming, 2 words have some meaning, but the other 2 words did not have any meaning. So the model will say what's happening here, right? Because it is not able to understand. So it happens, right? You're in a meeting, sitting, discussing with your project client, offshore client, or onshore client, and then suddenly you don't understand something that person said because the network was not good, or you could not understand the English he spoke. Like he might have brought in a really difficult word to understand, right? Or you could not understand the word or set of words that guy told you or just mentioned because of the accent or any issue as such. Isn't it you have to resort to say, can you please repeat? I missed it, right? Or I could not grasp what you said, right? So it's the same thing. You know what I mean? Because the context is lost for a minute or so, then you have to repeat. That's how text generation outputs are now getting better, because now model training is done solid. So, but if you're asking something tricky from ChatGPT, you realize that, oh, it is still dumb, right? It keeps telling you the same. So for, I think last year when I was trying to do it, when I say last year, I think almost a year happened, right? After ChatGPT has come. It's been a year now, ChatGPT 3 and all, right? So last year, when I used to ask something, right, it was making like baby mistakes. So I was doing some calculation and it was doing this 23 minus 5 that ChatGPT is writing, that kept writing 19, 19, 19. And I was like, please fix it, it's wrong. And so is wrong your next all 10 steps, right? So then I realized that, ChatGPT mathematically is still not there. But now I feel that they have done some good improvements, and there are some updates that in a year or so, it can also solve optimization problem, which is fully mathematical, right? Fully mathematical. It can run iterations on mathematics, so it's basically can write your own algorithms. So I think the world is going to be super interesting to see what is in that, right? What is stop word in NLP? Anybody knows this? Give me an example. Stop words. And the right is in, of, etc. These are called stop words. So basically words that are commonly used in a language but are often deemed irrelevant for specific NLP tasks, right? Which are not very important. That's right. So examples in English language I can give you. That's our common language here. So it can be and, a, and, the, and, or, is, in, of, to, etc. All the pronouns. So yes, continuing on this, I'm writing. The list is big. You don't need to remember this because model has already those things. So what is the primary goal of removing stop words? Is to focus on more meaningful words that carry substantial information for for text analysis such as sentiment analysis or topic modeling. By the way, right? Topic modeling is a big use case in industry, insurance industry, BFSI, banking, finance, service, insurance, right? Correct, no? So BFSI is where you have a lot of documents in place, so you'll be using it, my dear. I think financial services, right? This is a very big college, huh, by the way. Financial services, no, I said no, financial services. So here, what are the points? What's the point? The point was that topic modeling is a big thing here. So what is topic modeling? So topic modeling is, guys, it is an NLP technique used to discover, I'll just give one liner, the underlying themes or topics within a collection of text documents. How many of you have taken a loan, mortgage loan, in India, outside India? Have you seen the pages they have? And the terms and the contracts, deeds, right? Those documents which they actually process for you as a mortgage for the loan, right? Banks. So I don't know if you have taken a home loan by now, you know it. That bank goes through a lot of documentation process. The moment you have a collection of text documents, topic modeling is your thing. Now, what do you mean by underlying themes or topics? Even media industry, they're using this a lot, right? Now, suppose I'm trying to put some detail on the website, you'll get a call from bank for their marketing they use, kind of loan requirement you might have. And this is very, this is very tricky and you don't like it a lot of time. So you're gonna do this, that you might disconnect the call. Hey dude, I'm not looking for a loan, but how would they get to you that you need a loan? You understand what's my point here? NBFCs are not good for working as a work culture, also for taking something loan. But what happens now? Not everybody is having a very good profile, and not every bank will consider you. So you end up going to NBFCs, right? They give you an easy loan service, but terms are very strict. Experience is not that great. Okay. And see, I'm not like some finance expert here, but I'm just telling from my experiences and others' experiences. Okay. But don't take me or take my words as like a Bible here. So Priyank, you can have a word, and Srini can have a word together. Okay. I think he works, so he will be able to tell you more. Right. But Priyank, how is the work culture there? Is my understanding correct? Work culture is not that great. It's too much of. It's great. Okay. Okay. So maybe. See, I've never worked, so I don't know. But I think with my exposure and experience, right, I have felt banking and financial services. So BFSI is tricky. It's aggressive, but a lot of job opportunities are there for NLP guys. I'll just keep it to this. I'll stick to this point. See, work culture is a myth. Okay. If you are able to manage, it's good. Not, I think, can't say anything. I'll take an application to show you what you mean by topic modeling. Suppose, and you can also go to companies like Netflix, as a matter of fact. So it's not necessary that BFSI only doing topic modeling, but they are the major. See, wherever you have a lot of documents, you can do topic modeling. So content recommendation. Now this is out of the box kind of application, and it's not like something like a very common area to work in. It's a niche area, but this is something like a job. So those who are studying recommender system, right? So content recommendation is a big thing. Okay, so it's more like suggesting articles. And trust me guys, in my all phones, laptops, right, except this laptop, everything I browse in private mode. That not like I'm doing something shady. It's just that I hate it when I'm trying to browse something and the cookies. Mostly I use Mac, so I use Safari. They are more private, right? So I start getting irritated because the moment I suppose I'm trying to buy a pair of shoes, right? I'll start seeing shoes everywhere, which I don't want to see, right? On every page on Google Chrome, which I don't like. It's like it's like that. The shoe is like pursuing me that Akash, you have to buy me. There's nothing which can escape. Nobody can make you escape from here, which I feel not good. So suggesting articles or content based on the identified topics. Now those who are, so how do you combine BFSI and this example? Have you seen a lot of products? They keep talking, keep doing ad. So ICICI Bank, I'll tell you, I'm their customers, I know. So ICICI Bank, there is a concept of salary, sorry, OD against salary. Something they say. So I don't know how many of you guys are aware of these things, but I'm just taking an example. My bad. OD against salary. So those who are working, they might be interested in this, and that's how I got trapped. So it's not a service they give you, just it's like a recommendation. And so let's say someone is searching OD, for example, anywhere in the world when I say India, and you will, so those who are working here, they will agree to me. It's a real case use case example I'm taking. It's a as real it can be, right? As real as it gets. So OD is overdraft, very good. So let's understand quickly what is overdraft. So overdraft is like a credit line to you, and you only get paid the moment you use that money. You have to pay interest on only on the amount you're using. 100 rupees, 100 days, 100 rupees one day, doesn't matter. It's not like a loan. It's not like some EMI you have to give and pay back as soon as you can. If you don't pay, you will be keep getting charged as an interest. I never recommend anything such as such to any student here. Anybody who's in college or just started the job, this is for people like us who has a lot of expenses and less money, so you don't get trapped. Clear? This is the disclaimer. I'm not selling OD. Okay, I'm just explaining a use case. So I'll tell you my own experience, and when I look back, so I thought, okay, experience was not good. Why don't we use just that as a learning thing in my session? Okay, so that's what I'm doing exactly. So overdraft is like, it's like a credit line, right, for you. So it's like, suppose you get a 5 lakhs credit line, depends on a lot of factors, forget about it. So it is in your, it's like your money, but it's not your money. You know what I mean? It's not like credit card, because credit card has to be paid on the 40th days or 35th days, or they will charge you like, wow, like interest will be like 25%. So you can't afford, right? OD is like interest will be like 11%, 12%, whatever, but it is manageable. That's why you don't get OD easily. So I was looking for an OD, just like money for the rainy time, right? Obviously, I'm not like some big shot, like a sheikh from Dubai. You know what I mean? So at times I might have need some money. So rather than taking a loan or borrowing from somebody, I like to use the institution. So the moment I was searching for OD, you do a Google search and someone wrote that sort of very good. I started getting incessant call from Bajaj Finance, right? I'm not, so again, this is like disclaimer that I'm not demeaning anybody here so that Intellipaat doesn't get in trouble. And guys, be careful. Don't, that's why so disclaimer is that discussing these things for learning. Okay, good. This is very important. So Bajaj Finance started calling. So they are very good in their marketing. Their marketing team is good. You guys agree? So Bajaj Finance guys started calling me. Okay. So they do business on this. This is their business operating model. So guys, how many of you have experienced that? You're searching for overdraft, personal loan. Did you get any call? Suppose you're searching for loan, but Bajaj Finance guys reaches to you. They reach to you. Agree? Those are working. Those are a good civil score. Right? Mine is good. Okay. Don't ask me how much. Okay. Then obviously I had a ICICI Bank. So when I was searching for OD, I also saw there is a recommendation sponsored, you see, right? So one is recommendation, one is push. So if you know about that, so it's like SEO. So search engine optimization, obviously you will search somewhere here. and use the internet for it, and definitely will use cookies. Okay. So if you see SEO, right, SEO does a great job here, right? So I also got the call. Bajaj Finance always comes on the top. So came ICICI and some top banks, right? Now this content is being generated, right, on somebody's interest. It's not being generated in the real time. That's the AI will do. That's the future. So what I'm trying to say that this is for marketing, right? Suppose you search for something, you get recommendation like articles or content based on your inquiries. So you can say that it is search, but you know what? A lot of people are writing in real time doing a topic modeling for the BFSI. Suppose I'm looking for a term insurance, so you will see that there is a blog which is being written in real time, right, with your requirements. It's like if you are writing somewhere, suppose you have written in Coda, you have written on Reddit, and there are companies, I don't have a real example, but I have a very nice and niche group where I discuss these things of, of ideas of the today's world or the tomorrow's world. What is being done, you know what? And these are being tested. Suppose you go and write something on Reddit. Reddit is an app where you can put a big detailed context asking still more like reaching out to a community. They scrap those data, right? Web scraping, and see that if that's a common kind of query people are asking on these social media handles, be it Twitter, be it Reddit, be it Quora, right? Likes of those. And there are hundreds of them. What they do topic modeling to generate what? Generate what? Articles and blog, which will be so convincing that you will think that dude, this is it. That's how I got tracked. It looks so real and so fit to your requirement because they're using your input to put a content around that requirement. It's like you want to be a data scientist. I only talk about data scientists, right? But I am from a finance guy, right? This is so lame. So that is one thing. Second thing, that why BFSI today? So remember I was telling you that if you only hinging on AI coding, right, or Python coding or Python or AI based coding or Java coding, your days are limited, So trust me, your days are limited. How many of you are coders here? Can you say hi? Or let's do a quick survey. How many of you are coders here? Literally you are coding to make some bread and butter for your life. Just coding, nothing much, without putting a lot of brain. So you just do coding every day. You just do some code or code quality checking of the code, testing your code, creating applications. So you're coding. Building product is also coding. Okay. Sales for developers. So you're coding. Okay. Architect is okay. I'm only asking who is coding to build product, to do anything like that. So if you are a technical architect, I think you're okay. You don't need to worry. So now you understand. So I'm a guy who adapts very fast. So why BFSI? BFSI has a lot of future. Trust me. A lot of future. And this is the first time plugging BFSI in NLP because I see a lot of promising career with AI because document is there, NLP is there. Those who like NLP after I complete, they can think about building a career on top of this, and domain is already there. So anybody who is from MBA, commerce, accounts, I think engineers are like omnipresent. You can think about getting into this. It's not a bad job. It's a very good job. Okay. My folks they work for Credit Suisse. They work for, Morgan Stanley, Barclays, a lot of banks. So if you can get this domain understanding and you like this field, that was the intention for bringing BFSI here suddenly. Okay, because supply chain, I keep talking about. After supply chain, I feel BFSI is another top notch is pharma or life sciences or healthcare or Medicare. But in India, I think it's very limited. That's why I'm very choosy. In India, healthcare is not picking it up, but you can work for the global clients like name it. So I think India will take another 30 years to be a great healthcare country, but healthcare here is not picking it up. But definitely, pharma is picking it up. So right, there's a difference between healthcare and pharma. or life sciences. So those who are doing automation job now, and anybody who's just doing automation like RP and all, please start thinking about something alternative. Anybody who's just doing automation like a VV automation or doing RPA, right? Please ensure that you start upskilling yourself in something totally out of the box, right? Or those who are doing those, anything which can be automated with AI very easily. So I'm also working on creating something that there is a very good page which keeps updating saying that which area, which sector, what kind of jobs you are going to lose because of this AI revolution. So I think that will give you a lot of insight and you'll be on the top of the thing. But what I'm trying to say, although we are teaching you AI only, so you guys don't need to worry. So those who are all present in my session, you are already learning something which people are going to use against you, right? So you don't need to worry, right? Yes. So I feel RP automation is something AI can do it automatically. It's like there will be a set of, so there will be like a more like an assistant, and you just tell it, make some workflows in that, and it will do it on its own. It's very highly easily going to be, scalable, and because now understand, and I had done this RPA training when I was in Genpact, my very first company. What I'm trying to say that RPA is what? You look at some boxes and, location in the document, right? Images, right, on the screen. Then you make a box there and saying that if you find this similar, right, you do some action on top of it, right? Agreed, correct now? So if you think OK is there, so you have to click OK, right? Now, you know what? I don't know. I want to show you a demo. So shall I do it? Can I take 5 minutes? Because I know almost we are done, but I'll just take 5 minutes. Are you guys ready for it? Can you see ChatGPT? So I'm using a paid version, my dear. Okay. So this is something I try to use it the most of the time. Can you see ChatGPT? Okay. See, I'm just sharing a screenshot. Where is that screenshot? So stopword analysis. Let's say step 5. Obviously, this is a handwriting. All right. Suppose I just copy paste it. Hey, come on. I paid for it, right? What's wrong? This is not done. Why the attachment is not coming? My paid account is gone or something? Seems so. Yeah. Anyways, can you interpret and give me more detailed info on this screenshot? Now just understand this. I understand. Sorry. So I have to select the right one, but just understand this. See the power it has brought in. Can you see? You understand what's happening, my dear? It is able to understand what I've written, which is not that bad. At least ChatGPT understands. You can't see, can't understand. So it understands my handwriting. It understands that it is a step 5, stopwatch analysis, right? And it gave me the detail, right? What other steps I can do in NLP? Let's see. The moment I say, obviously I'm paying for it, so it will be better than what you see in terms of output. Yeah, it is only available in paid version. So see, it's going in like, and now it will start blah, 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 blabbering. So what I'm trying to say, look at the world we are living in, my dear. You know what I mean? Now going further, there will be there will be no need of trainers. It seems if the trainers are just doing coding and showing you coding, right? So that's how I keep, differentiating myself, saying that you have to be on top of the game, right? That's why I have to keep upskilling myself, that when I come and teach you the for loop, I am doing a better job than anybody who is a coder. And he might be a very good coder. He might be able to write all the efficient and production level coding, but with the real application, the industry exposure I have, I'll beat these guys, So now can you see when it can read handwriting like anything, then RP it can do. Yeah, I mean, you have to just tell it and train it. It will be just using its training to get trained, but I think the kind of training it has done and being done, don't think that the model we are using is not getting updated. So I'm paying it for it. So obviously I'm getting the latest model all the time, not the free versions, right? So they keep coming with new models. And I think my trained model on behind the my chat GPT is better than anybody else because that is the latest one available to anybody in the world. So that's where I'm sure about a lot of things. But what I'm trying to make a point, domain is important. And that's where, I came up with this BFSI thing. So you got it why I'm talking about it now. Makes sense? So the world is going to be very crazy, right? In coming time. It's very crazy. Trust me, there was a time when I was writing an OCR using a Tesseract library in R. R is a programming language, and I was hardly getting a very good accuracy. And now when I look at my iPhone images, it reads my handwriting. These guys are reading my handwriting. So far, we have come in so less time. 2016, 17, I'm talking. And 8 years down the line, it is reading handwriting, that too written by a pen. Are you guys believing what's happening here? I don't know if you're able to fathom what I'm trying to raise as a point. It is moving super duper fast. Be careful with your career. Trust me, this is going incredible journey for AI, but it is going totally out of hands. I don't know, government might bring a lot of regulation, start banning these things because I feel a lot of people will lose jobs, right? I'm not trying to create any frenzy here, any panic mode here, but I'm just trying to support you guys saying that you have taken a big decision that you are trying to learn AI. This is the best time to be in the field which is going to change everything. Okay, so be careful. And obviously, when you are talking to your juniors, siblings, right, younger brother, sister, pass on my message. Obviously, I am not like some big shot that if I go on a podcast and tell everybody will follow me, I'm nobody, right? Nobody knows me. Only you guys know that who am I. So please, whatever the mode is, but try to pass on to the next few guys so that they're aware of these things. It should not be like after 5 years they are waking up and saying, dude, I need to do something about my career. It will not work for them. Okay. Step number 6, dependency parsing. So you know what? Dependency parsing is very important for grammar. Okay. So let's talk about grammar a bit. I'm going to show you a nice diagram, guys, and you will see this. So if I say London is the capital, right? London is the capital and most populous city. Can you see? This is the sentence. Now, even you have done this in the grammar, right? In the grammar courses, that if you look at the sentence, you know that what is what. So you know that how quickly to understand the whole tree, that London is a proper noun, is coming from B and B is a verb, D is the determiner, right? A and D. D is the determiner, A and D the article. Capital is like a noun and its conjunction here, right? Most is adverb. It's trying to saying that most populous is like adverb. Populous is adjective. Or anything which bumps up the or pushes the adjective, that is your adverb, and city is a noun. So if you are aware, this is your parts of speech. Very good. There's a period, right? So under this topic, there is something called syntactic analysis, also called parsing, syntactic. Okay. So guys, syntactic analysis is crucial for understanding the grammatical structure, which I just explained quickly. See, for a human being, it's easy because you have learned the rules of grammar, you know that. Understanding the grammatical structure of sentences and how words relate to each other, right? Now, if you understand, right, look at the relationship here. So, London, right? So, if you see, is has a predecessor, which is saying London, and also has a successor, which says capital. So, London is the capital, right? So, I'll come to that, how to understand this chart, right? But what I'm trying to say that there is a relationship between from, to, and then we have the determiners. Okay, so I'll come to that. But let me just complete my notes or pointers so that I'm not lost. So syntactic analysis, someone can ask, so we have already explained the objective, but what is it? It is the process of analyzing a sentence to determine its grammatical structure. So that's the technique or the concept. And then I mentioned dependency parsing. So once you understand, so once we have identified the grammatical relationships between words, dependency parsing constructs a dependency tree or graph, which you just saw, that shows how words in a sentence depend on each other. And once the models were able to do this, the understanding of each and every line has become. So it has not been done, or it was not done in a day. It took its own time, right? So NLP is here for the last 10 years almost, I would say. I can be wrong also, but this is how it is. So you need to understand that the kind of relationship you are seeing here. So London is the capital and most populous city, right? You can quickly find out the grammatical relationship, right? But just imagine that there is no human behind it. There's no human behind it. Model is telling that relationship. So this tree, I'll get into more details now since I've completed it. So this tree is known as dependency parse tree. Okay. Just imagine that for each and every line you've written in that article, models fully understand the relationship. So London is the capital. So what is the line? I'll write it somewhere here. So London is the capital. So I'm saying London in the Hindi, but I can't say pronounce in the in British accent. British accent is the capital and most populous city. Right? This is a sentence, guys. Come on. So we are saying that London is the. So you see, right? Let's start here. So obviously root is the, this is your root. Okay, so don't miss that. Root is this, but you also know that London, which is the proper noun, what is the relationship, guys? You know that, right? If you have done a little bit of grammar. My God, those were the days in school. I remember, and my teacher used to beat with a rod. I'm talking about school days. I'm not bashing the teacher. Don't worry, I'll not tell the name. But he used to beat with a rod, a circular rod. And very difficult grammar question. I used to get nightmares. Okay, because without understanding, if you're right to cram it, just cram it, remember everything. It's very tough. So London is the subject of the sentence. Okay, and it's connected to the root verb is, right. So I'll also write it, and it's connected to the. So my teacher would have been proud. Now he is teaching grammar in grammar in AI, right? He must be proud about it. I'm not doing anything. The models are doing anything. Sometimes I feel, why we did so much of, so much of excellence, pursuing an excellence. Now model will take over. Okay, anyways, just kidding. Subject, predicate, remember all those things? Complement is the predicate. So I'm going to be grammatical here. So see guys, my starting was in Hindi medium, so I'm not too good at it. So forgive me if I'm saying something wrong, but at least my notes can't be wrong, so don't worry about it. What is capital, my dear? Capital is the complement, or also called predicate. Remember predicate noun, right? So can you see very smartly, I have told you that the root is attached to this guy, subject, follow this yellow color, and also attached to this guy, which is your capital. Hello, everybody. So subject, London is the capital. Okay, fine. D is determiner. Okay, very good. Thank you. But I can still stop it, right? London is the capital. This is your determiner. Very good. See the linkage, right? The relationship, subject and predicate. D is your determiner. Now, most populous city, you can put it into like a phrase. That, dude, this is a phrase. Most populous city, I can take it as a phrase. And that is being connected using this conjunction called and. Interesting. So what we're trying to do, the model, I'm telling to the model that, dude, understand, London is not only the capital, but also most populous city. So model saying, okay, boss, I got it. What are you trying to say? Are you feeling it? That's how human knows, right? That's how human knows. If I tell you, Masrat, that London is the capital and most populous city, you know, right? He means that it's not only the capital, It's also the most popular city, right? Very, very good. But model goes one step more. It also tries to understand that maybe that's the reason because it's the capital. Because model totally understands capital is like some major cities, right? Because if you're doing like a chat GPT kind of thing, it has got a lot of contextual learning. They know that top cities by population, London will be there. Why London is so important? Everybody's flying to London. Something is good. So they might have the flight data. That might be the reason that a lot of people are coming. The chat GPT can also go and find you reason that why it is most popular city, right? You want to try this with me, guys? Come on. So I'm just putting a command or prompt saying that London is the capital and most popular city and asking why, right? See, I was right. How good it can be, guys. My God. Look at this. Can you see that, guys? Obviously, I'm not trying to teach you with ChatGPT. I'm just saying that here ChatGPT should be used if you have a license, my fellow trainers. So see, London is the capital and most populous city. I ask why. It's a factual statement. So it's thinking like a human. Dude, you're right. It's a factual statement. It's correct. It looks correct. Why? Because it is a capital first, meaning it has all the political, cultural center of the country. See, it understand that why a city becomes capital. You understand? So when it has the center for the administrative, political, and cultural center, generally that becomes the center. Look at the training it has been gone through. Then it is explaining what you mean by capital, right? Then most populous city because, right, London's role as economic, cultural, and educational hub, attracting people from all over the country and the world. Isn't it just now? I just mentioned that maybe 2 minutes back before ChatGPT spit it out in a very one-liner. So do you think that the ideologies or the kind of, you know, that look at the beauty of these things, that it is trying to reason out that these two roles is the reason that sentence highlights both characteristics, and that is the reason that make London most important, which is capital and populous city. So what it has done in its honest way, Mr. ChatGPT 4a 4o responds to why. You think if I don't tell you that it is being written by ChatGPT, you might think that someone has written who has good knowledge, right? A very good, well-read person has written this. You understand why I'm saying this? Because this is going to be much better down the line. And it's getting better and better, I can see. So that's all from my side, guys. On the NLP, you can keep trying to make India more proud, Priyank and Srini. One guy can try to think about bringing the wealth back, you know, and one guy can think about, making the India independent, which I like. Okay. There's one more thing which is important, which is your step 7, POS tagging, which is similar to what we're discussing, called parts of speech tagging. So POS, which is parts of speech tagging. So POS, parts of speech tags, contains quite a lot of things: verbs, adverbs, nouns, pronouns, adjectives, right? That help. I'm not reading everything. That help the meaning of words, help to understand. Sorry, I lost my thought. That help to understand the meaning of words in a grammatically correct way in a sentence. So guys, trust me, it has a big list. So I'll give you this one. See here. So nouns, right? So if it is a noun which is coming like singular or mass, it will be NN. Plural will be NNS. Proper noun will NNP. P stands for proper. Proper noun, plural will be NNPS, right? Like London's, Smith's, right? Similarly, so it's a big list and you don't need to remember this. Don't worry about it at all. Model will take care of it for us. It will have this list as a more like a dictionary. You don't need to worry unless until you're trying to make your own. So this is like exhaustive list of everything. So that's all from my side on the pipeline, guys. As I mentioned earlier, and I'm repeating myself again, this is not the end, or this is not the exhaustive, or this is not like everything we have to do in every data and every project, but it's a good starting point for all of us. And you can build on top of it on your knowledge. So I want to show the data first, then I load it, right? So if you see, right, these are your IDs. I think it must be a text. So I'll say general, right? So these are the columns, guys, airline sentiment. So it's already being captured that, sentiment, confidence, negative reason, confidence, which are the airlines. I think it's a US Airlines, you have American, Delta, Southwest, right? I think this is mostly blank, not much blank, but yeah. Name, negative, reason, gold, retweet count, text. I think this is where I'm interested in, right? It looks like a real test. Can you see that? Read @Virgin America. Okay. So it's saying, seriously, would pay $30 a flight for seats that did not have this plane. So, obviously people have written a lot. Okay. So this is the data we are going to consume in our analysis, guys. Okay. With me here so far. So this is the screenshot of the data, guys. So what is our objective here? To classify the sentiment of tweets into one of the three categories. And you saw, right, what are the categories? It was positive, negative. Cool, guys? Make sense? Data description. Someone would be interested in knowing data description a bit more. So let's write it. So obviously source is tutor, no brainer. Coming from a project on Kaggle. Okay, Ji. Description, high level description, guys. Passengers tweets about airline performance, having sentiments about their journey. See, I could do this on Collab, but the problem is that Collab is really slow and time is less. You have seen, right, Priyank? So it takes time to react to what I'm writing. That's why I'm not much happy with that. That's the whole point. Anyway, you're not going to code with me, you just have to see on the screen. So let us do that. Idea is not to code with me. Okay. Now, what we are going to do, what are the learning outcomes, guys? So number one, we are going to do the, quickly text-based EDA kind of stuff. Then try to give you the basic understanding of text pre-processing. Then we will talk about after text pre-processing, which is like backup words and tensor vector IDF and other stuff. Then we build the classification model, tune it and plot it, right? So I've already written for you guys so that I don't waste time on this. So these are the learning outcomes I'm going to try to give you. Those who have not installed this, so you have to install certain library. If you're doing for the first time, pip install contractions. I think I have it. Let me see that if I have it or not. If it says requirement already satisfied, I'm good, which it did, right? So guys, we are going to take a lot of libraries here. The idea is to use and then understand rather than detailing only on the libraries doesn't make sense, right? This is a good set of starting point, but don't worry, I'll explain each of these when I'm going to use it. So don't worry. Okay, I'll come back and say, oh, I'm using this, I'm using this, I'm using that. Make sense? That's a promise. So it's not like a copy pasting the codes. It's just that I don't want to get into detailing out the libraries. There's no point. Okay. But since we have to do some detailing out later, we will do it. And I'll make a point where I'll come back and do it. So number one, I think you need to load the data into PD's data frame. No brainer. It's a CSV file. You saw that, right? I think, I don't know, did I import OS or not? So I need to see what is my current working directory and I'll keep the file there. Okay, so this is your batch, right? So I have to take tweets. the same file, I'll copy and paste it there also, which I did it for the 700 batch. Done. So let's load the data. So it will be pd.read CSV. The beauty of this is good. Okay. Let's do some sampling. So this is the reason that I'm doing here, how fast I'm able to code here. So see, the data loads nicely, right? You have the tweet ID. Basically, it will be the passenger. I think Srini, you were asking, right, that how do they collect data, right? So it's coming from Twitter. So for every person, there is an ID. Okay. So for every, I think, person tweet, it's an ID, and then airline sentiment. So few things are blank, you can clearly see, right? But we have to just worry that we have everything which we want to have it, right? So let's understand this data a little more. Obviously, we will start identifying the missing values and see that if that's a concern for us. How do we do it, guys? So you'll say data is null. You have seen me doing it earlier, and you do sum. So it will give you that how many guys are missing, and you can also do a percentage split. Okay, so you can say take this bunch and divide by the length of your data, right? So you know that you have some real stuff missing. 37% is your negative reason. Airline sentiment gold is like fully missing, right? Tweet. But one thing which I see that text is like fully there, right? That's what counts for us. For us, text is important, right? See that? So none of the tweet is blank. Can't be possible, right? How can you have a tweet without anything, right? You can't put just some 00, right? You understand? It can't be null. It cannot be an empty tweet. That's how they have designed it. Let us do some amazing EA. And this is not like what I'm doing is enough. You can always build on top of it. So I'll do some EDA. As simple as that. EDA, you know, right? Exploratory data analysis. Okay, let me write. So what I'm saying, guys, let's find percentage of tweets by airline companies, right? Nobody goes there and they tweet. Generally, people also tweet positive things, feedback they give. But have you ever gone there and tweeted something about because you liked it the most or you loved it, you did not like it the most? Tell me, where do you tweet more? I think I have only tweeted whenever I felt real harassment from the companies. Okay. So percentage of tweet will tell you that if someone is harassing someone, right? That someone is like company. So in US, Twitter is really famous. People tweet almost everything there. I'm feeling a little hot. Let me switch on the AC. Or no, let me switch on the fan only. Import C1 as SNS, right? Let's take a canvas, count plot, data equal to data, X equal to airline. What is the column name? Yeah, airline. Palette, paired. This you have done multiple times, right, guys? So you can clearly see that of all the tweets, how many tweets you have, by the way? 14,640. That's your total tweets, right? So you can say print total number of tweets is how much? 14,640. Out of that, who is having the highest? United Airlines, right? Some generally people ask me, Akash, this is so fine. Can you show some percentage on top of it here only? I know a lot of people thinking about it. Guys, can you show me percentage also? On this chart only? You can do it, but it is a little tricky, not that easy. But at least, see guys, we will not be able to spend more time on these kind of requests. But yeah, we can clearly see that. Yeah, this is an older data only. It's a very famous data set. I think if date is there, I would have told you what data is this one. But there's no date. Location, time zone. No. Yeah, but it's not like a recent data. Don't worry. I'm not saying that also. So what I'm saying, guys, we can see the percentage of tweets for United Airlines has the highest number of tweets, approximately 26%, followed by, I've done this maths outside, don't worry, by US Airways, which is 20%. Good. So at least you know that who are the airlines which is getting a lot of tweets. You can clearly see United Airlines is topping it, followed US Airways, and then American. Okay. I'm not saying that they have more issues. Don't jump to conclusion. I'm just saying that they have highest number of tweets. And you can do some pandas data aggregation technique to get percentage and all. What is the distribution of sentiments across all tweets? Right? Someone can ask me this question also. Like now, since it's interesting, right? So plt.subplots fixed size. Exactly my point, Masud. Our focus is more on to get into the NLP task rather than visualizing a lot. So as far as we are able to get a sense of the data, we are good here, right? And I know you can do much more on top of it, but that's your work. So data equal to data. Now, what is that X where the sentiment is? I think airline sentiment, right? This column. And airline sentiment is not having nulls, so we are good. So we'll write airline sentiment. Perfect. Palette, again, paired. Perfect. plt.show. Now you will see the reality of the tweets. So it's a human behavior, right? If you're not feeling happy, you'll go and tweet. Even Americans do that. Can you see it? It has to be high now. Let us see some negative comments randomly. How will you do it? Only filter for negative. Select negative equal to data. You know this, right? Slicing. Airline sentiment equal to negative, right? And then you will say data. Use this masking and do some sampling, right? Show some sample of 5. See? And only we have to print the text. Not everything. I don't need everything. I just need the text. So now obviously we are not able to see everything. So we do this list and then see if it happens, right? Amazing. Python is so happening here. You see? Yes, but should be able to get a push notification via the app if I'm logged in and on a trip. Email or text is so 2010. So this guy is telling it's very old. United Airlines, once again, your lack of customer centricity is astounding. It's a sarcasm. Wow. Why so expensive to go to Vegas with the stops in late flight zone as I can get non-stop for same on competition? See? Just flew to do this, paid from a third suitcase, who did not even make it on the plane, besides for the impolite service. See? Americans, right? They have a way of telling things. इधर तो गालियां लिखने लग जाते हैं, right? Okay, cluster continues still on connecting instead of direct. Back charge sits not together. So understand this is for the same one, right? And if you keep doing this, you'll keep seeing something. I'm at 4 or 5 morning. Will be nasty in Boston. Have Fabling driving 90 minutes to pick me up from everything flight. What if cancelled flight? I don't know, something they're writing. But why they know that it's negative? Because in the same data, hold on. In the same data, you don't do this, you will see that they have a category, no? See, negative, 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 negative. There's a reason also, customer service issue. Can't tell. So must be like a filter, right? Select, can't tell. Cancel flight, customer service issue, right? So as a matter of fact, for negative reason, right, you have some missing data, right? But similarly, you have for positive reason also, I think you have some missing data, I realized. No, only for negative reason they have this category. But anyways, we know that there are negative tweets. Let's see if it is, what about positive tweets? Let's see that. So आपको कुछ नहीं करना, you have to just go there. So I'm speaking Hindi. My bad. Say that, select positive, change this to positive, and just see this. Now, everyone has been so nice and helpful. Looks like positive, right? I'm already a card member as well. Enjoy flying with you guys. Wow. Thank you. Simple, positive. Thank you means positive. Thank you, positive, right? Let's see neutral. I would love to see neutral. So let's do any it. See, this is so fastly we are trying to get into it, right? You like my way of slicing and dicing the data, guys? I have a way of getting into the data. Now, if you're not good at basics, you will struggle. I recently moved and got a new license, and when I booked my flight a month ago, I used my old license. Do I need to change that? Obviously, it's more like a query. So it's not like DM these nuts. I sent you a DM, can you please help? Obviously neutral. Look into better service, more like a suggestion, right? So obviously somebody is tweeting and they are categorizing. I don't know what is they're doing to categorize. I'm not sure, but this is the data we have. Makes sense so far with me? I had written this code for you because I don't want to waste time, but I want to show you that there is a way of someone asking me, right, can you also show percentage? One of the learners did it. I realized that I have it in my other notebook. So I just source the code and it's on the same data frame, so it works. Data, right? See, 62% of the total tweets are negative, 20, 21% is like neutral, and then the rest of the 16% is positive. So as you can see, guys, you need to do some annotation, right? So Srini were right about it. So I think you have to spend some time on understanding this code. It's very easy. So what are our some key observation, my dear? Number one. So majority of tweets are negative as expected. We expected it, no, before we started on it, which stands at 63%. Followed by, that's how you have to give summary to your client also. Followed by neutral tweets. But this is very basic insights. I don't write these insights. I write insights which will take at least 10 minutes to understand. That's how you get valued, you know. If you write these statistical insights, they'll say, what is in it? Even I can do it, right? So you have to write something like you have to make a statement. And then they'll say, what? Then you prove that statement with your data analysis, which you have already done. That's how you win your clients, okay? Can you show me distribution of, this is a very interesting chart. Distribution of sentiments of tweets for each airline. Now this is interesting, right? So you're telling total, no? So total is negative, but for which it is negative? I think we have to do some data preparation for this. So understand, I want to know distribution of sentiments for each airline. I have to group by airline and airline sentiment, right? Guys, pandas aggregation, you know this, right? We can call it a multitasking ability. I also have some abilities. Count, and then I think I need to unstack so that I can show you this. Now, yeah, it worked. See, this is interesting, guys, right? So now it gives you that by different sentiments for each of these. Interesting, no? Now, the good thing that Panda says, I can only plot. Why you want to go to? And that's why I love some of Panda's plot. Although people bash it, it's very basic. Baba, but if you want to get something nice and fast, right? Pandas is good here. See, you don't need to do anything. See, interesting. So at least know that United Airlines is not having the highest. It is also having the highest bar in the negative. So is for US Airways, right? So it looks like it's already much in the line with what you would expect. So we identified top three guys, these ones, right? US United Airlines, followed by US Airways and American, right? Remember that? Same guys are coming here also. So you can do some sorting and all, and then the chart will look more better. So it's very evident. So what is our plot the stack bar, you know, right? Stack bar chart showing percentage split of sentiment for each airline. So there is other way to show the same chart. That's what I'm trying to do as a task. So rather than showing three, can you see three bars for each airline? What I'm saying, my dear, take this guy, take only US Airways and show like percentage split. You know what I mean? So basically we'll see only 5 bars, but showing percentage of these guys, right? That will be interesting to see if you can do it. Okay, I can do it in a matter of 5 minutes, but that's something. So it is evident from the output that for almost none of the guys, only Virgin America, I think they don't have, right? Virgin America, they don't have enough. So it's like I'm equal in all three. Can you see that? So you're saying that doesn't matter, dude. I'm neutral, I'm positive, I'm negative, I'm everything, you know. So Virgin America is like, okay, I don't have any idea what I'm doing. Obviously, it's insignificant business, right? But anyway, anybody would talk to you, any company, big company, during these meetings that, okay, talk about top three or bottom three. So it is evident from the output that for almost all the airlines, let me write, the majority of the tweets are negative, right? Followed by neutral and positive tweets. Virgin America airline, right, is probably the only airline where the ratio of the three sentiments group is somewhat similar. See, so as a matter of fact, right, you have to highlight it in your insights. Okay, good. Someone can also say, okay, I also want to see, okay, now I'm not worried about positive, I'm not worried about negative. Someone can say, dude, let us deep dive only on the negative reasons. So let us plot it. I'm just being selfish. plt.subplots 8,6. You know what I'm doing, right? Count plot data equal to data, x equal to negative reason. I'm plotting the negative reason distribution, palette equal to paired. Wow, it's so messy. Yeah. How we will fix it, guys? We'll do some rotation. You know, right? You can rotate plt.xticks. There's a parameter called rotation. See, not round. You can do by 90 degree. Interesting. Customer service issue followed by late flight. Okay. A lot of people are ranting, but they're not sure. So they can't tell, right? Lost luggage is also there, huh? Cancel flight. But the biggest thing is your customer service, right? Can you see that? So let's write it, guys. It's an insight, right? Customer service is the top reason for negative sentiments. Okay, this is good. Now, guys, let us do some NLP work. So let us start with word cloud. You know word cloud? It's an EDA thing only for negative tweets. It's a visual way of seeing that what is impacting us the most, right? So we'll call from word cloud. So this library helps you for plotting the word cloud, and you have to also take stopwatch. So guys, I'll create a data frame which is only filtered on negative tweets, right, guys? Which is airline sentiment equal to negative. I have just created a new one. I could have used the older one. So this is like filtered for negative sentiments. Now, guys, I'll do a join with a space, negative df and text. So what it does, guys, so you know, right, it filters for the negative sentence, and then what we're doing here, combines all the tweets, which are basically what? Stored in the column text now, guys. Stored in the column text, not text, text, into a single string where each tweet is gonna be separated by a space. So powerful techniques, huh? By space. As a matter of fact, you can put anything there. You can put APC also, huh? Let's see it works. Now see the words. So all the tweets have been combined into a big thing like an article. Okay. No need to do for loop and all. Sometimes people start thinking about for loop. Why for loop for everything, right? With me so far? Now we have to do some cleaning of the combined string. So obviously I need a clean text. So I'll say join. Now guys, understand. And I'll explain also, don't worry about it. I'll take word for word in words dot split. How many of you are able to gauge this? What I've written? This is something you should know. It's coming from basic Python. So you're writing for loop in one line. Split the text into words. How will you do it? What is this line of the code is doing, guys? Come on. Oh, let me also complete first because I think I'm asking question in the middle. Hold on. If so, split, and that's a problem with the commentary. I'll come to the commentary later, guys. Hold on. Then my block goes disturbed. Okay, if I think let's take away HTTP, not in Word, and not Word dot starts with, you know what? Every tweet is gonna start with @, so I have to take care of it also. And Word is not equal to right retweet, so it will be exclamation. Kidhar hai yaar, huh? Now what I'm doing here, anybody got an idea? Now you look at it. So number one step I'm doing, splitting. Come here now. Splitting the word. Which word? This is the word, no? Okay, let me write. Words. So this is the words, right? All these are words, right? Take a look. Okay. So I'm splitting the words string into individual words based on white space. How do you know that? Because I've written this. Now white space is there. Okay. Now I am going into the next, and this is called list comprehension. So this is what we are doing, guys. Okay, maybe I'll write here. So this is something leveraging. I don't know how many guys remember this. It must have been taught. Leveraging list comprehension. If not, we can discuss also this. I'm saying we'll discuss, but I don't know I'll get time or not. Now I'm saying if HTTP not in Word, what do you mean that? Exclude any word that contains HTTP, right? So generally social media will have HTTP, HTTPS, and you can improvise on this, right? So that's not like a hard and fast rule. Then what you're doing, you are excluding now anything. Exclude words which start with, not like any word just @, any words start with @. Then what? Retweet you don't want to use. So this removes the term retweet, right? What I did. There's some shortcut which works on this machine, which is in overlap with Jupyter. I have to rewrite word not equal to retweet. So I'll say exclude RT term. Okay. And then I have to do this so that it runs. Okay, it ran, guys. Let's see what it did. See. Now if you observe, right, do you see any @? Let's see this. So very first line was @, right, guys? Come on. The very first word was @. So @ version is gone. See, it's starting from, it's really aggressive to blast obnoxious entertainment in your guest. Okay, very good. Then what we excluded? We excluded anything HTTP. I don't see, so I'm not able to. Any retweet you're seeing somewhere, it should be also gone. But yeah, we will not definitely go and check. Okay, agree? So this has done all these steps which I mentioned. But obviously we are not able to validate. It's a big thing, so I can't go and pinpoint, but yeah. Now the other thing, if you see, right, we need to remove stop words, right? So for the word cloud, I'm gonna use word cloud without stop words. So stop words is a list which is gonna be there, and it is stop words. So guys, this is already there. Background, you can say, you have to give some color, you can say black is much preferred. Width can be, you can say 3000, and height can be maybe 2500. Just start with something. And okay, then I'm saying that generate clean text. So guys, it will exclude common stop words. But if you have some laundry list, did I miss something? Background color. Okay. No, the moment you give stop words equal to stop word, it will exclude. Default is to exclude, not the other way around. It is taking some time because loading a lot of data must run. So when you write stop word equal to stop word, it will do the job. So even my machine is like saying dude, fan is like, so it's done. We have to just print it. So obviously the word, it's run, it's run. So let me plot it. PLT.subplots, fixed size. I'm ready. 18 by 18. I'm show word cloud plt.access off plt.show. Interesting. See guys, I can make it more tiny so that everything can be, width can be 12. This can be 9. See. Oh, sorry, I did ulta. Height can be 6 and now see. But you can clearly see, I think we have to generally go to the square thing, but you can open the image in a new tab and see, right? So obviously people are talking about flight. So someone can say, right, why don't you remove flight first? Okay, and then do this. But you can clearly see that a lot of things has to do with bag. So you know that people are losing bag or something with respect to bag. Hour, time, right? Help. So they're looking for help. Customer service is also coming, see? So as bigger is the size, that means that that's what being come. It's like frequency, right? So if your font size is bigger, that word is existing or repeating more and more and more. That's the reason that we already removed the common word, because everybody will write English with the help of those common stop words, right? So I don't want to show is, he, she, I am fed up, what are you doing, right? I don't want to show those, are you an idiot, right? So those things we don't want to show that. Are, I don't want to show. Is, I don't want to show. That's why I removed the common and stop words. But even if you see bag is there, I think help is there, hour and time is there. So it gives a good feeling, right? Cancel flight is also coming if you're able to see this, right? On the vertical. I think this is the way it automatically handles. Some words are like vertical, some words are like, it takes random approach to it. Obviously, I have not written this library, so I can't be commenting on that. But you can clearly see that hour and time is to like superbly coming. Customer service is on top of it. Hold, something is coming as a hold. Can you see that? I don't know. Did I choose the right color combination? Guys, I'm really bad with colors. Yeah. So see. So gray is definitely not. It's a turn off. I think you might be looking for white. You can give some hex code also. It's a big hands-on, guys. It will take another an hour. So this is how it looks like, guys. So you'll see now it has slightly changed, but flight is still the bigger, then followed by the positioning will keep changing. Every time it's like a random. So hour and time was somewhere in the top, right? Remember? Now it has shifted slightly. So guys, this is all from my side on this. So I think black was better, so you can keep black. I'll save this image in the Google Drive so that you have it, you don't lose it. You love the black, it seems. So I have put it there, saying it as word cloud, negative sentiments. But same thing you can do for the positive also. I think we have a lot of things to do. Why U is highlighted? Where you see U is highlighted? Yeah, because a lot of people start writing you have done this. So we need to take care of it. This is what you have to do, handle this in WU as a stop word, right? So generally in our normal dictionary, nobody writes you, right? This is like a slang chatting language. So sometimes you have to use, there are a lot of library as well. So you means your you, right? So we write, no, you are like you means you, right? YOU. So people write you, like let is also there, into is there, info. So we can take care of this. So we can further clean it up, but that's something we have to handle at our end. Yeah, someone can, or WTF they can write. So Americans say what, what the WTF a lot of times. So if you if you don't do a proper cleaning, that might pop up here. So you have to be very careful before presenting to everybody. Okay, so this is just the beginning. I think I need another an hour on this, and then I'll be able to complete this whole hands-on. But this is just the warm-up I have done for the day, guys. I hope you liked it. So this is interesting. People are finding a lot of things, right? I think we can take away. So a lot of things we can do on top of it. I've just used the library. So you remember stopwords is coming from here. So if you see the library, right, we have the stopword. See, NLTK download stop. So NLTK natural language, kit. It's a library. It's a big one. People have been using this. So let me share this link. Natural language toolkit. So trust me, it's like a ocean in itself. So I'm sharing the link here. Beautiful soup is what? It will come later, Shalja. So I can't jump there, but I'll come to that. We have just used stopwords from here. Okay. So if you see here, the word cloud, I'm using the word stopwords, right? So that's something you can see.
Just a quick info, guys. Intellipaat offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.